Hello there, and congratulations for making the decision to sign up to the course and propel yourself towards Linux mastery. Hi, I'm Ziad, and I wanted to shoot a quick video to congratulate you for making the excellent decision to sign up, and I wanted to give you a quick introduction to what we'll be covering in the course. So first, we're going to get you all set up with Linux by walking you through step by step through an installation of Linux on your own virtual machine. Now, doing it this way means that you can play around with whatever you like without risking anything or damaging anything, and anything can't really go wrong. Think of it as your perfect playground to the awesome skills that you'll learn in the course. Then we're going to move on to learn all about the Linux terminal, an incredibly powerful program that is your gateway to doing anything that you want on your Linux machine. We'll discuss what the terminal is, how to use it, how to enter commands, and clear up popular misconceptions that may be floating around. Now, the important concepts that you'll learn in that section of the course will lay the critical foundations for everything that you'll do with the Linux command line, and it will make it all start to make sense. We'll then move on to discuss the Linux file system and how to work with files. Now, working with files is probably 99% of what we do on an everyday basis, and so understanding how to work with files effectively and efficiently using the command line is an incredible ability to gain. Now, in this section, you'll learn how to create, delete, copy, paste, edit, rename, move, find, open, search, archive, and compress files, and so much more, and it'll make you able to do anything that you want with files, but with the efficiency of the command line. It's going to be awesome. We'll then move on to how to automate tasks using bash scripts. So you'll learn how to write bash scripts and how to schedule these scripts to run at certain dates and times so you can automate your daily workflow. And finally, you'll learn all about installing third-party software on your Linux machine. You'll learn how to search for new software from the software repositories and how to manage your software using software managers. You'll also learn about open source software and what it means to be part of the open source community, as well as learning how to take source code and compile it into working programs. Now, by the end of this course, you'll be comfortable using the Linux operating system, and you'll wonder why you haven't been using it all along. And one thing I always aim for in my courses is to make the content unforgettable. So to help cement the learning, you'll have quizzes to check your grasp in the concepts, and you'll also have some assignments for you to complete to really test and improve your skills. And there are also some cheat sheets summarizing the concepts from the course, so you don't need to take notes. Just sit back, relax, and practice the skills, and rest assured that the important information is jotted down for you in professionally designed cheat sheets for you to refer to whenever you want. Now, if you ever need any help, feel free to ask questions in the questions area, and when you feel you've got immersed in the course, please leave a review to encourage other students to take the course so we can make the joys of the Linux operating system accessible to everyone. Other than that, I wish you a very pleasant time learning Linux in the course, and I bet you can't wait to get started. So let's jump right in and get you set up with your own Linux virtual machine. Hello there, you beautiful people. Now, one of the biggest reasons for someone to switch to Linux is to use what is arguably the most powerful feature of the Linux operating system, and that is the terminal. Now, if you've ever seen a film where a hacker or a computer genius is sat behind their computer typing commands into what looks like a big black box on their computer screen, that black box is called the terminal. Now, at one time, the entire Linux operating system was purely terminal-based, but as time has gone on, more graphical tools have been developed up until now, where we have these beautiful desktop environments like what we see on Ubuntu. Now, fundamentally, the main difference between using the terminal and using normal graphical methods that you're probably already familiar with from either using a Windows or a Mac is that instead of pointing and clicking with the mouse to control your computer, you'll be typing with the keyboard instead. Now, Linux is unique in that the development of Linux is inseparable from the terminal, and this means that knowing how to use the terminal gives you pretty much absolute control over how your computer works. By using the terminal, you can do pretty much anything that you want with your Linux computer. Now, you can't get this level of control over your computer in any other operating system, and this makes the terminal an incredible skill to learn. Now, although it's absolutely awesome, I understand that the terminal can be a bit intimidating at first, so in this video we're going to start off nice and easy, and I'm going to show you how you can actually open and close the terminal in Ubuntu. And by the end of this video, you'll have taken a very important first step in your mastery of the Linux operating system, and you'll also be able to open and close at will the most powerful tool that Linux has to offer. So let's go ahead and get started. Alright, so here we are on our beautiful Ubuntu desktop. Now I'm going to show you how you can go ahead and open the terminal using graphical methods. Now, down the bottom left here, you'll notice a set of 9 dots, and if you hover over it, it says Show Applications. If you click on that, it'll open up in a rather awesome way a whole list of different programs that are installed on your computer. And you can just look around here. You can see, like, there's a calendar, a calculator, some office software. You can keep scrolling down, and there's loads of different things. For example, the Firefox web browser, a music player, and so on and so on. And, like, I encourage you to have a look at these and see what they do. This is how you can explore all the files that are on your computer and things like that. But if you scroll down, or you click the second button over here, you'll see a program here called Terminal. Another way to do it is you could just go at the top here in search and just type Terminal, and it will come straight up. Now, if you just go ahead and click on that, here we are. Ta-da! Your terminal window has opened up. So in here is where we're going to be typing the commands for the course. We might maximize the terminal. We might make it a bit smaller. You can move it around the screen, and so on and so on. There's loads of different options at the top. For example, you can open terminals and things. You can edit, copy and paste, change the zoom, and so many other things. Play around with it as you wish, but it's rather easy to open. If you want to close it, just like you would on any other graphical system, you just click the X at the top there. Okay, so that's how you go ahead and open and close the terminal, which is rather easy to do, and it's once you've done it once or twice, you probably won't forget it. But there's also some keyboard shortcuts that will make this process a whole lot faster. For example, if you want to open the terminal using just your keyboard, you can press Control, Alt, and the letter T, and you will find that there we are, the terminal pops up. And if you want to close it, you just press Control and D, and it goes away. So you can see how quick this might happen. You can do Control Alt T, and it opens, Control D, and it shuts. Okay, so there you are. That's how you can open and close the terminal using both graphical methods and keyboard shortcuts. You've made an excellent first step already and should start feeling a bit more like a Linux pro, because now you know how to actually open and close the terminal. It's just like any other program on your computer. It's not scary, and it's actually rather easy to use, as we'll show you in the next few videos. But here's where your training really begins. In the next video, you're going to be running your first commands in the terminal, and trust me, they're pretty awesome. So for that goodness, I'll see you in the next video. Hello there, you beautiful people. Now, the terminal is a very powerful tool that is designed to allow you to issue what are known as commands to your computer. Now, the idea is that the computer will obey these commands, we hope, and make stuff happen as a result. Now, in this video, you're going to learn how to issue your first commands, which is very exciting. But as an aside, this course is structured so that each section of the course has its own cheat sheet that you can grab at the end of the section. So don't worry about memorizing all the commands or rushing down to take notes. Just try out the commands that I show you in your own virtual machine or on your own computer, and rest assured that everything is all jotted down for you in the cheat sheets that you can get at the end of each section. So that's awesome, right? So by the end of this video, you will have ran a bunch of Linux commands, and you'll start to see a pattern emerging in how Linux commands work. So this is going to be a very important lecture. It's going to give you that foundation. It's going to help you understand what everything is all about. So let's go ahead and jump into it. Okay, so the first thing we're going to want to do is to open up our terminal. Now, as a quick challenge, let's see if you can remember how to do that. Go ahead and see if within about 5 seconds or so, you can open up the terminal. You can do it using either graphical methods, or if you're feeling particularly pro already, use the keyboard shortcut you learnt in the last video. So you've got 5 seconds, give it a go. Did you get it? Well, if so, well done, you're learning already. Now, I'm going to open up the terminal using the keyboard shortcut, which is Control, Alt, and T. And ta-da, there's the terminal popped up. Now, I'm going to do it like that for most of the time from now on, so don't be confused if you see terminal windows popping up all over the place as we go through the course. I'm just using the keyboard shortcut. But to make the text a bit easier to read on the recording, I'm just going to hit View and click Zoom in. We'll make the font just that much larger. Okay, so that should make it a bit easier for you to read when I type stuff. But now that our terminal window's open, let's run a fun command called echo. Now, the echo command just prints out what you give it as an input. So type with me the following command. We're going to type echo, okay, then press space, and we're going to type the word hello. Now, when I press enter, I'm going to say to the computer, okay, actually run this command. And when I press enter, we see hello come out of the computer. So that's pretty cool. Let's try that again, okay? We're going to say echo, then type echo with a load of O's. Okay, then I'm going to press enter, and what comes back is echo. How awesome is that? It's just like a cave. So let's try now with another command called cal. So that's echo. Let's try with another command called cal, and cal is going to show up a calendar on the screen. So if we type cal, just like that, and press enter, you can see that we get a calendar for the current months, with today's date also highlighted. And now I'm doing this in October 2017. When you're watching this and doing it yourself, it may be a very different month, but you get the point. You type cal, the default behavior is that you get the current month with the current day highlighted. But that's just the default behavior of the cal command. Okay, now what makes Linux commands interesting is how you don't have to stick with the default behavior. You can actually customize the behavior of commands to exactly what you want them to do. So for example, what if I wanted the calendar not just for the current month, but for the current year? Well, what I could do, first of all, I could type cal, then 2017, and I could press enter, and it's going to give me the entire calendar for 2017, and also it's going to highlight the current date. So that's pretty cool. With very little typing, we got a lot more result out of that, right? But you can also give each command something called an option. Now, an option is something that allows you to customize the behavior of the command. Okay, so I could type cal, and instead of typing 2017, I could just type -y. Now, this would give the cal command the y option. Now, if I press enter, we also get the calendar for 2017. So you can see here cal-y gave us the calendar for 2017, again highlighted with the current date. So you've just seen two ways that you can customize a command's behavior. You can give it input and you can give it options, and we're going to be going into a lot more detail about the difference between the two and how they work, but you may be curious at the moment as to what other ways you can customize commands, but I'm going to save that goodness until later. At the minute, I just want to give you a little bit of an overview of some different commands that you can use on Linux, so you can get comfortable with the typing and pressing enter and seeing result come back up on the screen. Okay, so let's move on and take a look at another one. For example, you can see today's date using the date command. So if we type date and press enter, we see that we get today's date and time zone and year pop up. Okay, so that's pretty cool. It's quite a useful command. But at the moment, you can see that we've got quite a lot of text in our terminal. Things are starting to get a bit messy. We can clean that up a bit as well. So to do that, we can use the clear command. If we type clear and press enter, it's like we just cleaned up our workspace, and there we are. We've removed all the text from the screen. Now, because the clear command is used so often, there's a keyboard shortcut for it. Okay, so if I just type echo and then put blah blah blah, okay, you can see we've got some text come out on the screen. The computer said blah blah blah, but we can also use a keyboard shortcut to clear the screen. And that keyboard shortcut is you press Control and the letter L. And there we are, we've cleared the screen. Now, that's the way that I'm going to be doing it, because it's a lot faster and it's a lot easier than typing out the clear command every time. But you feel free, you do you. Just understand that if the terminal is all of a sudden having all its text vanish, that's what I've done. I've just cleared the screen. Okay? Now, we've entered quite a few commands already. So what if you wanted to enter a command that you've entered previously without having to, type it out again? Maybe it was a particularly long command, we don't know. But what you can do is you can hit the up arrow key on your keyboard. So if I press the up arrow key, we see echo blah blah blah, tops back up. If I press up again, it's going to go clear. And again, we see date, again we see cal, and so on. Okay, so you can keep pressing up and cycling backwards through the commands that you've already run, which is very, very useful. But you can also look at your whole command history using what's called the history command. So if you type history and press enter, we can see all of our previous commands with the line number associated with them. For example, we can see the line number for our echo command, which is the number 1, let's say. There we are, the line number is number 1. And to run that, what you could do, instead of having to cycle all the way back up to number 1, like that, what I could do is I could type the exclamation mark and then 1. Okay, so exclamation mark on 1, and you can see that we've run echo hello. Okay, so let's have a look again. Let's have a look at our history again. We see now, let's say we want to run echo blah blah blah. The line number for that is 8, right? So if I press the exclamation mark and press 8 and then press enter, we see we get echo blah blah blah. So you can see that that's a bit of a shortcut to save you going back through potentially hundreds of commands that you've run, and you can run them a bit easier like that. Okay, If you want to run the most recent command that you've done, you can just press exclamation mark, exclamation mark. And again, we see echo blah, blah, blah has run again. Now, this history file can get quite long. So if you want to clear the history, it's kind of a two-step process. You can type history and give it the C option. Okay, then add a semicolon, then type history and give it the W option. Okay, so what that does is it clears the history and then actually writes those changes and makes them permanent. So when we do that, and I've just cleared the screen and we look at history, we can see that all we've got is just the history command that we literally entered. So that's something for reference for you. It's not particularly important, but you've got it in this video if you want to refer back to it. Okay, now finally, let's say we want to close the terminal. Okay, well, to do that, we could of course click the X button at the top right over here, but you can also type the exit command and make yourself, just look that much more pro. Okay, so if we press exit, we can see that the terminal has now closed, and also you could of course use the Control D keyboard shortcut. So if I press Control and D, we can see that the terminal is also closed as well, like I showed you in the last video. And that allows you to type commands, operate the terminal, and also close it without ever having to take your hands off the keyboard. So there you have it. You've jumped right in and have now ran a whole bunch of Linux commands inside the terminal. So well done, you've got your feet wet and we're moving. As I mentioned to you, you can get a cheat sheet which covers all of the commands that we've covered in this video and all the other commands that we're going to cover in this section of the course at the conclusion lecture of this section. But the use case of these commands that we've covered in this lecture may not be completely clear at this point, and that's okay. I wasn't trying to teach you all, like a whole bunch of commands in one video. What I wanted to get across in this video is that commands are executed by typing some weird text in the terminal and pressing the enter key. You've also seen that commands can be, they can do a whole lot of different things, and they can also be customized for different behavior. But they all seem to follow a similar kind of structure. Okay, you type some text, maybe you've got some options, maybe you've got some input, and you press enter. Now, being able to understand that structure is of incredible importance to mastering the Linux operating system and leveraging the power of the terminal. So in the next video, I'm going to show you how commands are structured in Linux. And what we're going to cover next will serve as a critical foundation for pretty much everything that we're going to learn going forward, and pretty much everything that you will ever learn when you're using Linux. If you've used Linux before but never really felt as though you got it, or you felt that some stuff was missing in your understanding, it's probably because you weren't shown what I'm about to show you next. And if you're new to Linux, this is going to be the best place to start to make sure that everything goes smoothly and you start to see the pattern of how the Linux operating system and the commands are designed, rather than just memorizing a massive list. So for that super important stuff, I'll see you in the next video. Hello there, you beautiful people. So in the last video, you got stuck right in and used the most powerful tool on the Linux operating system. But as they say, with great power comes great responsibility. So in order to maximize your control over the Linux operating system, you need to get a solid understanding of what's going on when you type your commands. So over the next few videos, we're going to be doing a bit of a deep dive on what is actually going on when you run your commands, and also go into detail on how the commands are structured so that you can understand how to use them properly. Now, if you do already have some previous Linux experience but didn't feel as though you quite got it, or that something is missing in your understanding, it's very likely that you aren't 100% clear on the stuff that we're going to be covering in the next few videos. So this is super important stuff. Now, whether you do have some previous Linux experience or are a complete beginner to it, I really want you to pay your best attention to the topics that we'll be covering in the next few videos, because they are so critically important to your understanding of the Linux operating system. And if you do understand what we cover in the next few videos, everything you do in Linux will start to make a whole lot more sense. So be very, very excited that we're going to clear this stuff up. Now, in this video, you're going to learn the difference between commands, the terminal, and something called the shell. These are very important distinctions that will underpin basically every single thing that you do on the command line. And by the end of this video, you will have understood the difference between the terminal, the commands, and the shell, and you'll have a much richer and deeper understanding of what is actually going on behind the scenes when you use the terminal. So this is going to be a critically important lecture. Let's go ahead and get into it. So what is actually going on when we type a command? Well, to understand this, we need to know the difference between a command and something called the shell. The commands are just text, but when you press enter, the meaning of that text is interpreted by a computer program called the shell. Okay, so let's take a real world example. If we see the word here on the left, raspberries, On a physical level, that word is just the letters RASPBERRIES. And just like any other word, if you can't read the language, it won't mean much to you, right? But if you took this word and you could, for example, read English, then what would happen is you would see that text and you would interpret it for meaning. And what might come out is this fruit, okay? You'd see that text and you would match it with this fruit, the raspberries. But there's a process in the middle of interpreting that text into specific meaning, and that is the job of the shell, okay? So to make this a bit clearer, let's say you took the word gift, okay, and you read that word using the English language, and the meaning that might come out might be the idea of giving someone a present or something on their birthday, okay? So you might get this meaning coming out from reading the word gift. But instead of reading it in English with an English shell, so we call it, let's say you took exactly the same word, gift, but this time you read it with a German shell. Now, instead of a present coming out, the meaning that might come out of that if you read it in German would be that of poison, which is ironically not the best gift. But you can see here that the text is exactly the same, but the meaning that comes out is different depending upon the shell that interpreted it, okay? As another example, let's say we took the word smoking. Smoking, if you read that again with an English shell, the meaning that would come out would be the idea of using a cigarette. But if you took exactly the same word and in this time passed it through a French shell, okay, using the analogy here of human interpretation, what would come out would be a tuxedo, which is a fancy type of clothing. So you can see here the text can be exactly the same, but the shell that interprets that text can give it different meaning, and that is exactly the same on your computer. So what about the terminal then? We now understand the difference between a command and a shell. So what's the terminal for? Well, the terminal is nothing more than just a window into the shell. So let's make this a bit easier to understand. So if I asked you, how would you type commands onto your shell without opening the terminal? Well, you couldn't, right? And that's exactly what the terminal is. The terminal is kind of like the middle piece in between using in between typing commands and submitting them to the shell. You can't really type commands anywhere unless you've opened a terminal, and that's all it is. What you're doing is you're typing commands in the terminal, and you press enter, and then they are submitted to the shell. So the terminal is kind of like the middle piece, okay? And there are actually different types of shells. So the different types of shells, just like there are different types of human languages, can actually interpret the same command in different ways. But fortunately, there is one type of shell which has which is the most common type, which is called the bash shell. So if you've ever heard the term bash shell scripting or bash scripting or something like that, it means writing programs and writing scripts that can be read by the bash shell. Now, Linux, most Linux distributions use the bash shell, and Ubuntu definitely does by default. So that's something to bear in mind, that there are different types of shells on Linux. They can interpret commands in different ways, but the most common one is the bash shell. So there we are. We've got some standardization there. So to summarize, commands are really just the text that you type in the terminal, and when you press enter, that text is interpreted by the shell. Now, the shell is a program that translates that text into actions for the computer. Now, this means that different shells can actually interpret the same text differently, which might cause some problems, but fortunately most Linux machines use the bash shell, so there is consistency across most machines. And as we said as well, the terminal is just a window to the shell. It's just the middle piece that allows you to type your commands and submit them to the shell. And as a bonus piece of information, your commands are actually also case sensitive. So if you type a command in all uppercase, if the shell isn't expecting to see that, it will probably give you an error. So you need to make sure that things are spelled in exactly the correct way. Okay, which has the benefits of allowing you to have more options, because slight differences can give different functionality, but it means you have to be really careful on how you actually type your commands if you want them to work the way you want them to. Now, what's coming up next is, because we're going to spend a lot of the time in this course typing commands and submitting them to the shell, I don't want you to go through this course and just have to memorize loads and loads and loads of different commands, just like pretty much every other course makes you do. What we're going to do is we're going to take a bit of time to understand what commands actually are and how they are structured, so that you can start to see a pattern behind everything. You can start to look at the commands as a type of language rather than just random text on a screen that you've got to memorize. Now, it's likely you'll probably not have been shown this before, so this is going to be a complete game changer in how that you actually approach learning the Linux Linux operating system and learning the terminal. So I really can't wait to show you this. It's going to be really helpful. So for all that goodness, I'll see you in the next video. Hello there, you beautiful people. So in the last video, you learned that there is something called the shell that is interpreting the commands that you type into the terminal. Now, one reason that Linux is amazing is that the commands that you type all follow a similar type of structure in the way that you type them. Now, by understanding this structure, you'll be able to transition from simply just memorizing commands and hoping for the best to actually understanding the common language that all Linux commands use, and that will give you a massive boost in your abilities. So in this video, you're going to learn what commands actually are and how they are structured. And by the end of this video, you'll have a much deeper understanding of what commands are, and the commands themselves will actually start to look like a language rather than just random gibberish on the screen. So this is going to be a very game-changing lecture that, if you understand fully what I show you here, it'll make your work with the terminal so much easier. So let's not waste any time and get right into it. Okay, so the first thing you need to know is that all commands are effectively just little computer programs that are installed somewhere on your computer. So for example, date is a program, cal is a program, echo is another program, and so on. Now the command or program name that you want to use is always the first part of the command. So we'd start our command with the word date, or with the word cal, or with the word echo, like you saw before, right? Now each command has its own unique behavior that you can actually look up using something called the manual pages, which I'll show you how to do later in this section of the course. But the general command structure goes like this. First, you type out the command name, so that would be like date, cal, echo, whatever it would be. Then you give the command some options to customize its behavior. Then you give the command some inputs to actually operate on. Now, the first thing you type is the command name. Now that lets the shell know what program you actually want to run. And once the shell knows what program you want to run, or it knows the name of the program you want to run, the shell will then search for that program on something called your shell's path, which is just a list of folders that contain these programs. Now you can actually see your shell's path by typing echo, then a $, then path. Okay, so echo, space, then $, then path, and you press enter. And you see this terrifying output come out, but it's actually very easy to understand once you notice that these are just different folder paths, each separated by a colon, by these two dots here. So for example, there's a folder here that's called /user/local/sbin. Then you've got another folder here, /user/local/bin, then another folder here, and another folder here, and another folder here, and so on and so on, okay? So what the shell will do is it'll start at the very left of the path, and it will look inside that folder for a command called echo, or called cal, or called date, or whatever you called it, okay? So it will look in the leftmost folder, and it will, if it doesn't find it there, it'll move to the next one. So it would start at the very left, then it would move to maybe to this folder. Okay, then if it didn't find it there, it would move to this folder, and if it didn't find it there, it would move to this folder, and so on and so on and so on, until it got right to the end, so to /snap/bin, okay? And if it didn't find a folder with that name in any of those folders, okay, then the shell would give you a command, an error like command not found. So if I tried to do blah 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 and tried to call that as a command, it says it couldn't find this command. So what the shell did is it looked for a command called this in each of these folders, didn't find it, and said command not found. Now this has an interesting impact. The fact that it reads from the very left all the way to the very right. Let's say you had a program called blah, okay, and blah was actually in this folder here, /user/sbin, but it was also in the very far left folder. Which one do you think will actually be run? Well, actually what would happen is it would only run the version in here, because that's where it found it first. And if you wanted it to run the version that was in this folder, that wouldn't be possible because it found the same name here first. Okay, so that's just something to bear in mind. It's not something you'll really run into, but it's just something to bear in mind. Okay, now you can actually see which folder that a command is stored in by using the which command. So it's like, which folder is this command in? So I could say which and then cal. Okay, and if I press enter, it'll tell me that the cal command is actually in the /user/bin folder. And if we look at our path, we can see that /user/bin is located here. So it is on our path, and therefore cal was able to be found. And let's try that again for echo. If we do which echo, you can say /bin/echo. And if we look on here, we'll find somewhere /bin is somewhere, here we are, /bin. There we go. So /bin is also on our path. You can actually also look at the which command. So the which of which. which folder is the which command in? And we see it's in /user/bin, which is here. There we go, /user/bin. Okay, and we see the which command also runs as well. So that's how the shell knows where to find your commands. Now you can customize the way that commands work by giving them different options and different inputs. Let's go ahead and start with the inputs. So it's important to note that not all commands actually require inputs. Some inputs are optional. For example, the date command doesn't strictly require an input. You can just type date and be done with it. Okay, but most commands do require some form of input, which can actually have a fancy name called an operand. Okay, because commands operate on the input is sometimes called an operand. Okay, so to give the command an input or an operand, you simply type a space after the command name, then type the input. Okay, that's assuming you don't have any options. So for example, if we take the cal command, I could just type cal, okay, and press enter, and I would get this month's calendar. But to customize the behavior, I can give it an input. So for example, if I want to get the calendar for the year 2017, I could type cal 2017, okay, and if I press enter, now I get a completely different input, output, because I gave the command this input. Okay, you can also give more than one input. So let me clear the screen using Control and L, the nice shortcut. Sometimes you can give more than one input. So for example, I could type cal 12 2017, and if I press enter, you can see now that I get I've given the cal command two inputs, one being 12, which means the 12th month, and the next one being the year, which is 2017. So I've said here, can you give me the calendar for December 2017? Pretty cool, right? So we gave it two inputs, and that also customized our output. So basically, you can just give commands inputs. So like if I say echo and I say hello, then hello, was the input to the echo command. You see? So that's quite straightforward. All we did was type the command name, which the shell then found on the path, and we gave that command, that program, some input. Okay, so now that we understand inputs, let's discuss options, because this is where stuff gets really interesting. Okay, you've seen us use an option with the cal command as well. So the cal command, we gave it the Y option before. Okay, so if I do by default, the cal-y will show the current year's calendar. Okay, so we gave the cal command an option, the Y option, which you can see that has been preceded by this dash, and that's common for commands. They tend to be preceded by dashes and hyphens and things. So let's take a look at the date command to understand how options work even better. Okay, date by default will show today's date in our current time zone. So if I just say date, it says here's the date and time in the current time zone, which is apparently British summertime. Okay, so to get the date in universal time, such as UTC or Greenwich Mean Time, we can type date/U, and we can see now that the hour has gone back one. Okay, because now we're in UTC rather than British summertime, which is currently an hour forward. So we gave the date command the U option. Now, if we had other options to give the commands, we could list them right after one another. So, for example, we could do date /A-B-C-D-E-F-D, and this would give it these different options. So the A option, the B option, the C option, the D option, the E option, the F option, the G option. Okay, or more simply, you could just do -A-B-C-D-E-F-G. Okay, that's a nice shortcut. You can just stick them all together like that. Okay, now this specific example doesn't work, so if I try that, it will say invalid option, but it just illustrates the point that if you chain these options together, you can actually chain them together, and the order doesn't really matter. So I could do date D-H-G-E-F-A, and it would have exactly the same effect. Okay. All right then. So now it can sometimes be difficult to understand what these options mean. So sometimes options actually have long form names. So for example, date/U, okay, -U, sorry, which gives us the date in universal time. You could also do date --universal. Now and it gives us the same output. Now universal long names are preceded by two dashes. So you see a --universal. Whereas the short form options, which are just one letter, are usually just preceded by one dash. Okay. Now, the long form commands can make commands easier to read, but they're not available for all options. It really depends upon the command that you're using. And again, just notice the fact that I use 2 dashes for long forms and 1 dash for short form commands. Now, if you wanted to use, for example, 3 long form options, you would need to do something like this. So you'd have to do date dash dash universal. That's 1 long form option, then dash dash long form option 2, then dash dash long form option 3. You can't really chain those together like you can with the short form options. Okay, so that's not going to work. But the short form options, you can do date slash ABCDEFG. But with long form options, you kind of have to separate them. Dash dash universal, dash dash long form option 2, and dash dash long form option 3. Okay. Now, it's important to note that everything on Linux, including commands, is case sensitive. So, for example, the date command in lowercase is valid. So the date command in lowercase is valid, but the date command, like with a capital D, would not be valid. The date command with like a capital A here, that would not be valid either. So you need to make sure that you spell your stuff correctly and with the right case sensitivity, and that goes for options and inputs too. So it's not just the name of the commands. The date command, for example, has a U option, but I don't think it has a capital U option. See, it doesn't. So I put a capital U and it didn't give me the universal output because it doesn't know that it has a capital U option. It only knows that it has a lowercase u option. So make sure that you spell your commands with the right case sensitivity. Now, the only other thing to know is that sometimes options can have their own inputs. So, for example, if we go to Cal, I'm going to clear the screen. If we go to Cal, we could see the calendar for December 2017 by giving it 2 inputs, right? Cal 12 2017, not options, 2 inputs. But there is an option that will allow us to see a certain amount of months after that too. So, for example, if I did Cal, gave it the capital A option, then wrote the number 1, 12 2017, okay, this will show December 2017 with 1 month after. And the A option gives you after, but it also needs to know how many months after. So I said 1. So this 1 here is actually an input to the A option. And then you've got the inputs for the command. Okay. You can also show a month before. So for example, cal-b 1 12 2017. That will show us December 2017 with 1 month before it. And you actually also combine these together. So cal 1 month after, 1 month before of December 2017. Okay, so now you've got December 2017 with 1 month after, which is January 2018, and 1 month before, November 2017. So here you can see how you can actually provide options with their own inputs, and how options are okay to use when you give commands its own input. Okay, so you can use, there's loads of different ways to combine this stuff together. So here we have the A and B options with their own inputs, and the cal command has its own 2 inputs, 12 and 2017. So this is starting to get a bit crazy, right? Like it's starting to get a bit advanced and a bit hairy. But this should just begin to highlight just how powerful Linux commands can actually become. And then the only other thing you might need to know is that some commands allow you to put an equal sign to match up those options with their appropriate inputs more explicitly to make stuff a bit easier to read. This doesn't work for cal, but if it did, it would be something like cal after equals 1, before equals 1, 12, and 2017. Now that doesn't work for cal because its manual page doesn't let it happen. So we only get 12, 2017. That didn't quite work, but that's how it would work if it was possible for the cal command. And it might, it might just make it a bit easier to read that the options are linked up with their appropriate inputs. If there were long form options, you would do something like cal -- before equals 1 -- after equals 1 and 12 2017. So here you've got long form options also being linked with their inputs. Again, that's not possible for the cal command specifically, but you can see how features like that, joining up the inputs with the actual options, can make commands easier to read. So in this admittedly rather in-depth video, you've learned that commands are basically broken up into 3 main parts. First, you've got the command name. Then you've got some options, which are preceded by dashes and hyphens, and you've also then got some inputs for the command. Now, the command name needs to match a program that is on the shell's search path. Now, the path is just a piece of text that's stored in the shell that lists a bunch of folders that the shell will start searching from the left to the right, separating each folder with a colon, which is the two dots on top of each other. And if the shell finds an appropriate program, then that program will run, and the shell will pass to that program any inputs that you have given it in the command. Okay, so you can also customize a command's behavior using options. Now, options are usually just letters that are separated by hyphens, so a dash, like you see at the very top of the summary slide here. You give each option a dash before it, or you can chain the little letters together in one go. The order does not matter. And sometimes they have long form versions which need two dashes but allow you to use easier to read words. So instead of having -u for the universal option, you can use -- universal. Okay, but that really depends on whether the command allows that to be possible, and each command is slightly different. And one thing that became very clear in this video is that each command behaves very differently to other commands. So for example, some commands can take multiple inputs and others take none. Some can take long form options and others can't. Some can have an equals sign to match option inputs with their appropriate option and others can't. So now that you understand the overarching command name, then options, then input structure that commands follow, and the different ways of implementing that and the different options that you've got, how can you know what is possible for a specific command and how you use each specific command? Well, each command actually comes with their own manual page, or man page for short, that shows you how to use them. And in the next video, I'm going to be showing you how to access and read the man pages. So just imagine having all the deets on a big catalogue of computer programs just sat there waiting to be explored. Using the man pages is going to be a complete game changer for you if you want to become independent in the way that you use the Linux operating system. And I really can't wait to show it to you. So for that goodness, I'll see you in the next video. Hello there, you beautiful people. Now, in the last video, you learned the difference between the terminal and the shell, and you've also seen how commands are structured on quite a general level. We mentioned that commands follow a general structure, like command name, then some options, and then some inputs. But like we saw, each of the Linux commands is implemented slightly differently, and they behave slightly differently. So other than memorizing a bajillion different implementations of things, how can we actually know how to use each of the Linux commands properly? Well, the answer is to use the manual pages, known as man pages for short. Now, Linux comes with an incredible set of manual pages that will detail the workings of pretty much everything on the system, including commands. So in this video, we're going to be covering how the manual is structured. Now, because the manual is massive, having an understanding of the structure behind it is going to make it so much easier to navigate, because then you'll know not only what is available in the manual, but also where to look for it. So by the end of the video, you'll have an understanding of the manual structure and which sections are probably going to be most important to you, and you'll also have a cool cheat sheet to take away with you that pretty much has all the notes and all the top information from this video. So that's quite exciting. So let's go ahead and jump right into it. Alright, so the first thing you need to know when you're looking at the manual structure is that the manual is broken up into 8 sections, and each of these sections deals with a specific type of thing that is on your Linux operating system. Now, the manual is absolutely huge, and it would be impossible to deal with if it was all just in one big lump. By breaking it up into several sections, that makes it a lot easier for you and I to manage and understand where we're looking, so we can actually find what we're looking for. Okay, so let's go through each of these 8 sections and have a bit more of an understanding of what they do. Okay, so let's start with section number 1. So section number 1 is for user commands. Now, these are commands that can just be run from the shell by any regular user. You don't need any particular administration privileges or any root privileges to be able to run these commands. Anyone can use them. So things like the date command, the cow command, and so on. These are the kind of commands that would come under user commands, and pretty much any command that you'll use day to day will be in there. Okay. Section 2 is for system calls. Now, this is a more advanced section. So this contains programming functions that can be used within an application that you write to make calls to the Linux kernel, which is a very low-level part of the operating system that we'll be discussing actually later on in the course. But unless you're doing some rather advanced stuff that actually plays with the operating system and the hardware on your computer, you probably won't use section 2, but it's there and that's what it's for. Same kind of goes for section 3, which is about C library functions. Now, these are libraries for the C programming language, and these are functions and libraries that provide interfaces to specific things on your computer, such as graphical user interfaces or other libraries that you might want to use. So if you're writing some C code that you want to have access to your computer with, then that's the kind of stuff that you'll be looking at in there in section 3. But if you're just a regular user like me, you probably won't need to do so. Section 4 is devices and special files. Oh, it's got the word special in it. But this is about how the different devices on your computer are managed. So things such as CD drives, or things such as random number generators, or things such as USB ports and stuff like that. This is how they're managed and how you can access those using command lines and things like that. So anything to do with a device isn't going to be in section 4. Section 5 is an interesting one. Section 5 is about file formats and conventions. So if you've ever opened up a file on your computer and just been like, oh my goodness, what is that? That looks like an absolute mess. I have no idea what is going on. How can I possibly use this? That's what Section 5 is for. Section 5 is about all the different formats and the conventions of specific files and on your computer. So, formats for Word documents, or formats for PDF documents, or formats for specific configuration files. So if you want to start configuring things on your computer, start customizing stuff, Section 5 is what you're going to use often, because it will show you how each of the special files works and how they're structured, and once you know how they're structured, you can change them, right? So that's section 5. Section 6 is about games. So any games that are installed on your computer, they have their own section and different commands and stuff that are applicable to those. Section 7 is more miscellaneous stuff, more uncategorized stuff. So it's usually stuff like protocols or file systems and information about those. If you know what they mean, then maybe you'll want to check it out. If you don't, then don't worry about it. You'll probably never come across it. And section 8 is all the stuff to do with system administration. So this is like the reverse of section 1. Section 8 is all the commands that actually require root privileges and administration privileges to be ran on your computers. This is things like changing passwords. This is things like really editing important stuff on your computer, setting up automation and things like that. Whereas the section 1, the user commands, is stuff that anyone can run. Section 8 requires privileges in order to actually run those functions and run those commands. Okay, so those are the 8 sections, and as I say, this information with more explanation is actually in the cheat sheet that you can get in the resources section, so make sure to check that out after this video. But the main sections that you're actually going to be using are section 1, which is the user commands. We'll be using that all the time in this course, and you'll be using it all the time pretty much whenever you use Linux day to day. Section 5 is usually what you'll use if you want to start editing stuff and configuring things. You'll get information on how to edit the stuff and what to edit in specific configuration files using section 5. And section 8, when you want to set up things like automation or make some rather advanced changes to your computer, then you'll use section 8, which is all the system administration stuff. So that's when you want to do stuff that normal users shouldn't be able to do all the time. Okay, it's like changing other people's passwords and stuff like that, creating users for the system and things like that. Okay, so section 1, section 5, and section 8 are what you will likely use most often. So there we are. That's a structure for the manual. Let's take a quick summary of what we've seen here. We've seen the Linux manual is broken up into 8 sections, and more information about each of the sections is actually in the cheat sheet that you can find in the resources. But now that we've got an understanding of each of the sections and we see how the manual is structured, let's start actually using it. Okay, so in the next video, what we're going to do is we're going to take this information about the manual structures, and we're going to see how you can actually search the manual and read the manual pages to learn how to use new commands. So for all that goodness, I'll see you in the next video. Hello there, you beautiful people. Now, in the last video, you learned about the structure of the Linux manual, and you saw the way that it was broken up into 8 sections. And those 8 sections each deal with a different part of the Linux experience. Now, we're going to take that theory from the last video, and we're going to turn it into practice in this video. So in this video, you're going to learn how to search the manual and discover new commands. You're going to learn how to access the manual pages for those commands, and you're also going to learn how to read them so that you can go out there and independently learn how to use new stuff. So by the end of this video, you'll have the independence to search for new commands and learn about how they work, and this is going to put you in the driver's seat because it makes it possible for you to gain more control over your Linux system, because you can start learning independently about how everything works rather than waiting for random chances that you randomly bump into learning new commands. So you can take a lot more of an active role in your learning and your development of the Linux operating system. So let's go ahead and get right into it. Okay, so now that you know that the manual is broken up into 8 sections, how would you know what section to look in to find what you're looking for? Well, let's say that you wanted to look up information about the which command. First, to search the manual, you would have to use the man command. Now, the man command is short for the word manual, and it's the command that deals with everything to do with the manual, basically. And this is why they're actually called man pages, because it's the man command that looks through the manual, okay? Now, that's the command name, so we're good at that. Now we need to give it any options if necessary. And we're actually going to use the K option, which is what deals with searching, okay? So we've got command name, then options. Now it needs an input. And the input that we're going to give it is the search term. So we type which, okay? So we've got our command name, we've got our options, we've got our inputs, the same general structure that I was telling you about before. But now what we're doing actually is we're using the man command to search the manual for this search term here called which, okay? And it's going to look all the way through the manual and find anything that might be relevant to that search term. It's like your own mini search engine, okay, for your manual. So if I press enter, we get quite a few lines of output here, okay? So let's have a look at what this is. On the left here, you're going to get the names of certain manual pages. Okay, so every single one of these is a manual page that is appropriate to this search term. Okay, and on the right, you get a bit of a synopsis about that actual page, so you can pick which one might be most appropriate. Okay, and the other thing is in the parentheses here, you get the section number of the manual that page is in. So for example, this command, this manual page is in the first section of the manual, which means it's a user command. Whereas this one is in the 8th section of the manual, which means that it is a more system administrative kind of thing. And this one is in section 5, which is going to be about file configuration, how the files are structured and things like that, information about how files are structured. So there we go. We can actually see at a glance whether it actually suits our needs or not. And if we decide that we want to take a further look, it seems like this one is exactly what we're looking for. It's in the user command section, and it's a command that locates a command. We can actually take a deeper look at that by using the man command again. Then the section number. So the section number is 1. And then we type the search term, the page name, which is on the left there, which is which. Okay, and if I press enter, ta-da, we've opened up the manual page for the which command. Now, it's only very small, and once we've opened that, to close it and get back out, we just press the Q key on the keyboard. So I press the letter Q, and I'm back out on my command line. So, for example, we could open up this sol section here, this sol thing, by doing man 6, because it's section 6, sol. And I press enter, and it opens up that manual page for sol, which you can see at the top right there. Okay, now because the first section of the manual is used so often, you don't usually have to type the number 1 even. So instead of typing man 1 which, as a nice shortcut, I can just type the word man. I can just type man which will open up the same page, the same manual page, and you can see that it is indeed in section 1. Okay, so that's a shortcut. If you see that something is in section 1, you don't need to type the 1, you just type the actual name of the page. So like up here, we've got LCF, right? LCF is in section 1. I type man LCF, and we see that we are now in the LCF man page in section 1, which means that it's a user command. Okay, so that's how you would open up a manual page. And up next, now we're going to take a look at how you would actually read it. Okay, so let's take a look at the man page for the which command. So I'm just going to type man and then which. And because it's actually a command that I've used very recently, I could have just pressed the up arrow key a couple of times and I get back to the same result. Okay, so I press man which, press enter, and we've opened up the manual page. Now we can see that this manual page is actually broken up into the following sections. At the top, we've got name, then we've got synopsis, then we've got description, then we've got options, then we've got exit status. Okay, now other sections that a man page may include are examples, a see also section, an environment section, things about bugs, things about authors, things about reporting bugs, history of the command, copyright things, stuff like that. Okay, but this is what we get in this specific manual page. Okay, so they're not always structured the same way, but they usually follow this kind of structure. Okay, now in the name section, we see that we are dealing with the which command, and we see a little bit about what it does. And this bit is actually what came up when we searched the manual in the first place. Okay, this is exactly what came up. We saw the name, and then we had this little piece of information on the right hand side. Okay, Now in the description section, this is where you really see what the command does. And the description section is a very important section, and it gives you a much more in-depth description of what the command actually does. This is likely going to be one of the most useful parts of the man page for any command, and as it will try to explain what the command does in plain English. Okay, so you've got the which command description there, and up here you've got in the synopsis section, we can see a layout of how to actually use the command. Aha! So do you remember when I was telling you that each command is structured differently and you need to read the manual pages to see how to use a command? Well, this is the section of the manual page that will tell you how to use the command, the synopsis section. So for the which command, we can see that first we type which, okay, the command name, and then we see the A option in some square brackets, which we'll come on to in a minute, and then some kind of file name, and then 3 dots, or also known as an ellipsis, afterwards. So let me explain what this stuff means. Okay, so first we enter the which command name. We just type which. Then we have the A option, which is optional. Now we know it's optional because it's inside these square brackets. In a man page, if something is inside square brackets, that means it's optional. Okay, you don't have to enter it, but you can. Okay, now next after that, once we've entered our optional option, next you have to enter the name of a command that you're actually looking for. Now you can see, so you enter a name of a command you're looking for. So for example, which maybe -a and then echo. Okay, that would show you where the echo command was. But you also see this ellipsis, or these 3 dots. Now these 3 dots mean that you can enter more than one file name. So in other words, the which command can take more than one input. Aha, things are starting to fall into place now. Right? So how do you know how many inputs a command takes? Well, you look at the man page, you look at the synopsis, and it'll tell you how many inputs it takes. Okay. Now just to prove it, okay, just to prove this, we're going to take what we've learned here and we're going to apply it. Okay, so I'm going to go back, I'm going to clear the screen, pressing by holding Control and L, and we're going to try and use the which command to find the date command and the cal command at the same time. Okay, so we've used the which command. We didn't give it the A option, but we didn't have to because it's just optional, like because it was in the square brackets, and we've given it one file name and then another file name. Okay, so if we press enter, ta-da, we see that we get 2 outputs and that it's found the locations of the date command and then the cal command. We didn't need to run the command twice because if we look at the man page, it tells us we can actually give it more than one file name. Okay, so that's really, really useful, and maybe something we wouldn't have known how to do if we had not looked at the man page. And as I said, the things inside square brackets in the man page, let me open up again. Things inside the square brackets are optional. This kind of stuff you don't have to have, but you can have. And if you want to know what it does, you just go to the options section. So if I put in the A option, it says it'll print all matching path names of each argument. So all matching path names. So A is short for all. So what I could do is I could type which, I could do which, date, and cal, but I could type -a and see if that does any difference. It doesn't make any difference, but it will show us all of the different results. So maybe, you know, when I told you about searching on the path, maybe this would allow us to look in folders that were later on in the path if they had the same name as where they were earlier on. Okay, so there we go. Now there's other symbols in the manual pages, such as angle brackets. So these kind of things, right? So if you have something inside here, inside a manual page, so if we had like which, and then it was like this, and then you had something, okay, inside angle brackets, anything inside the angle brackets is mandatory. That means you have to have it, okay? So if you see something inside angle brackets, that means you have to have it and you can't miss it out. All right, so just bear that in mind. There's also the pipe character. So if you had an option here and it was something like, say you had the F option, okay, because there's a pipe character between the 2 options, that means, okay, that you have to pick one or the other. Okay, so the pipe means one or the other. You cannot have both. So I couldn't type which -af date, okay? I would have to type which -a or which -f, okay? I couldn't have both. That's what happens if you see something inside angle brackets, okay? So I'm just going to type my thing out again. Sorry, not angle brackets, with a pipe in between them, okay? See what we're doing so far. Okay, that's probably what you'll come up with most of the time. So these are all the different things that you'll see. You'll have the command name, you have some options. It'll tell you which ones are optional and which ones you need and which ones cannot be combined with others. You'll see things that maybe are mandatory inside square brackets. Anything with a ... after it means you can have more than one thing. So if it's had like this, it was file name, wasn't it? And then ... that means you can have more than one file name when you use this command. Now I'm actually going to put a PDF in the resource section for this lecture that lists out what the different symbols mean, so that you can use it if you ever need a quick refresher. But that's pretty much all you need to remember. Okay, just anything in square brackets is optional. Anything with a pipe in between it, you can only have one or the other. Anything in angle brackets is mandatory. Anything with ... after it, you can use more than once. Okay, that's pretty much all you need to know. And if you want to know how to look up what different options do, just scroll down to the options section in the man page and it'll tell you exactly how to use them all. Okay, awesome. So we've covered a whole lot of stuff in this video, and you should start feeling a lot more comfortable using the command line already. In this video, you saw how to search the manual using the man command with the K option, and after that you can give it any search term that you want. And the man command will search the manual for that search term and give you a list of results, as well as what those results are and what section of the manual page they're in. You saw how to access those specific manual pages and also how to read them for specific command structure. So we saw how to actually use the which command using its manual page, and we saw the different symbols that might come up in the manual page to tell you how to use it. But I've attached a cheat sheet in the resources section for this video that I massively encourage you to use and keep on hand, because it's going to give you an explanation of each of the different symbols that might show up in a manual page, so that you can keep that to hand and, you know, make sure that you don't forget anything. But to ensure that you don't forget anything, up next we're going to have some practice. What we're going to do is we're going to go together and we're going to search for a new command, and we're going to read about how it works. We're going to look at its manual page, and we're going to take that learning and actually apply it and show you how you would take a man page that you've never seen before and learn how to use it. So we're going to be applying what we've learned in this lecture about reading manual pages and apply it to a completely new command and go through it together. And after that, you should definitely feel as though, hey, any command or any manual page that I come up against, I'll know how to read and know how to use, which is going to give you a massive boost of confidence and a massive boost of independence for you to explore and learn more about the Linux operating system. So let's go ahead and jump into the next video and get some super, super cool practice. Hello there, you beautiful people. Now, in the last video, you learned how to search the Linux manual for specific keywords, open up manual pages, and how to read them to learn how to use specific commands. But there was quite a lot of stuff in that video and a lot to take in. So in this video, what we want to do is we want to give you some practice. So in this video, we're going to take a look at a completely new command that we haven't seen before, and we're going to learn how to use it. We're going to search the manual for it. We're going to learn how to use it using the synopsis in the manual page. We're going to read through its various options, and we're going to try some of them out and see how you can customize commands and stuff like that. And the idea is that this is going to show you how to independently search for stuff using the manual. We're going to put the whole process together. We're going to take everything we've learned, put it all together, and show you how you would learn about a new command from scratch. And the idea is you're going to have the independence to search for new stuff and learn how it works, and that's really where the value comes from the manual. It's not having people randomly show you things that they find cool. It's being able to go out there and find stuff that you find cool and learn how to use it independently, and it's going to take your Linux abilities to a whole new level. So let's go ahead and jump into it and start learning about our brand new command. Okay, so what we're going to do is we're going to look at a command that will allow us to list out what is in a folder, also known as a directory. Okay, so we want a command that will list out a directory's contents. Okay, so now that we know that, let's go ahead and search for what might be available. So the first step is to search for what might be available in the manual. And you might have to try this multiple times, okay? You might not get the search terms available right away. You might have to try different words and different keywords, but let's try that. So let's type the man command, give it the K option, and now we tell what we want to search for. Now I'm going to put in quotes, list directory contents. Okay, and the reason I put it in quotes is because I want to search for this search term in one go. I don't want to search for the word list, then the word directory, then the word contents. I want to search for list directory contents in one go. Okay, so once I do that, I press enter, and here we go, we get some results. Okay, now they all seem to pretty much do what we want, right? They all seem to say list directory contents. But the one that I'm specifically looking for, I've heard about it online, is the ls command. Okay, now the ls command is one that we will come on to as well in a later section of the course. But we can see that it's a user command because it's in the first section of the manual. So we could open it using man1ls, but because it's in the first section, we don't have to even have the one. We can just type man ls. And here we go, we're in the manual page for the ls command. So there we are. Now, right at the top, we can see that we're in the ls command. It's in the first section of the manual, which is apparently user commands. And we can see that the name of the command is ls, and it lists directory contents, and that's from the name section. Now, looking at the synopsis section, we can see that if you type ls, then you can have multiple optional options. We know they're optional because they're surrounded by square brackets, and you can have multiple of them because they've got the ellipsis after it. And then you can have multiple optional file names or paths to directories, and can have multiple of those because we can see the ... But the one thing that you might notice is because everything else is optional, right? The only thing you actually need to enter is the ls command itself, and it will work. So let's try that. Okay, let's try and see that. We don't even have to give the command any input. So if we press lowercase q to quit, we're back in our terminal. Now, as I said, the only thing we need to do is enter the ls command itself. So if I just type ls and press enter, we see that it has indeed listed out all the contents of our home directory, which is the directory that we're currently in. So how cool. Okay, now go back in the man page. Let's go back in the man page, and we can see in here that there's a whole bunch of options that we can use. We can look down in the description section. It says here that list information about the files, which is the current working directory by default, sorts entries alphabetically if none of these options or the sort option is specified, and mandatory arguments to long options are mandatory for short options as well. Okay, so that's fair enough. Now, we've got loads of different options in here, okay? Loads of them. Let me just scroll through. Loads of them, guys. Okay? So, memorizing all these, it's just not possible, okay? Just don't even try, okay? You're not going to be able to do all that, and even if you did, there are thousands and thousands of Linux commands, so it's kind of a waste of time to do it all. This is why you need to know how to use a manual page effectively, okay? There's a whole bunch of options. One that I might like to show you, which is a good one, is the L option. Okay, now of course you can browse through these and have a look at what they do, but you've got the L option here, which stands for long listing format. Okay, so let's try that. Sounds pretty cool. Let's see what that means. So if I type ls and give it the L option, right, I press enter, we now see that everything is kind of listed in a much more detailed fashion. This was the output before, and this is the output now. Okay, so we've got much more detailed view of what's in our folder. Now I'll explain what this means a bit later in the course, but for now I hope you can see that the process that you might follow for discovering a new command. Okay, we've searched for it, we opened its manual pages, we browsed a few of the options, and we tried them out, as well as seeing how to actually use the command in the first place. Now let's have another look in. We can see that this is a bit difficult to read, perhaps. If we look at the ls command again and we scroll down, we can see that there's another option here called the H option, which stands for human readable. Okay, so you can see here we've got a short form option -H or a long form option --human readable, and this is how you can tell whether an option has a long form or not, because it will be right next to it in the manual page. Okay, do you remember when I said some options have long forms and some don't? This is how you can tell. And it says that with the L option and or the S option, this will print human readable sizes of files. So for example, 1 kilobyte, 234 megabytes, 2 gigabytes, etc. Okay, so let's take a look at that. Here, this column here is actually all the file sizes, and it just says 4096 or 8980 or whatever it might be. Okay, but to make that human readable, you can type ls-l and then give it the H option as well. And we'll see that now it's telling us it's 4 kilobytes, 8.8 kilobytes, and so on and so on. Okay, but as well, because we have a long form option, we don't have to just type H. We might type H, but we could also type --human readable. I think it was like that. Nope, let me check. If I type ls, it's --human readable. I apologize. Human readable. Okay, and there we go. Now we've got exactly the same output that we had before. You see, so you can see here the way we've used a long form option, which means now it's a bit easier to read what H, what that means than it is to just see what H means. Okay, but it kind of makes the command a bit more difficult to type. So there's a bit of a trade-off there, but you get the same output, okay? So you can see just how useful reading the man pages actually is. Now, if we just go back into the ls command, okay, let me clear the screen, go back into the ls command and scroll all the way down, you will see a section, if we keep scrolling down, it's a long manual page, much longer than the which command, right? You'll see a section that is called see also, okay? So this section here that says see also, it's got a hyperlink. And you can click on this hyperlink, or any hyperlink that's in a manual page, by holding the control key and left clicking, okay? Now, if we control and left click, what that's going to do, if I clicked it right, we have to wait, I think. There we go, it's opening up. So I've clicked it multiple times, but it's opened up in the Firefox browser the link that was in there, okay? So it's going to give you more information about the command as long as you have internet access, okay? So that sometimes in manual pages there are links that you can click on. So there's another one here, for example, another one here. You can, if you hold the control key and click them, then they will open up in your browser and you'll be able to see what they're pointing at. So that's very, very useful, and that's something you'll definitely want to do if you want more information. And as a final note, although you can find pretty much information on pretty much all the commands that you'll ever need using the man pages, you can't quite get all of them. So some commands are defined directly in the shell and don't have man pages for them. So to find those commands, you will need to use the help command instead of the man command. Let me just show you what I mean, okay? So for example, one of them is the cd command. Now, the cd command is one you will use all the time, actually. It's used to change a directory. You'll see this in the next section of the course, all about navigating the file system. But if I type man cd, it'll say there's no manual entry for the cd command. But if I type the help command and then do cd, we then get something that's very similar to a man page, and we can see how to use it. Up here, we get a description, we get the options, and so on. It's okay, so it works pretty much just the same as a manual page. It's just you have to use help instead. Now, to find the commands that need the help command to be used, if you just type help and press enter, you get a big list, and every single one of these in here is needs the help command to see it. So, for example, here's cd. Okay, for example, if we do pwd over here, if we do man pwd, there actually is a man page for it, but if for one of those commands it didn't come up with a man page, you would just type help pwd and it will give you basically the same, like a very similar kind of output. Okay, so if man doesn't work and you know the command is correct, use the help command instead. And there's a lot of other things in here, like for example doing while loops in the shell, for loops, and other things like that. Okay, so it's quite an advanced thing, more about the shell rather than about the programs that are installed on your computer. Okay, so that's just something to bear in mind. Now, another thing that has actually come to my mind, when we're in the ls command here, notice this works for pretty much all commands. Notice when we've got a long form, so for example almost all, or block size, or ignore backups. When you have a long form command like this, they tend to break up the words with a dash. Okay, so ignore dash backups, block dash size, almost dash all, or down here, full dash time, group dash directories, no dash group, human dash readable. Okay, so when you're making a long form option, if I wanted the human readable one, instead of going human readable like the mistake I made before, because human is one word and readable is another word, it's going to be human dash readable, and that gives us the output. Okay, so that's just something to bear in mind with regards to spelling and things like that. But the main thing to remember when you're reading these manual pages is each Linux command is designed to do one thing and do it extremely well. That's why you've got the ls command with so many different options. Anything that you can possibly imagine to do with listing things out of directories, the ls command is going to be able to do it. Okay, so that's why the manual pages have a lot of information. To really get the information out of that, unfortunately, if you want to become a master of the ls command, or even just start using any new command, there's going to be no shortcut to reading. unfortunately. I wish there was. You can skim read, and sometimes they give you quick intros and quick starts to commands and things like that in the manual pages. But for all these options, if you want to learn it, you're going to have to read it. Okay, so there's no other way around that. So that's how you will go through and you'll learn about a new command. So let's do it really quick in quick succession. We wanted to learn about a command that shows you how to list directory contents. So we used man with the K option, list directory contents. It came up with some possible page names, the sections they were in, and the explanations. The ls command caught our eye. We noticed it was in the first section, so we just typed man ls. It gave us the manual page. We saw that, yes, it lists directory contents. We see a quick description, and we saw how to use it. You have to type the ls command. The options are optional. You can have multiple of those, and the files are optional, and you can have multiple of those. So we saw that actually you can just type the ls command, and you get some output. But there were plenty of other options. There's loads of things in here. One thing that we liked was the idea that you could have a long form option. Okay, so the long form option, we found it, where is it? It's down here. We found it under L, use a long listing format. So we had a look at that. We do ls-l, and we got that. We also saw that you can have long form options as well. Okay, one other thing is that you can see here there's a lowercase a, which gives you one option, and an uppercase a, which gives you another option. And here you are, you've got a lowercase b gives you one option, and an uppercase b gives you another option. That's very common. So you need to make sure that when you are spelling things in Linux, you get the case correct. So for example, ls-l will give us that, but if I do ls-capital L, it didn't even do anything. Okay, but so you need to make sure that you get that stuff right. And just for curiosity, what does the capital L? See if there is a capital L option. Yeah, dereference. When showing file information for a symbolic link, show information for the file in the link. Show information for the file the link references rather than for the link itself. So there you go. Okay, so you need to make sure that you get your cases correct. Things have to be spelled precisely. You need to have a very sharp eye and not make mistakes and make sure you're doing stuff right. Because the power of these commands are so powerful. They can do so many different things, but you just need to make sure that you enter them correctly. Okay, so there we go. That's a quick summary of this video. What we're going to do in the next video is we're going to actually be moving on from the manual, and what we're going to be showing you is how commands take input and actually give output. Because one of the most powerful things that Linux commands let you do is to chain different commands together to make up super powerful command pipelines. Now, because each command is amazing at what it does, when you can chain them together, each of these separate commands that is amazing at what it does, but chain them together, you can create some incredibly powerful functionality with very little effort. Okay, so I'm going to show you how to do that, but first we need to take a little bit of a look into how commands take input and give output, so you can actually start building together these command pipelines. You need to understand how they take input and give output. So for all that good stuff, I'm going to see you in the next video. Hello there, you beautiful people. Now, although each of the Linux commands are very powerful on their own, the true power of the Linux command line comes from our ability to chain these commands together to build what are known as command pipelines. Now, each Linux command is designed to do one thing and do it incredibly well. So, by being able to combine together loads of powerful and feature-rich building blocks, you can create very powerful workflows and pipelines without much work at all. But in order to chain the commands together and create these powerful workflows, these pipelines, we need to understand a bit better how Linux commands actually take input and give output so that we can link the outputs and inputs together. So in this video, you're going to learn about the different ways that a command can take input and give output. And by the end, you'll be able to understand the different ways that data can flow into and out of a command, and you'll be ready to connect these commands, these data flows together to build powerful Linux pipelines. This is going to be an absolutely revolutionary time for your Linux abilities, because we're going to step up from taking just one command and learning about it to actually learn how to chain multiple commands together. So I hope you're very, very excited. Let's go ahead and jump right into it. So as you learned earlier, each command is basically its own computer program. Now, a computer program is simply an automated way to take inputs, process them, and give outputs. So here's a diagram that shows you the different ways that a command can take inputs and give outputs. Now, you can see that a general Linux command can take input from 2 places and will output to 2 other places, making a total of 4 possible ways to get data into and out of a conventional Linux command. So the inputs are command arguments and standard input, and the outputs are standard output and standard error. You can see that 3 of these are indicated by the yellow dashed arrows and are examples of something called a standard data stream. You can tell this from their names because they all start with the word standard. So you've got standard input, standard output, and standard error, and they're all standard data streams. Whereas the command line arguments have a solid blue arrow and aren't a standard data stream. So in this video, I'm going to explain to you what the different input or output options are, and you'll also learn what is special about a standard data stream and how these data streams can be used to connect commands together. So let's jump over to Ubuntu and see all this stuff in real time. Okay, so for this discussion, it makes more sense to start with the outputs, so let's start there. Now, when a command has run successfully, the primary way that the data is outputted from the command is on the channel called standard output. Now, standard output is something called a standard data stream. Now, just like a stream of water, data streams start somewhere and they end somewhere. So where does standard output lead? Well, by default, standard output will lead to your terminal. So that's why when we type commands, the output of the command appears on the screen. So for example, let's take the date command. If we type date and press enter, when we tell the date command to run, the output will be sent from the date command and flow down the standard output stream, which by default is connected to our terminal screen. Therefore, we see the date appear below our command. Okay, so that's pretty cool, but I want to plant a little seed in your mind for us to come back to later. Now remember how I said that by default, the standard output of a command comes to the terminal? Well, the amazing thing about output data streams is that you can redirect where they go using a process imaginatively called redirection. So just like redirecting a pipe will change where water flows, redirecting a data stream will change where the data goes. Okay, so hopefully that seed has been planted and we'll come back to it in a moment. Now, the second type of output is something called standard error. So when a command gives an error message or a log message or something like that, anything that isn't the primary output of the command, that is outputted into the stream known as standard error. This helps keep useful output and log or error information separate. So for example, let's take the date command again. If I make the date command fail by giving it some invalid command argument like this, okay, and then I press enter, you'll see that we get an error message and it says invalid date, blah, 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 blah. Okay, now because it's an error message, it was sent down the standard error stream. And because the error message arrived at our terminal screen, we can see that the standard error is also automatically connected to our terminal, just like standard output is. But again, because standard error is a data stream, it can be redirected wherever we wish. So now that we understand that standard output is where the main output for the commands go, and that standard error is where the error and log messages for the command go, and that both of those are by default connected to the terminal, let's now turn our attention to inputs. As mentioned, there are also 2 ways for a command to get input. The first we will discuss is another type of standard data stream, which, as you can guess, is called standard input. Now, standard input is by default connected to the keyboard. So to demonstrate this, I will introduce a new command called cat. Now, we're going to discuss cat in a later section, but I'll just use it now to explain the concept of standard input. If we take a look at the man page for cat, so we type man cat, okay, we see in its description section that if cat is not given any, if it's not given any command line arguments, that's it, cat will read from standard input. So if no file is given, then it'll read from standard input, okay? So let's do that. If I just type cat and don't give it any other form of input, we can see that the terminal kind of just hangs there. But if I start typing and I type hello and press enter, we see that the text is read from our keyboard, i.e. from standard input, and then cat processes it and outputs the results to standard output. Now, because standard output is by default attached to our terminal, we see the output appear right in our terminal. Okay, that's pretty awesome. Now, because standard input is a data stream, it can be redirected as well. That means we can tell a command where it should read data from. Now, this could be a file where we already have some pre-configured input, or more powerfully, it could be another data stream. Now, it's this ability for data streams to connect together that makes them so powerful. You can simply pass the standard output stream from one command to the standard input stream of another, then pass the standard output stream of that second command to the standard input stream of the third command, and so on until you build up a very powerful pipeline. Now, connecting outputs to inputs in this way is known as piping together commands, and is an incredibly important concept in Linux, as it's what makes working with the command line so powerful and effective, as you will see in coming videos. Now, the final type of input is command line arguments. Now, we've already actually seen command line arguments in action already. For example, when studying the command structure previously, we took a look at the cal command, and we saw, by the way, I'm just going to press Control and C to cancel this, Control and C, and that cancels it, and press Control and L to clear the screen. So when we were using the cal command, we saw something like cal 12 2017, which will allow us to see the calendar for December 2017. And the numbers 12 and 2017 were command line arguments, and you can tell that because they were added on the command line as an input to the command. We also made the command more advanced, like this, if you remember. We had cal, gave it the capital A option, gave that option an input, gave the capital B option, gave that option its own input, and then gave the cal command two other inputs. Okay, so it was quite complicated, and it showed us the calendar for December 2017 with 1 month after and 1 month before. Now, the A and B options have their own command line arguments. Here, the A option has the command line argument, which is number 1, and B also has a command line argument of the number 1. And on top of those, the overall cal command has 12 and 2017 as its own command line arguments. Okay, so there's one argument for the A option, one argument for the B option, and 2 arguments for the overall cal command. Now, the difference between command line arguments and data streams is that data streams can flow. They can be redirected and piped together. Command line arguments only associate with the command or option that they're dealing with at the moment. Now, there are commands such as the xargs command that allow you to blur the lines a little bit between data streams and command line arguments, but in general, the difference is that data streams can flow and be piped together, but command line arguments are more static and still. There is one other key difference to keep in mind, though, in that not all commands accept standard input. For example, the echo command doesn't accept standard input, but pretty much every command can accept command line arguments. And if you want to know whether a command can actually accept standard input, just check its man page, and if it's not there, just assume that it can't. Awesome! So in this video, you've learned some incredibly important concepts. As a quick recap, we learned that there are 2 ways to get data into commands and 2 ways to get data out. The ways in are standard input and command line arguments, and the ways out are standard output and standard error. Now, the 3 ways that start with the word standard are examples of standard data streams. We mentioned that standard output is where the outputted data for a command goes, and that standard error is where the error and log messages for a command goes. And by default, standard output and standard error are attached to your terminal, but this can be changed. You also learned about standard input. Now, standard input by default is attached to your keyboard and is also a data stream, which means it can take data from other places too, using something called redirection. That's right, data streams can be redirected from their default locations to wherever you wish using a process called redirection. We also mentioned that you can actually connect the output streams of one command to the standard input of another using a method called piping. Now, piping and redirection are incredibly powerful abilities that Linux gives us, and being able to use them effectively will basically give you superpowers for interacting with your computer in ways that you never thought possible. And I hope that you're super excited, because piping and redirection are going to be the topic of the next few lectures. So if you want to gain superpowers, I'll see you in the next video. Hello there, you beautiful people. Now, in the last video, you learned about the different ways that commands can handle input and output, and I seeded in your mind the concepts behind the most powerful abilities that the Linux operating system can give us: piping and redirection. Now, piping and redirection allow us to create sophisticated command pipelines and move data around our computer system with such unbelievable ease and flexibility that it's basically a superpower. So in this video, you're going to begin gaining superpowers by learning how to perform redirection in Linux, and later on in the next few videos, we'll be covering piping. But by the end of this video, you'll be able to redirect standard input, standard output, and standard error to your heart's content, and you'll feel much more like a computer genius already. So let's go ahead and get right into it. Okay, so our main friend for this video is going to be the cat command that we saw a bit earlier. Now, the cat command is used to concatenate or stick together multiple different files. You'll see how it works in more detail in a later video in the course, but the reason I'm using the cat command in this video is because it's a simple command that reads from standard input and writes to standard output, so it fits our purposes of learning redirection perfectly. So let's watch cat receive data from standard input. So if I just type cat, here, the cat command waits to receive some data on standard input. Now, cat needs standard input in order to run, but because standard input is by default connected to the keyboard, cat just sits there and waits for us to enter something on the keyboard. So if I type meow, like that. Once we do, it will output the same input into standard output. And because standard output is by default connected to our terminal, it outputs the same word that we entered, which was meow, which is appropriate for the cat command, of course. It outputs that to the terminal. Now, in order to tell the cat command that standard input has finished, we need to press Control and C, and cat will stop listening, and we will have back control of our terminal, of our shell. Okay, so that's awesome. So what if I wanted to change where the standard output goes instead of having it come to the terminal? In other words, how can I redirect standard output? Well, let's say that I wanted to redirect standard output to a file called output.txt. To do that, I would use a special symbol. I would write cat, just like normal. Then I would type the number 1 and the greater than sign. And then I'd type output.txt. Okay, so let me explain to you what this means. I want you to remember that standard output is the name of the stream that output goes down. Okay, standard output isn't the destination, but it's the name of the stream or the pipe or the stream that the data goes down. Now, every data stream not only has a name like standard output, standard input, or standard error, but it also has a number associated with it. Standard input is number 0, standard output is number 1, and standard error is number 2. Okay, so what we're doing here is we're changing the destination of where stream number 1 points. In other words, we are redirecting or changing the destination of standard output because standard output is number 1. So that's why we typed the number 1 and we said put data stream number 1 in output.txt. Okay, so instead of pointing the standard output stream at the terminal, which is where it points by default, we're pointing it towards a file called output.txt in our home folder. Now, when I run that, cat is still waiting for some input to run. So if I type Linux is amazing, okay, and press enter, we notice now that actually it didn't come back out to the terminal. And when I tell cat that standard input is finished, again by pressing Control and C, first thing we notice is that the command is no longer running, and as well, we also don't see any output. But if I click here to navigate to our home folder, so I click Files, and when that window opens up, if I navigate to our home folder, we now see a file called output.txt. And inside output.txt, if I open it, we see the text, Linux is amazing. How cool is that? Now, because standard output is usually what you want to redirect, Linux makes it so that you don't actually even need to put the number 1. So if I just get rid of, if I just delete output.txt, I just press the delete key on my keyboard, you don't actually even need to put the number 1 in this symbol here. So actually, if I just do cat, then the greater than sign and output.txt, okay, and I enter Linux is amazing, okay, and output it, and then I press Control and C to stop the command, you can see that we basically get the same result. Output.txt has been created, and inside there is Linux is amazing. So that's a nice shortcut. You don't have to put the number 1 there, but it's useful to understand that for when you actually come to redirect the other data streams. Now, you might be wondering about the spacing. So let's take the long form again. The long form is cat 1 greater than and then output.txt. Okay, but I couldn't add, so I could write it like this. I could get rid of the space there, and that would be fine. But I couldn't add a space between the 1 and the greater than. Okay, so I couldn't do that, have a space in between there, because this has to be all one symbol. That wouldn't work. Okay, but this would. I could have, I could close the gap there, so this symbol is preserved. But I could have a space after it between that and output.txt. This is fine. This is fine. This is not fine. Okay, does that make sense? But yeah, just remember that the shell is interpreting what we write. The shell is looking for 1 greater than or just greater than as a symbol, and it has to find that symbol in order to understand what it wants us to do. So if we break up 1 greater than with a space, now it no longer works because the shell isn't looking for that. Okay, awesome. So let's try adding more text to the file. Let's try and add the text wow so that it says Linux is amazing and then wow. Okay, so if we do that and we type wow and then press Control C to stop. Now, when we check the output.txt file, we expect it to say Linux is amazing, wow, right? But when we open it, it just says the word wow. What happened to the text that says Linux is amazing? Well, redirection by default will remove everything in a file before writing to it. The fancy word for that is called truncation. But basically what happened is Linux emptied our file and then wrote wow to it. Well, that's kind of annoying. So how can we write to a file again using redirection without truncating it? Well, to do that, we would write the redirection like this. Okay, so you would write cat 1 greater than output.txt. So you can see we've used 2 arrows there. Okay, so instead of having 1 arrow, we have 2 right after one another. Now, when I type Linux is amazing, okay, and I press Control and C just to end that. Now we look inside output.txt. We now have Linux is amazing after wow. Okay, and again, the shortcut still applies. So instead of having cat 1 greater than, by the way, if that shortcut right there, I just press the up arrow key. Instead of having cat 1 greater than, I can just have greater than. Okay, when I do that and I say Linux is very amazing and do that and stop, then when I reload the file, we can see that now it adds Linux is very amazing. Okay, so this works just as well with just the greater than. It works just as well as having the number 1 because Linux makes it just that bit easier for us because usually you're redirecting standard output, which is data stream number 1. So that's how you redirect standard output. And this process, as I said, of using the double arrows is called appending to a file. So in the interest of time, we're going to cut our discussion short in this video and we're going to pick it up again in the next video. But in summary, what you've seen in this video is, first of all, that data streams have numbers associated with them. Data stream number 0 is standard input. Data stream number 1 is standard output, and data stream number 2 is standard error. And you can use these numbers to actually access the specific data streams that you want for redirection. Now, in this video, you've seen how to redirect standard output, which is data stream number 1, and it's probably the one that you will be using most of the time. But what you need to make sure of, and this works for all data streams, is you need to be careful of truncating your files. You saw that when you use 1 arrow, when you were redirecting standard output, the shell would delete everything that was in the file or in the place that you were redirecting to before adding the data in. But if you use 2 arrows, then you can actually append your data to the file. You can add your data on top of what is already there. So just be aware of that. So in the next video, we're going to take a look now at how you would redirect standard error and standard input. So I'll see you in the next video. Hello there, you beautiful people. So in the last video you saw how to redirect standard output, and in this video we're going to be picking that up and continuing by learning how to redirect standard error and standard input. So let's start with standard error. How do you go about redirecting that? Well, standard error works in very much the same way as standard output. Now the number for the standard error data stream is the number 2. So to redirect standard error, you would type cat, and then instead of 1 and then a greater than sign, which is what we use for standard output, you just have a 2. Because the data stream number for standard error is the number 2. And this would redirect the standard error from the cat command to error.txt. And to append the standard error to whatever is already in error.txt, you would do the 2 arrows. So remember, the difference between the 1 arrow and the 2 arrows is the 1 arrow will delete everything that's in the file before writing to it. So it will truncate the file, and 2 arrows will append or add to what's already there. Okay, so let's demonstrate this. The cat command doesn't have the K option. Okay, so if I do cat, give it the K option and just type blur, right, we're going to get an error and it's going to say invalid option K, try cat help for more information. So this is an error message. So therefore it was output on the standard error data stream, and the standard error data stream is by default connected to our terminal, and therefore we see it in our terminal. But let's redirect it to error.txt. So I'm going to press the up arrow key to save myself some typing, and I'm going to type the number 2 and then a greater than sign and say redirect that to error.txt. Okay, so I'm saying run this and redirect the standard error to error.txt. So when I press enter, first of all we notice that nothing popped out on our terminal, which is a good sign. And when we open up our files, we can now see that there's a file called error.txt, and when I open it, we can see that indeed the error message has been sent to that location. A common use for for redirecting standard error is to keep track of log messages coming from web servers and things like that. But a common mistake is to use just 1 arrow like we have here. Okay, because if I keep doing that, what that means is it will delete what's in the file before it sends standard error again. So if I keep doing that, okay, imagine a new error happens every time. Okay, if I keep doing that and open error.txt, only the most recent error has been saved. But if I, instead of having one arrow, I have two arrows, now I'm going to append each error on top of each other. Okay, which is exactly what you want with a log file, because you want to be able to scroll back and see what's happened in the past. Okay, so let's open it again. Now we can see that the errors are being added on top of each other. So that's the difference between having the one arrow and the two arrows. The two arrows appends onto what was already there. Okay, and that's really what you need for standard error. Now you can, of course, redirect standard error and standard output at the same time. So for example, we could type the cat command and redirect our output to output.txt. Remember that standard output is data stream number 1. And we could also redirect standard error to another place called error.txt. And we could make sure that we append both of them by making sure there's two arrows at both places. And then when we type something like Linux is amazing, and then we cancel, when we open up our file browser here, we will see that we now have two files, error.txt and output.txt. Output.txt contains Linux is amazing, and standard error, the error.txt doesn't contain anything because there were actually no errors from this output. It was a perfectly valid command. There were no errors required, but that is how you would go about doing it. So this is how we would be redirecting standard output to output.txt. We can tell that because the number 1 is here, and standard error to a file called error.txt. Now we can see what the number and the arrows that standard error would be appended, and so would output.txt. Now we actually, remember, you actually don't need the 1 for output.txt, so you could actually just do, get rid of that and do, let's say Linux is very amazing. And when I look at that, we're going to see output.txt has had its text appended, and again there will still be no errors in error.txt because there weren't any errors. But you can see here that without using the number 1 this will still work, but you do still need the number 2 for standard error because that shortcut isn't available. Okay, so you can only get rid of the number 1 for the standard output data stream. Okay, brilliant. So you now understand how to redirect standard output and standard error. So how about standard input? Well, actually, that's relatively straightforward. At the moment, the cat command is looking for standard input from the keyboard. But what if we told it to get standard input from a file instead? So let's make a file called input.txt and type in there the words hello world. Okay, so what we're going to do is we're going to use the cat command and we're going to output that now to a file called input.txt. Okay, so we're going to make a file and we're going to put in there hello world. Now when I cancel that, we have now effectively created a file called input.txt, and in there we have hello world. Okay, so you can see how you can use redirection to create files like this as well. Now let's try and read from that file using the cat command again. Okay, how can we make the contents of this file, this input.txt file, be read into standard input for the cat command so that we don't have to type it later on, let's say? Well, the standard input stream has the number of 0. So what we can do is we can type cat, then the number 0, and instead of the greater than sign, which is like an output, you actually use the less than sign. Okay, and we say then input.txt. Or as a shortcut, because the standard input stream is the only way that you can actually input. You don't even need the 0. You just put the less than sign right there. Now when we do this, we see the hello world message pop up on the screen. Now this is because cat has read the file from standard input and outputted it to standard output, which is by default connected to our terminal. Now here's a mini challenge, okay? I want you to get cat to read standard input from input.txt and redirect that output to hello.txt and make it so that that happens, okay? So go ahead and give that a go. Pause the video now and try to get cat to read standard input from input.txt and redirect the output to hello.txt. Then come back to see how you did. Did you manage it? Well, here's how I would go about it. I would first redirect cat's standard input so that it comes from input.txt. So we're just going to do like that. And then I would output it to a file called hello.txt. Okay, now to make it easier to read, I might add the stream numbers. So I might say, okay, I'm going to redirect into stream 0, input.txt, and I'm going to redirect from stream 1, which is standard output, to hello.txt. Okay, it's totally up to you which one you use. This might be a way you do it, it might not be. But just remember that 0 is standard input, 1 is standard output, and 2 is standard error. Okay, and here we can see that we're reading input.txt into standard input. It's quite easy to see that quite graphically, and we're writing from standard output into hello.txt. Okay, so if we go ahead and do that, now we should be able to see that in fact, yes, we now have a file called hello.txt, and when we open it, we see hello world. Isn't that amazing? So that's how you can redirect data all around your computer. Now, here's one more mind-blowing thing. Everything in Linux is actually treated the same as a file, even terminals. So let me open up another terminal. I'm going to use the shortcut Control Alt and T, and I'm going to open them right next to one another. So I'm going to put one over here, and I'm going to put one over here. Okay. Now, in the other terminal, this one over, this new one on the right, I'm going to run the tty command. Now, the tty command will actually tell us where this terminal is located, where on the file system it is. And we see it comes back with /dev/pts/1. Okay. Now, what I'm going to do is I'm going to redirect the content from input.txt, so just like this, and instead of writing it to a file, I'm going to write it to this location, /dev/pts/1. So /dev/pts/1. Okay, and when I press enter, oh my goodness, we can see that the data has been passed from one terminal to another. It's kind of like a really rubbish instant messaging system, right? Now, while this isn't particularly useful in itself, it shows how redirection can be used to pass data around your entire computer and even over computer networks, I've heard. So that's pretty amazing. So how awesome! You now know everything you need to know about redirection in Linux, and the beauty of the Linux system should begin to be making itself clear. Now, as a quick recap, you learned that standard input, standard output, and standard error are streams of data, and like normal water streams, their flow comes from somewhere and goes to somewhere. Redirection is all about controlling that where. Using redirection, you can control where standard output and standard error streams go, and you can control where standard input comes from. You also learned that these data streams have numbers associated with them. Standard input is stream number 0, standard output is stream number 1, and standard error is stream number 2. You then learned about the different symbols that can be used for redirection. They are basically the greater than and less than signs. Just remember that if you're redirecting output, one greater than sign means that the file will be erased or truncated before you write to it. So if you don't want to lose the data that's in there, make sure to use two greater than signs to append data to the file. In other words, add data to what's already there. Now, there are a few more cool things that you can do with redirection, but they're less common than what you've learned in these last few videos. So if you're curious, I've put a link where you can learn more about redirection in the lecture resources. But one question that must be burning in your head right now is, how can I redirect the output from one command to the input of another? Surely there must be a way. Well, that process is known as piping, and it is, in my opinion, that's the crown jewel of the Linux command line. Piping is probably the most important thing that the command line lets you do, because it takes all of the commands that do one thing very, very, very well and allows you to tie them together seamlessly to do basically anything that you want. Mastering piping will definitely give you superpowers, so to master the power of piping and gain superpowers, I'll see you in the next video. So here we are, you beautiful people. You're about to learn the crown jewel of the Linux operating system, piping. So in the last few videos, you've learned that you can use redirection to change the location of where you send command output and where you get command input. But what if you wanted to connect the standard output of one command so that it flowed into the standard input of another command? Well, that's where piping comes in, and it's ridiculously powerful. Each Linux command is designed to do one task extremely well, so if you can continually pipe these highly specialized commands together and pass data between them, you can build advanced pipelines to do pretty much any task that you can think of, and once you know how to do it, it will really feel like a superpower. So in this video, you're going to learn how to build your very own command pipelines, and then in the next video, in part 2, you're going to learn how to make your pipelines more flexible by using the T and the Xargs commands. This is going to be a great section of the course, and you will not recognize yourself after you learn what I'm about to teach you. So I hope you're excited. Let's go ahead and get into it. Okay, so piping is all about taking the standard output of one command and connecting it to the standard input of another command. So let's take, for example, the date command. The date command, as we know, will show us the date. Now we can write the standard output of the date command to a text file called date.txt using redirection. So as a mini challenge, see if you can remember how to do that. How would you take the date command and redirect it into a file called date.txt? Give it a go and then come back to see how you did. Did you manage it? Well, this is one way you could do it. You could type the date command and then say, I want to redirect the standard output into date.txt. Now, you could have just had the symbol like this, or you could have put the number 1 to indicate that you wanted the first data stream, which is standard output, to be written to date.txt. And if you did that, massive congratulations, you're learning already. But now that we've done it, we are going to take a look at our file explorer here, and we see a file called date.txt, and we see that the date information has indeed been written into that file. Okay, but now what if we wanted to just cut out the day of the week, which in this case is Monday? Okay, how would we cut out just the day of the week? Well, one way to do it would be to use the cut command. Now, you haven't seen the cut command before, but it works very simply, and it's probably easier to show you by doing. First, we want to read the date.txt file into the standard input for the cut command. So to do that, we would type cut and then read into the standard input date.txt. Okay, and you don't have to have the 0, so you could just get rid of the 0 and just do that. Have the less than sign and then date.txt, and remember this space here, this is optional. Okay, I'll probably just keep it because it looks a bit nicer. Now what the cut command does is it will cut up a file and give you specific columns. So if we look at date.txt, you can imagine that the file is broken up into columns with a space between each column. The day of the week, in this case Monday, is the first column, or the first field as it's known in the cut command. This would be the second field, this would be the third field, and so on and so on. But we want the first field. Now, to make the cut command work correctly for us, we need to give it 2 pieces of information using options. First, we need to give it the delimiter long form option, so delimiter. Okay, and what a delimiter is it tells you what divides the columns. Okay, so we need to tell it that spaces are what divide or delimit the columns, because spaces are what divide up these specific columns in the file. Okay, so to do that, we just type delimiter as a long form, put a space, and then in quotes put another space. Okay, so we're saying a space is what delimits this file or this input. Okay, then we need to say which field we want now that we've told it how the file is cut up. So we give it again the long form option, which is fields, and then a space, and then 1. Okay, and now what we've got, now when we run that, okay, what we're going to see is we're saying to the cut command, okay, read date.txt. It's broken up into columns with a space separating each column, and we want the first field. Now when I press enter, you can see that we get Monday as an output. Isn't that awesome, right? That's pretty cool. You've not seen the cut command before, but it's a very cool command. But this works, but it's kind of clunky. Okay, first we're writing the standard output of the date command to a file, which takes up space on our computer, right? Then we have to read that file into the cut command. Okay, and maybe we would also, after getting this data out, we'd then have to delete this original file because we don't need it anymore, which is another process that we'd have to undertake. So doing it this way, by saving the data into a file and then reading that file in 2 steps, takes a lot more typing. It makes unnecessary files, which then you've got to remove, or they just take up space, and it's just an inefficient and awkward way of doing things. So instead, we can pipe the standard output of the date command directly into the standard input of the cut command. Okay, so if I just use the up arrow key to keep what we had before, okay, now instead of saying read into the standard input of the cut command date.txt, what I'm going to do is I'm going to type date and then use this pipe symbol. Now this pipe symbol you can find by holding shift and then backslash on your most keyboards anyway. So yeah, that's the way it is on most keyboards, but if it's not there on your keyboard, if it's not possible by holding shift and backslash, just hop onto a search engine and look for how to do the pipe symbol on your keyboard layout. If you have trouble finding it, it should come up straight away. But now what's happening is we're saying pipe the data from the date command standard output into the cut command's standard input. Now, because date.txt was effectively the standard output from the date command, this is going to have the same effect. So when we press enter, ta-da, we get Monday out. And this happened all in one step. So that's really cool. We managed to take the data straight from the date command and pipe it into the standard input of the cut command so that it could be operated on. We gave the cut command some options that allowed us to cut out directly the name of the day of the week. Now I'm just going to press the up arrow key, and now I'm going to show you something really cool. What we can do is we can actually output that data into a file. Okay, so we could actually save that using redirection into a file called today.txt. So check this out. We're using the date command to get all this information here. We're cutting it out to get just Monday, and then we're writing that data into a file called today.txt. Pretty awesome, right? So let's try it. Let's go ahead and press enter. Ta-da! And now that's gone out. It hasn't come up on the screen this time. And if we look in here, we've got a file called today.txt, and if we click it, we've now got Monday. Isn't that awesome? I think that's fantastic. Now, as a side note, it doesn't actually matter where I put the redirection, okay? So I could have the redirection at the end here. I could have the redirection over here, and it would still work exactly the same, okay? That works absolutely fine. I could even actually put it in between the different options. So I could put it here. And that will also work exactly the same. Okay, and we're still getting today.txt with Monday inside. So that's just something to bear in mind. Okay, don't be scared about typing stuff wrong. All of these are valid ways to do it, but some are just a lot more readable than others. Okay, but let's say that instead of redirecting, we wanted to send the standard output of the cut command to yet another command. How would we do that? How would, instead of saving it into a file, how would we send the data from the cut command into yet another command? Well, it's simple. You just add another pipe, okay? So you just say, okay, let me cut that out. Let me just put another pipe. And then let's say I put a command and I've got some options and then I've got some command line arguments, and that's how that would work, okay? This new command could take its own options, its own command line arguments, and it could also read standard input from the cut command, okay? So you can see how this works. We're taking the date command, piping that output into standard input of the cut command, giving the cut command its own options. Then we're piping that output into another command, giving that command its own options and its own command line arguments, and so on and so on and so on. Okay, you can just keep on going, piping these things together, doing what you want and giving them options as you wish. So this is what gives the whole Linux terminal its power. Okay, up until now we've been doing things that are cool but not really necessarily useful. But when you can combine together really powerful commands and have them operating exactly the way that you want to, and pipe the data between them and all over your computer, it really gets amazing. So you can see that this piping stuff can go on, and you can see how to build up powerful pipelines this way. It's actually really straightforward. You just pipe together different commands. Isn't that awesome? So let me ask you a question. What if we wanted to actually keep the whole date in a file and then pass it into a pipe? Well, we can't simply use a redirection at the end here because we're already passing the standard output of the date command into the cut command, right? So we can't really save it in a file because we're already passing it on down the pipeline. And if we tried to do it, let me just get rid of the end here. If we tried to just pipe the output into date.txt, if we do that, then let me just delete everything we've got in here so we can see the effect. If I try this, we'll see that all we get is just date.txt. Okay, the whole data is saved into date.txt, but then there's nothing to pass on into the cut command. Okay, this is because redirections are processed before pipes when in the shell. So it will find the redirection and do that before it ever sees the pipe. Okay, and this basically breaks our pipeline. So the data can't really go two places at once. Or can it? Well, to make this work, we're going to need to use a command called the T command, and it's these kind of advanced stuff that we're going to be showing you in the next video. Hello there, you beautiful people, and welcome back I left you with a bit of a cliffhanger in the last video where you learned all about the basics of piping. Now, in this video, we're going to take what you learned about the basics in the previous video, and in this video, we're going to level it up and teach you some advanced piping techniques. So with the basic stuff you learned in the last video about just taking the output of one command and piping it directly into the standard input of another, that doesn't leave much room for flexibility. Whereas there's loads of really cool things that you can do with your pipelines if you learn just a few more techniques. So in this video, we're going to go over those advanced piping techniques, and by the end, you know how to make advanced pipelines using the T and xargs commands. So let's go ahead and jump into it. Alright, so let's just have a quick recap of what we did in the last video. So in the last video, we used the date command to get loads of system information about our computer's clock. And what we did was we passed that data into the cut command because we just wanted to cut out the day of the week, which is a Monday. Now, to cut out the day of the week, we have to say that this data is actually broken up into several columns, and each column is separated by a space. Now, another way of saying that is that each column is delimited by a space. That's a fancy word in computer lingo. And so what we did is we gave the cut command a delimiter, and we said the delimiter is a space. Okay, and now once we've said, okay, each column is split up by spaces, which field do we want? Which column do we want? Well, it's the first column. Now, fields in the cut command are called, columns in the cut command are called fields. So we just said fields equals 1. And when we pressed enter, that cuts out Monday. Okay, so that's what we did in the last video. Then I gave you a little bit of a challenge. I said, hey, how can we go about actually saving this information into a file, but at the same time also pass it down into the pipeline? So how can we save it into a file, but also pass it down into the cut command so that it can be operated on, so we can get Monday out? So we're trying to do two things at once. So to do that, we actually need to have another command called the T command. So let's take a look at how the T command works. So here's an image of how the T command works. Now I've put a link to the original picture in the video resources, but you can see here that we have a pipe between two commands. So here's a command over on the left, and we have another command over here on the right. And in the middle, we're using the T command. Okay. Now we haven't covered what these specific commands do. It doesn't actually matter so much. What I want you to focus on is the T command in the middle, and just understand that we're trying to pipe two commands together. Okay, now just like a T-junction in a pipe of water, we can use the T command to cause our data to flow in two directions. We can cause it to flow horizontally as well as flow vertically downwards into other files. You can imagine it working like that. Okay, so the T command allows us to pass the data on to the rest of the pipe, but it also allows us to keep it in a file. Okay, so you can see here that we've got a command on the left that is trying to pipe its data across into another command on the right. In the middle, though, we pipe it through the T command, and the T command, we give it a command line argument of file.txt. That could be any file name that you want. And what happens is the data does pass all the way through from the standard output of one command to the standard input of the other, but it also falls down. You can imagine it falling down from your command line into a file called file.txt, or whatever file name you gave the T command. So that's how the T command works in theory. This is how this graphic works. Let's go ahead and see it work in practice. Okay, so now that you understand how the T command works, let's just have a quick refresher of our command pipeline. We had the date command, which gives us a whole bunch of information about our system's clock, and we wanted to cut out the Monday or whatever day of the week it actually is. Okay, so we take the date command and we piped it into the cut command. Now we notice that the data is broken up into columns that are separated by spaces. So we say, hey, cut command, we have a delimiter that's a space. The data is delimited by spaces, and we want the first column, or as the cut command calls it, the first field, and that gives us the day of the week, which in this case is Monday. Now the challenge was we want to not only have that come out, we also want to save the entire date, okay, into a file called fulldate.txt. Okay, so here's how we would do that. I'm going to press the up arrow key to get where we got before. Now what I'm going to do is I'm just going to squeeze in here the T command. Okay, now the T command is going to put one of those like T-junctions in our pipeline. You need to imagine it in your head, okay? So what's going to happen is the data is going to pass all the way through the pipeline horizontally. So it's going to pass from the date command standard output and go into the standard input of the cut command. So it's going to flow straight the way through. But now what the T command is going to do is it's going to allow us to save the data vertically downwards. So you can imagine it being like a big letter T, okay, like a big T junction. The data is going to go downwards into the file called fulldate.txt. Okay, so here we are. The data is going to go horizontally down. Oops, I've opened a new terminal. My bad. That is going to go horizontally across. Okay, and it's also going to go vertically downwards into a file called fulldate.txt. Okay, so when we do that, we see that the output of the day of the week has still happened because that was passed through the cut command, and the cut command spit it out to its standard output, which is still connected to our terminal. But when we open up our file explorer, we can see that now we have a file called fulldate.txt. I deleted all of the other ones we had before, so we were starting afresh, and now we have fulldate.txt. Now when I open that, well, hey, we can actually see that all of the data has been indeed saved in a file called fulldate.txt. Isn't that awesome? That's proper cool, right? So what happened was the date command spat out all of its information all the way across the pipeline. And when it got to the T command just took a snapshot of the data in the pipeline and passed it down into a file called fulldate.txt. So that file contains all of the data that's coming out of the date command. Okay, but then the data was passed on into the cut command, which did some processing, and that spat out the day of the week, which in this case was Monday. Now I've got a quick challenge for you, okay? And I think you can do it. What I want you to do is I want you to, instead of having the day of the week spit out to the terminal, I want you to see if you can figure out how you can use redirection to actually cause that data to be saved in a file called today.txt. Okay, so instead of having the day of the week be spat out to the terminal, I want you to have it saved in a file called today.txt. But also, you still need to have the T command in here. So I want you to press the upper arrow key to get what you've got before, and now do the redirection. Okay, so I'm going to pause the video now, and then come back and see how you did. How'd you manage it? Did you do it? Well, this is how I'd go about it, right? So I would just, right at the end here, because here's where the data is actually coming out from, I would just have a redirection from standard output into a file called today.txt. And it's literally just that simple, okay? So once we've done that, if I go ahead and press enter, we can see that when we open up our file commander here, we've now also got a file called today.txt, and inside there it has saved the data, the day of the week, which in this case was Monday. Let me delete both files just so we can see this in all of its glory. We've got no files. I'm going to press the up arrow key, press enter, and when we take a look, haha, we've actually managed to save all the data into fulldate.txt, and we've also managed to save just what we wanted using redirection into today.txt. Isn't that awesome, right? That's really awesome. I think so anyway. So what we've got here is the T command basically takes a snapshot of the data that's flowing through the pipe at that point and saves it in a file that that you give it, okay? And then redirection will also do the same, but once you've redirected standard output, you can no longer pass it down the pipe, okay? So that's why we use the T command. The T command allows standard output to continue flowing down the pipe, but also allows you to effectively redirect it to a file and take a snapshot so that it's saved there. So another way of saying that is that once you've done redirection, you can't do any more piping. Okay, so once you've redirected standard output, like we have here in the today.txt, okay, we can no longer do any more piping down a pipeline. I'm just going to maximize the terminal. Once we've done this redirection to today.txt, that's the end of our piping days. But what we could do if we wanted to save all the data in today.txt but continue the pipeline, then that's when the T command would come in. Okay, so we do, for example, today.txt in the T command, and now we can continue to pipe. Okay, so just again, if you do redirection of standard output, that means no more piping. If you want to take a snapshot but continue piping, that's when you use the T command. And now I could continue piping on down. Okay, so I wanted to also cover the xargs command in this video, but I think we're pushing it for time here. I hope that has made it clear what the T command is. In final summary here for the T command allows you to save a snapshot of the data and continue doing your piping, whereas just using redirection will save a snapshot of the data, but you can no longer do any piping. So if you want to keep building your pipeline but keep a snapshot of the data, use the T command instead. So in the next video, what we're going to do is we're going to have a look at the xargs command, which is a really powerful command that allows you to turn your piped data into command line arguments. Ooh, okay, so let's go ahead and I'll see you there in the next video. Hello there, you beautiful people, and welcome to part 3, our final part of our discussion on piping. Now, in part number 1, you learned about the basic concepts of piping, and you saw that piping is all about connecting the standard output of one command to the standard input of another command. And in part 2, you saw how you can actually pass data through your pipeline, but also take snapshots of the data as it flows through and save those snapshots into a file using something called the T command. Now, the T command is really useful because by doing normal redirection, you break your pipeline, but by using the T command, you can save data but still keep your pipeline flowing. Now, in part number 3, we're going to take that understanding of piping to a whole new level using something called the xargs command. Now, remember, piping is all about connecting the standard output of one command to the standard input of another command. Now, not all commands actually even accept standard input. Some only accept command line arguments, and that's exactly where the xargs command comes in. The xargs command allows you to convert piped data into command line arguments for commands that only accept command line arguments so that you can keep your pipe going without having to break it at any point. So the xargs command is that missing piece that's going to make your pipelines basically indestructible. So we're going to teach you how to use that, and then we're also going to have a summary of piping start to finish to make sure that these concepts really sink in. And by the end of this video, you're going to be the master of piping concepts after you've probably received the most comprehensive explanation of it that you'll be able to find anywhere on the internet. So there we are, guys. Let's go ahead and jump right over now into Ubuntu and see this stuff in practice. Okay, so let's take a look at how the xargs command works. Let's say that we are, again, playing around with the date command, for example, and we're getting the date that's coming out of our system. Now, what do you think will happen if we take the date command and we pipe it into echo? Now, remember, echo is very simple. If I just take echo and I say, give echo hello, it'll just say hello back. So what do you think will happen if I take the date command and pipe that into echo? Well, you might think that when I press enter, the date command will pass on the date into echo and it will spit out the date, right? Wrong. Actually, what happened is echo doesn't accept standard input. So what happened here, this is a common mistake actually that people make when using pipelines for the first time. They try to pipe things into echo. Now, echo doesn't accept standard input. In fact, it only accepts command line arguments. So if I try to do this and I type to echo hello, again, even though I'm piping with the date command into it, if I go ahead and press enter, you can see that it's only processed its command line arguments. So the question becomes, how could we pass the data from our pipeline into a command that doesn't accept standard input? Well, the key is to convert the data from standard input into command line arguments so the command can continue to work like normal. So the way that you do that is that instead of piping it into echo directly, you pipe it into something called the xargs command. Now, the xargs command will convert the data from standard input and it will put it instead into command line arguments. So if now I do echo, so I basically put it into xargs and then give xargs echo to work with, when I press enter now, you can see that now it echoes out the date. Okay, isn't that cool? Now I can also give echo its own command line argument. So I could give it also hello, and what will happen is it will now process both, except it will process its own command line arguments first. So that's something to bear in mind, but it did indeed echo both of them out, which is a lot better than we had before. Now we can actually continue to pipe down because the data that comes out is still on standard output. So basically, xargs is like a little plaster or a little fix for when a command does not accept standard does not accept standard input, but only accepts command line arguments, you can use xargs to get around the problem, okay, and continue doing your piping. So let's say that we wanted for it to echo out just the day of the week. What we could do is we could say date, pipe that into the cut command, just like we've been doing a million times. Tell it that the delimiter is a space, tell it that we want the first field, and then you could pipe that into echo. Now remember, this isn't going to work because echo doesn't accept standard input, so we convert the data from standard input into command line arguments using xargs. Tell xargs, hey, we want you to work with echo, and now we'll see that it pops out the day of the week, which is Monday. So let me give you a bit of an example where this might take you, okay? This xargs ability, what it might be able to do for you. So, for example, if we take our full date.txt file, we've got some data in here. Let me just create a new document here. I'm going to call it, I'm going to press Control and S to save. Yep, that works. I'm going to call it deleteme.txt. Okay, so I'm going to make that file. I've called it deleteme.txt. Now when we look, we've got a new file in here called deleteme.txt. Now there's a command that you'll be coming onto later in the course in the section all about navigating the file system and things like that, which is the section after this one. But there's a command in there called the rm command. Now the rm command stands for remove. It's the command that deletes stuff. And if I type deleteme.txt and I click enter, watch on the left, watch just over here, okay? You'll notice that the file has just been deleted, okay? So you notice here that we actually gave the rm command a command line argument, okay? We typed it on the command line. We gave it a file name. Now, what we might want to do is we might want to have another file over here, okay, called files to delete.txt. So files to delete.txt. And in there, I'm going to give it the names of fulldate.txt and today.txt. So if I put that in there, fulldate.txt, and we're also going to have, what was the other one? Today.txt. Okay, so we've got a file that contains those two names. Okay, now we can read that file out using the cat command. You've seen this before. Okay, so if I do the cat command and I say files to delete, you see how it gives me the output. Now, I can't just pipe that information into the rm command. Nothing will happen, okay? Because the rm command only accepts command line, the command line arguments. But what I can do is I can read the data. Let me clear the screen. What I can do is I can read the data from files to delete, these file names, and pass it into xargs. Now, xargs is going to convert that data into command line arguments for the rm command. Now, the rm command does accept command line arguments. So when we do that, notice if I just pipe directly to the rm command, it doesn't work. It says it's missing an operand, it's missing a command line argument, okay? But if I pipe it into the xargs command instead and then type rm, watch what happens now over at the left. We notice that the files got deleted because now the rm command could work. What effectively happened, it was as if we wrote rm today.txt and fulldate.txt. Actually, the other way around, because the file, they were written in the other way around in the file. It's as if we did this. Okay, it's as if we wrote out this command here, but instead we just read the file and piped the contents to another command. So you can see that this is how you might potentially use the xargs command, just as a bit of an example, rather than just using the date command and echo all the time. So over the past 3 videos, we've covered a whole lot of stuff. So let's just try and summarize it all together in one place so that you can feel confident that you've got it all. First of all, you learnt that piping is a process that connects the standard output of one command to the standard input of another. And by the way, if you ever see these two words in orange, std out and std in, from now on, you know that means standard output and standard input respectively. Okay, and std err is standard error, okay? So if you ever see those things around, okay? So piping connects the standard output of one command to the standard input of another. Redirection of standard output breaks pipelines. So if you're making a pipeline and you do some redirection, you've broken your pipeline, the pipeline from that point on will no longer work, okay? So if standard output has just been redirected into a file, by default, it can't be continued to be passed down the pipeline. That is, unless you use the T command. So if you want to save a data snapshot without breaking your pipeline, use the T command instead, and that will make basically an imaginary T junction, just like you might find in pipes of water in your pipeline, so that you can save your data and also have it continue on through the pipeline at the same time. Now, if a command doesn't accept standard input, then as we know, piping connects standard output to standard input. So how can you still use that command in your pipeline? Well, if you still want to pipe to it, even if it doesn't accept standard input, as long as the command accepts command line arguments, you can use the xargs command instead. And commands that you use with the xargs command can also still have their own command line arguments besides the ones that you pipe to it. So you can still pipe data to it, you can still pipe data as command line arguments and also give it its own arguments right there on the command line, but just understand that the ones that you type to it on the command line will be processed first. So that's a whole bunch of stuff, guys. This really is the most important part of getting good at the Linux command line. If you can understand and you feel confident in what you've learned in the last 3 videos about piping, you have unlocked the crown jewel of using the Linux command line, and you should be massively proud of yourself. And if you haven't, then just go back, watch these videos as many times as it takes for you to get it down, take some notes, practice, try stuff out, because I promise you the effort will be worth it. And I'm really proud of you for actually making it this far, and so should you as well. Now, up next, we're going to show you a little trick that's going to make your use of the command line a whole lot easier, and we're going to show you how you can use something called aliases to save your command pipelines with easy to remember names, so they can be just used much easier later on. So that once you've written a pipeline, you don't have to write it again, just use the name and it will come up without any errors. So for all that good stuff, to learn about aliases and making shortcuts, I'll see you in the next video. Hello there, you beautiful people. Now, at the end of the last video, I gave you a little bit of a teaser about something called aliases. Now, aliases are basically little nicknames for your commands or for your command pipelines that make them a lot easier to remember. Now, in this video, you're going to be learning how to create your very own command aliases. So very exciting. Now, in this video, I'm going to walk you through step by step everything you need to do to create your own command aliases. And by the end of the video, you should have all the skills that you need in order to create easy to remember nicknames for your pipelines, so that once you've written them, no matter how complicated they are, you can just use them over and over and over again without typing them all out, just using instead the easy to remember nickname. So this is super cool stuff, and let's go ahead and jump right into it. Okay, so the first thing you need to do to start creating your own command aliases is to create a special file called bash aliases in your home folder. So to do that, to create the file, what we want to do is we want to click on activities at the top left, and then in this search bar here, just type the word text, and it should come up with a thing that says here text editor. Just click on that, and it will open up a new window where we've actually got a file. Now there's a button at the top here where you can click that says save. So I'm going to click save, and in my home folder I'm going to type a file that it needs to be spelled exactly the way that I'm going to tell you. Okay, so first of all you type a period or full stop. Okay, then you type bash, B-A-S-H, all in lowercase, then an underscore, then aliases, so A-L-I-A-S-E-S. Okay, so that's bash underscore aliases with a period or full stop at the beginning, everything in lowercase, and then go ahead and hit save. Okay, so now we have our bash aliases file, and actually I don't think for the minute we'll need the terminal, so I'm just going to close that as well. Okay, so make sure it is spelled exactly as it is up here, full stop, then bash underscore aliases, A-L-I-A-S-E-S, everything in lowercase, and once you've got that, we should be all good to go. So now you might be wondering, why did we actually need to name the file with a full stop at the beginning? That's quite strange. We don't normally name files like that, do we? Well, that full stop makes the file a special type of file called a hidden file. So if we go back into the file browser here, and we look in our home folder, you'll see that the bash aliases file isn't actually there. Where has it gone? Well, it's a hidden file, so it's kind of hidden. But where it actually is, if you click on this button here with the 3 bars, if you click that and then click on down here, there'll be a checkbox that says Show Hidden Files. If we check that, we'll be able to see that our bash aliases file has been created, but there are actually also plenty of other hidden files here that we hadn't seen before. But here we are. Here's our bash aliases file that we're currently editing, as well as actually even some hidden folders that maybe you didn't even know were sneaking around your system. But anyway, we don't need to worry about those for now. Let's just go ahead and click those 3 bars again and undo viewing hidden files so it all disappears again. So, we don't have to continue looking at monsters under our bed. And now we can go ahead and actually keep editing the bash aliases file. Okay, so now that we're in our bash aliases file, making an alias is actually really quite easy. So here's the command that we want to make an alias for. It's going to be a really long command with loads of complicated stuff in it, but we can do this. Okay, there's nothing new. It's just quite long. So we're going to type the date command. We're going to pass that into the cut command. We've seen this a bajillion times, right? We're going to tell it that the delimiter is a space, and we're going to get the first field. Okay, now we also want to have a copy of that data. We want to take a snapshot, so we're going to take the T command and save that in a file in our home folder called fulldate.txt. Okay, so we're doing well so far. Then we're going to take a snapshot of just the day of the week. We're going to save that in our home folder in a file called shortdate.txt. And then everything that comes out, we're going to pass into the echo command, but also give the echo command its own argument. Whew, that's quite a long command, right? So we're doing a lot of stuff in here, but the point is that it's long, because then you can see how useful aliases are, right? So the only thing to make it work for your computer is, instead of having Ziad, well, unless in a bajillion chance that your name is also Ziad and you chose it to be your username on your virtual machine, which I think is unlikely, but if you are, send me a message. But otherwise, just go ahead and change that with your username so that it matches the correct path on your computer. Otherwise, you're going to start getting errors. Okay, so just change, if your username was Sally, just change it to be Sally. Okay, but mine was Ziad, so I'll keep it at that. Okay, so this is the command that we want. Now, to make an alias for it, let's say, for example, we wanted to, instead of typing out this massive command every time we wanted to do it, instead of just typing out that, what if we wanted to just type get dates, and that was going to be our alias? Well, all we have to do is just type the word alias, which is a special word, then press a space, then get dates, an equals sign, and then an apostrophe on either side of that command. So you can see there's an apostrophe here, and there's an apostrophe here, okay? So like a single quote on either side of the whole massive command, then alias at the beginning, the name of the alias, an equals sign, and then quotes on either side of the massive command. So what we're saying is, hey, I want to make an alias called get dates that is exactly equal to this command. Now, when we save it and close it, so we need to close the editor. So we click on these three bars over here, click close, okay, and close all of this in general, I think. Let me just drag that down and close. Now, when we open our terminal, when we reboot our terminal, that alias should be loaded. Okay, so I want you to think of these aliases as being like your own commands, okay? So if we try and run the get dates command, shall we call it, if we go ahead and press enter, remembering that get dates was the name of our alias, we actually get some output. So that's pretty cool. Now, if we go ahead and look in our home folder, we'll also see that 2 new files have been created. So we've got fulldate.txt and shortdate.txt. So let's go ahead and take a look. In fulldate.txt, we've actually gone and got the full date. All the data has been passed into that. And shortdate.txt has had just the day of the week passed in. Isn't that awesome? Okay, because this has come from the alias. If I delete those and go ahead and run the get dates command again, we see that the files have been created one more time with the same data in them. So this is super cool, right? Like instead of typing out that really long alias, that really long command every time we wanted to get that functionality, because we've created an alias and basically given a cute nickname to the command, get dates instead of the massive pipeline, we can now get the same functionality but in a much easier to remember way, and a way that's actually easy to reproduce. So that's really awesome. But now let me show you something super cool, okay? You can actually also use aliases in bigger pipelines. So think of your alias as just being its own pipeline, right? If your alias, if that mini pipeline that you save can accept standard input, if the first command in it can accept standard input, then you can just pipe to the alias and run the whole pipeline, and then pipe out of the alias and continue on. It's like having your own little pipeline building block. So let me show you, okay? Let's say that we wanted to have an alias for our command that showed a calendar with 1 month before and 1 month after the current month. So the command for that would be cal, then A1, B1. Okay, so after 1 month, before 1 month, and we get the current month with 1 month after and 1 month before. Okay, so that's the command. If we go and head back in here, click these three horizontal arrows, horizontal bars, and show hidden files, click on our bash aliases file to open it up, and go onto a new line in the file. Let's create a new alias for that command. Okay, so we're going to say alias, we're going to say cal magic, short for calendar magic, and we're going to type an equals sign, and then you can actually type some speech marks. Okay, you don't have to have the single quotes, you can have speech marks as well, and we're going to type in there cal, then the A option, give it a number 1 as its own argument, then a B, capital B, then 1 as its own argument, and we're going to output that into a file in my home directory called thing.txt, and of course remember to replace this bit with your username that you're using on your virtual machine. Okay, so we're going to call that cal magic. But the cal command here, right, the cal command only accepts command line arguments. You can't pipe to the cal command by default. So to make this a valid pipeline that you can actually, this whole cal magic thing, a valid pipeline that you can pipe to, we need to actually put the xargs command at the beginning. Okay, so let's just do that. If you don't understand what I'm doing at the minute, just bear with me, okay? We're just making a building block, this whole thing that we can pipe to. Okay, so that's what we've done right there. Now, whatever's going to be piped to cal magic will actually be piped to the xargs command, which will then convert the data from standard input, which cal doesn't accept, to command line arguments, which cal does accept, and so therefore the whole pipeline will work. Okay, this is going to be awesome. Just trust me, okay? Let's go ahead and do this. Let's save and close that. Close everything and close our terminal and reboot it. So I'm going to press Control Alt and T to open up our terminal. Now, if I echo 12/2017 into cal magic, what's going to happen is I'm going to be echoing this data as command line arguments to the cal magic command. So what we're expecting to happen is that we're expecting that we're going to get December 2017, the calendar for it, with a month before and a month after. Okay, saved to a file in our home directory. So if I press enter, we don't get any output, but if we go into our files here, we will see that there is a file in here called, here we are, thing.txt. Ta-da! We've actually managed to save the calendars for December 2017, 1 month before and 1 month after, into a file called thing.txt in our home folder. And the reason that happened, it's probably a lot easier to see if I actually get rid of these hidden files. No. No, I will keep them, because otherwise I'll lose where I am. But what happened is we basically passed to the xargs command 2 pieces of information. We passed it 12 and 2017, which were then given as command line arguments to the calendar command. So you can see how all this stuff is starting to tie together, right? And we've made a mini pipeline called cal magic that will now be able to run a command whenever we want. So we don't have to type out this ugly thing, we just have to remember cal magic. And because we made it possible to pipe to the first command in our alias, the whole pipeline will work, and we can just use it like a mini building block in whatever programs that we want to make. So how awesome is that, right? Can you see how crazily powerful the ability to write aliases for pipelines and use those aliases in other pipelines can actually be? right? The possibilities really are limitless with what you can achieve with that ability. So let's just leave it there. I'm going to leave your mind blown with that. And let's just go ahead and now take a summary of what we've learned about aliases. Okay, so that's enough being mind blown for now. I hope you're as excited as I am by what you've learned in this video about aliasing. Aliasing is an absolutely incredible ability with really limitless potential if used in the right way. So let's just have a quick recap to make sure that you've got it all down. So in this video, first of all, you learned that an alias is basically just an easy to remember nickname for a command or a series of commands joined together in a pipeline. Now, to create an alias, you need to first have a file called .bash_aliases, all in lowercase, in your home folder, and that's where you actually put that's the file that you actually put your aliases in. And these aliases, therefore, will be specific to your user. Now, as a bonus point, you learned that a period or full stop or a dot at the start of a file name makes that file hidden. So, and you also saw how to turn on or off the visibility of hidden files in your file viewer. Okay, now inside the bash aliases file, you saw that it was actually quite easy to make an alias, right? This is the way that you do it. First, you type the keyword alias all in lowercase. Then you put a space, and then you put the alias name. So as was get dates, or it was Cal Magic, or whatever you want to call it. That's your nickname, okay? Then you put an equals sign without adding a space, without a space at all between the alias and the equals sign. So you just put an equal sign immediately. Then you open some quotes. These quotes can be either single quotes using an apostrophe, or normal double quotes like you would use for speech marks. Again, without any spaces, without any gaps between that and the equal sign. Then you just create your pipeline, or you use your command. Again, you can have options and command line arguments just like you normally would. Okay, these can go on for as long as you want. Okay, now as long as you make sure that you restart your terminal, you'll then have access to that alias forever. Okay, and as another bonus point, look, you get 2 bonus points in this summary. Feel very spoiled. But as long as you make sure the first command in that alias, in that pipeline, can actually be piped to, okay, then you can just pipe to the alias, pipe to the nickname, and it's as if you're piping to the whole pipeline. If I say the word pipe one more time, I'm probably going to go insane. but you get the point, right? If you make it so that your pipeline can be piped to, either by using the xargs command or by just using a normal command that can accept standard input, then instead of having to, you can basically use that alias, that mini pipeline, as a tiny building block in some massive other pipeline that you're building to create a really epic bit of functionality. Okay, so aliases used in the right way with what you've learned about piping and xargs and all sorts of stuff, making these long pipelines is an epic ability. So now you can build your own command pipelines and even save them for use later. When you understand that, basically anything in the Linux operating system can be modified using command line. You've really understood the crown jewel that makes the Linux operating system so amazing, because anything can be edited using the command line, and you know how to create how to use these commands and pipe them all together to do whatever you want. You've really got a master key there to take your computing to the next level. But in order to take advantage of this, all you need now are just some more building blocks to actually build your pipelines with, right? So in the next section of the course, we're actually going to be covering a whole bunch of those building blocks, because the next section of the course is all about navigating your file system, creating and manipulating files, making folders, copying and pasting files, creating backups of your system, and so much more. But before we get into all that goodness, I want to make sure that you understand everything that we've covered in this entire section of the course first, because it's been an incredibly foundational, incredibly important section of the course. And if you understand everything in this section, you will not go far wrong with anything else you learn when using Linux. And I also want to make sure that you're duly congratulated for your amazing progress so far. You really deserve to have, some recognition of what you've done in this section, what you've learned, and how far you've come. So in the next video, we're going to have a celebration of your really impressive progress and a quick recap of what we've covered in this section. It's going to be awesome. So for a review of this section and some well-deserved celebration and praises, I will see you in the next video. Hello there, you beautiful person. Well, you must be feeling super proud of yourself right now, right? You've come so far in this section of the course, so to fully celebrate that, I wanted to make a video and have a quick recap so that you can soak in all the awesome stuff that you've learned in this section of the course. So you started off with the very basics and you learned how to open and close the terminal using graphical methods and by using our now beloved keyboard shortcuts. And it was all very strange to you at first, but you jumped right in anyway and you started typing out and using your first commands. You saw the date command, the cal command, and the echo command, and you saw how to clear your terminal's history. We don't want any spies looking at our history after all, do we? Now, you were making progress, but it was all kind of weird, and you probably weren't too sure of what was actually going on when you ran a command. So then you learned the difference between the terminal and the shell. You learned that the shell is what interprets the commands that you type, just like you interpret the meanings of words that you read. And when you understood what commands actually were, you learned the general structure of a command, learning that commands follow a command name, options, arguments, structure. Okay. Now, because it became clear that although commands follow a similar structure, they do vary quite a bit in their usage. They each have their own specific options and use cases, and it would be impossible to memorize them all. So you learned how to look in the Linux manual. You learned how the manual was broken up, and you saw how to search for terms and read the manual pages, and how to learn new things for yourself and find things as and when you need them, rather than having to memorize everything. So it's like having your own personal search engine for your computer, which is pretty incredible in my opinion. Now, then we took our discussion even deeper and you learned that commands can take input as standard input and command line arguments, and they can give output via standard output and standard error data streams. You saw how to redirect these data streams to wherever you wish and how to pipe together different commands to build powerful pipelines, and how to use the T command and the xargs command for extra pipeline flexibility. And this really is amazing how far you've come in such a short amount of time. So I wanted to make this video to congratulate you on your progress so far. So well done, you little computer genius, you. Now, in the next section, you're going to learn about navigating the Linux file system, and you'll also learn some new building blocks to use in your pipelines. But before that, I have a project for you to complete. Now, the project will challenge you to build your very own Linux command pipeline. Now, it's going to be awesome, and it will serve as a badge of honor that you have learned everything that we've covered in this section so that you can feel confident moving on. Now, in the next video, I'm going to be giving you your project brief. So congratulations once again. You're doing amazingly, and I'll see you there. Hello there, you beautiful people, and welcome to this section of the course on the Linux file system. Okay, so with this section, you're going to be learning a whole load of commands that will show you how to manipulate files using the Linux command line. Now, we're going to start off by talking about the Linux file system and what files actually are from the file system's perspective. And when you understand that, you're going to move on to discussing how you can move around the file system and create files using the command line. Then you'll learn a whole host of new commands such as copying, renaming, deleting, moving, pasting, searching for files across your whole file system, viewing files, searching for text within files, sorting data, and also creating file backups and archives for storage. Now, the commands that you're going to learn in this section are super powerful and come with a lot of options and ways for you to customize their behavior, which is great, but as a super useful tip, don't worry about memorizing all the different command options in this section, but instead just learn about the possibilities that exist for each command, and know that these videos, the cheat sheets that I've provided, and the commands manual pages will always be available for you to use as reference. So I hope you are as excited as I am, because after this section you're going to have a whole lot of new commands to use in your pipelines, but you'll also be able to interact with your whole computer and do 99% of your daily work in a whole new way. And you'll find that with the techniques that you learn in this section, you'll find that they're much faster, more powerful, and more effective than the graphical methods that you're most likely using right now. And if you're like me, you'll likely never go back, okay? So it's going to be a really revolutionary section of the course for your Linux abilities. So for all that goodness, I'll see you in the next video. Hello there, you beautiful people. So one really amazing thing about Linux is the way that pretty much everything on the system can be treated as a file. Now, you saw this earlier when we did the totally awesome magic trick where we redirected data from one terminal to the other. Now, that was possible because the terminal was treated as a file by the Linux operating system, and you can redirect data between devices on your system just like you can redirect data between files. Now, every one of the files on the system is on a structure known as the Linux file system tree. And in this video, you're going to learn how the Linux file system is structured, and you're also going to get a tour of what some of the most important places on the file system are. And by the end of the video, you'll know the map of the land, so to speak, and by knowing what you're actually navigating and how it's laid out, you'll be much better prepared to actually navigate it and modify it. And that's what we'll start learning in the next video. So you're going to learn about some very important locations on your computer and also learn what they're for, which will help you navigate even better. Loads of really awesome stuff in this video, guys, so let's go ahead and get into it. The first thing you need to know is that the entire Linux file system follows a tree structure. So if there's no partitions on your hard drive, every single thing on the system can be accessed in one large tree structure. So let's go ahead and take a look at it. Here's an image of what the file system looks like. Now at the top of the tree we have what we call the root directory, represented by this slash here. Now just to be clear, in case you haven't come across the word before, when I say the word directory, I basically just mean the word folder. Okay, so when I say root directory, I'm just referring to the root folder on the file system, this slash here. Now that folder is called the root directory because everything on the file system can be traced back to that, just like every branch and leaf on a tree can be traced back to the root of the tree. Now under that root directory there's a whole bunch of other directories. These directories are said to be subdirectories of the root directory. Another way to say that is that the root directory is the parent directory for all of these directories in orange here. Now there may be more folders or directories present on your system, but I've taken the most important ones to show here in this image because a slide only has so much space. Now each of these directories can have other directories and files inside of them, and the directories inside those directories can have their own directories and files, and so on and so on and so on, so that the whole system does eventually look like a really big tree with hundreds and hundreds of branches. Now, one of the most important directories on this tree is the home directory. The home directory holds individual directories for each of the different regular users on the system. Here we can see that the system has 3 regular users. We've got Alice, Bob, and Charlie. And each of those users can have their own files. So, for example, if we take Bob, we can see that Bob has folders in their home directory for their desktop, documents, downloads, music, pictures, and so on. And each of those folders can have files and other folders inside them. Alice will have a similar structure, and so will Charlie. You can access your home directory by clicking on this files icon over here, and what opens up by default will be your home directory. Now everything that we've been doing in the course up until now, such as playing with pipelines, redirection and stuff, and creating files, all those files have all been in our home directory. And you can see that in our home directory we have a desktop, documents, downloads, music, pictures, and so on, just like Bob did in the diagram. And if you're navigating around your file system, you can always get back to your home directory by clicking on this home icon here, or by finding it in the path that appears at the top. You can think of everything on the file system as being in 2 major parts. Now this is a bit of an oversimplification, but you can think of everything below the user's home folder as being specific to that user, and everything that's above the user's home folder tending to affect the whole system. Now what good would it be if regular users could modify or even delete files that the whole system requires to run? Not very good at all, and that's why special files and folders that tend to affect the whole system usually require elevated administrator or root privileges. The root user on the system is similar to the administrator in Windows. On Linux, the root user has absolute power over the entire system. Now I'll show you how you can perform actions with the root user in a later video, but for now just be aware of their existence. For now, I just want to discuss what these folders at the top here do. Now there's a lot of them, so to save you from memorizing, I've made a cheat sheet that you can download from the resources section in this lecture. Let's go ahead and go through it together now. Okay, so as I said, you can get a copy of this cheat sheet from the resources section in this video, and what it basically contains is a list of the different folders that are right underneath the root directory, right underneath the slash, and a bit of a description about what they do so that you can have a bit more of an understanding of what each of the folders does on your system. But let's just do a quick whistle-stop tour of each of them, and then you can look at it later in more detail for yourself. Okay, so we've got the slash directory. Let me just zoom in a little bit, make the the thing a bit bigger. There we go. So you've got the slash directory, which is the very top or the root of the file tree, and this directory holds everything else. There is nothing higher up than the slash directory. If you get here, you are at the very top of the file tree. You've got the bin directory, which stores common Linux user command binaries, bin binaries, which is where bin gets its name. So for example, the date command, cat command, cal commands, they're all stored in the binaries section, in the binaries folder. You've got the boot folder. Boot is for everything that is required to boot the system, so bootable Linux kernel and bootloader configuration files. You've got the dev folder, so these are files representing devices. Now, there's many different files in that folder. If the file name starts with TTY, that's a terminal. If it starts with FD, that's a floppy disk. If it starts with SD or HD, that's a hard disk. If it starts with RAM, then it's RAM. And if it starts with CD, then it's a CD-ROM. You've got /etc, which is administrative configuration files. Now, etc, or etc, as it's normally said, is a very common folder. You'll be using it a lot if you ever want to edit configuration files. And how you edit those configuration files is where section 5 of the Linux manual comes into play, which is all about file formats and things like that. So for editing many of the configuration files that are in the etc folder, you'll be able to find a man page that will show you how to do it. Then you've got the home folder, and the home folder is where the home directories for regular users are stored. So under the home folder, you'll have a home directory for each of the different users. So for example, I have one at /home/Ziad. I have my home folder inside the big home directory. So if I had 3 other people on my computer called Alice, Bob, and Charlie, they'd be /home/Alice, /home/Bob, and /home/Charlie. But in my case, just /home/Ziad. So that's where your home directory is stored, in the home folder. You've got /media, which is where removable media, such as USB sticks, external hard drives, and things are mounted. Anything that is removable from the system, unlike hard drives, unlike actual hard drives, anything that's removable usually gets mounted on /media. /lib is where shared libraries, so lib being short for libraries, needed by applications in the /bin and /sbin folders to boot the system. So this is where all that stuff is. Loads of installed stuff goes in /lib. /mnt is a place to mount external devices. You don't use it that often. Usually /media is used instead. /misc, being short for miscellaneous, is a directory used to sometimes auto-mount file systems. It's just there just in case, so the system can use it. /opt, or opt, is where you can store additional, or in other words, optional software. So anything that you install, any programs that you install, usually the files go in /opt. /proc is about system resources. That's more administrative kind of stuff. /root. Now this is the home folder for the root user. So this is sometimes a point of confusion. You've got the root folder, which is the /, sometimes called the / directory, and you've got /root. And /root is the home folder for the root user. So it's a bit of a confusing terminology, but just bear that in mind, okay? The / is the root directory. It is the very top of the file tree, and /root is the home folder for the root user, or the super user, or the administrator, similar to the administrator if you're on Windows. That's the home directory for the administrator. Almost there now. You've got /sbin, which contains administrative commands or binaries for the root or super user. So sbin being super user binaries. Okay, so these are commands that can be run by the super user or the root user. You've got /tmp, which contains temporary files run by applications. Sometimes when programs are running, they create temporary files to make them more efficient to run. That's where those are stored, and the tmp folder is usually cleared out very regularly, or when the program's shut. /usr or /user contains files pertaining to users that in theory don't change after installation. And /var contains directories of variable data, so data that changes a lot, that could be used by various applications. So for example, system log files are usually found in here. Log files change a lot, so that's why they're in the /var or /variable, /var being short for variable. So there you are. These are the different folders that are, I mean, at least the most common ones, that are directly underneath the / folder. So have a look at this cheat sheet, read through it once again, and maybe with my voice playing in the background. You don't have to memorize this. The cheat sheet's there just in case. You don't have to memorize this stuff. You'll very quickly become familiar with the most common ones that you'll use. Most likely, you'll just stick to using etc, which is where configuration files are, the home folder, and maybe media if you plug in a USB drive or something like that, and maybe /user if you want to edit something to do with programs. But usually those are the most common ones you'll be dealing with. But you'll become very familiar at where files are. We'll be using a lot of these different folders as we go through the course, so don't worry if it all seems like a bit right now. That information is there forever. Just take it one step at a time. Don't be overwhelmed by it. It's gonna be fine, and you'll very quickly become accustomed to it. Okay, so there you have it. You should now have a much better understanding of the Linux file system and how it's structured. So as a quick recap, we discussed that the Linux file system follows a tree-like structure starting at a base directory, which is represented by the /. Now you learned that everything on the file system can be traced back to that base directory. You also learned that there's a special user on each Linux system called the root user. The root user is similar to the administrator on Windows, and the root user has absolute power over the entire system. They can do anything that they want. You learned that the home directory, or the /home directory, holds individual home directories for all the regular users on the system so that they have a place to store their personal files. And you learned that the /root folder is the home directory for the root user, for the administrator. You also had a look at a bunch of really important folders that are right underneath the base directory, and there's a cheat sheet that you can download in the resources section where all that information is summarized for you. Okay, brilliant. So now that you understand the whole structure of the Linux file system, which is totally epic in its own right, I've also put a link to a series of blog posts in the resources section that will allow you to learn more about the Linux file system if you want to. But for now, we're going to go ahead and jump into using the command line to start navigating the file system, which is going to be really exciting. So for all that goodness, I'll see you in the next video. Hello there, you beautiful people, and in this video you're going to begin to use the command line to move around your Linux file system. Very, very exciting stuff. Now, once you learn the techniques that you'll learn over the next few videos and begin to use them for your everyday tasks, you'll begin to find that they are faster and more effective than the graphical point-and-click methods that you are most likely using right now. So in this video, you're going to learn how to use the pwd and the ls commands to know where you are on your file system and what is around you. And by the end of the video, you'll know where you are on your file system and what's around you using the command line, and you'll be ready to start moving around using some other commands that I'll show you in the next video. So I hope you're very, very excited. Let's go ahead and jump right into it. Okay, so here we are in the terminal. Now the first thing we'd like to know when navigating the file system is where we currently are, and the shell already tells us this. Over here on the left you'll see a bunch of text that is known as your shell prompt, and the shell prompt is everything up to this $. Okay, now let's break it down and show you what each bit means. First of all, it tells you the user of who is logged in, which is Ziad on this computer. Then you've got an @ symbol. Okay, then you've got the name of the computer, which is VB. We called it this when we set up and installed the virtual machine, and VB is short for virtual box. Then you've got a colon, which is these two dots on top of one another, and then you have this squiggle that's called the tilde. Okay, now in the bash shell, which is the shell that we're currently using, that tilde, that squiggle, is a short way of representing the current user's home directory. So whenever you see that tilde, whenever you see that squiggle, it just means the path to the current user's home directory. So our shell prompt is basically telling us that we are in the home directory for the current user, which we can tell is Ziad. Okay, so we can actually confirm at any time what directory or what location our shell is currently operating in by using the pwd command. Now the pwd command stands for print working directory, and the pwd command will just tell us the folder that our shell is currently operating in. So if I type pwd and I hit enter, we'll see the full path to my home directory appear, which is /home/Ziad. Now the path starts all the way from the root directory, the very base directory, which is the /, and works its way down until we get to the home directory for the user Ziad, which is me. Now we can actually see this if we click on our files, and that opens up. Now if you click on other locations, then click on computer, this will open us up in the very base directory. Okay, this is the base directory for the system. Now if I click on home up here, then click on Ziad, That is where we currently are in the shell at the moment, okay? Now, because the path starts all the way from the base directory, from the slash, it's known as an absolute path. So now that we know where we are and we know that our shell is operating inside of our home folder, how can we take a look around and see what's in the home folder? Well, first of all, we could do it using a graphical user interface. We could click on our files here, and that's automatically going to open us up in our home folder, and we can see there's folders such as a desktop, documents, downloads, pictures, and so on and so on, okay? Now, to see something similar on the command line, we need to use the ls command. Now, the ls is short for list, and the ls command will list out our files in a directory. Okay, so if we take a look at the man page for ls, the manual page for ls, we'll see that ls can take a path to some folders. It says here file, it says list information about the files, which is the current directory by default. Now, as a side note, ls does not accept standard input, so you can't pipe to it, and instead you need to give it everything as command line arguments. That's just an aside. Okay, so now let's try and use the ls command to see what's going on in our home directory. Now, there's multiple ways to do this. I could do it the long way, and I could give it the full absolute file path. I could type ls/home/ziad. Okay, that's the long way to do it. Or because I know that the tilde represents my home folder, I could give it a shortcut. I could do ls, then give it the tilde, and that's exactly the same thing. The tilde is just the home directory for the current user. It's just a shortcut. Or even better, because I know ls will by default list out the contents of the folder that I'm currently in, and because I'm in my home folder, I can just type ls. Okay? ls will by default list out the contents of the directory that your shell is currently in, and because we're in our home folder, I can just do ls without any command line arguments. So let's go ahead and do that. There we go. So in there, now what's come out, we can see several blue words. Now by default, blue text from the ls command indicates folders. But to make that clearer, we can give the ls command the uppercase F option. So we put a dash and an uppercase F, and F is meant to mean classify, okay, with emphasis on the F, okay? So now when I do that, if I do ls-F, now we can see that the items that have a slash at the end are folders. Now, if I just make a file in our home directory by echoing the word hello into it, I'm going to call it file.txt. So here we're using redirection to create the file. There it is. Okay, you can see this has been made. If I now do ls-f, we can see that the folders all have slashes after them and are in blue, but the file itself doesn't have a slash after it, and its text is in white. So you can see that the ls command allows us to see the difference between files and folders, files and directories. Okay, but something to bear in mind is if I take that ls-f output and put that into another file called list.txt, okay, then I open up list.txt, you can see that there is no colouring, but you can see the difference between folders and files just by looking for the things that end in slashes. Things that end in slashes are the folders, and the things that don't are the files. So, you know, this is really good if you want to save the information to a file and be able to tell at a glance, or make a program tell at a glance what's a folder and what's not, so you can selectively operate on specific files or not. So it's just a cool little shortcut. Okay. Now, a much more useful option than the F option for the ls command is the L option. Now, if I do ls-L, actually let me clear the screen first. If I do ls-L, this puts everything in long form format, and you can tell here that we get a lot more information about our files and directories, including the file permissions over here on the left. Okay, anything that starts with a D is a directory. Okay, and then there's file permissions. So for the user, read, write, execute. For the group the user is in, the group being here is this column, the user is this column. So the user, read, write, execute. For the group, just read and execute, no writing. And for everyone else, just reading and executing. Then you've got the user that the file belongs to, the group the file belongs to, how large the file is, when it was last edited, and what the file is actually called. Okay, so this is the ls-L command is a command that you'll use probably very, very often, because you can get a lot of information about your files, much more than just using the normal ls command. The other thing I should mention is that this column here with all the numbers and the file sizes, this shows the file size in bytes. And to make that a bit clearer, you can give the ls command not only the L option, but also the H option. And the H option stands for human readable. It makes the file size a bit easier to read. So if we do ls-lh, we can now see that it's telling us that the desktop thing is about 4 kilobytes. This is about 4 kilobytes. This one is just 6 bytes. This is 93 bytes, and these are 4 kilobytes. If you had things that were megabytes in size, it would say an M. If you had things that were, gigabytes in size, it would say a G. And in general, it just makes the stuff a bit easier to read. Okay, so that's the ls dash with the L option. You've got the permissions on the file. So if it begins with a D, it's a directory. If it begins with a dash, it's just a file. The first 3 things are the permissions for the user: read, write, execute. The next one is for the group that the file is in. In this case, it just has read and execute, but no write. And then this third column is for everyone else. This is so just read and execute in that sense. This is the amount of hard links to the file, but don't worry about those. This is the user the file belongs to. This is the group the file belongs to. This is the file size in bytes. This is the date the file was last edited, and then this is the file itself. Okay, so I'll make sure that that information is available on the cheat sheet at the end of the section, but now you can start to see, if I clear the screen, that we can now use the pwd command to see where we are, and the ls command to see what's around us. All that's left to be able to understand is how to use the cd command to actually change where we are on the file system so that we can move about. But I think in the interests of time, we're going to save that until the next video. So in the next video, we're going to be covering how to use the cd command to actually change where you are on the file system, and also be going through a few examples to see how these 3 commands work together to help you navigate the file system much faster than would be possible using just pointing and clicking. So for all that goodness, I'll see you in the next video. Hello there, you beautiful people, and welcome to part 2 of navigating the Linux file system. So in this video, we're going to build upon what we learned in the last video about using the pwd and the ls commands, but in this video, you're going to learn how to use the cd command to actually move around the file system. You're going to learn the difference between absolute and relative file paths. You're going to learn some awesome keyboard shortcuts that'll make navigating the file system so quick and so easy, and you're basically going to see how you can put together the pwd, the ls, and the cd commands to elegantly navigate the file system. And by the end of this video, you're going to know everything that you need to know about navigating the Linux file system using the command line, and you watch, with a bit of practice, you'll soon agree with me that doing it this way is a lot faster and a lot more effective than using your pointy-clicky graphical methods that you've been using probably all of your life so far. So let's go ahead and jump right into this next part of your superhero training. Okay, so in the last video, we saw that we could use the pwd command to see where we were on the file system, and we saw that we could use the ls command with a variety of different options to basically look around and list what was in the directory that we're in. But using just these 2 commands, we're kind of stuck in the one place, right? How can we actually move from our home directory? Well, the missing piece is the cd command, and the cd command stands for change directory. So let's say that we used our ls command and we saw that the downloads folder, by noticing that it's in blue, it's a folder, we wanted to go into the downloads folder. How would we do that? Well, we could do it in a few ways. Firstly, we could give the cd command the absolute path for where we want to go. We could go, starting at the base directory, we'd go /, then home, then ziad, then downloads. Okay? And we could type that in like that, and that would totally work. Or, if we didn't want to have to write out the entire path to our home directory, we could just replace all that with the tilde. And we say, okay, go change to our home directory and then downloads. That's where you'd use the tilde. It's a nice little shortcut. Or, what we could use is something known as a relative path. Now, a relative path is a path relative to where you currently are. Okay, so because we're currently in the home folder, how do we get to the downloads folder? Well, let's think about it. If we open up the graphical menu, here we are, we're in the home folder. From here, what do we do to get to the downloads folder? We literally, all we have to do is just click downloads, right? So that, you can say that that's a relative path. We're just going from here to the downloads. That's all we've got to do. So to change to the downloads folder, all we've got to do is type downloads. So if we do that, if we just type cd, and then downloads, just like that, and press enter, you can see that we have changed directory and our shell prompt has changed as well. Before it was just the tilde telling us that we were in our home directory. Now it's saying we're in our home directory and the downloads folder inside that. Okay, so this is this text in blue here shows us the path to where we currently are. And if we use the pwd command now, we can see that we get /home/z/downloads, and we can also look around by pressing the ls command, and we can see that there's actually nothing inside that folder. Okay, so now that we're in our downloads folder, here's a challenge for you. Go ahead and pause the video and see if you can use the cd command to change back to our home directory. So go ahead and pause the video and give it a shot, and then come back to see how you did. Did you manage it? If so, really, really well done. You learn super quickly. Now, you could have done it using an absolute path like this. You could type cd, then /home, / your username, whatever it would be. In my case, it's Ziad, / and that's it. Okay, that would work. Or you could have used a tilde to make it nice and easy. Just use cd and then a tilde. Now, I kind of cheated a little bit because there's another way that you could have done it, and this is the way you'll probably do it from now on, but I haven't shown you this before. Now, by default, if you don't give it any input, the cd command will take you to your home folder. So if we just type cd, like from scratch, just type cd and press enter, you can see by this, looking at the shell prompt, that we've ended up back in our home directory. We can use pwd to confirm that, and it tells us that we are back in our home directory. And that will work no matter where I was previously on the file system. I could have been anywhere on the file system, and all I've got to do is type cd and press enter, and I will end up back in the home directory. Pretty cool, right? Okay, great. So now that we're back in the home folder, I want to show you a very useful option for the ls command that's kind of like wearing x-ray glasses, and it's the A option. Now, the A option is short for all, and it allows you to see all of the files in a directory, even the hidden files. So if I type ls and give it the A option, okay, now if I press enter, you'll notice that we see a whole lot of stuff in here printed out. Okay, if I clear the screen and type you just the ls option and then show you the ls with the A option, you'll see we get a lot more stuff with the A option. Now, a lot of these files, you'll notice, have file names beginning with dots. And that means that they're hidden files or even hidden directories. Okay, now if we look in the graphical editor, we may not be able to actually see them by default, but if we click up here like we did in the last few videos and show hidden files, we can now see them as well. So you can see that we're getting exactly the same output. So that's how you show hidden files using the ls command. Okay, and you may also notice in here that we've got our bash aliases file that we made a few videos ago. Now, the reason that I mention this is because there's two very important hidden folders inside each folder. Okay, they are the dot and the double dot folders. Okay, now these are shortcuts that allow you to move around easier or refer to stuff on your file system a whole lot easier. Now, the dot folder simply refers to the current directory. Okay, so for example, if I go to the desktop folder, okay, then we can print. My apologies. We can do print working directory, and we can see that we're in the desktop. And if I list its contents, there shouldn't really be anything on my desktop, but there always is this dot and double dot folders, which are only visible using the ls with the A option. If I just do normal ls, it doesn't show up. If I do ls-a, they show up. Okay. Now, in here, we've got the dot and the double dot folders. If I try to do cd to the dot folder, bash is basically going to stay where it is. The shell is going to stay exactly where it is. So if I do that, you can see that we're still in the desktop by looking at the shell prompt, because the dot folder refers to the current folder that we're in. Okay, it's just a way of saying this folder. Okay, now what if I went to the double dot? What if I do cd double dot? Okay, you notice that we did actually change, and we're in fact back in our home folder. The double dot folder means the parent folder, or the folder above where we currently are. Okay, so if I go back to the desktop, you can see that we've got the double dot folder. If I press cd double dot, we've gone back up a folder, which brings us into the home directory. Okay, so we're back in our home directory. Let's clear the screen. What if I kept going? Okay, if I go cd dot dot, I'm now in the actual home folder, which is not my home folder, but it's the folder above my home folder. Okay, let's keep going. CD dot dot. And now we're actually just in the slash folder. We're in the base directory for the whole system. Okay, see if we can go any higher. If we go CD dot dot, you can see that we can't go any higher because the slash folder is the highest point on the file system. Okay, we can actually have a look around. If I do an ls, what's in our base directory? We can see there's quite a lot of files here that you saw when we had a little bit of an explanation of the file system. You've got the bin folder, the boot folder, the dev folder, the etc folder, which is full of your configuration files, the home folder, which is where we just were to get our home stuff, the libraries, media, which is where you have your removable hard drives, your optional stuff, the root users home folder, and so on and so on, the variable files, temp files, user stuff, and so on and so on. Okay, these are the folders. The most important of these anyway are the ones that I gave you in that cheat sheet where we talked about the file system. Okay, and now let's see what happens now. This is the root users home folder, right? This is the home folder for the administrator. Let's try and see what happens if we try to enter it. If we do cd root, okay, and press enter, you can see that we get permission denied. Okay, so there's some folders that you're allowed into and some folders that you're not allowed into. So we don't have enough privileges to be able to access the root user's home directory. Aww. Well, what about the etc folder? Okay, the one with the configuration files. Let's try that. If we try cd etc, aha, we can get into that one. Let's see what's in there. If we press ls, ooh, you can see there's a whole bunch of stuff in there, right? And there's some folders in here. There's the blue ones are folders and the white ones are files, and some of them have different types as well, but you know, don't have to worry about that. Mostly what you'll see are blue and white. Blue ones folders, white one files, and you can enter anything that you want in there. For example, there's one here, where are we looking? There's one here called dhcp. We could go into that folder. We could try cd dhcp. Okay, now what's in there? We could do ls and we could have a look around. We can see there's other stuff in there. There's another one there, dh client enter hooks.d. Let's try to go there. dh client dash enter dash hooks.d. You can see that we're in there. What's in there? So ls, we can see there's other stuff in there. The green ones here are programs. But you can see here, right, the way that we are moving around the file system using either cd to move, ls to see what's around us, or pwd to confirm exactly where we are. And it's this way that you will actually move around the entire system, and it doesn't change no matter where you are. As long as you've got the permissions to enter those folders, you can get there using just the cd command, and you can look around using the ls command, and you can confirm where you are using the pwd command. Now, how do we get all the way back to our home folder? Very easy. Just press cd, press enter, and we are back in our home folder. So you can see that pretty much anything that you need to do in the Linux file system, anywhere in the Linux file system that you want to move to, as long as you have the required permissions, all you need are the cd, ls, and pwd commands, and you can get wherever you want. And if you get lost, just use the pwd command to check where you are. Pretty epic, right? So now that we're back in our home folder, there's one final thing that I want to teach you, and that's called tab completion. But for that goodness, as well as a summary of everything we've learned in the past few videos, I'll see you in the next video. Hello there, you beautiful people, and in this video we're going to be wrapping up our discussion of how to navigate the Linux file system using the command line. And in this video you're going to learn how to use tab auto-completion to speed up your navigation of the file system, and we're also going to have a recap of everything that we've learned about navigating the file system in the past few videos. Now by the end of this video you're going to have all the knowledge that you need to navigate the file system like a pro, just add practice, and you're going to get plenty of that as we go through the course. So to get the final few pieces of information about tab auto-completion, let's go ahead and jump right into it. Okay, so let's go ahead and learn about a really awesome feature known as tab completion. Now at the minute we're currently in our home directory, as you can see by looking at the shell prompt and also by using the pwd command, we see that we're in our home directory. Now we could actually jump all the way to the base directory of the system by just typing cd and then a slash. And if I do that, you'll see that if we use the print working directory command, we can see that we are in the base directory of our system. And I want to do this just to highlight that you don't have to go folder by folder when you're using the cd command. You can actually just jump all the way around your system. So for example, if I wanted to jump all the way to my desktop, I don't have to go cd then slash, I don't have to go step by step all the way through. I can just say cd, give it the tilde, and then say, because that's my home folder, and then say desktop. Okay, and there we are. We end up in the desktop. So you can use the CD command to jump around. You don't just have to go step by step. Okay, so clearing the screen, let's go ahead and now learn about tab completion. So let's say that we wanted to get all the way to my home directory using an absolute path. Okay, we could do that simply by just typing it all out, right? We could type cd/home/ziad, and if we wanted to go to documents, we could type /documents, and we would be there. Okay, we would get all the way to the documents folder. But typing that out, it takes a bit of time, it's error prone, and we're kind of lazy as programmers. Okay, so we want speed and we want things to be without errors, and we want things to work right the first time. So that's where tab completion comes in. Let's head back to our home. Let's head back to the very base directory and clear the screen. pwd, we're in the base directory. This is how you could use tab completion to get there. Remember, we want to get to the documents folder. Okay, so that's going to be like this. Okay, that's where we're trying to get to. So let's see how we would get there. We type cd, then a slash. Now, instead of typing out home, we could just type out h and press the tab, and you'll see that the shell automatically completed that piece of text for us. Now, that's pretty cool. Let's try and type out ziad. So we just type z, and then we press tab, and it's filled out my name. Awesome, right? Now, let's say we want to go into documents. Okay, let's type a capital D and press tab. Now, why isn't that working? Let's try again. Okay, well, it's not working. Well, the reason is this capital D could refer to lots of things in our home folder. So let's take a look at it. If we go to our home folder here, clear the screen, and take a look, you can see that the capital D could refer to the desktop, it could refer to the downloads, or it could refer to the documents, and it's the documents that we want. Okay, so if I say, okay, I want to go to the capital D here and press tab twice. Well, if I just press it once, it won't work. If I press it twice really quickly, just like that, it will actually, it's a lot. It will actually, let me clear the screen. It will, press it twice. It will actually tell us which ones it matches. Okay, so we want to go into documents. So if I type doc, okay, because if I type do and double tap, that's still no good because it could go for documents or download. So if I type doc and then press tab, now it's going to go to documents. Okay, and there we are, we're in the documents folder. So that's awesome, and it cut down our level of typing and error proneness massively. So if we go all the way back to the root directory, now we can just type cd /h tab z tab doc tab, and there we are, we're in the documents folder. Okay, so that's really, really cool. This will work for file names just like it will for folders, and it's amazing, and I use it all the time. Okay, now there's one final awesome trick. Let's navigate to the desktop the graphical way. Okay, so we're going to go into the GUI, and we're going to get to the desktop. Now, to actually open a terminal so that the shell is operating from in this directory, you can right click, and you'll notice that you'll see an option here that says open in terminal. Okay, so if we click that, you can see that we've got a terminal that's automatically opened in the desktop. So say for example you're doing stuff and you're navigating files in your, I don't know, in your documents folder. Okay, we've got some files in here, let's say. Then you could actually just right click and click open in terminal, and you're directly now operating in your terminal from within that documents folder. So if you're doing stuff graphically and then you want to switch to the terminal and then switch back, this is a nice shortcut to be able to use. Okay, so you've learned a whole bunch of stuff in the last 3 videos or so about navigating the Linux file system. So I just wanted to take a bit of time to have a quick recap of what we have learned to make sure that it's all sunk in. So you know that you use the pwd command to print the current working directory that the shell is operating in, and it will print out an absolute path to where on the file system your shell is currently operating. You can use the ls command to see what's around you when you are in that directory. It just lists out the contents of the directory. Folders are in blue and files are in white, but you can make that easier to see using the capital F option, and we went through several other options that the ls command can have to make viewing things and viewing files in the command line a lot easier. You saw that the cd command can be used to change directory or move to a new location on the file system, and you saw that absolute paths are paths that start at the very base directory of the file system, so the slash, and relative paths are the paths that start from the directory that your shell is currently in. So relative paths are usually easier to type, but absolute paths are very clear as to where they end up. Okay, now every directory has the dot and dot dot hidden folders that you can see using the ls command with the A option, and the dot, the one dot means the current folder, and the two dots refer to the parent folder of where you currently are. So if you did cd and then did dot dot, that would move you up a folder. Okay, because it's saying go to the parent folder of where I currently am. And if you did cd dot, then that would just basically keep you where you are. It wouldn't make any difference. Okay, now tab auto completion we saw in this video, and we saw that tab auto completion is a really useful technique to speed up typing and avoiding errors. And if you press tab and nothing happens, just hit tab twice really quickly and it will show you several options that are conflicting, and you can just then type out a bit more to make sure that it selects the one you want. So like we saw when we typed the capital D, it wasn't working, but if we pressed tab twice, we could see that it was clashing with documents, downloads, and desktop, and then we could modify it thereon to make sure tab auto completion worked. But you'll use tab auto completion all the time. It saves you so much time and so much hassle. It's a great feature that the shell has, and it can also be used anywhere, not just when navigating. So if you are trying to enter an argument to a command and it's a file path, you can use tab auto completion to there as well. It's not just when using cd or ls or whatever it might be. You can use it for pretty much any command. And if you want to open up a terminal where you currently are when you're navigating graphically using the graphical user interface, just right click and click open in terminal, and a terminal will open up with the current directory being exactly where you were when you opened that terminal. So that's a really useful feature as well. If you just need to make some quick edits on the terminal and then shut it again and get back to doing what you were graphically, it's a great feature, so make sure you keep a hold of that. So we've covered a whole bunch of stuff in the last few videos, and now you should start feeling comfortable with how to navigate. You just use PWD to see where you are, ls to look around, and cd to move. And in the next video, we're going to start discussing file extensions in Linux, because they don't work like they might do on other operating systems. And there's quite a few cool freedoms that file extensions let you have when working in Linux. So for that goodness, I'll see you in the next video. Hello there, you beautiful people, and welcome to this video all about file extensions in Linux. Now, on operating systems such as Windows, file extensions allow you to tell what type of file that you're dealing with at a glance. For example, we know that files with names ending in .txt are text files, and files with names ending in .jpg or .png are likely to be images. But in Linux, file extensions usually don't matter, and the system tends to look at the contents of the file rather than just its name. But sometimes file extensions really do matter. So in this video, we're going to take a bit of a deep dive into understanding file extensions in Linux and shine some light onto their strange behavior. And by the end of the video, you'll know what freedoms the Linux operating system gives you when naming your files, what interesting things can happen and what you need to be aware of. Oh, and you'll also have a new command in your toolkit that will help you when dealing with files on your file system. So this is all very useful stuff, very exciting stuff. Let's go ahead and jump right into it. Alright, so I've gone ahead and put some files here on my desktop. First of all, I've got an image of Tux, the traditional penguin logo for Linux here, in PNG format. Now Tux, in case you're interested, is short for the word tuxedo, which is a fancy type of black and white suit usually worn by waiters and poshly dressed people at high-class parties. Now penguins are said to look like they're wearing little tuxedos because of their black and white colouring, and that's where Tux gets his name, from the word tuxedo, in case you were interested. But besides a picture of the lovely Tux here and random trivia, I've also got a text file here with some Shakespeare in it called shakespeare.txt, and I also have a spreadsheet file with some random numbers in it. Okay, so let's go ahead and take a look at the file command to see how Linux handles file types. So if I go ahead and open a terminal using the Control Alt and T keyboard shortcut and just drag it a bit out of the way so we can still see the files, I'm going to introduce you to a new command called the file command. Now the file command will tell us basically what type of file that we are dealing with. So for example, if we try to have a look at Tux here, if we do file tux.png, we actually need to go to our desktop first. So let's shift over to our desktop, clear the screen, and do file Tux, and I can actually just so you see, I can actually just with TU go ahead and press tab and it will auto-fill that as well, just showing you that tab auto-completion works perfectly fine for file names, just like it does for folders. So it's a great thing that we learned in the last video. Okay, so let's have a look. File of tux.png, and it will tell us that this is PNG image data. It'll tell us the size of the file and loads of other stuff as well. Okay, but it tells us the file type. Okay, now if I rename tux.png, okay, if I rename this to tux.jpg, okay, which is another type of image file, okay, you can see that it's been renamed there. But now let's do that again. Okay, let's try file of tux.jpg, and let's see what happens. Now you can see here that it still says that it is a PNG file. Now this is important, point number 1. In Linux, file extensions don't matter. Okay, unlike Windows, Linux doesn't determine file type using the file extension, but instead it reads a piece of code inserted at the top of every file. Now that piece of code is known as a header, and it serves as a kind of label for Linux to read, and when Linux reads that label, it knows the file type. So changing just the name of the file won't make a difference because that file header won't have changed. Okay, so here we have some Shakespeare script in text format. So if I open that up, you can see that there is plenty of text in there, which I just copied and pasted from Romeo and Juliet. Okay, so because that's the kind of stuff that I do. So when we check that the file type we have here, if we do file shakespeare.txt, it'll tell us that it is an ASCII text file. Okay, but now if I try to turn this into a PDF, so if I rename it and try to say, okay, this is now shakespeare.pdf, okay, and I rename it. Now the system, it appears to have changed the icon, right? It looks like that's a PDF file. But if I try to run the file command again, file shakespeare.pdf, it still tells us that it's ASCII text. So Linux read the header of the file and saw that it was still a text file. But what happens when we try to open it? Because it looks like the system thinks it's a PDF, because you can see the logo's changed, but it's still telling us that it's a text file. What's going on there? Why does it think it's different? Well, if we try to open it, what happens? Well, now we get an error. Okay, we see that the default program to open files with names ending in .pdf is a PDF reader. And when we try to open this file in the PDF reader, we get an error from the program as it's trying to open our file as a PDF file. And what the system basically did is say, that's a file that ends in .pdf. It's probably a PDF file. So let me be helpful and allow the user to open it in a PDF viewer. Now, obviously, a PDF reading program isn't designed to read text files. It's designed to read PDFs, and that's what's causing the issue here. Now, this is important. This is an important distinction to make. Important point number 2, although the operating system will know what file format the actual file is by reading the header, the extra programs that are installed on top of the operating system, such as this PDF viewer, are trying to open the files that might require certain formats or other file extensions in order to work. So what's happening is to make this automatically want to open as a PDF, it just saw the file name. It just looked at the file name, but the content is still text. And it says here, file type plain text is not supported. But the program got tricked. It saw the file name, and that's why it wanted to open it as a PDF. If I rename it back to text, just change the text, change that back, you'll see now that it will open fine as a text file. Okay, so that's the important distinction to make there. The programs that are installed on top of the operating system, such as PDF viewers and stuff like that, they might need the file to have a specific file extension in order to open them, but the operating system itself does not care. So let's see this in a bit more detail. If I take a look at the spreadsheet, here it's called data.ods. If I do file of data.ods, okay, it says that it's an ODS file, which stands for Open Document Spreadsheet. Okay, now this means we can open it up in LibreOffice Calc, which is basically the Linux version of Microsoft Excel, okay, or the Apple equivalent. It's like this spreadsheet program, okay, and it's got a few numbers in there, okay. But now if I close the spreadsheet and rename that, for example, to a .txt file, okay, so if I rename it to data.txt, rename that, okay, you can see that now it wants to be opened up in a .txt format. Okay, and now I try to open that up in LibreOffice Calc. So if I click up here, I type Calc, and it comes up. I click LibreOffice Calc, wait for that to boot up, go on File, Open, go to my desktop, so Home and then Desktop, and then try to open up data.txt. You can see now that we've got all kinds of problems happening here, okay? So if I try to just open it like that, let's try and click OK, we're going to get an error, okay? And this is because the .txt file extension is fooling LibreOffice Calc. LibreOffice Calc made the mistake of reading the file extension and trying to open the file as a .txt file, okay? Whereas the actual content, as we can see here, is a spreadsheet file. It's not a text file, okay? But if we rename that back and we rename it so that it's data.ods, now it will open fine. So this is the important distinction that we need to make. I'm going to hammer this home. The file extension isn't important to the Linux operating system, but it might be important to the software packages that we install on top of Linux. So do bear in mind that don't give your file names really weird file extensions that don't match their content, because it might confuse third-party software that is installed, okay, even though you don't necessarily have to. Okay, so let's give the spreadsheet a completely, now let's try something else. Let's see something quite interesting. Let's give the spreadsheet a completely made up file extension. So if I call it spreadsheet.shablam, okay, I'll call it spreadsheet.shablam. Now, isn't that interesting? Notice how it automatically still wants to open it up in the spreadsheet software. Now, we notice here that we didn't fool the software, and it still knows it's an ODS file. And we can actually open it up. If I just go ahead and double click that, it's going to open up perfectly fine. You see we've got our data in here. No funny business this time. So why can it open up a weird file name but not a simple one like .txt? Well, the reason is the software just simply didn't recognize the .shablam file extension, so it might have looked to the operating system to help determine the file type instead. But when we called it a .txt file, when we actually named it directly to be .txt, the software thought it would be a bit clever, and it thought, aha, I know how to deal with this, and it made a little bit of a shortcut to itself and was like, I'm just going to open this automatically as a txt file. But that assumption was wrong in this case, because the content is a spreadsheet. We just named it .txt, and that caused the program to throw an error when it found out it wasn't a txt file after all, but actually was a spreadsheet. Now, the bottom line is that you have a lot of freedom to name files whatever you want in Linux. You can even call them, you can even give them file extensions like .shablam, which of course you couldn't do in any other operating system. This is common for having files, for example, if I just try and copy and paste this, if I copy and paste this file, you might have a backup. You might, for example, call one file an original, so you'd say, okay, I'm going to call this one .orig, and then I'd call this one, maybe I'd call another one .back, or, I copy it and call it .copy, or something like that, okay? And this is how you might name your file. So I'd be like, this is the original, this is the copy. I can see just by looking at the file name without it actually affecting the way the system works. So this is sometimes used to allow people to read file extensions that are a lot more human readable than, things like .ods or whatever, okay? But just make sure that if you name your files in such a way, don't give them file names that might confuse the software that you expect to open them, because not all softwares like to play ball with strange file names. Okay, so that will bring our discussion of Linux file extensions to a close. So as a summary of what you learned in this video, you learned that you can use the file command to know for sure what type of file that you're dealing with, and you learned that file extensions aren't important to the Linux operating system, which means you can name files whatever you want. Yes, even .shablam. But while you're doing that, make sure you try not to confuse third-party software that might need to open the file, because it might be expecting specific file extensions. And if you try to confuse it, then you'll just get errors and a very, very bad time. So Coming up next, in the next video, we're going to take your command line skills to a whole new level by looking at the concept of wildcards. So let's say you had a really messy desktop and you wanted to move all of your images to one folder and all of your PDFs to another folder and all of your spreadsheets and office files to another folder using the command line. How can you use a command that's actually so specific? Well, you can do that using wildcards. Wildcards allow you to make your commands really, really specific and also really general, thereby allowing you to level up your control over what commands actually operate on. Now, this is an incredibly useful ability when dealing with files, so for another dose of epic superpowers, I'll see you in the next video. Hello there, you beautiful people, and welcome to this video where you're going to be learning about wildcards. Now, other than having an awesome name, wildcards are very useful tools that will make your commands a lot more precise, a lot more expressive, and a lot more powerful. Now, in this lecture, you're going to learn about the most common types of wildcards, and you'll see how they can be very useful for manipulating files in Linux. And by the end of the video, you'll know how to use some of the most common types of wildcards, and you will also have the ability to create more powerful commands. So let's go ahead and get right into it. Okay, so first let's take a look again at the ls command. Now the ls command will list the contents of every directory that we give it a valid path to. So for example, let's say we wanted to list the contents of our documents directory. We could do ls and then give it a path to our documents directory. Okay, so we'd use the slash and then maybe we'd throw in a bit of tab completion and get it to list out our documents. Or if we're already in our home folder, like we are now, as you can see, we could just say list out documents and that'll do fine. But what if we wanted to have a look at what's inside our documents folder, our downloads folder, and our pictures folder at the same time? Well, let's clear the screen. The way we do that is we just say ls, then documents, bit of cheeky tab auto-completion, downloads, bit of cheeky tab auto-completion, and some pictures with a bit of cheeky tab auto-completion. And then if we go ahead and press enter now, you'll see that we can actually see the contents of each directory are listed. So far, so good. But you can see how manual of a process this was, right? We had to type out documents, then type out downloads, and then type out pictures, even with tab auto-completion, in order to pass them as command line arguments to the ls command. Now, wildcards are basically special symbols that the shell interprets to have a special meaning. The idea behind wildcards is to build up powerful patterns known as regular expressions so that instead of typing out every command line argument manually, you can instead say something like, hey Linux, make this command act on anything that matches this pattern. The patterns are known as regular expressions, and you can think of wildcards as being some of the useful building blocks for creating regular expressions. Now, using wildcards to build regular expressions gives you lots of flexibility and control over how your commands work and can save you a whole bunch of typing. And using regular expressions makes your commands a lot more expressive. So for example, instead of expressing the ls command, like list out the contents of this folder and this folder and this folder, which is the way that we would usually be using it with command line arguments, right? We'd be saying ls do documents and downloads and pictures, downloads and pictures, okay? That's how it works like that. You've got to list them out manually. Instead, you could just do something like, hey, why don't you just list out the contents of every file that starts with the letter D? For example. Or if you're removing files, instead of saying remove this file and this file and this file, you can say remove every file in this folder as long as its name ends in .txt, for example. Or if you're copying files, instead of saying copy this file and this file and this file, you can say copy every file from this folder and this to this other folder as long as its name ends with .pdf. Okay, so now that we understand that we're using wildcards to build these patterns, these regular expressions, let's start building some regular expressions using wildcards. Now, one of the most used wildcards is the asterisk or the star wildcard. Now, I find the star by pressing Shift and 8 on my keyboards. If I press Shift and 8, I get this star come up. If you ever use Microsoft Excel or a software spreadsheet package, it's the symbol you use to do multiplication, but I find it using Shift and 8 on my keyboard. It might be different on yours, but it's that symbol we're looking for. Now, wildcards each match a specific pattern, and the asterisk or the star wildcard matches any piece of text regardless of the length of that text, and it also matches numbers. So let's say that we wanted to check the contents of every directory in the home folder. Let me clear the screen. If I clear the screen, instead of listing them all out, okay, because there's quite a few folders in here, right? Instead of saying, okay, ls desktop and documents and downloads and so on, all we have to do is just do ls star. Okay, so if I do that, you can see that it has just listed out all of the contents of the home folder, the desktop, documents, downloads, music, pictures, public, templates, and videos all in one go. So let me clear the screen. Okay. So how did that happen? The reason that happened is because the star matches anything. Okay, so what you need to think of is when you give a command a regular expression to work with, imagine it putting as command line arguments anything that matches that pattern. Okay, so because the star wildcard matches anything, it put everything as command line arguments to the ls command. Does that make sense? Let's take another example. Okay, so let's say I just wanted to list out the contents of the folders starting with D. So the desktop, downloads, and documents folders, okay? What I could do is I could say, okay, let's do ls, then a capital D, and then a star. Now, the pattern is this bit, okay? The pattern is the D, then the star, okay? And the star is one of the building blocks, but so is the letter D. So what we're saying here is list out, then giving it as a command argument, anything that has a D, a capital D, and then followed by anything. So basically anything that starts with a capital D. So if I do that, you can see that we just see the desktop, documents, and downloads. And you can see that they all match this pattern, this D star. They start with a capital D and then are followed by anything. They start with a capital D and then are followed by anything. What if we just want documents and downloads? Well, they start with DO and then are followed by anything, right? So if I do ls, DO, then anything, you can see we just get documents and downloads, but desktop is ignored. Now, something that is important to remember here is that these wildcards and these regular expressions are case sensitive. So if we did ls, D, and then a star, notice how the D is lowercase, you can see that we get nothing. Nothing comes back because nothing starts with a lowercase d. But if we do capital D, now that will work. Okay, so that's really awesome. Let me just clear the screen. You've seen a few ways that the star wildcard can be used to match any text, and you've seen some ways that it can be used to build regular expressions. Now, there are a few other common wildcards that you'll likely use when working with regular expressions and wildcards, and the first is the question mark wildcard. Now, the star wildcard will match anything regardless of length. So, for example, if I do something like star.txt, that could match anything as long as it ends in .txt. Okay, so if I do ls star.txt, you'll see that we only see things that end in .txt. Now, it doesn't matter if what at the beginning that comes before .txt is one letter long, one number long, or 100 letters long, or is full of numbers or whatever. It doesn't matter if it's 1,000 characters long. It'll still match because the star matches anything. But the question mark wildcard will only match one place. So if I do question mark.txt, okay, if I do ls now, nothing will actually show up, okay? Because the question mark, this says, basically what this says is, show anything that ends in .txt but only has one thing before it, okay? So this would match things like a.txt, or q.txt, or l.txt, or 1.txt, okay? You notice how they've all just got one place just before the .txt. Okay, the question mark is a way of saying it's like a placeholder for just that place, whereas the star, it doesn't matter how long it is. Okay, so the question mark wildcard allows you to maintain the generality of the star wildcard because it doesn't matter what it matches. It could match a number or it could match a letter, but it allows you to limit the length. Okay, the star doesn't put a limit on length. Whereas the question mark does, but it doesn't really matter what fills that place. Okay. Now you'd usually use the question mark wildcard when you want to build a general pattern, but care about the length of the file name. Okay. So if we did something like question mark .pdf, then that would match things like A1.pdf or B2.pdf or HA.pdf or, Z7.pdf or something like 77.pdf. You see how we're just taking up two spaces and then .pdf? That's what question mark .pdf would do. Okay, we're saying we're going to fill it with two things, two spaces. We're not sure what's going to go there, but there's got to be two spaces, two places, and then .pdf. Okay, so that's how that works. Okay, that's the question mark. Now, another type of wildcard is the square brackets, which are these ones here, these square brackets here. Okay. Now, the square brackets wildcard is similar to the question mark in that it will only match one place, but instead of matching anything like the question mark will, square brackets only allow the pattern to be, they allow it to be more specific and only match the letters or numbers if they belong to a given set of options. Probably a bit easier for me to show you than to explain. Okay, so let's say we had 6 files. We had file A.txt, we had file B.txt, we had file C.txt, and we had file 1.txt, file 2.txt, and file 3.txt. Okay, which hint, if I do an ls, we actually already have those in our home directory. Okay, so let's say we wanted to match the files that just had numbers in the file name. Okay, so file 1.txt, file 2.txt, and file 3.txt, but we don't want the ones that have A, B, and C. Okay, to do this, we could do ls, then file, because the name's got to start with file, then open the square brackets and give it a bunch of options. We could say 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. .txt. Okay, so what's this? Basically, everything in these square brackets is an option that could fill that one place. So anything that goes file and then either 1, 2, 3, 4, 5, 6, 7, 8, 9 or 0, any one of those, then .txt. Okay, so if we do that, you see that we get file 1, file 2 and file 3, but we don't get the A, B, and C because they're not part of the options, right? From our given set of files, that just matches file 1, file 2, and file 3. Now, but what I want you to notice is how this wouldn't be possible using either the star wildcard or the question mark wildcard. If we do ls file question mark.txt, the question mark will match anything, okay, but only one place. If we do the star, you're going to get... I need to ls it. You're going to get basically the same thing as well because these don't restrict what goes in that place. The star will have anything regardless of length. The question mark will need just one place, but it doesn't care what fills it. The square brackets also only have one place, but they allow you to restrict what goes there. So they're like the most restricted. It's like a very restrictive kind of wildcard. Now, you may have noticed that typing out all these numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 is a bit of a hassle, right? So the shell makes it a bit easier for us. We've got a shortcut. We can just do file 0 to 9. And that gives us exactly the same thing. So instead of having to type out all the numbers, it's much easier, which is really useful for when you want to work with the alphabet and you can go A to Z. And that will work perfectly. Okay. What if you want to match 2 digits? Okay. So what if you wanted something like file 11? Okay. How would I do that? Well, the way you'd do that is you'd say ls file, then for the first digit 0 to 9, then just give it another digit 0 to 9, then .txt. Okay. So this one becomes the first digit. This one becomes the second digit. What if I wanted to have a number and then a letter? Well, that's easy. Just change that to letters. What if I wanted to have a number, then a letter, then a lowercase letter? Well, that's simple. Just change that like that. And you can see now we're going to have file, then one space, which can have the numbers 0 to 9, then another space, which can have the letters A to Z in uppercase, then another space, which can have the letters A to Z in lowercase, and then ends in .txt. So you can see just how powerful these regular expressions can become just by adding a few simple wildcards. We could also, what if we wanted to have the numbers 0 to 9, but also the letters A, B, and C? You can do that as well, just like that. And that's going to show up exactly what you'd expect. Anything that has the word file, then one of the numbers from 0 to 9, or the letters A, B, and C in uppercase, then .txt. If I reduce that to lowercase, A, B, C, now we'll just get file 1, 2, and 3 because these wildcards and these regular expressions are case sensitive. So you can see wildcards are really, really powerful stuff, guys. And the only three that you really need to know are the star, which matches anything, the question mark, which matches anything but only for one place, and the square brackets, which allow you to match just one place, but they also allow you to define what matches. Okay, so that's enough wildcard goodness for now. Wildcards can make your commands a lot more expressive and give you much greater control over how the commands work. And using wildcards in this way to search for file names actually has a funny name, and it's called globbing. So if you ever hear the word globbing floating around, it just means using wildcards to look for file names, just like we've done in this video. So before closing out, let's take a quick recap of what we've learned. First, you learned about the concept of regular expressions. And regular expressions are basically patterns that a piece of text needs to match. Okay? And anything that matches that pattern will be passed as a command line argument to the command. Now, the star wildcard matches anything, regardless of length. The question mark matches anything, but just for one place, and the square brackets match just one place, but allow you to specify options that, will actually be matched. So unlike the star and the question mark, which will match anything, the square brackets allows you to choose what will be matched. And of course, you can just type letters and numbers in that you want specifically to appear as well. So if I did capital D, then star, that means anything that starts with a D and then has anything afterwards. So you can type letters and numbers in there as well. You don't just have to only use the star, question mark, and square brackets. Okay, so with wildcards understood, you now have a very solid foundation for learning about the different ways to manipulate files in the file system. Now, each of the commands to create, delete, move, copy and paste files and so on is actually rather simple. And when you learn them, you might wonder what's the point of actually learning how to use them instead of just pointing and clicking. But by knowing how to use these commands along with wildcards, you'll be able to manipulate hundreds of files at once and with complete control, to the point that pointing and clicking will soon seem like a very slow and sluggish way of doing things, believe me. So up next, you're going to have a quick quiz to help you cement your understanding of wildcards, because, practice makes perfect. And then in the next video, you're going to learn how to create files and directories using some new commands. And you're also going to combine those commands with wildcards to make them even more powerful. You'll even learn about how something called brace expansion, which will show you how you can create 3 folders with 100 files in each of them using just 1 or 2 commands. Don't believe me? Well, I guess I'll see you in the next video. Hello there, you beautiful people, and in this video, the time has come. Over the last few videos, you've been learning about the structure of the Linux file system. You've been learning how to navigate the Linux file system using the command line. You've been learning about file extensions in Linux and how they differ from what you might find on other operating systems. And in the last video, you've learned about wildcards and how you can use them to turbocharge your workings with the command line. But in this video, you're going to take your first step from just looking at the Linux file system to actually modifying it by learning how to create files and directories using the command line. And in this video, you're going to learn how to use the touch and the mkdir commands to create files and directories. And by the end of this video, you're going to be able to create your own files and folders using the command line. And then in the video after, we're going to show you how to take what you learn here and turbocharge it by combining it with wildcards, so you can create like a bajillion files and folders in just one command. And that's not even an exaggeration. Let's go ahead and jump right into it. Okay, so the first command we want to take a look at is something called the touch command. And the touch command can create new empty files. So let's say that I want to create a new file called file1 on our desktop. So if I just head over to the desktop and I try to create a file called file1, all we have to do is type touch file1. And we can see here that file 1 has been created and it's appeared. Okay, that's pretty awesome. Now, you don't have to do this in the directory that you're in, by the way. So for example, if I did something like touch and then said I want to put that in the documents folder and make another file called distant file inside the documents folder. Now, when I go ahead and take a look inside the documents folder, we can see that distant file has been created. And remember that these files here are all completely empty. They're just blank files when you use them, when you create them using the touch command. So that's pretty cool, right? Now, the files that we create with the touch command are completely empty, as I said, but if we want to create files that actually have some content in them, that's where we can use the echo command to redirect content into it. So I'm on the desktop. If I want to use the echo command to make a file called hello.txt and want to put the content, just the text hello in there, then I just type hello and redirect that into hello.txt. Now, redirection, when you redirect to a file that isn't made yet, the shell will automatically create that file and put what was going to go inside it. So if I go echo hello and then redirect that to hello.txt, the shell will create the file, and when we open it, we'll see that hello is inside that file. So that's another way of creating files. Okay, so that's how you use the touch command to create files. Let's see how you might go around creating folders, making directories. Okay, so the way you make directories in the shell, if I just clear the screen, is with the mkdir command, which stands for make directory. Okay, so make folder, and it works basically the same as the touch command. So if we try to make a folder on our desktop called folder, then all I'd have to do is type mkdir and call it folder, press enter, and we see that a new folder called folder has appeared. Pretty cool, right? Again, this can happen at a distance. It doesn't have to be in your current working directory. So if I wanted to make a folder in our pictures directory called holiday, okay, and I press enter, then I can check that in two ways. I could press CD to go back to our home directory, go into pictures using CD, and when we take a look, we'll see that the holiday folder is there. We can have a look in our graphical user interface as well. We go pictures, and we've got a folder called holiday that exists right there as well. Pretty cool, right? Now you can, instead of creating folders one at a time, you can actually create entire folder paths all in one go. So I'm back on the desktop, and let's say I wanted to create this path. I wanted to create blah slash thing slash shablam. Okay, but I can't go ahead and make that in one go because the shell's going to give us an error, and it's going to say that the blah folder doesn't exist. This is because the shell tried to go to blah, then to thing, and then create shablam. Now that's just the most ridiculous sentence in the course so far, don't you think? Anyway, if we tried to give the mkdir command the p option, so we do mkdir, give it the p option, it will then create the entire path, even though none of the folders exists. So if we do blah slash thing slash shablam, and type it like that, and press enter, we'll see that now we've got blah, and inside there we've got thing, and inside there we've got shablam. So that's really cool. We made the entire path all in one go. How awesome is that, right? Now there's something to bear in mind when creating new files or directories, and that is to try and avoid putting spaces in the name. So for example, if I create a folder called happy birthday, if I type mkdir happy birthday, you see that what actually happened is we created two folders, happy and birthday. And that's because there was this space in between the text, and that basically made it two command line arguments. Okay, we gave it one input, which was happy, and one input, which was birthday, but we wanted to be just one input, happy birthday. Okay, just one input. So how do we do that? Well, actually, the way you do that is you do mkdir, then surround it in quotes, happy birthday. And when you do that, you see we get one folder called happy birthday. But just in general, having folders or files with spaces in them is just a bit of a nightmare in Linux, okay? Because of this whole space issue and the command line arguments and all that stuff, okay? So usually what you want to do is, instead of having spaces, have underscores instead. So instead of having happy space birthday, usually what you'll want to do is have underscores instead, underscores being this little symbol here. So here you can see that we have another folder but with an underscore instead of a space, and that just makes it work a lot nicer with tab auto completion, okay, and just loads of other stuff like that. It stops you messing up your command line arguments and things like that. Okay, another thing, of course, I think I've mentioned this multiple times, but folders and file names are case sensitive in Linux. So if I do mkdir happy underscore birthday, that's a completely different folder to happy birthday in lowercase, whereas on something like Windows it actually wouldn't be. Okay, so that's a quick overview of how to create files and folders using the touch and mkdir commands. In the next video, I'm just going to break it here. In the next video, we're going to take it up a notch and start combining all this goodness with wildcards and a really powerful ability called brace expansion, which is going to allow us to create hundreds of files and folders all in one command. So let's go ahead and cut it right here, and I'll see you in the next video. Alright, so now that you know how to make files and directories using the touch and mkdir commands, let's take it up a notch and mess around a bit. So let's say that you're working on a big 5-year project, and every month, because the admin staff hate you, you need to write 100 memo files to keep track of the project. And the folders should be named something like Jan 2017, Feb 2017, March 2017, and so on for 5 years. And in each of these folders, there should be 100 files. File 1, File 2, File 3, all the way until File 100. How can you create those files and folders up front? Well, doing it graphically would be horrific. There's actually just no way around it. There would be a whole lot of copying and pasting and a whole lot of renaming, and your right-click finger would be basically in agony by the end of the whole ordeal. But let me show you how easy it is to do on the command line. So to make this possible, we're going to use a powerful feature of the shell known as brace expansion. Now this is totally awesome. Check this out. So let's go ahead and open our terminal using our Control Alt and T keyboard shortcut. And then what we're going to do is we're going to head over to the desktop using our CD command, and we're going to make a big folder called project. Okay, and there we are. It has appeared. Now in here, let's go change into that project folder. We can see that now we're in the project folder on the desktop, and this is where the magic happens. Okay, we need to make 60 folders, right? And they should all be in the format Jan 2017, Feb 2017, Mar 2017. Okay, so like three letters, then 2017, all the way up until December 2022, so DEC 2022, okay, which is when the project ends. So what if I told you we could make all of those folders in one line? This is all possible using the power of brace expansion. So here comes the command, okay, and what I'm going to do is I'm actually going to maximize the screen because it's kind of a big one. What we're going to do is we're going to type mkdir, okay, then we're going to open up a pair of braces, and the braces are these squiggly brackets here. And then we're going to type, without any spaces, Jan, comma, Feb, comma, March, comma, April, May, June, July, August, September, October, November, December, without any spaces at all, okay? Then we're going to type an underscore. Then we're going to open up another pair of braces, okay? Then 2017, 2018, 2019, 2020, 2021, and 2022. Whew! So that's quite a long command, right? But what's happening here is something called brace expansion. And here we have some braces. So we've got one set here and another set here for the years. And the way that the shell is going to expand these braces is similar to how you would expand brackets in algebra class, okay? So what would happen first is you'd get January 2017, then February 2017, then March 2017, and so on until you get December 2017, okay? Then it'll just start all over again. You'll get January 2018, February 2018, then March, April, May, June, July, all the way until you get December 2018, okay? And so on until you get all the way until December 2022, okay? So enough suspense. Let's go ahead and press enter. Let's go ahead and run that. Now, let's see if it worked. So we're going to go into our project folder. Oh my goodness. Look how amazing that is, right? So we've managed to create folders in that wonderful format there for every single one of the years. And if we highlight them, it tells us that there's 72 folders actually created. So from January 2017 right here, all the way until December 2022, which is right there, and everything in between. Isn't that awesome? Just as an aside as well, if I just maximize this here, to save us a bit of typing, we could have actually, instead of typing out each of the dates, because it's just numbers, they're just numbers, right, that are in a constant pattern, we could have just done ... So 2017 to 2022. So that's another aside right there. Now imagine how long it would have taken to do that stuff using point and click methods. Can you imagine how annoying that would have been? Well, we just did it in one command line. Okay, so now that we're sitting here feeling very smug that our command line has just created like a bajillion folders all in one go, we've still got a little bit to do. And that is we've got to create 100 files in each of these folders. Now, how are we going to do that? Well, actually, it's quite easy. We'll just use brace expansion again. So what we're going to do is we're going to open up our terminal again, go onto the desktop, go into the project folder. Okay. Now in here, I'm actually going to maximize the screen. Just watch what I do, and then we'll see how it works. Okay. So I'm going to type touch. Then I'm going to open up the braces: Jan, Feb, March, April, May, June, July, August, September, October, November, December, our underscore, and our years, so 2017, 2022. Oh, by the way, it doesn't just have to be numbers. It could be A to Z, or A to Z, or something like B to F, or something like that. Okay, so anything that has a pattern, like, you know, the alphabet or numbers, you can use the ... thing to make that happen. Okay, but we're after 2017 till 2022. Okay, now inside each of those folders, we're now going to make a file that starts with file and then the numbers 1 to 100. Okay, so what is going on here? This is mad, Ziad. Where has this command come from? Well, basically what I'm saying is, for each of these folders from January 2017 all the way until December 2022, in each of those, make file 1 to 100. Okay, now this is just a bit of fun, okay, so don't worry if it seems a bit like, what? It's just to show you how powerful the shell can be. Let's take a look at it. Okay, so let's run that, and let's close the terminal again. Let's go ahead and take a look. Let's open up June 2022, okay, because that's a good date. So if we open up June 2022, we click that. Oh my goodness, we've got file 1 to 100. Okay, maybe that was just a fluke. What if we open up December 2020? Nope, there's file 1 to 100 in there as well. What if we open up January, or let's say April 2020? There we go. Again, we've got file 1 to 100. Okay, so isn't that awesome, guys? Like, you can see the way that we've just used brace expansion to make our terminal command unbelievably powerful. And if we've got 72 folders, I said we were only going to do it for 5 years, we ended up doing it for 6, but if we have now got 72 folders with 100 files in it each, we've just used one command line to create about 7,200 files in one go. Now, I hope you can see just how powerful the shell is from that little example right there. Okay, and by the way, brace expansion isn't only possible for the touch and mkdir commands, by the way. It's actually usable across the whole shell. So for example, let's take the ls command. Okay, let's take the ls command. We can look in every single folder and get a list of what's in there. So if I do Jan, Feb, March, April, May, June, July, August, September, October, November, December, and then 2017 till 2022. Okay, so I'm saying list out the contents of every single one of these folders, basically, and I press enter. Oops, I'm in the wrong place. So I go to desktop/project. Now press up key twice to get back there. Go again. Wah! We now can see the contents of every single one of the folders, and you can see they all have 100 files in it. And we can see here that we get the files 1 to 100 in every folder. And it might look like the file ends in file 99, but what's actually happening is if you look over here near file, what it's doing is it's sorting them alphabetically or sorting them numerically here. So you see file 1, file 10, file 100, because they all start with 1, right? And then the 9s end up over there. But no, we are getting files 1 to 100 in each. And let's say that we wanted to take all of this output, right, this massive output that we just got, and redirect all that output into a file called out.txt. And now when we take a look, we've now got a file called out.txt. And when we take a look in there, we can see that we've got all of that content in there. So April 2017, it tells us the files that has, and then it tells us what's in April 2018, and it tells the files in there, and this is all alphabetically sorted in there. Isn't that awesome? I'm just showing you here, we now have an epic file with the contents of 72 folders and in about 7,200 files in just one command line. Tell me that isn't epic and would have took you forever to do using point and click methods. Now I appreciate this bit is really going to be a bit like whoa, and that's okay. All right, I'm just showing you these basic skills, how these basic skills such as creating one file or creating one folder can easily be turbocharged with very little effort, as long as you understand a little bit about brace expansion and wildcards. But I'll leave the imagination as to why you would do so up to you, because these skills can be applied to many different things. And you know, just to show a much simpler case of brace expansion, if we go to the desktop right here, and let's say we just want to, instead of saying touch file a.txt, file b.txt, and file c.txt, which will work fine, we'll create 3 files. Brace expansion just makes that a bit easier by saying file, you give it some brackets, a, b, c.txt. So you can see we're using the braces here because it's going to go file a.txt, file b.txt, file c.txt. I press enter. There we've used brace expansion to expand that out. Okay, so brace expansion comes into play all over the place, and because here we've got some text which follows a very simple pattern, we can use the dot here and we're going to get the same result. Okay, we could maybe say, okay, I want file f all the way to v. There we are. We're going to get file v all the way to f on the desktop as well. So here we are. Here's f and there's v. So just showing you, that's brace expansion. It's not a particularly complicated thing. Trust me, there are useful things for what I'm showing you here, but I just wanted to show you just how powerful the shell can be with just a little bit of tweaking. So that's enough command line craziness for now. Let's just have a quick recap of what was actually important from the last 2 videos. So first of all, you saw how to use the touch command to create new files, and you also saw how to use the mkdir command to create new directories, which is my favorite way of saying the command, by the way. And you also saw that the mkdir command also has a powerful P option that can be used to create entire folder paths. So this is creating one folder inside of another folder inside of another folder, all from scratch, which is very, very powerful stuff. You learned that creating files and folders in Linux is case sensitive, and you learned that it's kind of a bad idea to have spaces in your file names, so use underscores instead. And finally, we took file and folder creation to the next level by using brace expansion. Now, brace expansion is kind of an advanced technique, so don't worry if you didn't understand it. It's not technically part of the course, but you got to see it here anyway, so lucky you. But now that we've got a whole bunch of files and folders cluttering up our computer, in the next video, you're going to learn how to remove them. So to learn how to delete files and folders, I'll see you in the next video. Hello there, you beautiful people, and welcome to this video where we're going to be kickstarting our discussion of how to delete files and directories using the command line. So in this video, you're going to learn how to use the rm command to delete files, and you're also going to learn how to use the rm command along with wildcards to make the rm command even more powerful. And by the end of this video, you'll know how to delete files using the command line, and in the next video, we'll move our discussion onto directories. So let's go ahead and get right into it. Alright, so let's kick off by creating a file called delete me in our home directory. So we can see that we're already in our home directory by looking at our shell prompt. We see the tilde, the squiggle up there, which means we're in the shell prompt. But to confirm, we could just type the pwd command, print working directory, and see that we are indeed in our home folder. So let's create a file called delete me. We're going to use the touch command and type delete me. Okay, and press enter, and now if we use the ls command, we'll see that we do indeed have a file called delete me been created. But we can confirm this, of course, by opening up our graphical file browser, and we'll see a file called delete me. Okay, so far so good. Clearing the screen. Now that we've created delete me, how can we actually delete it? Okay, well, the way to actually delete or remove that file is using something called the rm command. Now, the rm command is, rm stands for remove, and all you've got to do is give the rm command a set of paths to files that you actually want to delete, and these could be absolute paths or relative paths. So if we open up the man page for the rm command, it says that you can give it more than one file. Okay, you see you can give it a file, and then it's got three dots after it, and we know from our discussion of command line syntax, a command line layout, that these three dots mean you can have more than one. And if you need a refresher on that, check the cheat sheet in the previous section. It's got all that information in there for you. So let's go ahead and remove delete me. So I could, because I'm already in the same folder, I could just, use the relative path like that, rm delete me, and when I press enter, we'll see that delete me has indeed been deleted. I could, if I create delete me in our documents folder this time. Okay, so if I look in our documents folder, we see delete me has been created. At the minute, in the command line, I'm just in the home folder. So if I try to do rm delete me, that won't work because there is no such thing as delete me in this directory. So to delete it, I have to do rm documents/delete me. So I have to give it the path relative to where we are now, which is the home folder. So here I am in the home folder. To get to delete me, I have to do documents, then delete me. Okay, so documents/delete me, and I press enter, and then it gets deleted. Okay, and you can have more than one. So if I go ahead and create a file called, let's say, file1.txt, that's in our home directory. I create a file called file2 in our documents, so file2.txt in our documents, and I create a file called file3.txt in our downloads. Okay, so I've got one in the home folder, one in the documents, and one in downloads. Okay, so to delete all those, I can just enter them one after another. So I do rm file1.txt. I don't have to do anything because that will do because I'm already in the home directory, the same folder as it. Documents/file2 and downloads/file3. And if I press enter, you see that file1 disappeared, file2 has disappeared from documents, and file3 has disappeared from downloads. So the rm command is a very simple command to use for files. Just think of it as the opposite of the touch command. So if you want to create a file, you do touch file1. If you want to delete it, rm file1, and it'll work just like that. So now that we've seen how to use the rm command in a basic way, let's take it up a notch and use it along with wildcards. Now, wildcards can really level up the power that your commands have. So let's just see how we do this using the rm command. Let's make a few new files. Let's make file1.txt. Let's make file2.png and file3.jpg. So when I press enter, you see that all three of those have been created in our home folder. Okay. Now, how would we delete every single one of them that ended in .txt? So that's actually just for now. Let's make another one, file4.txt. Okay, so we've got two that end in .txt, and we've got one that ends in png and one that ends in .jpg. How would we delete them? They're the ones that end in .txt. Well, first of all, we could do it manually. We could say rm file1.txt and file4.txt. That would work, but I want a bit more of a clever solution than that. I want to say delete every file that ends in .txt. Now, the way we do that is by giving the command a pattern, and anything that matches this pattern will be added as a command line argument to it. So if the pattern that I'm going to use is this, star.txt. Now let's break this down, okay? So the star means anything. Anything could go there. So this whole thing is our pattern, okay? The star means anything, and then .txt. So what this means is, for anything to match that pattern, all it has to do is end in .txt, right? So basically what this is saying is remove everything that ends in .txt. And when we press enter on that, you see that file 1 and file 4 have been deleted because they ended in .txt. Okay, so let's try and see if we could make some other files. Let's make file 1.txt again and file 4.txt. Let's make those back, and then let's create some other files. Okay, let's create some called shablam.txt, and let's call it shablam1, right? And then shablam2.png and shablam3.jpg. Okay, so we've got some that start with shablam and some that start with the word file. Okay, how would we delete the ones that start with the word file? Well, the way that we do this is we would use the rm command again, of course, because we need to delete. Then we need to give it another pattern. So let's think. How would we create a pattern that would match anything as long as it started with the word file. Well, the way we could do that is we could type the word file and then put a star, because this means as long as it starts with file and then has anything after it, it matches. So all it has to do is start with the word file. And if I press enter, we see that file 1, 2, 3, and 4.txt, that, doesn't matter about the file extension or anything. As long as they started with file, they've been deleted. But all of the shablams have been kept there. Okay? So let's create file 1, 2, 3, and 4 again. So we're going to create touch file 1.txt, file 2.png, file 3.jpg, and file 4.txt. We'll make them back again. Okay? Now we want to delete all of the files that have the number 2 in them. Okay, so how would we do that? Well, what we might do is we might say, okay, let's remove. It doesn't matter what it starts with, but it's got to have the 2 in there, and it doesn't matter what it ends in. Okay, so here we are, we're saying it could have anything, then the number 2, and then anything afterwards. Okay, so if we do that, we see that file 2 has been deleted and shablam 2 has been deleted, but all the others are okay. What about getting rid of the ones that end in .jpg? Well, to do that, you just do rm ends in .jpg. I press enter. File 3.jpg and shablam 3 have been deleted, but all the others that end in .txt are still there. What about deleting those? Rm everything that ends in .txt. Press enter. And they've all been deleted as well. So you can see here how wildcards can really make your commands a whole lot more powerful and a lot more specific. There's one more that I want to show you. Let's just go up here. We've made back our files, and let's make back our shablam files. Shablam2 .png, I think, yeah, and shablam 3.jpg. Okay. Now, what if we wanted to get rid of the ones that had 2 or 3 in them? Well, to do that, remember how we got rid of the one that had 2 in it, right? We said it could start with anything, then have a 2, then end in anything. Well, now we want to give it some options, and this is where the square brackets come in. So if I said, okay, something like that, that's saying it could start with anything, then have either a 2 or a 3, and then end in anything. So this should get rid of file 2, file 3, and shablam 2 and shablam 3. So if I press enter, ta-da! File 2 and file 3 and shablam 2 and shablam 3 have been deleted. So wildcards are incredible tools that really allow you to control what's going on when you use your commands, and anything that matches this pattern will be passed as a command line argument to the command that you use the wildcards for. So that's a bit of wildcards in action as well. So there you have it. In this video, you learnt about the rm command. Now, the rm command is the command that's used to remove stuff from your file system. And in this video, we focus specifically on deleting files. You also built upon what you learnt in the last video about wildcards and saw wildcards being used in action to delete files. Now, what you saw about wildcards in this video, it doesn't only apply to the rm command. What you learnt about wildcards and how you might do specific tasks works for any command. You build patterns called regular expressions with wildcards, and whatever matches those patterns is passed as a command line argument to the command that you're using. So there you are, you've seen some wildcards in practice as well. Up next, what we're going to be doing is we're going to be developing this discussion a bit more, and we're going to move on to looking at how you might delete directories. How can you delete folders? So that's a completely next level. It's going to be very exciting stuff. So I'll see you in the next video. Hello there, you beautiful people, and welcome to this video where we're going to be finishing off our discussion of how to delete files and directories using the command line. So in this video, you're going to learn how to use the rm and rmdir commands to delete folders, and by the end of this video, you'll know pretty much everything you need to know about deleting files and folders using the command line. So let's go ahead and get right into it. Alright, so let's start off by creating a folder in our home directory called del folder. So if I use the mkdir command and type del folder, we'll see that we created a new folder inside our home directory called del folder. Okay, so let's remove it. Okay, now all we have to do actually to remove it is use the rm command again. So if I use rm and use del folder and press enter, we actually get an error. Now, this is because, yes, we will use the rm command, but in order for the rm command to remove folders, we need to give the rm command the R option. Now, the R option stands for recursive or recursively. Now, if you delete something recursively, that means that you'll delete that thing and everything else inside of it. So if we try that now, rm/r and then del folder, okay, and press enter, we'll see now that del folder has indeed been deleted. So let's make it again. Let's make del folder, okay, and let's make some more folders inside of it. So we're going to use brace expansion for this now, okay. We can do make directory del folder, and inside there we're going to make 3 folders called delete me 1, 2, and 3. Okay, so if I press enter and take a look at del folder, we can see we've got delete me 1, delete me 2, and delete me 3. So that's how this worked. It made delete me 1 inside of del folder, then it made delete me 2, then it made delete me 3. Okay, so that's brace expansion again. Okay, so let's make some files inside each of those. So if we touch del folder, delete me 1, 2, and 3, and then inside of there, make file 1, 2, and 3. And now if we take a look, we can see in delete me 1, we've got file 1, 2, and 3. In delete me 2, file 1, 2, and 3. And in delete me 3, we've got file 1, 2, and 3. So now, if we go ahead and if we just look, we've got del folder here. We've got del folder in our home directory. Now, if we use rm with the R option to delete that del folder, remember, to delete something recursively means to delete it and everything else inside of it. So if I use rm with the R option and give it del folder and press enter, we'll see that del folder has indeed been deleted, and so has everything else inside of it. Now, one thing you might notice is that the rm command, when it did that, it actually didn't give us any warning. It just went ahead and deleted everything inside the del folder, okay? Now, because of this, rm with the R option is a very powerful command that should be dealt with very carefully, especially when you start using the star wildcard as well. All things can go wrong, and you can find yourself just deleting everything and not being able to get your files back, which is sad times. So, for example, if I do go ahead and do that now, if I just delete that on everything on our system right now, I'm not going to do it, I'm joking. So one way to make the rm command safer is actually to give it the I option. Okay, so the I option stands for interactive, and this will make the rm command ask you interactively whether to delete each file or not. Now, at the moment, we don't have the del folder anymore. So to make del folder and delete me 1, 2, and 3 all at once, I'm going to use the make dir command, give it the P option, which allows you to create an entire path, and do del 2 and tell it create delete me 1, 2, and 3. So if I do that, actually not del 2, sorry, del folder. Okay, then so if I do that, I get del folder. Inside there, delete me 1, delete me 2, and delete me 3. Kind of cool, right? Now let's create the files inside there. So del folder / delete me 1, 2, and 3, and we're going to make file 1, 2, and 3 inside each of those, and inside each of those we've got our files back. Okay, so there we are. Didn't take too long at all. We've got our files back. By the way, can you see just how much quicker this is than pointing and clicking? We created all of those files without ever even needing to enter the folders. We just created them right from our home directory. So cool. So now if we try to delete everything, again, try and delete del folder by giving the rm command the R and I options. Okay, it doesn't matter which order you do it. So we give it del folder. We'll see that now it's asking permission for us to actually delete things. So it's saying, can I go into del folder? Let's tell it yes. Okay, it will now say, can I go into delete me 1? Let's say yes. And can I delete file 2? Yes, you can. Can I delete file 3? Yes, you can. Can I delete file 1 inside delete me 1? Yes, you can. Can I remove the directory delete me 1? Yes, you can. Can I go into delete me 3? You see, it's not particularly doing it in any order, but it's asking you before it does it. Okay, so let's say yes. You can delete that. You can delete that. You can delete that. Now let's leave file 2 inside delete me 2. Okay, so it's going to delete me 3. Go into delete me 2. No, don't delete file 2. Yes, delete file 3. Yes, delete file 1. No, don't delete the entire folder. No, don't delete del folder. And that's it. Okay, so now if we look inside del folder, we should see delete me 2 and file 2 still left over. Okay, so that's quite cool, right? You can control what the rm command deletes. But this is kind of tedious, right? Saying yes and no every time. It's, if you had a lot of files, that would really be a massive hassle. So fortunately, there's another command that's specialized for only removing directories that are empty. Now, because this command only removes empty directories, this means that you can tell it to delete everything. It will only delete the folders that are actually empty, which means you'll never delete a file accidentally. And that command is called the rmdir, the remove directory command. So to see the remove directory command in action, first let's go ahead and delete everything inside del folder. So remove recursively del folder. And there we are, del folder has been deleted. Now let's go ahead and create some folders. So we're going to use mkdir with the P option to create, let's call it del folder, and then folder 1 to 3. That's another way of doing it, by the way. You don't have to type 1, 2, 3. You can just do 1.3. And if we look in del folder, we've got folder 1, folder 2, and folder 3. Okay, and let's put 10 folders inside folders 1 and 2, but not in folder 1, not in folder 3. So let's do touch del folder, folder 1, 2, and then put inside there file 1 to 10.txt. So if we look inside folder 1, we've now got 10 text files. We look inside folder 2, we've got 10 text files, but in folder 3, we don't have any. Okay, so now that we've got 3 folders inside del folder, folders 1 and folder 2 have 10 files in them, but folder 3 is completely empty. Now, if I try to do remove directory, and I say remove directory del folder / everything, okay, what we're saying here is delete everything inside del folder, delete the empty folders inside del folder, basically. So if I do that, we'll see it failed to remove folder 1 because the directory is not empty. It failed to remove folder 2 because the directory is not empty, but folder 3 has indeed been deleted. So just so you know, this wouldn't have worked if we'd just done remove directory of del folder without putting the star. So you see we've got the star asterisk wildcard here. If we just had remove del folder, the shell will say, but del folder's not empty. How can I just delete it? But what we did is we said remove everything that is inside del folder that is empty. Okay, so we had to have the star there to make that work. So that's just something to bear in mind. Okay, so as one final challenge, in the last video we created a project folder that had a whole bunch of other folders inside with like a bajillion files, okay? You must remember this from like the last few videos. Now what I want you to do is I want you to try and delete all of those folders and directories and files and stuff in one command. Okay, so that's your challenge. That's your challenge. You've got to try and delete that entire project folder with everything inside of it, all the thousands of files in one command. So pause the video now and see if you can figure it out, figure out how to do it, then come back and see how you did. Did you manage it? If so, well done! You learn super quick. So here's how I do it, okay? Now the folder was called project, right? It was on the desktop, so let's shift there. It's called project. So we want to delete everything. So we don't want to use the rmdir command because that only deletes empty directories. We want to use the rm command instead because we want to delete directories that have stuff in them, okay? Now, we want to delete the project folder and everything inside it, so we need to delete recursively. So to do that, we're going to use the R option, okay? And putting that all together basically means we'll just do remove recursively the project folder. Or if I was in my home directory, like this, I would do remove recursively desktop/project, okay? Just giving the path to that folder. And when I press enter, as if by magic, however many folders there were, the thousands of files have been deleted. How absolutely epic is that? So that'll just about wrap up our discussion of deleting files and folders using the command line. So in this video, you learned that the rm command needs the R option in order to delete folders. And the R option stands for recursive deleting. So to delete something recursively means to delete that thing and everything else inside it. And this is why you need to be especially careful when using the R option, because you can end up deleting stuff that you didn't want to. Now, one way to make that a bit safer is to use the I option for the RM command, which will allow the RM command to be interactive when it does its deleting. So this is where you can say yes or no to each file or folder being deleted. But the best thing is there's not really much you can rely on. Just be careful when doing your deleting, okay? But the safest of all options is to use the rmdir command, which will only delete folders that are empty. So if you just want to do a bit of tidying up and delete folders that don't have anything in them, you can use the rmdir command and rest assured that you won't delete any data. So coming up next, we're going to discuss how you might copy and paste files and directories using the command line. So instead of cutting our file tree, we're going to make it grow. So for all that goodness, I'll see you in the next video. Hello there, you beautiful people, and welcome to this video where you're going to learn how to copy and paste files and folders using the command line. Now this should be a nice and quick lecture with just one command, the cp command, which handles all the copying of files and folders in Linux. And by the end of the video, you'll know how to copy and paste files and folders using the command line, and you'll also see how to use the cp command with wildcards to make copying and pasting even more awesome. So let's go ahead and get right into it. Okay, so here we are, and as you can see by the shell prompt, I'm currently on the desktop, and on the desktop I have a file here called file1.txt, and if I open that, it says, hello there, you beautiful people. I wonder how that got there. So let's say we wanted to copy that file to another file called file2.txt. Okay, because I'm very, very imaginative. So to copy it, we need to use the cp command, and the cp being short for copy. Now we just need to tell the copy command what we want to copy and where we want to copy it to. So what do we want to copy? Well, we want to copy file1.txt. And remember, I'm on the desktop already in the shell, so I can just write file1.txt. If I was in the home folder, I would say copy desktop/file1.txt, just so that you're aware. Okay, so let's go to the desktop again. So we need to tell it what we want to copy and where we want to copy it to. So we want to copy file1.txt, and we want to copy it to another file called file2.txt. So that's all we've got to type. We want to copy file1 into another file called file2.txt. And when I do that, we'll see we get a file here called file2. And when I open that, that also says, hello there, you beautiful people. Okay? So that's how you copy a file to another file, which is pretty simple. So how would you copy a file to another folder, to another directory? Well, that's pretty simple too. As I say, the copy command, all you've got to do is tell it what you want to copy and where you want to copy it to. Okay? So let's say I want to copy file1 into this folder called destination. Okay, so all I have to do is say copy file1, so file1.txt, and copy it to destination. And also, let's say I also wanted to copy file2 at the same time. Okay, so I want to copy file1 and file2 into the destination folder. Okay, so you can see here that the last thing that you put as a command line argument is the destination, and everything else that comes before that is what you want to copy. So I could have many, many, many different commands and many, many different files that I want to copy here, but the last one is where I want to copy them all to. Okay, so with that, let's go ahead and press enter, and when I look inside destination, we can see that we've got file1 and file2. They have both been copied into there. So as you can see, this whole copying and pasting business is actually rather simple with the command line. And of course, you can also do it with wildcards. So I'm on the desktop at the minute. Let's say I want to remove everything that starts with the word file. So if I do that, both the text files should disappear because they both begin with the word file. So if I do that, there we are, they've both disappeared. Now I can copy and paste all the stuff from in the destination folder to the desktop by just saying copy destination/everything, okay, to this folder. Now, how do I select this folder? Well, if you remember back, there's always a hidden folder in each location that refers to the folder that it is. So if I just do, and that is the full stop. So if I just do that dot, what that means is copy everything from within the destination folder into this folder, so, which is the desktop, which is where we currently are. Okay, so if I do that, if I press enter, you'll see that file 1 and file 2 have been copied and pasted to this location, which is represented by the full stop here. And if you don't remember, if I just do ls with the A option, you can see here that we've got these two hidden folders, and the one with the 1 dot refers to this folder, and the one with the double dot refers to the folder above it, which is our home folder. Okay, so I could, for example, copy everything from the destination folder to the parent folder of where we currently are, which is the home folder. So if I do that, and I now look in our home folder, we can see that file 1 and file 2 have been created in there. So look, wildcards work absolutely great with any command, even the copy command as well. So let's clear the screen. We have seen how to copy and paste a file into another file. We've seen how to copy and paste a file into a folder, and we've seen how to copy and paste files from folders into other folders. The only other thing we need to know is how to copy and paste entire folders. Okay, so we have here this copy me folder on the desktop, and that's got 3 files in it. It's got file A, file B, and file C. Okay, and we want to copy this entire folder into the destination folder. So we don't just want the files, we want the folder as well. So we don't just want the chocolate, we also want the wrapper. Okay, so the way that we can do this is by giving the cp command the R option, which also stands for recursive. Now, if you remember from when we were deleting files and folders in the last few videos with the RM option, recursive deleting meant delete that folder and everything inside it. And it's very similar for the copy command. What we're saying is copy the folder and everything inside of it. Okay, so to actually copy the copy me folder into the destination folder, we just type it out. We say copy with the R option, then copy me into the destination folder. And if I do that, and then we look inside destination, we will see that the copy me folder has been copied and pasted, and all of the different files are inside there as well, all safe and sound. So there you have it. You can now copy and paste files and folders using the command line. It's quite easy, right? So as a very quick review, you saw that the cp command is what deals with copying and pasting of files and folders in Linux. And the way that it works is you have the cp, you type cp, then what you want to copy, and you can have as many of those as you like. And then at the end, the last command line argument that you give it is your destination. Okay, so you can have many things that you want to copy, but the final thing that you give it is the single destination where you want all of those things to go. Now, if you want to copy entire folders, so not just their contents, but the actual wrapper, the actual folder itself, then you need to give the copy command the R option to allow it to copy entire folders recursively. And now with copying and pasting underway, up next what we're going to be doing is we're going to be discussing moving and renaming files and directories in Linux. And what's really interesting is that you can actually use just one command to do both of those things. So to learn how to move and rename files using just one command, I'll see you in the next video. Hello there, you beautiful people, and welcome to this video where you're going to learn everything you need to know all about moving and renaming files and directories using the command line. Now, the interesting thing is both of these functions can be completed with just one command. So in this video, you're going to learn how to use the mv command to move and rename files and folders, and by learning the one command we're going to cover in this video, you're going to gain 2 very important abilities for working with your file system. Talk about efficiency, huh? So let's go ahead and get right into it. Okay, so let's first talk about renaming files. Now on the desktop, I have a file called oldname.txt, and I want to rename it to be called newname.txt. Very imaginative, I know. Now, to do this, rename, it's really very simple to do using the mv command. So first let me get to the desktop. Okay, so now I'm on the desktop where the files actually are. And to rename old name to be new name, all I have to do is just do mv, then oldname.txt, which is the current name of the file, and then give it its new name, which is newname.txt. And when I press enter, you'll see that the file has been renamed. Okay, and we can see that using the ls command as well. It's now newname.txt. Simple. And the same thing works for directories. So I have a folder here called old folder, and as we can see, old folder actually contains a few files. So it's got file 1 to file 10 inside there. Okay, now to rename old folder to be called new folder, if I clear the screen, all I need to do is move old folder, new folder. And when I press enter, we can see that the folder has been renamed, and it's just that simple. And even though we've just changed the name of the folder, if we open it up, all the files are still in there exactly as they were before. So renaming folders doesn't damage any of the contents inside. So with that said, how can we move files from one folder into another folder? This is also actually really simple. All we need to do is give the move command what we want to move, and then the directory that we want to move them to. So this is very similar to the copy command. With the copy command, you gave it a list of all the things you wanted to copy, and then the final command line argument you gave it was where you wanted to move it to, copy it to, sorry. And it's the same idea with the move command. Okay, so if we want to move everything from in new folder onto the desktop, then all we'd have to do is say move from new folder, okay, move new folder, everything in there to here, which is the desktop. Okay, so the dot, remember, means the current working directory, and as you can see from the shell prompt, that is the desktop. So what we're saying is move everything from within new folder to the current working directory, which is the desktop. So if I press enter, you'll see that all of the files have been shifted onto the desktop, which we can see using ls. We've got file 1 to 10, and if we look inside new folder, we can see that they haven't just been copied, they have indeed been moved, because the folder is completely empty. Okay, so let's move all of these files back into a new folder. So if I move everything that starts with file back into new folder, that should take care of all that. So there we go, we've moved them all back into this new folder. Okay, now how can we move the whole of new folder just as one go? How can we move this into our documents folder, for example? Well, that's really easy to do as well, okay, and it works just like you might expect. We just do move, new folder, and where's our destination? Well, we want it to go into the documents folder, which is in our home directory. So we put the tilde to say our home directory, slash, and then documents. So the documents folder inside our home directory. We press enter, and then when we look inside our home directory and go into our documents folder, there we are. There's new folder sitting there, all intact. So now for the jackpot, how can I move new folder inside of documents or move it somewhere and rename it at the same time? So let's say I want to move it from our documents folder to the desktop and rename it to be jackpot at the same time. So how would we do that? Well, first we need to tell the move command what we want to move. So let's say we want to move the new folder inside our documents folder. And this is something you should be comfortable with, by the way, using the tilde to represent your home folder, then documents, then new folder. Okay, this slash at the end is optional, but I think it comes with the tab auto completion, so we'll leave it there. Okay, now where do we want to move it to? We want to move it to our desktop, so we could say this current working directory, because as you can see we're on the desktop, so we're going to move it to current working directory, but we're going to call it jackpot. Now, because the jackpot folder doesn't exist, new folder will become jackpot. So if I press enter, we'll see that jackpot has been created. Inside there are all the content over every single one of the files from new folder, and if we go back into our documents, we will see that new folder is no longer there. So what happened? We said move the new folder from within our documents folder and put it in this directory, which is the desktop, but as a folder called jackpot. So that is how you can move a folder and rename it at the same time. Pretty awesome stuff, right? So there you have it. The MV command is a very simple but very effective command for anything that you'll ever need to do with moving or renaming files. And in this video, you've seen how to move and rename files and directories using the MV command. And this is how it works. So if you want to move files and directories, first you type the MV command, then you give it as command line arguments everything that you want to move, and you can give it multiple of those. And then the final command line argument is the destination of where you want to move all of those things to. And if you want to rename files and directories, well, you can only do one at a time, but you give it what you want to rename and then the new name and location if you want to move and rename at the same time. And you've seen how to do that in this video. So just remember that if you ever want to move or rename a file, the MV command is what you need. So in the last few videos, you've learned how to modify the file tree quite a lot. You can now create files and directories using the touch and mkdir commands. You can delete files and directories using the rm and rmdir commands. You can copy files and directories using the cp command, and you can even move and rename files and directories using the mv command. Well, in the next video, you're going to learn how to actually edit these files using the command line. Now, obviously, this is going to be something that you'll do all the time. So for all that good stuff, I'll see you in the next video. Hello there, you beautiful people, and welcome to this video where you're going to learn how you can edit files from the command line using a really cool command line program called Nano. So in this video and the next video, I'm going to be showing you how you can use a command called Nano to edit and create files using a user-friendly command line interface. And by the end of the next few videos, you're going to know how to edit files in Nano, and when you combine this with the commands that you've already learned so far in this section, it's very likely that you'll be able to get many of your file-related tasks done with Linux without ever having to leave the command line, and therefore you'll be able to maximize your productivity on Linux. So this is going to be awesome, so let's go ahead and get right into it. Alright, so in this lecture we're going to make a file called diary.txt using the nano command. Now the diary.txt file doesn't actually exist yet, but that's okay. We can also create the file using nano. So if we type, let's go to the desktop first, let's head over to the desktop, and then if we type nano diary.txt, okay, and I press enter, you'll notice that our terminal has changed its look, and we're actually now editing a file called diary.txt, as you can see at the top, in the Nano editor, as you can see here, Nano version 2.8.6 apparently. Now we can type whatever we want in here. So for example, I could type, hello, my name is Ziad and I teach Linux and Python courses and more. Okay, and it works just like any other graphical text editor that you've ever used before. You can just type directly there in the shell. Now down the bottom, you can see that there's actually a little toolbar that tells you some of the things that you can do in Nano, and the options are in the white squares and they're in the form of keyboard shortcuts. So let's show you how to read them. Okay, so in Nano, the little arrowhead that you see here, the little hat or the caret symbol, means the control key on your keyboard. So for example here we have the get help command, we have the get help I guess option from the toolbar, and it's given this shortcut here. It's got the arrowhead and then a capital G. So if we press Control on our keyboard and press G, which is exactly what I'm going to do, I'm just going to press Control and G together, that executes that command, and we can see here that we have now we're now in the Get Help menu, and we can scroll down and see some help about using Nano. Okay, and we can see here that there's some, to close this, we would need to press Control and X, because you can see the little arrow and then an X. So if I press Control and X, we're back out of there and we're back writing. Okay, we can also close Nano, for example, by pressing Control and X, and it will say, do you want to save, yes or no? Let's just click cancel by Control and C. There we are, we've cancelled, we're still back in. Okay, so how would we save this file? How would we save this diary.txt in our home folder? Well, sorry, on our desktop, sorry, because you can see up here, our shell prompt says that we're in our desktop. Well, to do that in Nano, you would use the write out function. So writing a file is a fancy way of saying saving a file. Okay, so saving and writing are basically the same thing. And so to write a file, we need to press Control and O. So we've got the arrow, the little caret symbol here, which means the control key, and O. So that means we press Control and O. And now it's asking us, what do you want to save it as? Let's save it as diary.txt, and we press enter. It'll say it wrote 3 lines, but you can see here that we've actually got diary.txt. So if we open that in any other editor, we can see that that file has indeed been created. So I could write something in here. I could say, like, something like Jack and Jill went up the hill. All right, and then press Control and O, press enter. And if I press Control and X to exit, okay, it's gone away. But if I look inside diary.txt, it's saved that data in there. Jack and Jill went up the hill. So Nano is a text editor that you can control from the command line. So isn't that incredible? You can now edit files without needing to load up graphically intensive editors, and plus working with files like this will work pretty much anywhere. Even if you have remotely accessed a server that might not have a graphical user interface installed, text editors such as Nano will still work. So what other things can Nano do? Well, let's just work our way across the options. Now, we've seen how to get help, how to quit using Control and X, and how to write or save files using Control and O. What about the read file option down here, the Control and R? Well, read file allows you to get content from another file and basically place it inside of this one. So if I head back to our shell, if we exit and we try to create a file that says happy birthday, and we echo happy birthday into a file called birthday.txt, we can see that birthday.txt has been created. Now if we open up again the diary.txt, and we head down the bottom and we press Control and R. Control and R is for read file, and it's going to say which file do you want to insert. And notice it says from /, so that means from this directory. Okay, so let's try and tell it that. So the one we want to actually insert data from is birthday.txt, and if I press enter, you can see that happy birthday has just been inserted. So that's reading files. What about the where is option? Well, the where is option is Control and W, and what that does is basically search for words in your file. So if we head back up to the top of the file and we press Control and W, now we can search for a word. So let's search for the word birthday. So if we type birthday and press enter, we now see that Nano has jumped us right down to where the word birthday starts, and so we can edit it from there on. Now by default, the where is option searches forward in a file, and it searches in a case insensitive manner. So that means that uppercase and lowercase don't matter. So if I went up here and I searched for birthday all in uppercase, actually you can notice that it shows you what you searched beforehand. So I'm just going to put birthday in uppercase. We can see that it actually didn't matter, and it found birthday even though birthday was all in lowercase. So where is searches in a case insensitive manner, and it by default searches forward. But if we head down to the bottom of the file, so if we shift down here and use Control W again, you can see down the bottom, if I maximize the screen, maybe it makes it a bit clearer, that there are actually other options that pop up as well. Okay, now some of these options begin with the caret symbol, the hat, which means the control key, but some start with this M-. Okay, you can see M-C, M-R, M-B, M-J. So what's that M- mean? Well, that M- stands for modify, and this is usually the Alt key on your keyboard, so the ALT key. So you can see here that we've got the M-C option, which stands for case sensitive. So if I press Alt and C, you can see now that it has changed so that we are now searching in a case sensitive way. Okay, so if I now search for actually hold on as well, because this is only going to search forward, so if I press Alt and B to search backwards as well, you see now we're going to search case sensitive and backwards for birthday in uppercase, and we'll see that nothing was found, you see. But if I do just like that, Control and W, you see it's saved our settings. It's going to be case sensitive and backwards, but now if I search birthday all lowercase, we see that that has been found. Okay, so that's quite awesome, right? You can also modify the way that these commands behave. So if you see M-, that means press the Alt key, the ALT key on your keyboard, and if you see the triangle, the hat, the little arrowhead, that's the control key on your keyboard, and that will cover pretty much everything that you'll do in Nano. So let's just head back to our normal menu here. So in the interest of time, we're going to cut the video here and we're going to pick it right up in the next video where we'll go through the rest of the options that you have in Nano. So I hope this was useful. You've seen that Nano is a text editor that you can open from your command line that allows you to do all your file editing stuff without ever leaving the command line. So I could just see, here we go, we've got diary.txt, edit it, make some changes, save it, exit, and we're back in the command line. So it gives you a really nice way of editing files and getting back to what you were doing. So let's just get rid of that, save it, exit, clear the screen, and we're good to go, continue on with our work. So let's pick this up in the next video to take a look at the other options that Nano has to offer. Hello there, you beautiful people, and welcome back to our discussion of how to use the Nano command line text editor to get your work done. So in the last video, we were discussing some of the options that Nano has, and we discussed the write out option, the read file option, the where is option, and we got up to the replace option. So let's actually use the read file option to read in birthday.txt again. So we're going to say birthday.txt, and you can see that we've got happy birthday read into the file once again. And the reason I've done that is so that we can now use the replace command. And you can see here that the replace command, or the replace option here, is activated by pressing Control and a backslash. Now I find the backslash next to the letter Z on my keyboard, but it might be wherever that is on your computer, on your keyboard. Okay, so I'm going to press Control and backslash, and now it's asking me what I want to replace. So let's replace birthday. Okay, and we're going to replace it with code day. And when I press enter, it's going to now go through each instance of where it found the word birthday and ask you if you want to replace it. Now you can see down the bottom here, it's going to say, do you want to replace this instance? I could say yes, I could say no, or I could say all, or I could say Control and C for cancel. So let's just press A to make it replace all. And we see that every instance of birthday has been replaced with the word code day. So happy code day to you, you beautiful person. So that's replacing text. What about cutting text? Cutting text is the next one. So cutting is very easy. You can see here we've got this line that says happy code day. If I press Control and K to cut, that basically deletes the line. And if I want to paste that, so basically it's just like cutting and pasting just in your normal everyday computer use. So if I want to uncut it, I press Control and U, and I can do that as many times as I want. So this is a very, very happy code day. We can also justify the text using Control and J. So if I press Control and J, we'll see that the text has been set so that it takes up the full width of the screen. So I can press Control and U now to unjustify, but you can see if I press Control and J to justify the text, the paragraph that I'm in takes up the full width that it takes up the full width of the screen. And if I press Control and U, I can unjustify it. So that's something to bear in mind. If you look at Control J is justify, and before you justify, Control U is uncut text. But if I press Control and J, you see that Control and U has now switched to unjustify. Okay, and it tells you here you can now unjustify. Press Control and U, it goes back to the way that it was. So up next, we've got the to spell option, which is basically a spell checker. Now, by default, a spell checker isn't set up for Nano. So if I press Control T, it'll say spell checking failed, error invoking spell. Okay, what that means is that there's a spell checker not actually set up. But we can set one up. So let's just save our file by pressing Control and O to write it. Yes, that'll do. And then press Control X to exit and clear the screen with Control and L. See, a lot of keyboard shortcuts going on here. So to actually edit the text, the spell checker that is used for Nano, that's in the Nano configuration file, which is actually located in our Etsy folder in a file called nano.rc. So let's open that, really ironically, with Nano. Okay, so if we do that, here we are. We've now opened our nano.rc. So it's /etc/nano.rc. So if I show you that graphically, where we're going, we are in our base directory by going to other locations than computer. So this is the slash folder. Then you go etc, so /etc. Then somewhere in here there'll be a file called nano RC. There it is. So if we click on nano RC, that's basically what we've opened. Okay, but let's make sure that we open it in here. Okay, actually at the minute this file is in fact unwritable because we don't have the permissions to edit it. So to make that actually editable, we need to do sudo nano /etc/nano rc. Okay, so this sudo bit basically allows you to run this command as the administrator, but we'll come on to that a bit more later in the course. You enter your password that you normally use for logging in, and now you can edit the file. Okay, now there's a line in here that has the word a spell or a spell in it. So let's find that by using the where is command. So let's use the where is a spell, press enter, and it found it. Okay, so this line, it says here, use this spelling checker instead of the internal one. This option does not properly have a default value. Okay, so to get rid of that, actually to make that actually happen, we just need to get rid of this hash symbol and get rid of the leading space. So now there's no hash, just set speller a spell -x-c, just like that. Now if we write out and close, and now if we go back into nano for our diary.txt, if we press Control and T to actually start the spell checker, we now have a spell checker working. So isn't that quite cool, right? We just use nano to edit nano. It's awesome. So here we are, it's going through our spell checker and it's telling me my name is wrong. Well, that's charming, isn't it? But there you go. That's how you can actually go about setting up your spell checker. And you can just enter things in here. So if I wanted to change my name to, let's say, Yoda, which of course I do because that's totally awesome, I just enter 5 and you see that my name is now Yoda. And it's a fact because it's on a video. Okay, so if I can also close, you can enter any of these options. You can ignore, replace, add to dictionary, replace all or ignore all or whatever it might be. But let's just press X to exit, and there we are, we're back into normal stuff. So once you've edited that, all you've got to do, once you've edited that so that your spell checker works, you're good to go. And it is possible to also add different dictionaries and stuff like that as well, and you can find that information online as well. Okay, so there we are, that's how you do spell checking. And Control and C is apparently tells you your current position. So if I press Control and C, it'll tell us I'm on line 1 out of 19, 5% of the way through, column 1 out of 70, and character 0 out of 275. So if I move over here now, and I press Control and C, that'll change. I'm now on line 7, column 10, and stuff like that. So this is good, you know, if you are working on a file and you want to give it to someone and you say, oh, hey, can you change this file at this given position? Or you're giving people instructions on how to use a file and you say, on line 7 in column 11, change this text. Okay, so in fact, just to show you, let me actually save that. Yes, if I go to edit our /etc/nano rc file, and I can search for where is that a spell. Now I can tell you, here we are, I'm on a spell, and if I press Control and C, I can see here that I'm on line 172. So if you want to set your spell checker, go to line 172, and that's the line that you need to edit. For example, that would be one way to do it, right? So I can close that, get back into diary.txt. Now we're getting through. The next option is Control and underscore, and that allows us to go to a line. Okay, so if I press Control and underscore, and if I press Control and underscore, oh, sorry, I'm pressing the wrong button here. Oh, there we go, because underscore is in a bit of a weird position on my computer. So I press Control and underscore, and it says enter the line number and column number. So let's go to line 10, column 2. And there we are. I'm in line 10, column 2. Now let's see if I can actually get this stuff to get a bit bigger. There we go. I've made the font a bit bigger. So Control and underscore, darn it. Because I have to press Control and Shift and underscore. There we go on mine. Anyway, so now you can enter a line number and column number. So let's say line 9, column 12. There we go. We are in line 9, column 12. And columns aren't separated by spaces. They're separated by letters. Okay, so here we are. Here's column 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, and that's where we might get to if we went to column 12 on whatever line. So if I said to you, let's edit our /etc/nano rc file, and I looked for using the where is command. I do Control W and I search for a spell, and I get to this line. I'm like, where is this line? Controlling C, which is current position, it says line 172. Okay, so now on your computer, okay, when you open the file, you'd be like, Ziad says line 172. So if I press Control and underscore, enter line 172, press enter, and I've ended up at the correct line. So you can see how useful that might be if you're collaborating on something with someone. So let's get back into our diary.txt. We've then got undo and redo. So if I, for example, cut out all these things here, and then I was like, I don't want that to happen, let me undo. You can see I just undo and it undid all those deletings. I could also press Alt and E, and remember this could be escape or command depending on your keyboard layout, just the modify key, whatever that is for you. On my keyboard it's Alt, but if I press Alt and E, that should redo. Alt and U, undo, redo, oops. Alt and E, Alt and U. I've broke it now, but you get the point. so that's how you can undo and redo stuff. And instead of cutting, because you see here if I cut, now I can uncut. Instead of cutting, you can actually just directly copy. So here you've just got to do Alt and the number 6. So if I press Alt and the number 6, now I can press Control and U, and I'll start pasting. So maybe if I do it here, Alt and 6, and then press Control and U, now I'm copying and pasting just like that. Okay, so that saves you from actually cutting. And mark text, as far as I've seen, or I don't use that one very often, but as far as I can tell, all that does is allow you to highlight stuff. So yeah, it just kind of allows you to highlight stuff. So there we go. That's basically everything you need to know about using the nano command. So there you are, you beautiful people. In the last couple of videos, you've become very familiar with using the nano command line based text editor. Now, the benefit of using a command line based text editor such as nano is that you can get all of your work done without leaving the command line, which basically maximizes your productivity. Command line editors have lower resource requirements than graphical equivalents, so you don't need as much hardware usage in order to actually run them. And also, if you were remote administering something like a server, the techniques you've learned here would still work, because nano basically comes with every version of Linux, at least the most common ones anyway. So you've learned how to use nano, and we looked at a lot of keyboard shortcut options, and you saw how to use pretty much all of those. So you don't have to memorize them. Don't worry about that. Now you've got a bit of an idea about how they work. Honestly, nano is just a text editor. You can just type text in there. You can write code in there, whatever you want to do. You can edit files in there, but just bear in mind that the tools are, the options in there are accessed using keyboard shortcuts. So if you see this little hat, then that means the control key, and if you see M-, that's either the Alt, Escape, or Command keys on your keyboard, depending upon your layout. Just try them out, see which one works on your keyboard layout. On mine it was Alt, it might be different on yours. And you also saw that you can edit how nano works by editing its configuration file, which is located at /etc/nanorc. So a lot of this stuff is going to be probably for reference for you, so you've got it here in this video, in this course, to refer back to later on if you ever want to look anything up. But really, nano is very simple to use. You just type nano, then the command, then the file name that you want to edit, and you can just go and edit it like any other text file. So there you are. You now know how to edit files from the command line. It should be feeling quite a lot more like a computer wizard at this point. So with all this super awesome file creation, moving, copying and pasting and editing that you'll be doing, it's possible that you might want to find where certain important configuration files are located so that you can edit them, or where that file that you created has run off to, but you don't want to have to go through each folder manually to look for them. So in the next video, you're going to learn how to search for files anywhere on your system using the locate command. Now, the locate command is one of my favorites, and I can't wait to show you. So for all that good stuff, I'll see you in the next video. Hello there, you beautiful people. So in the last few videos, you've been learning how to create and modify files and directories in all kinds of different ways. And when you're working with files in your computer, it's really easy to misplace one or two and wonder where an important file that's new to you, such a configuration file, might be hiding. So in this video, I'm going to show you how you can use the locate command to actually search for files by name and find them no matter where they might be hiding on your computer or with the command line. Pretty cool, right? So we're going to break this up into two parts. In this video, you're going to learn how to use the locate command and some of its options, and you're also going to appreciate some of the limitations that the locate command can have. And then in the next video, the one after this one, you're going to learn how to overcome those limitations and also how to access administrator privileges on the system in order to update a database. So this is all going to be very cool stuff, very, very exciting. It's going to give you superpowers basically. So let's just go ahead and get right into it. Okay, so the locate command is actually really simple to use, but it's very, very useful. Now, the first thing that you need to know about the locate command is that it works by searching a database file that's on your system. Now, this database holds location information about every file that's on your system. And the way that the locate command works is that you will give it some pattern to look for, and then locate will search the database for every path that matches that pattern and give it back to you on standard output. Now, this is actually really easy, so let's just jump right in and get a feel for how this works. Okay, so for example, let's try and find every file on our system that ends in .conf. Okay, now .conf is a file extension that is common on Linux to indicate that this file is an editable configuration file. Okay, and because file extensions don't really matter to Linux, Linux users and developers usually leave meaningful file extensions like .conf so that you can understand what the file might be about just from reading the file extension. .log is another common example, and it's used for log files that store error messages from programs and server applications. So you can look at these log files later on in case anything breaks and see where the stuff went wrong. Okay, but we're going to look at files that end in .conf. Okay, now to search for all the .conf files on our system, all we need to do is type the locate command and then give it the pattern we want to search for. Now, you should start remembering what we did about regular expressions and wildcards. So just think for a minute, how would you make a pattern that matched any file that ended in .conf? Just think about it for a second. And you might remember that perhaps you need to have the star, wildcard, and then .conf. This says anything that matches this pattern here, and so that means it can start with anything and then end in .conf. Okay, so this pattern will check for files that end in .conf. And that's actually all we need to do, right? So if we do that and press enter, whoa, right, you'll see like a whole bunch of different file paths come out, but you'll see that every single one of these files ends in .conf. Now, it's worth noting that by default, Linux is case sensitive, but you can make searches using the locate command case insensitive by giving the locate command the I option. So, for example, if we just clear the screen and we do locate and just say .conf but spell everything in uppercase, now you'll see that we actually get no results because Linux searched case sensitively. It had to be exactly everything in uppercase. Okay, but to make locate search in a case insensitive way, we could give the locate command the I option. And what this does is say, hey, don't worry about the case, I'm just looking for these letters. And when I do that, we get, again, files that end in .conf. Okay, so that's something to bear in mind there. And you can also limit the amount of results that you get. So we get hundreds of results coming out of this one. Look how many there are, a lot of configuration files. But if we clear the screen, we could say, okay, let's search in a case insensitive way, but let's limit the output to just 3 results. Okay, and you can see here that I am using the long form limit option. So we've got the 2 dashes, then the word limit, and then we give it its command line argument, which is 3. So this limit option has an input of 3. So when I do that, you can see that we are just limiting it to 3 results. If I change that to 5, we'll get 5 results. If I change that to 10, we will get 10 results, and so on and so on. So this is useful to, if you just want to get the first few results or you only want to find a few results, you can limit it like that as well. Now, the key consideration to have when using the locate command is to understand that it uses a database. In fact, you can actually find out information about the database using the capital S option. So if I clear the screen and we use locate and give it the capital S, the uppercase S option, I can press enter and you'll see that we get some information about the database itself. So it tells us the path to the database file. as well as some size about the general some information about the general size and complexity of the database. So I'm actually going to save this information using a redirect. So if I use locate S, and I'm going to save that into something on our desktop, let's call it database before.txt. So there we are, we've got a file called database before.txt on our desktop with all that information saved in it. Okay, so you can see redirection is actually a very useful skill, and you'll just use it all the time, and you should be proud. Now you understand how to use it as if it's nothing, right? So this database, just like any other database, is only useful if the information in it is up to date. Okay, now the database by default is updated just once a day. So this means that anything that happens in the meantime is not logged in the database. Files could have been created, moved, deleted, and unless the database is updated, then the locate command will start to give incorrect results. Now, there are a few options that come with the locate command to help minimize this issue. They can't make the database list files that haven't been added to it yet, because that's impossible, but they can prevent the locate command from showing files that have been deleted in the meantime or links that no longer work. For example, there is the E option that requires the locate command to check that the file is existing before it reports it back. So for example, if we did locate with the E option of everything that ends in .conf, then this would check the database for all files that ended in .conf, but also do a check to make sure that those files actually existed before reporting them, rather than just taking it from the database directly. It will take them from the database, but also do a check to make sure that they are there. So it gives you that extra bit of assurance. There is a long form option for the E option. So instead of typing -E, you could type --existing, okay? And that does exactly the same thing. So that's very, very useful stuff. And sometimes there are shortcuts and links on your system called symbolic links that might be broken if files get moved around. Now, to check whether these shortcuts and links are still valid before the locate command reports them back, you can use the capital L or the follow option like this. So locate, follow, everything that ends in .conf. For this, so if there are any symbolic links or if there are any links to files, it will check that they aren't just dangling, they actually arrive somewhere, arrive to the right place before reporting it back. So that's another bit of assurance, and of course you can do both at the same time. So existing and follow gives you basically the maximum assurance you can get there. And again, you can combine it with case insensitivity and limit it to just show 5. You can combine all these options, showing you here just how powerful the Linux command line can be to have multiple different functions going at the same time. Now, these safety features are all well and good, but what we really need to solve our problem is to have a way to update the database whenever we like. And there is. It's called the update DB command, and for the purposes of time, we're going to cut the video here and pick up learning how to update the database in the next video. So I'll see you there. Hello there, you beautiful people. So in this video, we're going to be finishing off our discussion of the locate command. And in particular, you're going to learn how to update the database using the update DB command. And you're also going to learn in the process how to gain super user privileges, so administrator privileges, using the sudo command. So this is going to be a very important lecture, touching not only on how to make the most out of the locate command, but also giving you an absolute nugget of information on how to gain administrator privileges, which is such a useful thing to be able to do more higher level things on your system. So by the end of this video, you're going to know how to update the database that the locate command uses, so that the locate command always gives you accurate and correct results, and you'll also know how to run administrator commands using sudo. So this is going to be a very important lecture. Let's go ahead and jump right into it. Okay, so let's start learning about the update DB command, which is short for update database. How well named, right? So let's create a new file on our desktop. So I'm going to move to our desktop, and we're going to create a new file called findme.txt. So we're going to use the touch command, findme.txt, and there we are. We have a file called findme.txt on our desktop. Now, if I try and run the locate command, because this find me file has been created before our database has been updated, the locate command won't be able to find it in the database. So if I try locate findme.txt, we see we get absolutely nothing back. Okay, even though the file exists, it's not been entered into the database yet, and therefore the locate command can't find it by searching the database. Okay, so to update the database, to add it to the database, we need to update the database, and that's where the update db command comes in. So if we try it, we'll notice that we actually get an error, and the error says that the shell cannot open the actual database file. And the reason for that is the update db command requires administrator privileges in order to run. And we can see this by looking at the man page for the update db command. And we see at the top of the update db command that it is in the system managers section. It's in section 8 of the manual, and that means it requires elevated privileges in order to run. And you can see here what I was saying about update db being run daily. So you can read more about that if you like, but the important thing here is that it's in section 8 of the manual and therefore requires administrator privileges in order to run. And refer back to the cheat sheet about the manual structure if you need a bit of a reminder of that and what the sections of the manual do. Okay, so how can we get the administrator privileges in order to run this command? Well, to do that, you use the sudo command. I'm not sure if it's pronounced sudo or sudo, but I like sudo, so we'll stick with that. So the sudo command is very simple. You just write it before any command you want to run as the administrator. So I'm going to type update db, and that's it. Okay. Now, when I do that, because we're trying to get administrator privileges, the sudo command is going to ask us for our password. So I'm going to enter my password, which is the password I just use normally to log in to the Linux computer. But you'll notice that we don't see any password being typed out. Now, this is a security feature that's built into the shell that stops people from knowing the length of your passwords. And the reason is that if people know the length of your password, it makes cracking it so much easier. So don't worry that you don't see any feedback. Just type your password. It is being accepted by the shell. And when you've done that, press enter. And we'll see that the shell will pause for a bit as it updates the database. And then we have our shell prompt back, which lets us know that the command has completed. So now that we've updated our database, the find me file should be in the database now. So let's try and see if the locate command can find it. Let's type locate findme.txt. And when I press enter, you'll see that, yep, it did find it this time, and it tells us that it's on our desktop and it's called findme.txt. And we don't have to be on the desktop. We could be in our, let's say, in our documents folder. Okay, and we can press print working directory. We see that we're in our documents, but if I do locate find me, anything like that, and you see it comes up with /home/ziad/desktop/findme.txt. So it tells us where the actual file is. Now, if we take a look at the database file as well, let's just head back to our desktop for a minute. And let's take a look at the database file. So we use locate with the capital S option. We can see that actually this has changed. If I save that as database after.txt, so here we are, we've got database before and database after. If I open up database before, we see that we have 16,008 directories, 144,853 files, and whatever else. Now if I try to open up afterwards, we can see here that we've got, this is before, 144,853 files. Afterwards, 144,848 files. So it looks like some files have actually been deleted or something like from the system. How many we got? 7,592,826 bytes afterwards. Yeah, it actually looks as though since we last updated the database, some files have indeed been deleted. So maybe there was some temporary files in operation or something like that. But you can see that the size of the database does change when you update it. Okay, but if I do that again, so if I do database after 2 and take a look, there should be absolutely no difference between these two. So this is database after, and I look at database after 2, and we'll see that they are actually exactly the same. Okay, so when you update the database, it does indeed change. Now, because the update db command needs administrator privileges or root privileges in order to run, you can see why the existing and follow options exist for the locate command. So you can see why these ones exist. You've got existing and follow. They're so that when you're waiting for your administrator to update the database, you as a regular user can still get on with your work, even if you don't have administrator privileges. You could just get on with your work while the administrator is probably catching up on emails or something. Pretty clever, right? So you've learned a lot about the locate command in the past few videos, so let's just take a quick recap of what you've learned to make sure that you've got it all. First of all, the locate command searches a database that's stored on your computer for files matching the pattern that you give it and returns a list of results. And using a database is a very fast method of searching, but it requires that the database be updated in order to give you a complete and correct list of results. Now you can protect yourself against errors using the existing and follow options for the locate command, but that's not really the best solution. The best thing to do is just to update the database using the update db command, but this is done automatically daily as well. Now, in order to do that, it does require administrative privileges or root privileges or super user privileges, whatever you want to call it, and therefore you need to use the sudo command in order to actually gain those privileges. So you enter your password and then the command is ran as the administrator. So in order to update the database, you don't just type update db, you type sudo update db, enter your password, and then the database is updated. And then you can use the locate command from that point on and know that your results will be 100% correct and up to date. So locate is a fantastically useful command and I use it all the time. It's a really quick command to use, but there's another command that doesn't require a database and it can actually be way more powerful, and it's called the find command, and we'll be covering that in the next video. So it's amazing. It really is cool. You can do such powerful things with it and I can't wait to show you. So for all that good stuff, I'll see you in the next video. Hello there, you beautiful people, and welcome to this video where you're going to be learning about one of the most useful and most important commands on all of Linux, the find command. Now, the find command is used to execute sophisticated search tasks on your file system, and there is so much stuff that you can do with the find command that we're going to break up our discussion into a few videos. And in the next few videos, what you're going to learn is you're going to learn how to use the find command, so what the find command's default behavior is. You're going to learn how to control the search depth that the find command searches on your file system. You're going to learn how to search by type, so how to get the find command to only return files or directories. How to search by name, so if you know exactly what you're looking for, you can search by name, and how to search by file size, so you can say, hey, find command, find me all the files that are bigger than 5 megabytes or smaller than 10 kilobytes, for example, or something in between. And one of the really cool things about the find command is that once you get this big list of results, as you'll see in the videos, you can execute other commands or other pipelines on each of those results. So we're going to show you how to do that, and you're going to have a really powerful tool in your Linux toolkit for manipulating loads of files at once. It's going to be awesome. So by the end, in general, you're going to be able to perform sophisticated search tasks with the find command. So that's it in a nutshell. And you're going to want to pay attention to this section for sure, because this may be very useful for your assignment. Hint, hint. So I hope you enjoy it. Let's go ahead and jump over into Ubuntu and start playing with the find command. Alright, so here we are in our home directory. So let's just go ahead and see how the find command will work by default. So the default behavior of the find command, if we just go ahead and run find, is to list every single file and every single folder that is lower down in our file system than the current folder that we're in, okay, and everything inside the folder that we're in, okay. So because we're currently in our working directory, if I just type find and press enter, we see a big long list of every single file and every single folder that is in our home directory and below it, okay. So it will go into every folder, every hidden folder, and expand out and expand out and expand out and list everything. So for example, here we've got our pictures folder, okay. It will not just show our pictures folder, it'll also show that we have a folder inside the pictures folder called holiday. We also have a file inside the pictures folder called findme6.txt. For example, we've got our desktop, we've got findme1.txt, and our desktop itself, videos, and our videos/findme3.txt. So it'll list out the folders and everything inside them, and if there are folders inside those folders, then it will do exactly the same. It will go into those folders, expand those out, and if there's other folders in there, it will go into those folders and expand it out to an infinite depth. It will just go as deep as possible into your file system from starting in the current directory. Okay, so this is an immediate difference for us between the locate command and the find command. So the find command will list out files and folders, but the locate command will only list files. And the find command does not need a database in order to work. The find command just works right there and then. So it's always up to date because it operates directly on your file system. It doesn't use a database, so it's always up to date. But the one downside of that is it's slightly slower than using a database. So that's a trade-off to bear in mind. Okay, so because the find command will list every single file below where you give it, you can actually also, for example, give it the slash folder, the base folder for the entire system, and this will list every single file and every single folder on the entire system. So that's a fun thing to try if you're bored and you potentially want to smash your computer. But if you give it find/etc, then it will list everything on the system below etc. Okay, you can see it's giving us files and folders. If I give it find/home/ziad/documents, for example, it will list out everything below the documents folder. Okay, so we can see that it's given us the documents folder and the findme2.txt inside there. Okay, and if I make in our documents folder, if I make another folder, let's call it blah, let's just call it that, and copy and paste into there, we're going to call it this one test.txt. Okay, now if I do find again with the documents folder, okay, home/ziad, let's just do this, let's do the tilde. Okay, what's going to happen here is you'll see now that it's done the blah folder as well, and it's gone into the blah folder to find test.txt. Okay, so it said we told it look in the documents folder. It listed out find me2, and it saw another folder here called blah, and it opened that and listed everything out inside there. If I make another folder called blah blah, and inside there I copy and paste it so it says test2.txt, and now I just say find everything in the documents folder, you'll see that it's also listing out blah blah and test2. So the find command is searching deeper and deeper and deeper into the file system to an infinite depth. Okay, so that's something to bear in mind, and it starts either with the current directory, so I can start at the home directory, which is where we are at the minute. Okay, or wherever you give it. So if I'm tell it to start at the documents folder, it will start there and continually dig deeper into the file system until it's shown you every file and every folder, no matter whether they're hidden or not. It doesn't matter. It'll show you every file and every folder deeper than that point on the file system. So just to make this clear, if I go to the documents folder, because I'm currently in the documents folder, as you can see by the pwd command, if now I just run the find command, because the find command will start by default at the folder we're currently in, if I do that, you can see now that it has started listing out the same stuff as up here. It told us that we've got the blah folder, the blah/blah blah, and it's showing us test2 and test and find me2, exactly what we were getting in our documents folder up here, because we were in the documents folder when we ran the find command. So you can either be in the directory that you want to start searching from, or if you're not, for example, we're not in the /etc folder, we can start the search from there, and it will search from the etc folder and continue to go to an infinite depth from that point. Okay, so that's what the find command is. It doesn't use a database, it operates directly on your file system, so it's a bit slower than the locate command, but it's incredibly powerful. So now that you've understood the basics of what the find command does, in the next video we're going to show you how you can customize some of its behavior, starting with how you can control the depth to which it searches and what it searches for. Okay, so the find command searches from where you give it or from the current directory by default, and in the next video we're going to take a look at how you can control some of the way that it searches. So I'll see you in the next video. Hello there, you beautiful people, and welcome back, where we're going to be continuing our discussion of the find command and how we can control the search depth that the find command searches to. So if I open up our file explorer, I've made a few new folders. So in our documents folder, I have made a folder called level 2, and inside there I've got a file called 2.txt, and then a folder called level 3, and inside there I've got a file called 3.txt, then level 4, 4.txt, level 5, and 5.txt where it ends, okay? And we're going to be using this to take a look at how we can control the search depth that the find command searches to. So all of that stuff is in our documents folder, as you can see here. So I'm just going to change into our documents folder and use an ls, and you can see that level 2 is in there. So this is what we're seeing at the minute. This is what we are currently in. Okay, so let's clear the screen and start our discussion. If I just run the find command from here, the find command will search to an infinite depth. It will list every file and every folder from this point in the file system. Okay, so from here and downwards. So if I run that, you'll see it shows us level 2, and it will show us everything inside there. So you'll see we get 2.txt, and it shows us level 3, 3.txt, level 4, 4.txt, level 5, and 5.txt. Everything is shown in there. But we can control the depth that the find command searches to by using the max depth option. So let me show you how we do that. So if we type find, we're going to again start from our current working directory. We can actually specify that to make it a bit clearer by using the dot. By the way, remember dot means this directory, so I'm actually going to use this from now on. I'm just going to always start by saying, okay, start from this directory by using the dot, okay? So the max depth option, you type 1 dash and then max depth, and you can specify the depth here. So let's say we put 1. So the first thing you might notice is, Ziad, why is there just 1 dash? I thought you said for long form options you need to have 2 dashes. Well, that's right, but for the find command you only have 1 dash for these options, okay? Because there's so many of them, there's so many long form options. I guess they tried to save you typing by just reducing it to 1 dash, okay? So here we are, we have just 1 dash, max depth, and then 1, and this is saying only search to a maximum depth of 1, really. So if we see that, let's see what happens. You see here that we only see the level 2 folder. So a max depth of 1 is just like seeing what you see here. It only shows you what is in the current directory, okay? Now if I do max depth of 2, that's like showing you what's here and what's 1 level down, okay? So if we take a look here, what we should see is we should see level 2, and then it will go inside and it will show you 2.txt and the level 3 folder. Okay, so if we run that, max depth of 2, here we are, we see level 2, which is here. It's showing us the level 2 folder. This is where we start, so it's showing us the level 2 folder, going in there, showing us 2.txt and level 3. So we see the level 2 folder, 2.txt and level 3. Okay, now if we want to go to a max depth of 3, that's going to go down another level into level 3. Okay, so if I run that, we'll see now that we see 3.txt and the level 4 folder shown as well. If we keep going deeper, if we do max depth of 4, we're now starting to take a look inside level 4. We're seeing 4.txt and the level 5 folder. And if we do max depth of 5, it's going to go down even further all the way until we see 5.txt. And you can give it, like, a max depth of 100. And it will still work because all you're defining is a maximum depth. Okay, it doesn't mean it will go all that way. That's just as far as it could go if it was possible. Okay, now by default there is no maximum depth, so it will list everything here. We didn't have to specify a maximum depth if you wanted to go all the way into the file tree. But if you want to limit how far it goes, that's when you'd use the max depth option, and you'd say, hey, I only want you to show me what's in this folder. That's when you'd use max depth of 1, and it's incredibly useful for listing out what's in the current folder. Now, if we just clear the screen, there's another really great option that the find command has, which is the type option. So if we just go all the way back up to our documents here, the type option allows you to search for just files or just directories. Notice by default, the find command lists both. It lists both files and directories, but the type option lets you specify just one. So if I start here in our documents folder and I list out everything, starting at this folder, you see that we list out the folders and their files. But if I said, okay, I just want to list out the files, what I'd do is type the type option with, again, noticing just one dash. And if I just want files, I would type F for file. Okay, so if I press enter now you'll see that we just get 4.txt, 5.txt, 3.txt, and 2.txt. We just get the files. Likewise, I could just get the folders by pressing, instead of having F, have D. Okay, so if I type D, we now just get the folders. So level 2 folder, the level 3 folder, the level 4 folder, and the level 5 folder. Okay, starting at this directory here. Okay, and you can combine this, of course, with the max depth option. Okay, so if I do max depth of 1, now all we're doing is we're going to a maximum depth of 1 and just showing the folders. Now I did this on purpose to show you that if you put them this way around, you'll get a warning, and it says, warning, you have specified the max depth option after a non-option argument type, but options are not positional. Okay, I'll tell you what this means shortly, really quickly. Okay, what this means is just put max depth first. So that's all you've got to do, okay, and that warning goes away. So if you're going to specify multiple options, just put the max depth first. If I clear the screen, you'll see that warning goes away, okay? So now we're searching to a maximum depth of 1 and showing all the directories. Let's go to a maximum depth of 2. We're now seeing the level 3 folder. If I go to a maximum depth of 4, let's say, oops, not 42, max depth of 4, let's do 3. Can't type today. Maximum depth of 3, we're going to level 3, and we're seeing the level 4 folder. And if we go into the level 4 folder, we'll see the level 5 folder. And if we go into the level 5, go to level 5, it won't make any difference because all that's in level 5 is another file which isn't being shown because all we're looking for is directories. Okay, so if I go and change that to an F now, you'll see we list all the files, and it works exactly the same. So these are really good options to combine together, and there's loads of things that you can do to customize the way that the find command actually searches. But just to quickly summarize that, the type option has 2 possible inputs. You could give it F for file or D for directory, and if you're going to use it with the find command, make sure that you give it the max depth option first. Okay, and if you're going to specify where to start from, make sure that comes as well. So if we're going to do in the Etsy folder, and we're going to list every single file in the Etsy folder, let's say, but only to a maximum depth of 1, there you are. This is every single file that is in the Etsy folder. Oops, let me just clear the screen and do that. This is every single file in the Etsy folder without any directories, and if we just want to see the directories, then here they are. So that's a very useful combination of commands to have there, and it will come very useful in your assignment. So I'm going to break this video here, keep it nice and short and sweet, and in the next video we're going to pick up with some more awesome stuff you can do with the find command. Hello there, you beautiful people, and welcome back. We're going to be continuing on our discussion of the find command in this video by starting off showing you how to search for things by name. So let's say we want to find this file here called 5.txt, and we're back in our home folder. Okay, we're not in our documents folder anymore, we're just in our home folder, and we know that this 5.txt is somewhere in our home directory. It's somewhere below this point in the file system, but we're not exactly sure where, and we're going to use the find command to find it for us. Okay, so if we clear the screen, let's say, okay, we're going to use the find command. We're going to start from this point in the file system. By the way, this is just a matter of personal preference, actually having the dot. You don't need it, but I like to put it there just to make it a bit more complete. Okay, so there we are. Find. We're starting at this position in the file directory, and we want to search by name. So we give it the name option, again, just with 1 dash. And then in speech marks, so in double quotes, we want to search, we're going to put the pattern that we're searching for. We're going to put 5.txt, and it does need to be in quotes, otherwise the find command plays up sometimes. So make sure you just put it in speech marks in these double quotes, and you know that will be much better. Okay, so if we do that and press enter, we see that the find command has indeed found the 5.txt, and it's given us the path all the way to it, starting at the current working directory. Okay, so what if we wanted to find 3.txt? That will work as well. So it's found a path to 3.txt. You can build regular expressions in here. So if I put a star, it will find every .txt file from this point in the file system. So we see we've got one in music, we've got find me 4.txt, which I'd forgot I'd created earlier in the course. We've got some in some hidden folders. We have them all over the place. We can actually also limit the depth that we search to. So if we go to a maximum depth of, let's say, 2, remembering that we're going to put the max depth option as the first option, Okay, otherwise we get a big warning, don't we? So if I do max depth 2, name any name that ends in .txt, we can see that we found all the files that end in .txt, but only going 2 depths in. So that's really, really cool, right? You can search by name like that, and you can also have wildcards. So I could do file and then a number .txt, and nothing comes up. What if I did something like question mark.txt? Nothing comes up. But if I go to a big depth of, like, let's say 10, now we see that we just get 4.txt, 5.txt, 3.txt, and 2.txt. But these find me 1, find me 2, find me 4, etc. are ignored because they don't match this regular expression. So that is a really powerful ability. Just by building upon your knowledge of regular expressions and wildcards, you can really tailor the find command to your needs. And the one thing I should note here is that you can't do brace expansion inside the name command. Okay, so that's just something to bear in mind. Okay, at least inside double quotes. Let's just leave that there. Okay, so the other thing is that you can search in a case-insensitive way by searching .iname. So if I change this here to .txt all in uppercase, let me clear the screen, txt in uppercase, that will now match. Okay, I probably did that wrong way around. If I do it like this, just search name, okay, now you'll see nothing matches because now it's searching case-sensitive. But if I change it to iname, so it's case-insensitive, searching for the name, so uppercase and lowercase don't matter. Now it will match because it doesn't care that this txt is in uppercase. So that's good. If you're not sure whether you put an uppercase in the file name, it's good to search with iname to make the search just a bit more general. Now, another interesting way to search for files with the find command is by file size. So let's say that we wanted to search the entire file system for every file that is larger than 100 kilobytes. Okay, so let's clear the screen. How would we do that? Well, what we'd do is we'd type the find command. Then we need to give it, of course, a place to start searching from. So let's start from the very base of the file system because we want to find every file on the system. So let's start at the very base of the system. We want to search for files that are larger than 100 kilobytes. So let's say that we want files. So let's specify a type of F, so because we were just looking for files, not folders. And we want a size. So we're going to give it the size option. Again, 1-. And now this is how you'd say greater than 100 kilobytes. Okay, so you see the plus meaning greater. If it was less than, you'd have minus, so that's less than 100 kilobytes, but we want more than, so more than 100, then a lowercase k for kilobytes. So if I press enter, you'll see that we get a whole bunch of output as we look for all the files that are bigger than 100 kilobytes starting at the very base of our file system. But one thing you might have noticed, if you had a quick eye, if I scroll up to the top, is that we got a lot of permission denied errors. If I can show you by scrolling all the way back up, there we go. You can see that we've got a lot of permission denied, permission denied, permission denied. And the reason is that's because we started at the base of our file system, and remember the find command will try to enter every folder, but it couldn't because it didn't have the required privileges to enter some of the folders in our base directory that are only accessible to the root user, to the super user, to the administrator. Okay, so to fix that, we just prefix the command with the sudo command. So we're going to go sudo and then do the rest of it, and we'll get a whole lot less errors, okay, because we're not going to have those access errors before. Now we can count the amount of results that we actually got out of this by piping the entire thing into the word count command with the L option, and what this will do is it will count the amount of lines in the output that you give it. So if you notice when we run this, we get 1 result per line. Okay, so if we pipe all of that into the word count command and give it the L option, this will count how many lines there are. And if we do that, we get 3,144 results, which is a whole bunch of results. Now, one thing that's interesting is the way that you can chain together different sizes. So here we're saying it needs to be greater than 100 kilobytes, and this is how we'd say it has to be less than 5 megabytes. Okay, so here what we're doing is we're chaining together all these different requirements. We're saying that it has to be a file, and the file size has to be bigger than 100 kilobytes, and the file size has to be less than 5 megabytes. And if we count how many of them there are, we see that we get quite a few less. Now we're going to get 3,030 files instead of 3,144. So there's about 114 files that aren't being shown anymore because they were bigger than 5 megabytes. So if I clear the screen, one thing that I really want to highlight here is the way that we're chaining together different requirements, okay? So here we're saying it has to be a file, and the size has to be greater than 100 kilobytes, and the size has to be less than 5 megabytes in order for it to be contained in our requirement, okay? So how would we say something like, okay, I want to find all the files that are less than 100 kilobytes or bigger than 5 megabytes, okay? Well, the way that we do that, I mean, first of all, if we wanted to say less than 100 kilobytes, we'd do that. And if we want to say greater than 5 megabytes, we need to change that to a plus. But at the minute here, let's see how many results we get. We're going to get 0 results because it's impossible for a file to be less than 100 kilobytes and greater than 5 megabytes. Okay, you can't be bigger than 5 megabytes at the same time that you're less than 100 kilobytes. That's not possible. What we want to say is it needs to be less than 100 kilobytes or greater than 5 megabytes. Not and. It needs to be less than 100 kilobytes or greater than 5 megabytes. The way that you do that is you type a -o in between the two requirements. So here what we're saying is it's got to be a file and its size needs to be less than 100 kilobytes or greater than 5. So if we do that, you can see now that we get a whole bunch of results, 199,112 results. Now you can go quite wild with this anding and oring, but I think that will do. I think that'll do for now. You can also do not and loads of other different logical operations, if you're familiar with Boolean logic. But I'll leave that up to you if you want to find more by looking at the man pages. It would just be a bit of a mess to show by video. So we've covered quite a lot in this video. We've seen how to use the name option for the find command to search for things by name. So you'd use -name and then give it in double quotes a certain regular expression that you wanted file names to match. So I could do anything ending in .txt, for example, using the star wildcard, and that would give us all the files that ended in .txt. And you can make the search case insensitive so that uppercase and lowercase don't matter by using the iname option. So now that even though we have said .txt in uppercase, it doesn't matter because we're using the iname option. So that was the first thing we looked at, how to find files by name. Then we took a look at how you could find files by their file size, and you saw that you use the size option and then you give it a certain file size, and the plus means above, the minus means below, or you could actually give it just exactly, for example, 500 megabytes. That's exactly 500 megabytes. This is above 500 megabytes. This is below 500 megabytes. A capital G, by the way, is gigabytes, and you can find more on that in the man page for the find command. But in the next video, what we're going to be doing is we're going to be jumping onto some very exciting stuff, and what we're going to be showing you is how you can use the find command to not only give you a whole bunch of results, but in the same command also execute another command or even another pipeline on every single one of those results. So this is a turbocharger for your work on the Linux command line, and I hope you're very, very excited. So let's cut the video here and jump over into the next one where we're going to learn how to gain even more superpowers. Hello there, you beautiful people, and welcome back. Now in this video we're going to be discussing one of the most powerful features of the find command, and to be honest of the command line in general, and that is how you can, once you've gotten your big list of results from the find command, how you can take those results and perform another command on each of those. This is an incredibly powerful ability, so I hope you're very, very, very excited. So you can see here that I'm on the desktop using the pwd command, and we're going to make a directory called copy here. Okay, noticing that I'm having an underscore to represent the space. That's good practice, as I've mentioned to you before, to stop our command line messing up. Okay, so what we're going to do, okay, let's say that we want to search the entire file system for every file that is bigger than 100 kilobytes and less than 5 megabytes. So what I want you to do is I want you to just have a go at writing out that command. So how would you, starting from the very base directory, find every single file on the system and that is greater than 100 megabytes and less than 5 megabytes? Okay, so pause the video now, go have a go at it, and then come back to see how you did. How'd you get on? Did you manage it? If you did, I'm so proud of you. That's like a technique that you're going to use so often when you work with the command line. I'm really, really proud that you've got that skill. And if you haven't, practice makes perfect. Don't worry, you'll get plenty of practice as you go with your assignment later on. Okay, but this is how I'd go about it. Okay, I'd use the find command, and we're starting at the base directory. So we're going to press, we're going to type a slash. We're going to specify that we want only files by using the type option. Then we're going to say the size has to be greater than 100 kilobytes, and the size has to be less than 5 megabytes. Now, because we're starting at the base directory here, to make sure that our find command has the ability to go into every folder, we're going to prefix this entire command with a sudo, because otherwise we get permission access errors, and we don't want those. So let's just run the whole command as the administrator. Okay, so if we run that, okay, we're going to find a big list of results. When I give in my password, we're going to find a massive list of results comes out. Okay, and by the way, when these things are running, you can actually cancel it from running any command on the command line by holding the control key and pressing C. Okay, and that will stop the command running. Okay, if you know it's taking too long, or you typed something wrong and you realize it and you don't want to have to wait until the thing finishes. Okay, but we're getting a whole bunch of results. And actually, we can tell you how many there are. When let's see by piping it into the word count command, you can see we've got 3,031 results. That's quite a lot of results. Okay, now let's say that we wanted to copy every single one of those files. Every single one of those 3,031 results that matched our find command's criteria to this copy here folder. Okay, how would we do that? Well, the way that we would do that is using another option. If I clear the screen, using another option for the find command called the exec option. Now, the exec option stands for execute, and what I'm going to do is I'm actually going to maximize the screen to make this a bit easier to see. So we're saying, okay, once you've done this search here, on each result, execute something. Now here, you just type the command as you normally would. So we'd say copy, because we're going to use the cp command to copy, which is, you know, like we normally would. Now, if you remember how the copy command works, first what you do is you say what you want to copy, and then you say where. Okay, so you say what you want to copy, and then you say where. Well, we know where we want to copy it, which is going to be on our desktop. Okay, and it's going to be in the copy here folder. So that's our path to the copy here folder, /home/ziad/desktop/copy here. We could write that a bit shorter by just putting the tilde there as well. That would be fine. Okay, but what do we want to copy? Well, we want to copy every single one of those files. And the way that you represent that is by using a pair of squiggly brackets. Okay, so you type some squiggly brackets, and that what fills that space is every single one of those files. Okay, so in turn, it'll say copy, whatever file 1 was to this directory. Then it'll copy file 2 to this directory, and copy file 3 to this directory until we've got all 3,000 results. Now, when you build out these expressions, you can have multiple of these, if you needed to in your command for whatever reason. But once you have created it, like we have, so we're saying, okay, find every file that's greater than 100 kilobytes and less than 5 megabytes. And once you found all of those, execute the copy command on it and copy it to our copy here directory on our desktop. And then once you've finished all of that, to end the command, you don't just press enter. You've got to tell it when you've finished your execute option. And the way you do that is by pressing a backslash and then a semicolon. Okay, so you see the backslash and the semicolon, and that is the command completely finished. Okay, so if I go ahead and run that, okay, and we wait just a little while until our shell prompt comes back, what it is doing is it is copying and pasting every single one of those options into our copy here folder. Okay, so I guess if I stop that for now and then close this and go to the copy here folder, there we go. You'll see that we actually have every single one of those files copied and pasted into our copy here directory, or at least as many as it did before I stopped running the command. So isn't that awesome? Like, we've managed to just use the find command to not only find what we want on the whole system, but also execute a command on each of the results. So just as an aside, depending upon what type of hardware that you're running, running this command in its entirety might give your computer a bit of trouble. So if you're finding that your virtual machine crashes, just try and run the whole command to just a maximum depth of 4 to save it, finding every file on your file system. This should reduce it quite significantly, the load on your computer anyway, or try a maximum depth of 3, and that should stop any problems if you find your virtual machine is crashing. But first of all, what I want you to do at the minute is just take a look at this command. Isn't that awesome? I mean, considering that you maybe didn't know anything about the Linux command line just a few videos ago, now you're looking at this command and you're probably thinking, wow, have I actually come that far? And this is the thing, the Linux command line isn't unbelievably complicated. It's just a few concepts that if they're explained to you badly or you don't quite understand what they mean, it can be an absolute nightmare. But once you understand them, it's very easy to take, just a few building blocks here and build something incredibly powerful. So here you found a way to search for every file in your system in between 100 kilobytes and 5 megabytes in size and copy them all to a specific folder in just a command, and now you know how to do that. So I think that's amazing, and I really just wanted to pause in this video just to say I'm very, very proud of you for making it this far, and you're going to get many more congratulations on this in the conclusion section for this section of the course. Now what I want to do is I want to move on just a little bit to talk about this exec option here. This exec option is awesome. Okay, it allows us to execute a command, but it's not the safest of all things. Okay, so if what you can do is instead of using the exec option, you can actually type the OK option. Okay, and what this will do is it'll do exactly the same. It works exactly the same. You don't have to change anything, but instead of just doing the action directly, so if I try this, it will now ask me every time that it tries to copy something whether it's okay or not. So if I type Y, it'll continue, and if I type Y, it'll continue. If I type no, it won't, and so on. So I have a choice here about what it does for each file. Now this would clearly be a massive pain if you had thousands of files, but it's a good thing to bear in mind if you are doing something for a few files and you're doing something destructive like deleting or moving files instead of just copying, like in this case, and you want to make sure, doubly sure, that nothing goes wrong. You can use the OK option instead of the exec option in order to do exactly the same stuff. So the OK option is exactly the same as the execute option. You don't have to change anything else from here on. Just bear in mind that it's a bit safer than using the exec option, but it's a massive pain if you've got thousands of files to do. So as I was saying, I'm really, really proud of you for getting as far as you have in this section, in this video. By the way, you can cancel your way out of the OK option by pressing Control and C, like you see I've just done here. And of course, you can clear the screen by pressing Control and L. But what I want to do in the next video is we're going to take this to the extreme. Okay, we're going to really, really show you how powerful the find command can be by doing a little finding the needle in the haystack kind of activity. In the next video, we're going to create a folder called haystack that contains 500 other folders, and in each of those folders we're going to make another 100 files, and this will be very easy using our knowledge of brace expansion. But inside one of those folders at random, we're going to create a file called needle.txt, and then we're going to use the find command to find the needle in the haystack and move it into our home directory. Okay, so out of about 50,000 possible files, we're going to find that one and copy it exactly where we need, and it's going to be so easy to do you won't believe it. Okay, so what we're going to do is we're going to shift over into the next video, and I'll see you there to find the needle in the haystack. Hello there, you beautiful people, and welcome back. So let's go ahead and make our work with the find command totally extreme. Okay, so let's just go ahead and create a folder on our desktop called haystack. Okay, so there it is, that's appeared. And what we're going to do in here is we're going to make 500 folders. Now, I want to see if you can remember how to do this. See if you can remember how to use brace expansion to create 500 folders that are called, folder 1, folder 2, folder 3, all the way up until folder 500. So go ahead and pause the video now. Try and use brace expansion to make folder 1 to folder 500 inside of the haystack folder, and then come back to see how you got on. How'd you get on? Did you manage it? If so, great memory. If not, don't worry, it's been a while. So let's actually try and see if we can do this, right? What we're going to do is we're going to do make directory haystack slash folder 1.500. Okay, so this is saying make folder 1 to 500 inside the haystack folder. When I press enter and we look in haystack, ta-da, we've got 100 folders in there, and I probably should change the layout. There we go. Folder 1 to folder 500. Try doing that with your mouse and pointing and clicking. It will take you forever. So there we go. We've done that. Now in each of those folders, we need to make 100 files. 100 files in 500 folders? That's right, and it's actually not difficult to do at all. So challenge number 2, see if you can remember how to use the touch command with brace expansion to create 100 files called file 1, file 2, file 3, all the way until file 100 in each of the 500 folders. Okay, so go ahead and give that a go, and then come back to see how you did. All right, how'd you do that? That was a bit harder. Hopefully you got it. If not, don't worry. This is how I'd have gone about doing it, okay? So I'd use the touch command, because that's what we use to create files. And I'd say, okay, in the haystack folder, in folder 1 to 500, I want you to make file 1 to 100. Okay, so if I go ahead and do that, we shall see that inside each of these folders now we should have 100 files. So there we are, there's folder 1, now has file 1 to 100. If I pick another one here, folder 26, file 1 to 100, and so on. If we go all the way down to folder 402, that's got its own 100 files. So you can really start seeing now how powerful the shell is when you've got all these different pieces that you can use together. Okay, now what we've done is we've made a folder called haystack, 500 folders, in each of those 100 files, okay? So there's about 50,000 files if my maths is all right. So now what we're going to do is I'm going to just type something here. Don't worry about how it works, but I'm going to type a bit of code here that's going to create in one of the folders, okay? In one of the folders from 1 to 500, what we're going to do is we're going to find a file. We're going to make a file called needle.txt. Okay, so what this is saying is touch inside a random folder. It can be folder 1 to 500, any random number in there, a file called needle.txt. Okay, so we've created a file called needle.txt in somewhere in the haystack, but we don't know where. And it's our job now to use the find command in order to find it. Okay, so how can we find the needle? Let's have a think through this, clear the screen and maximize it. So let's just take a look how we might do this. So first of all, we're going to use the find command, okay? And we're going to start, where are we going to start? We'll probably start with the haystack folder, okay? Well, we know it's in the haystack, so we're going to start searching from that point. And we know that it's a file, right? So we don't need to look at all the directories, but remembering that the find command will by default list out files and directories, so we don't have to worry about searching through all the, searching and returning folders. Let's just look for files. And we know that its name is needle.txt, don't we? Okay. Okay, so if we do that and press enter, let's see if it works. And it has, okay? It's found needle.txt inside folder 449. So how awesome is that, right? We've managed to find the needle in the haystack. But now let's try and move it to our desktop, okay? So to do that, now that we've got the result, we will use the exec option to execute something on it. Now, to move something, remember, you would type move, then what you want to move and where you want to move it to. And remember, of course, we've got to end everything with a / semicolon. Okay, this is how you end the exec option. So here we are. We're going to move something to somewhere. Now, we want to move it onto our desktop. So let's just put a / desktop. Okay, so that is our desktop. That's where we're going to move it. And what are we going to move? Well, that file. So we just put a square, a set of squiggly brackets, and it works the same for one file as it would for, 100,000. So fingers crossed, if we go ahead and do that, we press enter. And now if I just close the terminal and have a look on our desktop, woo, we've actually done it. We've managed to move needle.txt all the way from somewhere inside that haystack of potentially 50,000 files, find it and move it to our desktop. So that's just how awesome what you've learned in the past few videos can be. So what you've seen in the past few videos is that the find command is a total beast of a command. You've seen it to do so very many things with it, but the main key points I'm just going to go through in a quick summary. Okay, so the find command can be used to execute sophisticated search tasks. You've also seen how to use the locate command, and that's very good for just quick searches. But if you want to do something very sophisticated, the find command is what you're going to want to use. First of all, it doesn't use a database, whereas the locate command does. The find command works directly on your file system, which means that it's always going to be correct, but it might be slightly slower. So that's just something to bear in mind. And the find command allows you to build up search queries where you can search by the name of the file, the type of the thing that you're searching for, the size, and so much more. Okay, you can see examples of those in the man page. Just type man, then find, and you'll be able to read the manual page for the find command. There's just so much that it can do. Okay, and once you've got this big list of results, you can use the exec option to execute another command on each of those results. Just remember to end that with the backslash, then a semicolon. And if you're working with a small number of files and you're doing something potentially destructive, like deleting or removing or something like that, or moving files, then use the OK option instead, because then it will prompt you to say, is this one okay, or is this okay, or is this okay, and you've got to authorize it every time. Okay, so that's something to bear in mind as well. Now, after what you've learned from the last few videos about the find command, everything else that you're going to learn in the next few videos is going to seem really like a breeze. Okay, so in the next video, I'm going to be showing you how to open files on the command line and read what's inside them. And I'll also be making plenty of kitten jokes. So for all that good stuff, I'll see you in the next video. Hello there, you beautiful people. Now, in the last few lectures, you've been doing so much stuff with files, okay? You've learned how to create them, move them around, copy them, delete them, paste them, rename them, search for them, and so much more, okay? All from the command line. But even though we can now manipulate files on a grand level, we haven't really seen how to take a quick peek at what's inside them and manipulate their contents yet. Well, that's what these next few videos are for. Over the next few videos, you're going to be learning 5 new commands that will allow you to manipulate file contents. So this is stuff such as reading files, reversing files, and even sticking files together, as well as reading them in some paging programs. So what this is going to allow you to do is to get most of your work done from the command line without ever having to need to open up external editors, which is going to be a massive productivity boost, and it's going to keep you inside the whole command line work process ecosystem. So this is going to be very, very useful. It's kind of like a missing piece at the minute, and after the end of the next few videos, you're going to be able to perform a whole bunch of useful functions on the contents of files, which when combined with what you know about manipulating files in their entirety is going to make you, the file manipulation master. So let's just go ahead and jump right into it. Okay, so the first command that we're going to take a look at is the cat command. Now, do you remember those kitten jokes that I was talking to you about earlier? Well, meow. So now you've actually seen the cat command before, so this will be a rather nice refresher. Okay, so you can see here on our desktop we've got a few files. We've got file 1, file 2, file 3, file 4, and file 5.txt. So let's take a look at what's inside the first file, but instead of opening it, we're going to look in our terminal to see what's inside the file. Okay, so if we type cat and then file, I need to be on the desktop, don't I? So let me change to the desktop. Clear the screen, and then type cat and file1.txt. Okay, and when I press enter, we'll see that the contents of the file have been written to standard output, and we can see that the file contains the word hello. Now, if I double click that and open that graphically, we can see that yes, all that file contains is the word hello. Okay, so using the cat command, we managed to get that the contents of the file printed to standard output. Okay, so let's try and see what's in file number 2. Okay, so if we do cat file2.txt, we can see the word there is inside. I guess you can imagine where this is going, right? So if I go file 3, it says you. If I see file 4, it says beautiful. And I bet we can all guess what's in file number 5. So if I press 5, it says people. Okay, so if you put all the 5 files together, it says hello there, you beautiful people. Well, what a coincidence. I wonder how that happened. So, in fact, you can actually use the cat command to stick files together, okay? And that's actually usually what it's for. Cat is short for the word concatenate, which is a fancy word for stick together, okay? So what cat does is stick together all of the input files and then pass that stick together stuff to standard output, okay? So if I clear the screen, if we do cat file1.txt, file2.txt, file3.txt, file4.txt, and file5.txt, and press enter, you can see that hello there you beautiful people has been made by sticking together the 5 different files, and then that has been printed to our standard output. But we can of course redirect this to a new file called beautiful.txt on our desktop, which we see has been created here, and when we open that, we now see that we've got a new file that says hello there you beautiful people, that has been created by sticking together 5 other files. Now we can actually see, you can see this command line here is quite long, right? Well, we can actually simplify that using our knowledge of wildcards. So instead of having cat file1.txt, file2.txt, file3.txt, file4.txt, and file5.txt, you can just use a wildcard like this: cat together files 1 to 5.txt into beautiful. So if I delete beautiful.txt and run that wildcard, and it's been created again, and we can see here that yep, we get exactly the same result, hello there you beautiful people, but a lot less typing. So that's pretty cool, right? Now the cat command, when you want to stick files together like this, it's useful for sticking together text files, obviously, but it can be very useful when working with audio or MP3 files, for example. So if you could have multiple different single MP3 files, different songs, for example, but you can actually concatenate them together, stick these different files together to create one long file that has all the music in it. So that's pretty epic. So the cat command is used to stick files together, or actually, if you want, just read the contents of a file. So we could just do cat beautiful.txt, so cat beautiful.txt, and we can see the contents of any file, which is really, really useful. But another command that I want to take a look at is the tac command. So let me just clear the screen here. So the tac command is just cat spelled backwards, and it's used to reverse whatever it receives as an input. So if we make a file called alpha.txt by echoing, let's say, ABC to alpha.txt, and we're going to also echo DEF to alpha, and notice the way that we've got 2 arrows here because we're going to append to the same file rather than overwrite it. Okay, so now if I look in alpha.txt, we've got ABC on one line and DEF on another. Okay, so if we read the file, using cat, we do cat alpha.txt, we get ABC, then DEF. Okay, but let's see what happens if we read it using tac. So instead of cat, we read it using tac, which is the cat spelled backwards. And you see now that we get DEF, then ABC. So you can see that the tac command actually reads the whole file in reverse, but leaves the lines the same. So it just wrote the last line first, and then the first line last, right? But it didn't affect any text on each line. So if we stick together the various different files here, the file 1 to 5, using cat, so if we do file 1 to 5.txt, you see that we get the output there. But now I want you to think what might happen if we pipe that into tac. Okay, now tac will reverse the file line-wise, so the last line will be printed first, and the first line will be printed last. So what do you think might come out of this? Just take a couple of seconds to have a think about it. So what might happen is the last line, which is people, would come first, and the first line would come last. So what might come out is people, beautiful, you, there, hello. Okay, so let's have a look. There we go, yeah. People, beautiful, you, there, hello. So think of the tack command as reversing a file vertically, okay? So it just flips it upside down. It doesn't affect any of the lines, it just flips it upside down. And of course, because this is all being printed to standard output, you can, of course, redirect it into another file called reversed.txt. And here we are, here's reversed.txt. When we open that, we see that we've saved the output in that file. So that one good thing about the tack command where it can be used is, again, if we take the example of MP3 files, I don't know if you've ever seen those videos online where people say, oh, look what this song says when it's played backwards, and like, you know, they try to say it's got some hidden messages in the file. Maybe you've seen those kind of videos. Well, maybe they were made using the tack command, because if you run an MP3 file through the tack commands, if I did something like tack myfile.mp3 and save that into another myreversed file.mp3, then this file, this one here, will be the same song but played backwards. Okay, so that's something to potentially give a go if you would like. Okay, so that's the tack command. The tack command will reverse files vertically. There's one other that I want to look at, which is called the rev command. So the rev command allows you to reverse the content on each line. So if I clear the screen, okay, and we cat together the various different files, again, we get hello there, you beautiful people. But if I pipe that into the rev command, okay, look what happens here. It's still saying, if you can read it, it still says hello there, you beautiful people. So the lines are vertically the same, but horizontally they've been reversed. So the last letter of each line, so here's the O, is now become the first letter. And, you know, it's reversed them along the lines, but the order of each line is the same, if that makes sense. If we put the tack command, you can see that people is the first line, whereas here people is the last line, but the letters have been reversed. Okay, so this is the way you can think of rev and tack. Tack reverses a file vertically, and rev reverses a file horizontally. Okay, now you can really jumble up files by piping it through both of them. So if I pipe it through tack, it's going to reverse vertically, but then if I pipe that also through rev, you've now got a vertically reversed and horizontally reversed file, which is a good way of jumbling up stuff if you ever find that particularly useful. But yeah, just to make it easier, just think of tack as reversing files vertically in columns, and you can think of rev as reversing files horizontally across the rows. So all of these commands, whether it be cat or it be tack or it be, you know, rev, all they're doing is they are taking a file, reading it into standard input, doing some processing, and then, you know, just spitting that the output to standard output. Okay, so they're a good way, well, cat is a good way of reading files, and, you know, the others are a good way of jumbling up stuff. But the problem is when you read files to the terminal like this, if a file is particularly long, it can really just clog up your screen, and it's not very useful, and you find yourself scrolling a long way. So if we try to find a file that's quite large, so if we say, for example, let's use the find command. Let's search our system up to, let's say, a maximum depth of 4. We don't need to go too far. For any configuration file, so a name that ends in .conf, and a size that, let's say, over 20 kilobytes. Okay, so here we are. We only get 2 really, but there's one here called cupsbrowsed.conf, and this is to do with like printing services, and it's apparently rather large file. So if I copy that, and try to cat it out, okay? So if I try to cat that out, oops, you see it just happened right there. If I try to cat that out and press enter, you see that we've just shot down a stupid amount of lines. Can you see now? And if I wanted to have a look at it, I ended up scrolling all the way through here. It's not very good, right? So that's a problem when you're dealing with stuff on the command line, and we want a more elegant solution to dealing with relatively large files. And sometimes, you know, if I just wanted to read out a file, maybe I don't want all of the file, maybe I only want a certain snippet of it, maybe I only want the top 10 lines or the bottom 10 lines or something like that. And we need to have a better way of being able to deal with file contents on the command line. So in summary, so that's what we're going to be covering in the next video, but in summary of this video, we've seen that the cat command can be used to actually read out files. So if I look at beautiful, on our desktop. If I read out beautiful.txt, we can read that out. If we want to reverse files vertically, we can use tac. If we want to reverse files horizontally, we can use rev. But either way, all of these, what they're doing is they are just reading a file's content and spitting it out to standard output, where you can then of course pipe it into other commands to do other processing. Okay, or like, while you're working on the command line, if you just want to see quickly what's in a file, you can just use the cat command and then see that really quickly and get on with what you were doing. Okay, so there we are. Those are the cat, tac, and rev commands. But in the next video, we're going to take a look at how you can level up this ability to do more sophisticated things. So I'll break the video here and see you in the next video. Hello there, you beautiful people, and welcome back. So in the last video, you learned how to open files and read their contents by using several command line commands. So for example, the cat command will open up a file and allow us to read its contents. So if we use file1.txt, we can see that it contains the word hello. And when we open files like this, what happens is everything is shown all at once. So no matter how long the file is, it will all be spat out right into our terminal, and that can be kind of a pain. So for example, if we try to open up a really long file, such as the file that I showed you in the last video, which is something to do with printers and stuff on your system. So if I type that in, so cupsbrowsed.conf, okay, and I try to print that out, you can see that we've just shot out a whole bunch of information, and if we want to read it, we've got to scroll up and down like this right in our command line, and it's a bit of a pain, right? Like this is not really a nice way you want to be able to deal with long files. So to help with this, there are programs on Linux called pager programs that allow you to page through large output to make it easier to read. And the one that we'll be covering in this video is called the less command. So if we just do, instead of cat, if we do less and then give it the file that we want to read, you can see now that what's happening is we started first of all at the top of the file, and by just using our keyboard keys, our arrow keys up and down, we can scroll through this content and read it by scrolling up and down a lot easier than if we'd had it just on the command line. And if I press Q, you can see down the bottom here we got these two colons. If I type Q, it closes, and now we're back on our command line with no mess that we have to scroll through. So that's a nice way of doing it. And actually, you can pipe to the less command. So instead of opening it directly like that, I could use cat to open the file and then pipe into the less command, and it will give us the same result. Now, this ability to pipe to the less command is incredibly useful because it doesn't just have to be files that you are dealing with. For example, if I said, okay, let's go into our home directory and let's find all the text files, okay? So we're going to find by name everything that ends in .txt, okay? And we see that we get a whole bunch of information here. Now, this could be quite long. It could be quite a lot of stuff. But what we're going to do is we're going to, instead of that, actually, instead of just the text, let's just try and find everything, okay? It's printed out a whole bunch of stuff that we've now got to scroll through. Instead of that, we could just pipe it into less, and now we can scroll through line by line. So the less command is a really useful one when working with the command line because it saves you from having a load of mess filling up your screen, okay? And piping to it is really, really, really useful, okay? Because now we can just press Q, and all the mess has gone. Now, sometimes you don't want the whole output or the whole file, and you only want to operate on a piece of it, okay? So perhaps you want to take a little piece from a file and pass it through your pipeline instead of having the whole file on your screen, okay? You just want to peek at a little piece before getting on with your work. So for this purpose, we can use the head and the tail commands. Now, the head command will allow you to see a little piece of the file starting at the top or the head of the file. And the tail command will kind of do the opposite. It will allow you to see a little piece of the file starting at the bottom or at the tail of the file. Okay, so for example, let's concatenate together the 5 files again. So I'm going to go to our desktop and clear the screen. And I'm going to cat together files, clear the screen, cat together files 1 to 5, okay, .txt. And we see that we get 5 rows out, okay? Now, if I just pipe this into the head command, we just get the same output. So why is that? Well, that's because the head command will by default show you the first 10 lines of a file, and since there are only 5, we'll see it all. But we can edit this behavior by specifying how many lines that we want to see. So if I just press the up arrow key to get what we want, I can give the head command the n option and specify how many rows we want to see. So now we're just going to see the first 2 lines, and you'll see there we go, we just see hello and there, the first 2 lines of the output. Now, the head command is very useful in pipelines. Again, let's say we were doing the find command and we're back in our home directory and we ran the find command, we get a whole bunch of output, and let's say you just wanted the first 5 of these options. You could just pipe it to the head command, give it the n option and say, hey, I just want 5 lines. Let me press enter, and you see, there we go, we get the first 5 results. And then you could take those and pipe them down the pipeline for whatever reason you wanted. So maybe I wanted to, then pass those into the tac command and reverse the order that they're in, or whatever it might be. Okay, so that's a really useful application of the head command. It works the same for the tail command, but the tail command will just show you from the bottom rather than from the top. But I want to show you that actually you don't need to just pipe to the head command. You can operate directly on files. So we had that really long file, didn't we? We had, what was it, /etc cups browsed .conf, and you see we've got this really long file. Now, if we can actually see how long that is by piping that to the word count command and giving it the L option, like you've seen a bit earlier in the course, and we can see we've got 673 lines. That's quite a few lines. But what if we just want the first 20 lines? Well, instead of piping it, we don't have to do that. What we can do is we can just say head, give it the N option of the first 20, and then give it the file and just operate directly on it, and we will get just the first 20 lines. And we can confirm that we do indeed have 20 lines by, just pressing the up arrow key here and piping that into the word count command with the L option to count the amount of lines, and we'll see that, yep, we do now only have 20 lines of output. So that's perfect. Now, the tail command works basically the same way as the head command, except it starts from the bottom of a file. So if we do our catting again, we go back to the desktop and we cat out file 1to5.txt, and we'll see that, yep, we get hello there, you beautiful people. Now, if we pipe that into the tail command and say we just want the bottom 2 lines, then we'll just get beautiful people, so the bottom 2 lines, okay? And if we, again, were operated on the really long file, so instead of having head, let's have tail, get rid of this word count at the end. Now, if we press enter, you can see that we just get the bottom 20 lines, and we can again pipe that into word count and see that, yes, we do indeed have 20 lines. So head and tail allow you to cut either the top of a file or the bottom of a file, respectively, to control exactly what you want. And you can use these together to kind of filter out specific lines. Okay, so let's say we did, let's go back to our head example, and let's say that we cut out the first 20 lines. Okay, so these are the first 20 lines of that big long file. And then if I piped that into the tail command and said, okay, give me just 1 line from the bottom, okay, then this blank bit here is going to be the 20th line of the file. Maybe that's not that exciting. Let's say if I get, say, 3, okay, then that's going to give me lines 18, 19, and 20 of the file. And you can use the commands in this way to cut out specific lines. Okay, so that's quite a useful combination right there. But really, where these things come into their real use is when you are building your pipeline. So the example I've been using and leaning on is the find command, because it gives us a lot of output. But if you wanted to just get a specific set of lines, so let's say I wanted the last 3 lines, I could just pipe those into the tail command and just say, okay, just give me the last 3 lines, and then continue to pipe that down, or even export it, let's say, into export.txt on our desktop, and then you can save that and keep just the lines that you want, rather than having to have a whole bunch of output that you don't need. Okay, so it's like a filter. The head and tail commands are best seen as filters that allow your pipelines to get you just what you want to work with. Whew, so we've covered quite a lot of stuff in the past few videos, right? But fortunately, none of it is particularly complicated, but it's all very useful. So as a quick recap, you've seen how to join files together or concatenate files using the cat command, which is a great tool for not only joining files together, but also allowing you to take a file's content and putting it right into standard output so that it can be used in your pipelines. You've also seen how you can reverse files vertically, so using the tac command, and you've also seen how to reverse files horizontally across their lines using the rev command, and using both of those together is a real good way to jumble up your files. Now, some files that you want to read are very, very long, and just viewing their contents with the cat command, for example, is a bit of a mess, and it gives you a lot of stuff you've got to scroll through. So you saw how to use the less command to page through massive amounts of output or large files from the command line without needing to make unnecessary files just to view the output. And piping from commands to the less command is a great way to keep your terminal tidy and make your workflow more effective and just make dealing with large amounts of data a lot easier to handle. And finally, you saw how to use the head and tail commands to cut out just what you want from a file, and if you would like, then pass it straight on down your pipeline. So these are really, really useful tools that will come in handy quite often when working with file content. So now you not only know how to manipulate files as a whole, so copy a whole file, move a whole file, delete a whole file, but now you know how to operate a bit more on their contents. But there's so much more that you can do with file contents than simply just looking at them or sticking them together. So in the next video, you're going to learn how you can sort a file's contents either alphabetically or numerically. And being able to sort contents is super useful. It makes finding what you're looking for easier and works perfectly alongside commands such as the head and tail commands that we've seen in this video to make really powerful combinations for getting just what you want out of a file. So this is going to be epic. Sorting files is just a really, really useful ability. So for all that goodness, I'll see you in the next video. Hello there, you beautiful people, and welcome to this video where we're going to be learning about the super useful sort command. Now, the sort command is one of those commands that you can kind of use anywhere to sort data and make it more ordered and easier to manage. And over the next few videos, I'm going to be showing you how you can use the sort command to sort data in a variety of different ways. And I'll also be showing you some use cases of when this can be really useful, and we'll be building a super powerful pipeline that will allow us to sort data in tabular format. So by the end, you're going to be amazing at sorting data, and you'll have a really good understanding of how to use the sort command to sort data in Linux, no matter whether it's text, numbers, modified numbers, or even in tables. Ooh, so this is going to be a very useful section of the course. Let's go ahead and jump right into it. Okay, so the first thing I should probably say is that I've put 3 files on my desktop. I've got words.txt, which contains 100 random words, sorted in no particular order. They're just 100 random words that are just in that file. We've got the numbers 0 to 9.txt, which is a file that has loads of numbers in there. I think 100 numbers, each between 0 and 9. And we've also got this other file here called numbers.txt, which is I think another 100 random numbers, but they're in no particular range. Okay, they're just 100 random numbers with no specific limit on them. And I've made these files available in the resources section, as well as some information about how I created them. So if you want to grab those and try this stuff out for yourself, then you can go ahead and download them and give it a go. Okay, so let's start off by taking a look at this words.txt, which is the file that contains 100 randomly generated words. And as I said, if we just open that up again, it's just got 100 random words in there in no particular order, no particular length, just 100 randomly generated words. Okay, so first of all, how can we sort that file so that it's sorted alphabetically? So everything that starts with an A is at the top and everything that starts with a Z is at the bottom. Well, that's actually the default behavior of the sort command, which is the perfectly named command for this kind of thing. So it's really simple to use as well. If we just type sort words.txt, ta-da, we've now got a list of sorted I've sorted words from A to Z. So you can see that all the words that start with A are at the top, and all the words that start with Y are at the bottom. And it doesn't look like we've got anything that starts with a Z. So they've all been sorted alphabetically. So that's pretty cool. And of course, we can write this standard output to a file, or, you know, to a T command. We can use that as well. Okay, so like, you know, we could say another file here called sorted.txt, and that's going to be output there. And we can pipe it down the pipeline. You know, it's just written on standard output. All the same rules apply. So what if we wanted, instead of sorting it A to Z, what if we wanted to sort it in reverse? How would we sort it so Z was at the top? Well, two options come to mind. First of all, what you could do is you could just sort the words, like just like normal, but then pipe that into the tack command. And as you can see here, what's happened is the letters, the words that start with A are now at the bottom, and the words that start with closer to Z are now at the top. And the reason for that is that, as we know, the tack command will flip output vertically. So what would be at the bottom is now at the top, and what was at the top is now at the bottom. So that's effectively as though we've just reversed the sorting, right? But a better way to do it, I suppose a more built-in and efficient way to do it, would be to just give the sort command the R option. And the R option stands for reverse. So if I do that, we can see, again, we've got the letters starting with A are towards the bottom, the words starting with A are towards the bottom, sorry, and the words starting with closer to Z are now at the top. And now you may notice that when I'm showing you this output, that I'm scrolling up and down the shell quite a bit. So this is where the less command would come in. I could just pipe it into the less command to make the output a bit easier to view, because now I'm using the arrow keys instead of scrolling with my mouse pad. So that's, you know, a bit of a nicer way to deal with things. I can press Q to come out of that. So just building upon what we did before. So awesome. Notice how you now have enough building blocks that you can solve the same problem in multiple ways. You know that you could now use the R option to reverse it, or if you didn't want to do that, you could also pipe it into the tack command. This is one great thing about Linux. It gives you multiple different ways to solve the same problem, because you've got so many different building blocks. So there's plenty of room for creativity in the way that you approach these problems. There's no necessarily one right way to do it. So there we are. Now, how about sorting numbers? Well, I have a list here of 100 numbers called numbers.txt, and if we take a look, there's 100 numbers in there that don't have any particular size limit. They can be any number, but there's 100 of them. Okay, so how would we sort those? Well, sorting with letters, so sorting A to Z, sorting alphabetically, is different from sorting numbers, which is sorting numerically. So if we try to do sort numbers.txt like that, you see, it didn't really work that well. What kind of happened here is, if you notice, let me pipe this into the less command so we can make it a bit easier to see. You notice that all the numbers that started with 1 have come to the top, and then it kind of, as you see now, we're getting all the numbers that start with 2, and then we're getting all numbers that start with 3, and so on, okay? But we're not 4, 5, 6, 7, 8, 9, okay? You can see it's sorting by the first digit, but it's not sorting by the value of that number. For example, 16,029 is much bigger than 1,641. So why is it above it, right? There's no real sense of the size of the number. It's just the fact that it starts with a number 1, and it's sorting numerically as it goes. It's sorting as it goes along by just looking at the number. It's not looking at the value of the number. It's just looking at the digits. But if you want to sort using the value of the number, you need to give the sort command the N option. So the N option allows it to sort numerically. When we take a look at that, now you can see that we're getting the smallest numbers at the top. So we're starting with 123, and then the numbers are getting bigger as they go down. So that's something important to bear in mind. Sorting just by the digits is different than sorting by the value of the whole number. And if you want to sort by the value of the whole number, you need to give it the N option. And of course, you can reverse this so that the biggest are at the top by giving it the R option as well for reverse. So now we see that the biggest numbers are at the top, and as we scroll down, the numbers get smaller. So that's very, very nice. So you've seen how to sort text alphabetically, and you've seen how to sort numbers numerically, but one thing that's very useful is to only show unique results rather than the same result over and over and over again. So we've got a file here called numbers0to9.txt, and in there's 100 rows of data, but only the rows only contain one of the numbers from 0 to 9, so you'll necessarily have some duplicates. For example, here we've got 0, 0, 0. Okay, it's not just unique results, there are results that are repeated. Okay, so if we take a look in here and we try to sort that, if we try to sort numbers 0 to 9.txt, let's pipe it into less, you'll see that all the zeros come first, then all the ones, then all the twos, then all the threes, then all the fours, the fives, the six, the sevens, the eights, and the nines. Okay, and that's it's a bit annoying. Okay, maybe we just want to just have the results once. Well, to do that, what you do is you give the sort option, sort command, the U option, and the U option stands for unique. And when you run that, now you'll see that we only get the results once. Okay, so let me just, instead of piping that into less, there you go, you can see that you only get the results once, so 0 to 9. And this is useful. Sometimes you don't want to have the same result repeated over and over and over again. You only want the results to appear once, and that's where you would use the U option, which allows you to sort uniquely. And of course this still works with other options such as the reverse, which, you know, now we're sorting backwards, and you can still sort numerically and whatever else you might need to do, but that's just how you can make sure that you only get each of the results once. So in this video, you've had a bit of an introduction to the sort command, and you've seen that you can sort data using the sort command. Now, the sort command tends to sort smallest first, so it'll tend to sort from A to Z, or from 0 to 9 by default, okay? But you can reverse this by using the R option. So the R option stands for reverse, and if you're ever sorting numerical data and you want the sort command to take into account the actual value of the number rather than just the digits that it contains, then make sure that you give the sort command the N option to allow it to sort numerically. And if you only want to get unique results out of the sort command, provide it with the U option, which will filter out just the results that appear once. So that's what we covered in this video, but in the next video we're going to take it to a next level and show you some advanced sorting techniques that will allow you to sort data that comes in table format. So, and we're also going to be building a really cool pipeline that will do some of this as well. So let's just go ahead and get right into it in the next video and take your sorting skills to the next level. Hello there, you beautiful people, and welcome back. Now in this video we're going to be discussing how you can take your sorting abilities to the next level by looking at how you can sort data that is in tabular format, so data that comes in tables, by showing you how you can sort up and down various columns. Now this is super cool because it means that you can do all this kind of data sorting right from the command line. You don't need to open up a spreadsheet software, you can do it right there in the terminal and save all that juicy processing power. So let's go ahead and jump right into it and see how this works. Alright, so sometimes you get a lot of data out of your commands, and one example of this is the ls command with the L option, so the ls-L command. So if, for example, if we did that on the etc folder, so this is the folder that contains all of the system configuration files, you can see that we just get a whole bunch of results out of this, okay? You just get loads and loads and loads of stuff coming out of there, okay? But, you know, just to make this a bit easier to see, let's just pass that into the head command and get the first 20 lines, okay? And there we are. There's the first 20 lines of output. Okay, so what if we wanted to sort this data by the columns? So what if we wanted to sort by certain columns? Now you can actually do that in the sort command using the K option. So for example, if we wanted to sort by, I don't know, I guess this column, which is about the file sizes. So you see this one here, that this column is all about file sizes. Or maybe we want to sort by date, for example, and we wanted to sort by date, which would be these few columns or whatever. You know, you can do all that in the sort command. So let's just see how we might go about doing this. So how we'd do it, if I just clear the screen, is you'd pipe it into the sort command, all the data into the sort command, and you give it the K option. Now after the K option, you need to tell the sort command how to sort this input using what the sort command calls a key definition, or a key def. Okay, this is all in the man page, by the way, but let me show you how it works. First, you tell it what column it should sort by. Okay, so if I just scroll up a little bit, you can see our results that we got before. We want to sort by the column with these big numbers here. Okay, now those numbers, as I said, are actually file sizes in bytes. So let's say we want to sort our files from largest to smallest. Okay, so first we need to give the key def the column number we want to sort by. So if we count, here's column 1, so that's 1, it's column 2, that's column 3, that's column 4, and that's column 5. Okay, so the column number is 5, so if we come back to our new command line, we're going to type 5. Okay, then you need to tell it, then you basically can pass it any other options that we like. So for example, if we want to sort numerically, we would type N. Okay, and you can pass any options you like. So if you wanted to sort reverse, you'd type an R there as well, just like you've seen in the last video. If you wanted unique, you'd type a U, and that's it. That's how you make your key definition. But let's just have the N for now. So what we're saying here is, okay, list out everything that's in the Etsy folder, take the first 20 lines, and then sort it by the 5th column. Okay, and when we press enter, we'll see that, yes, actually the data has been sorted by the 5th column. You can see that we're starting with the smallest files first and working all the way up until the biggest, but actually we wanted it the other way round, didn't we? We wanted the biggest files first. So if we wanted to make that happen, we just type an R there. So we're saying sort numerically, but in reverse order, so largest to smallest instead of smallest to largest, remembering that the sort command by default goes small to big. Now we're going big to small. So when we do that, we see that, yep, now we're starting at big, 4096, and getting smaller as we go down. So that's super cool, right? Like, we've just taken a big set of data and sorted it by columns, which is an amazing ability to be able to just do from the command line. Notice we didn't have to open anything like Microsoft Excel. We just sorted the data straight from the command line. But one thing that you might notice, especially with the ls output, is that these file sizes are kind of hard to interpret, right? These are all in bytes, and I don't know about you, but I tend to read things in kilobytes or megabytes or something like that. I don't tend to read it directly in bytes. So, as you know, the ls command has an option that allows you to read, to give the data in human readable format. So if we do that, if we do human readable format, you can see now that what's happening is we're getting, it's telling us the amount of kilobytes. So it's saying this is 4 kilobytes, 4 kilobytes, 4 kilobytes, 3 kilobytes, 2.2 kilobytes, and then the rest are just in bytes. And it would say megabytes, gigabytes, whatever it was for the files that we were dealing with. So that's the H option for the ls command. It gives you human readable output. But you may have noticed that this has just completely messed up our sorting. Right? It's just like before we were sorting perfectly, like we were sorting biggest at the top, smallest at the bottom, but now it's just doing whatever it wants. And the reason is the sort command, when you tell it to sort numerically with the N option, that's a completely different thing to sorting with human readable data. Okay, so to make it actually sort with human readable data, you need to give it the H option. Instead of the N, you give it the H option, and you can't have both at the same time. Okay, so if I clear the screen, and instead of having the N option, we now have the H option, and we press enter. Now you can see that it's working, and we're getting the largest sizes at the top and the smallest at the bottom, while still getting the data in human readable format. So we get the best of both worlds, really. So remember, if you want to sort by human readable data, you just need to give the sort command the H option in its key def, or just in general if you've only got one column to deal with. But here we had it in a key def, so we typed the H option there. Now you can also sort by month, so let's see how we might sort by this column here, which is all about, you know, the date and the file was last edited. So let's clear the screen and let's take a look here. So we're saying print out list for us in long form format with human readable file sizes, everything in the Etsy folder. Give us just the top 20 lines and sort for us by the 5th column, human readable reversible. Okay, reversed. Well, actually the date is the column after this one, so we need to have, instead of the 5th column, we want the 6th column. So what we're going to do is in our key def, we're going to change the 5 to 6, and instead of human readable, we're just going to put a capital M. Okay, now this is going to allow us to sort by month, and if I press enter now, you can see that yes, we have indeed sorted by month, and we've got January at the top, and we've got then May, August, and then October coming all the way down the bottom. So that's really, really cool, right? You can also as well combine this with, you can combine this with reversible by putting an R in there, and now we'll find that if I clear the screen and run it again, you'll see that October is at the top, and now January is at the bottom. So there you go. Like it's once you understand these several different options, it's really not that much more difficult to sort by certain columns. All you've got to do is sort, is just in the key def tell it which column that you want. Now here's a challenge for you. I want to see whether you can tell me how you might sort by this column so that the smallest numbers come first. Okay, so how would you sort by this column, which is just, that has these numbers here? How would you sort by that column so that the smallest numbers were first? Go ahead and pause the videos now and then come back to see how you did. How'd you get on? Did you manage it? Well, if you did, well done. That's really, really quick learning. Here's how I would have gone about doing it, okay? So what I'd do is we'd keep everything the same, ls-lh, with the etc, taking out the top 20 lines, and now the only difference is our key def, okay? So the first question, we know we've given the K option to the sort command. The first question is, what's the column number? Well, the column number, well, here, this is the first column, this is the second column, right? So let's put 2, and we want to sort this numerically, right? So we're going to sort it numerically. Now, by default, the sort command will sort smallest first, right? So that means we don't have to reverse anything. It will start with the smallest number first by default. So if I clear the screen and try that, ta-da! Now we see that it has been sorted by this column with the smallest numbers coming first. And if we wanted to reverse that, we just give it the N option, and it would reverse that, so that now you're getting the 8s at the top and the smallest numbers, the 1s, down the bottom. So there's loads of different ways that you can do this, but there you are. That's how you would use the sort command in order to sort data in columns. And as usual, one thing that I should note is that here we're having N and R. It doesn't matter if I wrote that R and N. It doesn't matter at all like what order that you write stuff in these key definitions. Just think of them as normal options that you just put right there in the key definition. So order doesn't matter. So there you have it. We've covered a whole lot of stuff in the last 2 videos about sorting data, and in this video we took a look at how you would sort data that is in a table format using the command line. And you saw the key to this was to use the sort command with the K option. Now you need to give the K option something called a key def, and a key def follows like this kind of structure. So first you'll give it a number, and that number is the column that you'll sort by. So for example, we have the number 3 here, and that means sort using column 3. Then after that, you can give it any other options that you want, like you've seen in the last video. For example, you could give it the N option to sort numerically and the R option to sort in a reverse manner, so largest to smallest instead of smallest to largest. And to sort human readable data, you'd use the H option, not the N option, and those are incompatible. You can't use both at the same time. So if you've got human readable data, then use the H option instead of the N option, okay, like you saw with the ls command that we used in this video. Now you can also sort using months using the capital M option, and because the sort command sorts smallest to largest, you'll find that January comes first and then December comes last, but of course you can reverse that using the R option as well. And the order of options in the key def don't matter as usual, just like you were entering them normally on the command line. It doesn't matter if you put N and then R instead of R and then N. It doesn't matter the order, but just make sure that you don't have incompatible options such as the numerical sort and the human readable sort at the same time, because that won't work very well. So you now know how to sort data using tabular data using the command line, and now you should be really the master of sorting data using the command line. So well done you. So in the next video, what we're going to do is we're going to take a look at an incredibly versatile command called the grep command. Now, because one thing that is super useful when working with the command line is being able to search through data to find what we are looking for, okay, and pick out just the bits that we're interested in. Now, the grep command has got to be one of the most commonly used commands of all time, and it's going to be such an awesome addition to your Linux toolkit. You've probably already come across it in some form or another. If you've ever done some searching around on the internet for anything to do with Linux, you've probably come across the grep command. So I can't really wait to show you this and show you how to use it properly. So for all that good stuff, I'll see you in the next video. Hello there, you beautiful people. Now, when you're using files or when you're using data from standard output, it's very likely that you won't want all of the data, but rather you'll just want a specific piece of it, and you'll want to cut out all the rest. Now, the way that we do that in Linux is using a command called the grep command, and if you've ever searched about Linux on your own, maybe just been, using a search engine, having a look around, you'll no doubt have already come across the grep command. That's just how useful it is. So in the next few videos, we're going to be showing you how you can use the grep command to search through files and standard output so that you can filter out just the data that is important to you. And by the end of the next few videos, you're going to have a very powerful new tool that will allow you to do what you want much faster, help you find things in data much faster, and really help you cut out a lot of the fluff that you don't want so that you can get the results that you want. So let's just go ahead and get right into it. Okay, so as a quick heads up, the first thing I want to talk about is what the grep command actually does, okay, before we start discussing how it works. So the grep command will search whatever input that you give it for lines that contain a particular piece of text that you tell it to search for, okay? So for example, I have a file here called hello.txt on our desktop, and if I head over to the desktop and use the cat command to take a look at what's inside it, surprise, surprise, it says, hello there, you beautiful people, with each word on its own line. Now, let's use the grep command to find all the lines in there that contain the letter E. Okay, now the way that we do that is we would type grep, then what we're searching for, so the letter E, and then what we're looking in. So we'd say in hello.txt. Okay, so here what we're saying is, hey grep, find every line in hello.txt that contains the letter E. And now by default, the grep command is case sensitive, so uppercase and lowercase do matter. Okay, so if I press enter, you'll see here that we're seeing the lines that contain the letter E, and even the letters themselves have also been highlighted. So that's pretty cool. Now, interestingly, in 1939, there was a person called Ernest Vincent Wright who wrote a novel called Gadsby that was about 50,000 words long. Now, the special thing about Gadsby was that even though it was 50,000 words long, not once was the letter E used. Now, isn't that incredible? Especially if you consider that the letter E is apparently the most commonly used letter in the English alphabet. So that's really quite an achievement to write a 50,000 word book, like a story, without using the letter E. And I just so happen, I don't know how this happened, to have a copy of Gadsby here in this randomly created folder on our desktop called Gadsby. Right here, so here we are, Gadsby manuscript.txt. Now the book is so old now that it's freely available in the public domain, and you can get access to it too using the link that I'll put in the resources. Now anyway, the reason for this is that we can use the grep command to count the number of lines that a certain piece of text appears. Okay, so for example, we see that when we search for the letter E in hello.txt, we get 4 results, right? So we get hello, there, beautiful, and people. Okay, so we can actually confirm this. We can take a look by giving the grep command the C option, and this will tell you how many lines. It'll just give you the number of lines that it finds, and it tells us that we get 4. Okay, so it says, hey, I found 4 lines that had the letter E in them in hello.txt. Now we have the text file called Gadsby manuscript.txt. Okay, and if we open it, you can see that there is so much stuff in here. Okay, there's in fact the book is about 43 chapters long with over 50,000 words, and actually I can tell you how many lines is in there by going into the Gadsby folder and using the word count with the L command on the Gadsby manuscript, and it tells us that there's 1,914 lines, which is quite a lot of lines. Okay, so let's try and search for the word Gadsby in the book Gadsby. Okay, so if I do grep Gadsby inside Gadsby manuscript.txt, you'll notice that nothing shows up. And the reason that nothing shows up is because Gadsby starts with a capital G, and we spelt it with a lowercase g here. Now we can search in a case insensitive manner, so that uppercase and lowercase don't matter at all, by giving the grep command the I option. Okay, so when we do that, we'll see that it's shown us the different amount of results here. Okay, and there's quite a few times that Gadsby has appeared in the book Gadsby. Okay, so let's clear the screen. You can also search for the letter A in the Gadsby book just by putting the letter A here, and we'll see that we get a whole bunch of lines where the letter A is used. Okay, and we can count that as well if we want by pressing the C option, and we see there's 951 lines that contain the letter A. So that's quite a lot. So now let's try it and see how many times the book uses the letter E. Okay, so the way that we do that is we don't care whether it's uppercase or lowercase. We don't want any E's, so we're going to keep it case insensitive, and we're going to count how many lines there are, and we're going to put there the letter E. And if we go ahead now and press enter, we can see that the answer is 0. So the Gadsby manuscript doesn't use the letter E, and this has been approved, Linux approved, that it doesn't use the letter E. So download the manuscript in the resources section and try it out for yourself. Now, you can actually also search for full sentences as long as you surround them in quotes. So one phrase that's used quite a bit in the book is the line "our boys." So we could search in there for "our boys." And we're going to put that in quotes to make sure it goes in as one argument. And when we press enter, you can see there's 9 lines that contain it. But let's just take a look as well to see them. So you can see there's quite a few results for the text "ah, boys." Now, you can also search for lines that don't match a specific piece of text, okay? So you can see how many lines there are in the whole Gadsby document using the word count command. So if I do word count -L, Gadsby manuscript, there's 1,914 lines, right? Now, because there's no letter E in Gadsby, there should be 1,914 lines without the letter E, right? Now, we can check that using the V option. Now, the V option basically does the opposite or invert the search, okay? So if we do grep, we do grep with the V option for E, okay, in Gadsby manuscript.txt, what we're doing is this is going to find all the lines that don't have the letter E in them, okay? So without the V, it'll find all the lines that do have E in them, and with the V option, it'll find all the lines that don't have the letter V in them. So let's do that. So now we saw a whole bunch of stuff has come out, but how many of them? How many of them have actually come out? Well, we can count them using the C option, and I'm gonna cut it right there. Will it be 1,914 lines? Will Gadsby actually contain no letter E? Well, to save on time, come back in the next video to find out. Welcome back, ladies and gents. I'm sure the anticipation has been killing you. So here we are, we're trying to find out whether Gadsby does in fact use the letter E. Now, Gadsby is 1,914 lines long, so if by using this command here we get the answer 1,914, then we know that every line doesn't contain the letter E. Okay, so let's go ahead and press enter. Let's see. And we get 1,914 lines, just like we expected, and the crowd goes wild. So there we are. Yeah, the grep command has managed to work that way as well. We got the same answer both ways. Now, you can use the grep command to search inside multiple files at once, by the way. Okay, so I have a file on the desktop, don't I, called hello.txt. So if I just head back to the desktop a little bit and cat it out, it says hello there, you beautiful people, unsurprisingly. Now, if we wanted to compare the literary genius of my hello.txt file and the Gadsby manuscript, then we could use grep-I with search for the letter E inside the Gadsby manuscript. So that's going to be in the Gadsby folder, Gadsby manuscript, and my hello.txt file. We can see that it's shown us that my hello.txt file has a result here, it has a result here, it has a result here, it has a result there, but you don't see anything for gadsby.txt, and you can count as well. So if I just do that, you can see that the Gadsby manuscript returns 0 results for the letter E, and my hello.txt file returns 4. So even though I had 5 lines of text and the Gadsby one had 1,914, 4 out of my 5 lines, 80% of my text had a letter E in it, and theirs had none. So that just, well, I just think Gadsby was showing off, eh? So now that you know how to use the grep command to, analyze literary masterpieces, the most common way to actually use it is to search within data that you pipe to it. Okay, so if I just clean out this command line here, we're going to show you how you, and clear the screen, we're going to show you how you can do something a bit more heavy duty with the grep command. So let's say that you wanted to look inside a big folder to see whether a file is inside. Okay, we could use the find command, but perhaps we decide that the find command is a bit heavy duty for such a quick check. Okay, so let's make a folder on the desktop called hello in there, and let's move the hello.txt into that hello folder. Okay, and when we look, we should see that that is indeed the case. Yep, there we are, we've got hello.txt inside. Okay, then let's create some more files inside. Let's touch inside the hello folder, I don't know, I guess like files, let's say 100 other files. Okay, so in there, Now we can see that there's 100 other files, and somewhere in there is hello.txt. Okay, so let's say that we wanted to use the ls command to list out what's in hello. Okay, and you see you get quite a bit of information coming out of the ls command, especially if we had the L option. Definitely a lot of information coming out of there. But what you can do is you can just use the ls option and pipe it to the grep command and say, hey, we're looking for hello.txt, and you'll see that it has highlighted hello.txt as something that's being present. Okay, so that can help you search things in there. Another example that I use often is when I'm looking for details about a particular file or folder's permissions using the ls command. So for example, if I want to see the permissions for the root home directory, I could do ls with the L and capital F option with the forward slash to see everything, all the permissions for everything in the base directory. Okay, but let's say I wanted to look specifically at the folder called root. Well, then I could just pipe it into grep and say root, and it will tell us that you'll be able to see here the root folder coming out like that. Or we could have a look at the optional folder. If we wanted to look at that, we just look at opt, and it will just cut out that line for you, and you can just see that. So you can see how you're filtering out just what you're looking for. Okay, so this is a very, very useful option. Let's say we were looking in, say, I wanted all of the files, not the folders, in the Etsy directory, let's say. Then what I could do is I could say ls with the F option for the Etsy folder, and you can see that it showed us everything in here. All the folders have a slash after them, and all the files don't. Okay, so if I want to find all the files, I just have to find everything that doesn't have a slash, right? So if I take all that data, pass it into grep, give it the V option and a slash, this is saying, okay, take all that data and give me every line that doesn't have a slash. And there we are, we've got all of the files. Okay, and then I could maybe redirect that into a list of files.txt, and now here I've got a list of files that are in the Etsy folder. Okay, and of course we could sort all of those and whatever else if you wanted. So, we could take it from there and then sort it reverse. Let's say we wanted them backwards and then put that into the files.txt, and we'll see that everything is now backwards with Z at the top and the letter A at the bottom. So you can see how using all this stuff really links together very well. And if you're understanding this, you're a pro, okay? Because, if you're, it wasn't that long ago that all of this would have been complete and utter gibberish to you, but now you understand that, hey, we're just using the ls command, we're classifying what's coming out with the F option, so it gives us a slash around directories and nothing around files, and we're looking in the Etsy folder. We're searching inside there, inside all that data, using the grep command for everything that doesn't have a slash. That gives us all the files, and then let's say we're sorting them reverse-wise, and then saving that in a file called files.txt. Okay, so you can see how we're using multiple different commands to build up these pipelines easier and easier as we go through the course. Now, another really common usage of this is when you're using the man-k command. So when you wanted to search for things in the manual pages, so say we wanted to search for print, okay, we can see that we get loads of different options to print. Now, you could read all of these out yourself, but it's kind of a bit of a pain. What if you wanted to search for something a bit more specific? Well, you could grep and say, okay, well, I'm looking for files specifically. Okay, so, and then it will tell me, it'll find all the ones that mention files, which makes it a lot easier for us to see, and we might then notice the lpr command, which prints files. Okay. There's also the cat command up here, which can concatenate files. Try saying that 3 times fast. Can concatenate files to standard output. Okay, so this is another common usage of the grep command, and we have less results to page through than we would have otherwise had because we filtered out what we were looking for. So there you have it, you beautiful people. That's how you can use the grep command to search within files and filter the output from other commands. Now, the grep command has to be one of the most commonly used commands of all time, and you'll probably use it a whole lot in your work with the Linux terminal as well. So to make sure that we've got the important points down, let's have a recap. So first of all, you saw how to use the grep command to search for text within files, and the grep command can search through any kind of data, whether it's static within a file or it's piped to it. And what you found was that the grep command will return lines that match a certain piece of text or a regular expression made up of wildcards. So you could give, instead of giving the grep command a piece of text to search for, you could give it a regular expression using wildcards, and it will find all the lines that have something that matches that wildcards. That's a really useful ability as well. And you can count how many lines that match that text. Instead of returning the lines themselves, you just return the line count by giving the grep command the C option, which we used multiple times in the last few videos. Now, by default, because Linux is a case-sensitive operating system, you can make the search case insensitive so that uppercase and lowercase don't matter by giving the grep command the I option, which is really useful if you don't know whether it's an uppercase or a lowercase letter that you're searching for, but you know it's that thing that you're searching for. Okay, you don't know whether it's uppercase or lowercase, but you know it's at least that word or at least that letter or something like that. Okay, then we also used the grep command to analyze the validity of the 1939 literary masterpiece of Gatsby, which is a 50,000 word book that never used the letter E, and we have now confirmed that using our Linux grep command, and you can find a copy of that manuscript and a link to where I got it from in the resources section of this video and the last one if you want to take a look and play with it yourself. Okay, we also saw the V option, which will invert the search, so that means it'll do the opposite. So instead of searching for lines that match a certain piece of text or match a certain regular expression, it'll find all the lines that don't. And finally, one thing that we saw was how grep works so well when you pipe data to it, and you saw how you can use it to filter out a lot of data to just give you the lines that you're looking for from a big bunch of data that comes out. We saw how it's useful with the ls command, the man command, so many other things as well. Just any time that you are looking for a specific piece of text or a specific word or something that matches a certain format, use the grep command and you'll save yourself a bajillion hours of time. Okay, so there we go. Now, the great thing about the grep command is its flexibility and its versatility. Now, it can be used pretty much anywhere, and it will be a tool that you'll likely use time and time again. So now you know how to do many, many things with files and directories. You can create them, copy them, delete them, move them, rename them, edit them, search for them, search within them, sort them, and so much more. Okay, you've come a very, very, very long way in this section, and I applaud you for your progress. Okay, but we have one last thing that I want to cover: file compression and archiving. Now, the last thing that you want to do is lose data on your system, and knowing how to compress and uncompress files to create backups will allow you to ensure yourself against loss of data. And it's one of those things that's so important that you've just kind of got to know how to do it. Okay, so in the next video, we're going to be discussing how you can compress and uncompress files to create and restore backups. So for that good stuff, I'll see you in the next video. Hello there, you beautiful people, and welcome to this video where you're going to start learning all about file archiving and compression. Now, I'm sure you've heard millions of times about the benefits of keeping backups of your data, and that's exactly what we're going to be covering in the next few videos. In the next few videos, you're going to learn how to archive and compress your files in Linux to create backups. Now, just creating the backups isn't good enough. You're also going to learn how you can restore data from those backups in the future, so when you need to uncompress it, your data will come back out perfectly. By the end, you're basically going to be able to create and restore your own backups to make sure you don't lose any important data, and you're also going to learn about various compression algorithms so you can save the maximum amount of space on your file system as possible. So let's go ahead and jump right into it. Okay, so when you're compressing and archiving files in Linux, the first thing you need to know about is something called a tarball. Now, I want you to imagine that you're at a shopping centre or at your local store and you're buying some apples. Okay, now let me ask you a question. How would you make those apples, after picking them up, easier to carry? Well, you'd put them in a bag, right? And that's what creating a tarball is basically doing. Okay, so creating a tarball is basically a way of putting your files in a bag to make them easier to compress and make them easier to store. Okay, and when you add files to a tarball, you make it possible to store all of your files in one place. Now, the tarball itself doesn't do any compression, but tarballs can be compressed using compression algorithms. Okay, so archiving files is basically a two-step process. First, you make a tarball, Okay, you make a tarball, and then secondly, you compress the tarball using some kind of compression algorithm. Okay, so let's go ahead and create our very first tarball. All right, so we're on our desktop, and we can see that we've got file1.txt, file2.txt, and file3.txt, and we're going to put those inside a tarball. Now, if I do an ls on these files and just have a look at them, you can see that they're all about 10 kilobytes in size, okay? 9.8 kilobytes are about 10 kilobytes in size, and we're going to put all of these into a tarball, okay? So to do so, we're going to use the tar command, the tar command, okay? Now, the tar command takes quite a few different options, okay, in order for this to work. So first we type tar, then we need to give it 3 options. Okay, so let's type a dash, and the first option is the C option. Now the C option lets the tar command know that we want to create a new archive. Okay, the next is V, which lets the tar command know that we want it to speak to us. We want it to give us some feedback so we know how it's doing. Now V stands for verbose, and it basically says, hey tar command, don't do this silently, talk to me and let me know what's up. Okay, now the V option is entirely optional. You don't need it to make an archive, but you know, it's good practice to keep it there. Okay, and the final option is the F option. Now the F option is so that it lets the tar command accept files. Okay, so now we need to tell the tar command what we want to call our tarball. Okay, now by convention we end tarball files with the .tar file extension. This is just a convention, so we know what they are called later. So let's call it our archive.tar. Okay, and finally what we need to do now is we need to tell the tar command what's going to go inside our tarball. Okay, so we want file1.txt, file2.txt, and file3.txt. So let's just use a wildcard to save some typing and put file1 to 3.txt. Okay, and with that, we're ready to go. So what we're saying is, hey, tar command, we want you to create a new archive, so we give it the C option. We're saying speak to us so we know what's going on, so that's the V option. And we're going to give it the F option so that it can accept new files and create a new archive. So let's just go ahead and press enter. And we see that it told us what's going on, and now we've got this new tar file that's actually been created, and you can see that it looks like a little box, like a moving box, so you know that it's an archive. And if we do an ls, we can actually see that the tarball file has actually been highlighted in red just to make it stand out that bit more, which is quite nice. So hooray, we've actually managed to create our first tarball. Now that command, this tar command, had quite a few different options in it. So what I've done is for all the commands dealing with archiving, so in this video and the next video, I've made a cheat sheet for you to download that details how to do different archiving tasks. So don't worry about memorizing. Now you can find that in the resources section for the next video when we've finished dealing with archiving. Okay, so let's take a look at how large the file is by using ls with the L option. And actually what we're going to do is we're going to look for the ones that have .tar in them using grep. So we just see what has .tar in it to focus our results a little bit, and we see that actually it's about 40,960 bytes. Well, that's strange, because we had 3 about 10,000 byte files, and now we've got 40,960 bytes for the tarball. Shouldn't it be 30,000 bytes or somewhere near there? Well, not exactly, okay? Well, think of the apples example. If each apple weighed 100 grams, and you have 3 apples, and then you put them in a bag, will the whole bag weigh 300 grams? No, because the bag has some weight as well, right? So what we're seeing here is just that in order to create a tarball, we need to add some data. So just think of the extra size being like the extra weight from a bag when you put apples in it. It's just part of the convenience of building a tarball, but don't worry. When we compress the tarball, it will be much, much smaller than the files would have been on their own, okay? Now, we can tell that this is a tarball by looking at the .tar file extension, right? But remember that in Linux, file extensions don't really mean anything. They're usually just a convenience so that we can see it as humans, but they don't mean anything necessarily to the system. So to double check that it is a tarball, we can use the file command that you learned about earlier in the course. So if we do file, let me clear the screen, file archive.tar, and you'll see that it tells us that it is indeed a tar archive. Okay, now if we renamed this tarball, so we renamed it to be our archive .shablam, let's say. Now if we do if we do the file command on that, so file of our archive.shablam, you see that the Linux system wasn't tricked, and it still knows that it's a tar archive, even though it didn't have the tar file extension. So let's change that back because we don't need any more confusion than is necessary. But that's just to let you know that the .tar file extension isn't particularly anything special to the system, but it might be to other programs that you have installed upon it. But you can always check what the true nature of something is using the file command. Okay, but the .tar file extension is just something that, you know, allows you and potentially other users to know what type of file it is at a glance. Now, you can actually take a look at what is in a tarball without having to extract it. So let's say you downloaded this this archive from the interwebs, and you wanted to take a look at what's inside. Okay, well, you can do that using the tar command, and what you do is you give it two options. Okay, you do the T option and the F option, and then you tell it our archive.tar. Okay, so the T option means test label, and it basically lets you check what's inside the tar file, and the F option, it's just necessary in order to pass a file to the tar command. Okay, so when we do that, it tells us that file 1 and file 2 and file 3 are inside the tarball. So that's pretty cool, right? Now we're going to come on to compression in a little bit, but first let's take a look at how we can get these files outside of our tarball again. Okay, well, it's actually very simple. First, let's delete the file whatever.txt. Okay, so they've all disappeared, and we've got just our tarball here, and we're going to extract the files out of that. Okay, so let's try and do this now. The way we'll do it is it's actually very simple, right? So you'll have the tar command, and remember, to create an archive, you had cvf, and then we wrote our archive.tar, and then we gave it some files. Okay, now to extract, it's very simple. Okay, instead of C for create, you use X for extract. And everything else is the same, but you don't even have to give it any files because you're not putting any files into the archive. It's just that. Tar, X for extract, V for verbose, so it tells us what it's actually doing, and F is necessary so you can pass a file to the tar command. And when we press enter, we'll see that it has indeed extracted out for us file 1, file 2, and file 3 from the archive, and we have those back in the directory that we were in when we ran the command. So there we go, pretty easy, right? And again, all of this is in the cheat sheet for us. So now you might be thinking, okay, we've just extracted these files from the tarball. Is the tarball now empty? Well, actually, it's not. You can actually check that the files are still in there by telling it, just like you saw before, checking inside with the T and F options. You can check that file 1, file 2, and file 3 are still inside the tarball. So no matter how many times you extract from a tarball, the tarball still contains what's inside of it. So it's like it's a reusable bag that maybe you get from shops. Okay, so that's pretty awesome, right? Now I'm going to break the video here in interest of time, and in the next video we're going to be talking about how we can compress our tarballs to make them smaller. So for all that goodness, I'll see you in the next video. Hello there, you beautiful people, and welcome back. Now, in the last video, we put our files into a tarball, and now we want to learn about how to compress that tarball to save space on our hard drive. Now, compression happens using compression algorithms, and there are two main compression algorithms in use in the Linux world. And the first is the gzip algorithm, and the second is bzip2. Okay, and the main difference between them is usually gzip is faster but has less compression power, and bzip2 on the other hand can generally compress files to a smaller size than gzip but does require more computational time. So both of these compression algorithms are really easy to use, so let's just start by talking about gzip. Okay, so to compress a tarball using gzip, all you need to do is type gzip and then the archive name. So here we are, our archive.tar, and press enter. And we'll see that that file has been compressed in place using the gzip algorithm, and we can see that it has, if we use the ls command here, we can see that the .gz file extension has automatically been added, and we can use the file command to confirm that, yep, this is indeed gzip compressed data, and it was our archive.tar. Okay, and it tells you when it was last modified as well. Okay, so that's really cool. We can see quite a lot of information about that. Now let's take a look at the file size. So if I do the ls command with the lh option, actually no, let's just the l option. we'll see that file 1, file 2 and file 3 are 10,000 bytes in size, but our archive, the compressed archive, is only 23,000 bytes. So it's about 7,000 bytes or 7 kilobytes less than what the files would have been originally. So we actually have managed to do a compression of about 23%. So that's not bad. Now this will vary from file type to file type and what you're actually compressing, but in this case we got a compression of 23% with gzip. So notice how compression is a two-stage thing. First we make a tarball, and then we compress that tarball with a compression algorithm, okay, which in this case was gzip. Okay, cool. So how about reversing the gzip? How can we get the tarball back? Well, this is very easy. All we need to do is just, if I clear the screen, unzip our archive.tar.gz. Okay, so you just use unzip on whatever it was, and when you do that, you see it's now back to a tar file. And if we look, we can see that it's a tar file. We're using the file command, so our archive.tar, and it tells you it's a POSIX tar archive. Hooray! Okay, so we've managed to undo the gzip operation. Okay, so what about bzip2? Well, bzip2 is a more heavy-duty compression algorithm, and now it takes more computational time than gzip, but usually, not always, but usually, returns more compressed files than you get with gzip. Okay, so it's a bit of a trade-off. Now let's compress our tarball with bzip2 and see what we get. Okay, so it's very easy. All we have to do is bzip2 our archive.tar. And when we see that, we now see that it's gone and got the bz2 file extension. And if we use the file command on it, we can see that it says it's bzip2 compressed data. It doesn't tell you what it was before it was compressed, so we lose a bit of that information, but it has indeed been compressed, and the file command knows that it has. So how big is it? Well, if we take a look with the L option, we can just have a look right there, and we can see that this is 23,137 bytes. So it's slightly larger than the gzip version of 23,023 bytes. Now bzip2 is usually best saved until you have really large files. Now for these relatively small text files, it didn't do us much good to use bzip2, but on a large file such as a video, you'll definitely see a large difference between the compression results achieved by bzip2 and gzip. Now to undo a bzip2 compression, it's actually very easy. All we've got to do is bunzip2 and then whatever the bzip2 archive is. So in our case, this archive.tar.bz2. And when we press enter, we see that we've come back to the tar file, and again we can use the file command to check, and we've got our tar archive back. Now there are other compression algorithms out there, such as the XZ compression algorithm, and if you want to see a more in-depth comparison between the performance of gzip, bzip2 and the XZ algorithm, I've put a link in the resources section for you to find out. Now there is something that you should bear in mind, however, which is how do you create zip files? Now zip files are files that are commonly used on Windows or Mac, and as compressed archives. Now they're not I don't think they are as compressed as what you'll get with gzip or bzip2, but they are commonly used on other operating systems. So if you want to create a zip file, it's actually a one-step process. You'll just type zip, okay, then you'll put the file, so let's call it ourthing.zip, and then we'll put file1.txt, file2.txt, and file3.txt, and when we press enter, we'll see that we now have a zip file in there. So if I press file, .zip, it tells us that it's a zip archive data, and this is what you can use on other operating systems such as Windows, and you usually can't with gzipped files or bzip2 compressed files. They don't tend to work too well on other operating systems by default. You tend to have to install other software like 7-zip or WinRAR or whatever it might be to extract them, and of course you can just unzip that zip file, and it'll ask you, do you want to extract them all, and then you can extract them all. This is just asking us because it was like, oh, you might have to overwrite some stuff, but that's no problem. We just said yes, and that worked. So if you want to make zip files, zip and unzip is the way to go. So if we clear the screen, now so far we've been looking at compression as a two-step process. Okay, first we've been creating a tarball using the tar command, and then compressing that tarball using either gzip or bzip2 or any other compression algorithm. Okay, but is there any way to do it in one step? Well, because creating backups is such a common thing to do, the answer is yes. You can actually create a tarball and compress it using a compression algorithm straight from within the tar command. So let's just delete our tarball for now in our zip folder. So our archive.tar, we're going to remove that, and our thing.zip. So we're going to get rid of every archive that we've got. And now we're going to take it right from just the raw data here, these raw files, straight to a compressed archive in one go. Okay, so to create the tarball itself, how would we do that? Well, what we do is we'd do tar cvf, so create verbose and allow it to accept files. We're going to create our archive.tar, there we go, and file 1 to 3. So this is the way that we normally do it, okay? But now to compress the files, we just need to give it one more option, okay? So to do it with gzip, you just give it the Z option, okay? And if we do that, that will compress using gzip. And we should remember that instead of naming it as our archive.tar, because this is going to be a gzip file, we should add .gz at the end as well, just for convention, because it won't be added automatically when using this method, okay? When you ran gzip on it before, it was added automatically, the .gz file extension, but now because we're doing it all in one step, we have to provide the file name. So we need to add it on there, just so you know, it's a bit easier to see what's going on. And when we press enter, we'll see that our archive.gz has been created, and we can check that it is in fact a gzip file using the file command, and it says that it is gzip compressed data. So that's super cool, okay? Now, how would you do it using bzip2? Well, if we clear the screen, bzip2 is exactly the same, except instead of Z, you just have J. Okay, so if you have J, and now remember we're going to change our extension to bzip2, and when we press enter, we'll see that our archive.bzip2 has been created, and we can check that that is indeed valid by using the file command, telling it to look at the bzip2 archive, and it tells us that it's bzip2 compressed data. So that's how you can compress in one go. How would we go about extracting from those compressed archives in one go? Well, that's really easy as well. Okay, let's delete them again. Actually, no, let's not delete them because we'll need them, right? So here's how would we normally extract from a tar file. Well, how we'd normally do it, if you remember, is tar, then xvf, so X for extract, V for verbose, and F to accept a file, and you'd give it the tar file, okay? But let's try and extract the gzip option first. Let's delete these original files. And let's try and extract the gzip option first. So to extract the gzip option, all you've got to do is type the Z again, because Z is for gzip, okay? So you had the Z when compressing, you'll have the Z when extracting. All you've got to do is change the C to an X, and you're good to go. So when we press that, we'll see that now we've extracted them all out again, and we've got the data back. So if we delete these files here, if we just delete them there, now how about extracting using bzip? Well, you remember that J is for bzip, so instead of having Z, let's just put the J, and then we just need to tell it what the archive is, and remember that it's a bzip2 archive, so we need to actually change the name. So here we are, tar, extracting verbose through bzip2, and then giving it the file, and there we are, we've extracted using bzip2. So it's very, very easy, as long as you can remember that Z is for gzip, J is for bzip2, you're sorted, and you can extract and compress all in one go. Hooray! So we've seen so much in the last two videos. It's quite hilarious that a section on compression would take so long, right? Anyway, let's have a quick recap. So you first learned about the concept of a tarball. Now, tar files or tarballs are just containers for you to store the files that you want to compress, okay? Now, you can create tarballs using the tar command, and tarballs do not really do any compression on their own. That's the job of a compression algorithm. The tarball just contains the files. And you saw how to add files into tarballs and how to extract files from tarballs using the tar command. And remember that there's a cheat sheet in the resources section for this video that will list out the different options and different ways of using the tar command. Now, once you have the tarball, in order to compress it, you need to use a compression algorithm. Okay, so tarballs can be compressed using a variety of different compression algorithms, and we took a look at gzip and bzip2, which are common options on Linux, but the xz option is another option. We didn't discuss it here, but if you want to read more about the comparison between the different algorithms, I've also put a link to a interesting blog post in the resources section for this video for you to have a look at as well. Okay, but with regards to gzip and bzip2, gzip tends to be faster but give less compression, whereas bzip2 tends to give more compression but take a bit more computation time. Okay, so that's just something to bear in mind, but by all means, check out the link in the resources section for a more in-depth discussion. You saw also how you can create zip files for compatibility with things like Windows or Mac using the zip and unzip commands. So that's something as well that you've got on record as well. Okay, and you saw as well how to not just do making the tarball and then compressing in 2 steps. You saw how to do archiving and compression in just 1 step using a variety of shortcuts, and all that stuff is in the cheat sheet that you can find in the resources section for this video if you ever need a refresher. Okay, it's all very simple, and once you look at the cheat sheet, probably you'll be able to see the pattern, but it's really quite simple stuff once you've done it once or twice. Okay, so all in all, you can now create your own archives and backups using the Linux command line, which is super awesome, because on this section all about learning how to use files. Now when you've created your files, you've edited them, you've copied and pasted them, you've moved them, you've done whatever you want with them, you can also create your own backups and save for later in a space efficient way. So well done you. Now in the next video, what we're going to be doing is we're going to be closing our discussion for this section on files and the file system. And I want to say that you've really come so very far in this section. In the next video, I want to take the time to have a recap of what we've learned in this section, and also to celebrate your progress. So well done you. Now for a summary of this section of the course, as well as a deserved set of praises, I'll see you in the next video. So congratulations, you've made it to the end of this section of the course all about the Linux file system. Now being able to effectively navigate the Linux file system and work with files is likely going to be skills that you will use over and over and over again. So congratulations for making it this far. So to celebrate your success so far in the course, in this video I want to have a quick review of what we have covered in this section so you can see just how far that you have come. Okay, so we first started off with a discussion of the structure of the Linux file structure, of the Linux file system, sorry, and you saw that the whole file system has a tree-like structure, starting with a root directory and branching out from there. And once you understood that the structure of the file system and had a map to work with, you learned how to tell where your shell is currently operating from using the pwd command. Now pwd stands for print working directory, and it basically prints out on your screen the location that your shell is currently operating in. And you also learned that you can do the same thing by glancing at your shell prompt, which is the bit of text in your terminal on the left where you enter your commands. Okay. Now once you saw how to find out where you are, you saw how to move around the file system and change directories using the cd command, and how to look around by listing out the contents of directories using the ls command. Now, after learning these critical navigation commands, you had a discussion about the meaning of file extensions in Linux, and you saw that file extensions don't matter much to Linux, but might matter to the programs running on it. Now, this means that you have the flexibility to give files whatever names that you want, but just remember that you might want to stick to standard file conventions if you're expecting those files to be used by other programs. Then you learned about a feature of the shell that I'm sure you have fell in love with by now, which is wildcards. Now, wildcards allow you to operate on many different files at once and just operate on specifically what you are looking for, which saves you lots of time and typing, and it basically makes your commands a whole lot more powerful. Now once you had got those very important basics down, you learned a whole bunch of commands. You learned how to create files and directories, copy them, paste them, delete them, rename them, move them around, and also how to edit them with a command line based text file editor called Nano. But with all of this creation, moving and editing of files, it's quite likely that at some point you won't know exactly where a file is created or located, and you might need to find it. So you use the locate command to find files on your system, and you learned that the locate command uses a database to find files, and you saw how to use the update db command to update this database. Now for security reasons, updating the database requires elevated privileges that normal users don't have, so you saw how to use the sudo command to temporarily become the root user and do what you need to do, and you can use that for any command, not just the locate command. Now although the locate command is awesome and can get the job done quickly, sometimes you need something a bit more customizable and heavy duty. So after learning about the locate command, you learned how to find files using the find command. Now the find command is a super powerful command that has loads of options to make sure that you can find whatever you want on your system. Now it also has the added bonus that once you have found a bunch of files or directories with the find command, you can actually tell the find command to run another command or series of commands for each result that it finds. Now this allows you to create incredibly powerful functionality with very little effort. And then you moved on to learn about how to look inside files using the cat command. You saw that you can also stick files together or concatenate different files using the cat command, and sometimes you need to reverse data. So you saw that you can reverse files vertically using the tac command or horizontally using the rev command. Now, sometimes when you open files or run commands, you get a whole lot of output on the screen, and having it all on the screen at once is not very helpful. So you learned about the less pager program that allows you to page through large amounts of text to make it more manageable. And you also learned a whole host of useful tactics for getting just what you want from a file, such as the head command, the tail command, and grep command. Then you saw how you can sort a file's contents in a variety of different ways. And finally, we topped off the discussion with a look at file archiving and compression. Whew, so you've really learned a lot of stuff in this section, and you should be incredibly proud of yourself. So well done. Now, you will use the skills that you've learned here all the time with your work with the Linux command line. So it's a really amazing moment right now in your Linux skills development. So in the next section, you're going to learn about how you can schedule and automate tasks on your system using bash scripts and a super useful utility called cron. But before we get to that, I have a project for you to complete. Now, the project will challenge you to do various things with the Linux file system and use a whole bunch of the commands and build a really advanced pipeline. Okay, now it's going to be awesome, and it will serve as a badge of honor that you have learned everything that we've covered in this section of the course, so you can feel confident moving on. So in the next video, I'm going to be giving you a project brief. So congratulations once again for what you've done in this section. You're doing amazingly. I'm super proud of you, and I'll see you in the next video. Hello there, you beautiful person, and welcome to this very exciting section of the course all about automating tasks using bash scripts and cron. Now, up until now, you've been learning how to do commands one after the other on the command line. But sometimes, however, you want to complete tasks that require multiple steps. So instead of just memorizing the steps and entering those steps, those command steps every single time you need to complete that task, you can instead write those commands into a text file known as a bash script and then just run the script. Okay, and when you run the script, each of the commands in the script will be run one after the other from top to the bottom. So the shell will start at the top of the script and work its way down through the script, executing all of the commands on the way. All right, so in this section of the course, you're going to learn how to create and run your very own bash scripts, but you're also going to see how you can schedule those commands and bash scripts to be run at certain times using a really handy scheduling program called cron. Now, bash scripting is a whole massive field in and of itself, so this won't be an overly detailed section of the course, but I hope that by the end of the section, you'll have the fundamental concepts and understanding of what bash scripting is all about so that you can start writing your own simple scripts. You'll also know how to schedule and automate commands and scripts to run at any time you choose by using cron. And combining these two skills will allow you to truly set your workflow on autopilot. So now that you've got a quick heads up about what's going to be covered in this section, let's jump right in the next video by learning how to write your very own bash scripts. Hello there, you beautiful people, and welcome to this very exciting section of the course all about bash scripts. And in the next few videos, you're going to learn how you can create your own bash scripts, which are incredibly useful tools that will allow you to automate your workflows. Now, learning about bash scripts is a massive field in and of itself, and it would require its own course to cover properly. But by the end of the next few videos, you're going to have the fundamental understanding required about how bash scripts work and how to create them so that you can begin automating your workflows using the commands that you've learned so far in the course. So this is going to be an incredible piece of learning for you to let you understand how, what bash scripts are, how to use them, and how they basically work. So it's going to be very, very exciting. I hope you're ready to gain some serious superpowers. So let's not mess around anymore. Let's go jump right in and start making our very first bash script. Alright, so let's go ahead and make a simple bash script. Now to do that, all we need to do is just make a text file. So to do that, let's go ahead and open up Nano on our desktop and make a file called rscript.sh. Okay, so all I'm doing here when I give the file the .sh file extension is just making it easier for us to see that this is a bash script, with .sh being short for the bash shell. Okay, so if I open that and press Ctrl and O to save it, you'll see that the script has popped up on the left, and if I just close that and clear the screen, we've now got this file. Now let's take a closer look at this file. Let's see if it's anything special to the shell using the file command. if I do file rscript.sh, we see that it's nothing special. As far as the shell is concerned, it's just an empty file. It doesn't matter whether this was .sh or .shablam or .whatever. It's just an empty file, okay? So with that piece of information, let's go ahead and open our script, and let's do the most important thing that you need to do whenever you write a new bash script. Okay, you need to tell it that this is actually a special file, and that this file isn't just a text file. It needs to be read using a certain interpreter. Now, an interpreter is something that will read a file and interpret each of the lines in that file as a certain type of code. Okay, so instead of just reading cat, okay, if I told this that this is a bash script, it would read this as the cat command instead of just cat as in, you know, the animal, okay? If I typed echo, it would interpret this file as the echo command. It wouldn't just interpret it as an echo that you hear in, you know, when you're in a cave or when you shout into a hall or somewhere like made of stone, okay? So this is the important part. We need to tell it that this isn't a normal text file. It needs to be interpreted as code, and more specifically as a bash script. So to do that, you need to first type what's called the shebang. Now the shebang is a hash, so sh, and then a bang, an exclamation mark, a hash symbol, then an exclamation mark is called the shebang, and then you type the path to the interpreter. Now the bash interpreter is at /bin/bash. So this is our first line. We type the shebang, hash bang, okay, then /bin/bash. Now that /bin/bash is the path to our bash interpreter, and we can see that if I close out of nano by using the which command and typing bash, and we see that we get /bin/bash as the path to the bash shell. Okay, so what we're saying here is, hey, this isn't a normal text file. You need to interpret this file using the bash shell interpreter. Run this as a bash shell script. And the key is this line needs to be the first line. It cannot be the second line. It has to be the absolute first line. And there can't be any spaces on the line. So you finish the line right away. Okay. And when we save that, now if we look at the script with the file command, we see that it is now a shell script. In fact, a born again shell script. Now the born again shell is bash. So you've got born again shell. Okay. Born again shell is bash. Okay, so this is saying it's a bash shell script. Okay, and it knows that because it's got this shebang line. Now, if you know anything about Python programming, you'll know that the Python programming language is also an interpreted programming language, and the command to run something as a Python script on Linux is Python 3. Okay, for Python 3. So if we type which Python 3, it'll tell us the path to the Python 3 interpreter, just like it did for the bash interpreter. And if I copy that, open up our script again, and I write the shebang line again. I write shebang, so shebang, and then I paste in there the path to the Python interpreter, so /user/bin/python3, and save the script. If I now look at our script, you can see that the shell sees that this is now a Python script. So that's how you would do this kind of stuff if you wanted to write a script in the Python programming language. But because we want to write a bash script, we're just going to give it the path to the bash interpreter, which is at /bin/bash. Save that, and now when we look, we see that it's again a born again shell script, a bash script. Okay, so with that important concept understood, let's go back to editing our bash script in Nano. So let's clear the screen and edit it in Nano. Now, anything that we write in here, with this special line added, anything that we write below it will now be interpreted as they do in the normal shell. So for example, if I write echo and then something like hello world, okay, this line will be interpreted as a command. It's as if I just typed echo hello world in my shell. So let's see this in action. Okay, let's save the file using Control and O. Okay, and now if we type bash our script, we see that it's ran hello world. How cool is that, right? So it ran the commands that are inside there. Now we can do whatever we want in our script. So let's just try and add more stuff. Okay, let's open it up with Nano, and now let's clear out this echo thing. Let's just get rid of this using the cut command, the Control K. I just got rid of the whole line. So that's a nice little shortcut for deleting a line. Now let's actually use in here. Let's try and create a folder called magic. Okay, on our desktop. Now, inside the magic folder, we're going to make 100 files. And then we'll use the ls command to get information about each of those files and save all that information to a log file on our desktop. Okay, so what command, here's a test for you now, what command would we need to create a folder called magic on our desktop? Well, the mkdir command, right? The mkdir command. So let's make a directory. Let's type mkdir on our desktop. Let's make a file called magic. Okay, so that's going to be our magic directory. Now we need to make 100 files in it. So how might we do that? Well, we might move into the directory. So we might move into that magic directory using cd. Then we might touch, I guess, 100 files. So file 1 to 100. Okay, that might be what we do. So far so good. So we've created a folder called magic. We've gone into the folder and then we've created 100 files. Now let's use the ls command to get data about each of those files. So if we use the ls command and we let's say we want to use long form information and human readable information and save all that to a file on our desktop called magic.log. Okay, and let's leave it there. Okay, so what we've done, we've made a directory on our desktop. We have changed into that directory. We've created 100 files, and then we use the ls-lh command on our. I should actually. Good thing I checked. I should check our magic folder and then redirect all that information into a file called magic.log. So if I save that there, close it. And now we can see the contents of this file using the cat command, just like any other file. We can just cat that out and we can see the contents. But now let's go ahead and actually run it. Okay, so if we try to bash our script, whoa, did you see that? We've managed to create a folder on the desktop. Inside there are now 100 files. And if we look in this magic.log file, we see detailed information about every single one of the files inside that folder, just like we told the script to do. So isn't that absolutely awesome, right? So this is how bash scripts work. You basically type in there the commands that you want it to do, just as if you were typing them in the normal shell. But the benefit is we now have this file that we can keep and do stuff with whenever we want. Okay, so if you can actually, save that for later. Now, this should be a moment of amazement for you. So think about this for a moment, okay? In Linux, you can control anything using the command line. Whatever you want to change, whether it be your desktop background, whether it be your font color, whether it be, messages that pop up when you log in, you can change anything using the command line, okay? And you can write scripts to hold command line commands. So therefore, you can write scripts that can do anything on your computer and save them for later so that you can run them whenever you want. And bash scripts are therefore part of what give you complete customizability over your Linux machine, and they are incredibly, incredibly powerful tools. So you've seen in this video how to make a bash script, but in the next video what we're going to do is we're going to do it all over again, and we're going to show you how you can write a bash script to make regular backups for you. So that's going to be very, very cool, and we're going to show you how to run it in a much more convenient way as well. So I'm going to break the video here, and in the next video we're going to pick it up again by showing you how to make a bash script to do backups. Hello there, you beautiful people, and welcome back to the second part of our discussion about making your very own bash script. And in this video, we're going to make another bash script that's going to allow us to back up all the folders in our home directory, and we're also going to show you how you can set up your bash script so they can be run in a more convenient way. So let's make another bash script. We're going to call it backup.sh on our desktop. So we're going to type nano, then backup. .sh, and in there we're going to add as the very first line our shebang line, and our shebang line tells the shell to not read this file as a text file, but instead to interpret it as a bash script. So the way we do that is we type a hash then a bang, so a hash and then an exclamation mark, and then the path to the interpreter that we want this file to be interpreted with, and that is going to be our bash shell, which is located at /bin/bash, and we can check that if I close out of that and you go back to our command line by typing which and then bash, and we can see /bin/bash is where the bash interpreter is located. So with that, if we open back up our backup script, we can now underneath here start writing commands that will make up our script. Now we want this script to compress and archive all of the folders inside our home directory, or at least the downloads, documents, desktop, pictures and videos folders, because they're the best. So let's see how we might do that. Okay, now if you remember from what we learned at the end of the last section, to make this happen, we'll need to use the tar command, and we need to give it a few options. So for example, we'll give it the C option to create a new archive, the V option to make it speak to us, and the F option to tell it that the next argument is going to be our archive file, and we're going to call it backup.tar.gz. Okay, but to make it compressed using gzip, we actually need to give it the Z option as well. So we're going to compress it through gzip into a file called backup.tar.gz. But now we need to tell it what we want to actually store. And this is what we're going to tell it. We're going to say, hey, I want you to put in there, we want to put in there everything in our home directory. We're going to put in our documents folder, our downloads folder, our desktop folder, our pictures folder, and our videos folder. Okay, so what we're saying here is, hey, use the tar command, compress it, be verbose, tell us what's going on, zip it through gzip, and make the file called backup.tar.gz, and inside there put the documents, downloads, desktop, pictures and videos folders from our home directory, using a bit of brace expansion to save us some typing. Okay, so that's it. Okay, and now when we run our bash script, if we do bash backup.sh, you'll see that it's given us some output, and now we've got a backup.tar.gz file on our desktop. So isn't that very cool, right? And you can see here all the files that have been added into the backup folder. Now in there we gave it the V option here for verbose, and that's why we got to see all that output on the screen. Maybe we don't want that, so if we just get rid of the V, and let's say we remove backup.tar.gz, and now we run it again, you can see that now we don't really have as much output from it, but we've still got the backup file. So you can see here one benefit of writing these things in scripts. You can save and edit the behavior of those scripts over time as your needs evolve, and they're always going to be there for you to run. For example, we might not like the fact that this message comes out on standard error, so we can just go back into our backup.sh and redirect this command standard error to a place called /dev/null, which basically gets rid of it. Okay, so there we are. We've redirected standard error to /dev/null, which is a place on the file system called the bit bucket that basically just deletes whatever is sent to it. And now if we try to run bash backup.sh, clear the screen, we run it now, we notice that we can now get no output. But if I delete this backup archive and run it, you can see that the backup is still created, but now we don't get any error. So you can see that you can customize these scripts as time goes on. So what I want to draw our attention to a bit right now is how we can make running the bash scripts a bit more efficient and user-friendly. So at the minute, what we're doing is we are on our desktop where the bash script is located, and we're typing the bash command and then giving it the path to the bash script, which at the minute, because we're already on the desktop, is just backup.sh. When I run that, we get the required output, but that's kind of a bit of a hassle, because if we weren't on the desktop, then we would have to give it a different path and we have to run the bash command. There's a better way to do it in just one step. Okay, and this is how you set that up. So what you do is you go back to your home directory, and you can see in here that we've just got our normal folders. But what you do is you make a directory called bin, all in lowercase. Okay, bin, and you can see that that's been created. And what you do is you move all of your shell scripts into that folder. Let's move from our desktop the backup.sh file. So backup.sh, we're going to move it into our bin folder. Okay, so we're moving from our desktop the backup.sh file into our bin folder. Okay, so you see it's been moved from there, and when we now go into our bin, we see that backup.sh is in there. And actually, I'm just going to rename it from backup.sh into just backup. Okay, so now we've just got the same file called backup, and if I run it, it'll still work, so there's nothing wrong. I've just renamed it a little bit. Okay, Now I need to make this so that it can be run from the command line. Okay, so what we're going to do, there's two ways to do this. First of all, we can open up in our file browser, we can go into bin, and then we can right click, click properties, go on permissions, and then click allowing executing file as program. Okay, that's one way to do it, but I'm not going to do it like that for now because I want you to learn the terminal way. So what you do is you type the chmod command. Now the chmod command stands for change mode, and what it does is it allows you to change the permissions that a certain file has. And then as a second argument you type +x, which means give it executable permissions, so add executable permissions, and then you tell it the file, so just backup. When I run that, so what we've done is we've added executable permissions to the backup. Now when I look at it with ls, you can see that it's gone green. Okay, so that means that it can be ran as a script. Now the cool thing about this is if we close actually what I'm going to do is as well, just to make it a bit clearer, if I go back into backup, what we're going to do is I'm going to make sure that the backup is always saved on the desktop. Okay, that's just going to make it a bit clearer to demonstrate what's happening. So what we're going to do is I'm going to close the terminal. I'm going to delete our backup here. Okay, and now notice I'm in our home directory. Okay, but if I type backup, we can see here that we're getting an error saying that the backup program is not currently installed. Now, if you remember what I told you a long time ago, right at the start of this course, when the shell says it can't find something, that means it's not on the shell's search path. So we need to edit the shell's search path to include our recently created bin folder. Now, the way that we do this is we're in our home directory. If we go ahead and use the nano command, I want you to edit the .bashrc file. So the .bashrc, no spaces, all lowercase, will open up this very important file. Now, if we scroll all the way down to the bottom and add a line down there, this is what I want you to write. Okay, I want you to write path in uppercase, then an equals sign, then some double quotes, so 2 double quotes, and inside those double quotes, $path, a colon, then $home in uppercase /bin. Okay, so let me explain this a little bit. So what we're saying here is a variable called path. We're going to set our path equal to what the path currently is, then a colon, then our home folder /bin. So the bin folder in our home folder is going to be added to the path. And when I close that, we write to the bashrc, close it. Now if we close our terminal and open another one, what that has done, if we echo the path, what that has done is it has added /home/zad/bin to our path. Now that means it'll be able to search for our backup script in the path just like it would any other command. So now when I run backup, you can see that our script has just been run and it has now created the backup. So if I now go into our bin folder and I create another file called hello, for example, and in there I tell it that it's a bash script with the shebang, and I say echo hello world, okay, and save it, and then I give the file executable permissions, so chmod +x hello, see that it's gone green. Now I can be anywhere in my file system. I could be in my documents folder, okay, but if I run hello, you can see that hello world now works, and I can pipe these to wherever I want to redirect them. So if I redirect it to a file called hello.txt on my desktop, there we are. We've now got a file called hello.txt on the desktop, and we're now basically creating our own commands. So isn't that awesome, right? Like we've got our own commands, and anything that we put in this bin folder, if we give it executable permissions, we can run it just like any other command. So that is incredible. But now you might be thinking, okay, Ziad, this is cool and everything, but what's really the difference between an alias and a script? So remember, aliases are things that you put in your bash aliases file, this .bash aliases file. And if we take a look in there, what we're doing is we are, setting command names and we're giving them what those commands mean. Why didn't we just make an alias and we say backup equals tar-cvzf to our desktop, and then put backup.tar.gz and say we want in there, we want our desktop and our documents and our downloads and our pictures and our videos, and then close it. Why didn't we just do that, Ziad? Like, we know how to make aliases. Wouldn't that work the same? Well, yes, it would work the same in this instance because we have a one-line script. Okay, I'm going to close that. We're not going to do that. That's because we have a one-line script. So aliases can become, either the same as one-line scripts, really. But the good thing about scripts is that scripts are designed to contain more than one command line, whereas aliases are usually just to give more convenient names to just one command line. Now, secondly, scripts can have more complicated programming constructs, such as loops, if statements, and functions. Now, if you've never done any programming before, suffice it to say that scripts are more heavy-duty than aliases can be. Okay? And thirdly, scripts can be scheduled to run at any time using cron. And that scheduling part is what we're going to focus on in the next video. So over the last couple of videos, you've seen how to create your very own bash scripts, and the key about bash scripts is that they allow you to store useful command sequences in files that you can use later on. Now, because anything on your computer is changeable and editable through the command line, and because you can save these series of commands that can do specific functions, you can create incredibly powerful bash scripts that can do whatever you want and save those bash scripts for later by using the fundamental skills that you've learned in the last two videos. Now, a key piece of information is that bash scripts must have the shebang line telling them that the file needs to be interpreted as bash commands using the bash shell interpreter, which is located at /bin/bash. Now, this shebang line is the first line of every script, and there mustn't be anything above it, and there mustn't be any spaces in the shebang line, the text that's highlighted here in orange, so it must come just as you see it there. And it's the shebang line that turns your regular text file into a bash script and tells the shell to interpret everything in that file as bash commands. Now, if you wanted to make a Python script, you could put as the shebang line something like /bin/bin/python3, and that would allow the script to be interpreted as a Python program. But this is how you do it in orange here for bash scripts. Now, you've also seen how you would make scripts runnable just like regular commands, and you saw how you would make a bin folder in your home directory and add each script to that bin folder. You would then give each of the scripts executable permissions using the chmod command and add that bin folder to your shell's path by editing your bash rc file. Now, this allows you to run scripts just like regular commands. So we type backup and our backup script ran. We typed hello and our hello script ran. And this will also work for Python programs as well. Now, as an aside, if you're interested in learning more about the Python programming language, then go to the last video of this course where you'll have some discount coupons for all my courses, including my best-selling Python course, The Python Bible, which will take you in a project-based way from absolutely no previous Python experience all the way to writing 11 Python programs. So if you're interested, go ahead and check that out. But the bottom line is that scripts are more powerful than aliases, and scripts that can be run at any date or time that you like, which allows you to automate your workflows. And it's precisely that scheduling that we'll be coming on to in the next video. So in the next video, you're going to learn the true power of shell scripts by learning how to automate them using an incredibly useful utility known as cron. So to learn how to schedule automated tasks, I'll see you in the next video. Hello there, you beautiful people, and welcome to this video where you're going to take what you've learned about bash scripts in the last few videos and supercharge it by using cron to make those scripts run on a schedule. It's going to be super awesome. And over the next few videos, you're going to make some bash scripts and schedule them to run automatically, and we're also going to top it off by showing you how you can schedule automatic backups of your files. So epic, right? So by the end of the next few videos, you're going to be able to automate your workflow by scheduling your scripts to run wherever you want. And this really does open the doors to untold awesomeness going forward. So let's go ahead and jump right into it. Okay, so cron is a command line based program that is used to schedule tasks. Now, cron gets its name from the Greek word chronos, which means time, in case you were wondering. So cron actually has quite a good name for a scheduling program, right? Now, each user has what is known as a cron tab, which basically is just a text file, and each cron tab lists which commands or scripts will be run automatically by that user, and it also lists when they will be scheduled to be run. Now, to edit the cron tab for your user, you just open a terminal and type cron tab Command-E, and the E option is for edit. And when you open it, you'll see that the cron tab begins to open. But if this is the first time that you're opening up a cron tab, it might ask you what editor you want to use. So we're just going to press 1 for nano and press enter, and we will see that now we've opened up our cron tab in nano. Now the first thing you'll notice is that there's a lot of text in here, and this is a kind of introduction to how cron tabs work, but these are commented lines, and what I mean by that is they are not interpreted by the cron tab as actual valuable information, and you can tell that because they start each line with a hash, and that allows people to write what they want in a file, like some notes, but it's not interpreted by the actual cron utility. But down the bottom, each cron tab is broken up into rows, and one row is for each command or script that you want to schedule, and each row will have 6 columns. So the first 5 columns are scheduling information, and the final 6th column is the command or script to be run at that scheduled time. So you need to get into the bottom and to enter your information. Okay. Now this is really one of those things that's easier to be shown than explained. So let me show you how this works. So let's say that we want to run a command that just outputs the text hello world to a file called hello.txt on our desktop, and we want that command to run every minute of every day all year round, because for some reason we just really like saying hello. Okay. So to make this happen, we need to enter a new row in our cron tab, and so here we are, we're on a new row, and there are 6 columns in that row, each column being separated by some blank space. Okay, so let's take it step by step. Now the first column of the row is for the minutes of the hour that you want the command to run on. So let's go to the first column, and we could put any number we want in here as long as it's a valid minute. So we could type 15, for example. Now this would make the command run at 15 minutes past the hour. So things like 12:15, 2:15, 9:15, 7:15, and so on. Okay. Now the numbers for minutes can go from 0 to 59 because that's what numbers for minutes do on a normal clock, right? So you can go from 0 to 59. Now, because we want the command to run every minute, we'll just put a star in there to say run any minute. Okay. Now, no, this isn't exactly like a wildcard. The star happens to mean any in this case, but cron tabs don't really support other wildcards, so don't put symbols such as question marks or the brackets in there because they won't work. Okay. The star is only what's accepted, and it just means any value. We don't really care. Okay. So the first column is the minutes of the hour. The next column is the hour number, and we could put numbers like, for example, 11. So this would make it the command or whatever we scheduled to only run at 11 a.m. each day. We could put 14 so that it would only run at 2 p.m. each day. Now the numbers here are based on a 24-hour clock and can go from 0 to 23. But we don't mind particularly what hour our command runs at, so let's just put a star there as well. But if I put, for example, an 11 in the hour column and a 20 in the minute column, then our command would run at 11:20 a.m. So the first column is for the minutes and the second column is for the hours. And by the way, it doesn't really matter where we place these columns as long as there's some space between them. Okay, so we could separate them out like that with more than one space, but as long as there's some blank space in between each of the columns, cron isn't too fussy about how the stuff is laid out. So let me just try and make it a bit clearer which column we're filling in here. So there's the first column is minutes, second column is hours, and so on. I'm just going to kind of spread out our stuff a little bit here, so we've got a bit of a nicer layout. But we don't really care about the minutes, so we'll put a star there. We don't really care about the hours, so we'll put a star there too. Now the third column is what we see here, DOM, is the day of the month. So if we put a 1 here, then it would only run on the first day of the month. And so, for example, if we had a 20 in the minutes column, and we had in the hours column, we had an 11, and here we had let's say a 10 in the third column, then whatever command that we gave it would only run on the 10th day of the month at 11:20. Okay, but it would run all of the months of the year, but only on the 10th day of the month at 11:20 a.m. But again, we don't really mind what day of the month, so we'll put a star there, and we'll put a star in the other columns as well. There we go. So let's just lay this out a bit nicer. Okay, cool. Now, the fourth column is actually the month itself. Now, in here, we can put numbers. So we could put 1 being January, 12 being December, and all the other months in between. But you could also do it using text. So, for example, in capital letters, I could put Jan for January, Feb for February. I could do May or DEC for December. So 3-letter months can be used as well for the months if you write them in capital letters. But here we don't really care about the month, so we're just going to put a star as well. And so just to see how this is all coming together, if we had a 20 in the first column, and we had in the hour column we had an 11, and in the day of the month we had a 10, and in the month we had a JUN for June, then this command would run on the 10th day of the month, on the 10th of June at 11:20 a.m. Okay, so that's how that works there, but we're going to replace them again with stars. Okay, so as I say, the cron tab doesn't really care about the amount of spaces, just that each column is separated by at least one space. Okay, so there we go. The next column is the day of the week. Now, the day of the week can have numbers from 0 to 6, with 0 being Sunday and 6 being Saturday. But as well, you can do this doing text using 3 letters for each day of the week. So SUN would be Sunday, MON would be Monday, THU would be Thursday, SAT would be Saturday, and so on. Okay, so let's say if we had a Sunday in there, and the month was June, and the day of the month was 10, and then the hour was 11, and then the minute was 20, then this would run at 11:20 a.m. on the 10th of June, as long as the 10th of June on that year was a Sunday. Okay, so you can see how you can become incredibly specific with how you schedule your commands to run, but you can also be very general and very relaxed as well. The cron tab, the cron utility is amazing for that kind of stuff. You can be very expressive with your scheduling. So there we go. We're going to set those back to stars because we don't care what day of the week it is. We want this command to run all day, every minute, all year round, so we don't really care. Now, so those are the first 5 columns, and these first 5 are scheduling information. Okay, now the final bit is actually where you tell it the command or script that you want it to run. Okay, so the 6th and final column is the command to actually run. Now, we said that we want a command that will output hello world to a file called hello.txt, let's say on our desktop. Okay, so how would we write that? Well, we might write echo, okay, then hello world, and then we'd append that to somewhere on our desktop, a file called hello.txt. Okay, so if I just expand the window here, you'll be able to see it a bit better. There we go. So you can see here that we're just saying, this is just the command basically, echo hello world, and put that on a file on our desktop called hello.txt. But we're using the 2 arrows here to allow, whenever this command runs, it will append data to the file, so we can see extra data being added each time the command runs. Okay, so when we save the cron tab, so the cron will make sure that this command is now run at every minute of every hour of every day of the month, for every month, no matter the day of the week. Okay, so this command is going to run every minute all year round. Okay, so if I press Ctrl and O to save that file and I exit, you can see here that we get a message saying that it's installing a new cron tab, and we can see here that hello.txt has actually just been executed. Okay, so if we take a look at, you can see that it actually just ran right then. We can see that it's actually executed hello world and put it inside the file. Now, if I run the date command, you can see that we've got about 40 seconds until this command runs again. So what I'm going to do is I'm going to cut the video here and come back closer to the time when that runs. Okay, so here we are. We can see that it's just gone, and literally as I press date, that's awesome. It's just past the minute. So if we look in there now, we should see that we now have 2 rows of data. So fingers crossed. Yes, we do. We now have 2 rows of data in there because the cron tab has executed again right at the top of the hour, and we'll just continue to wait until the next minute passes, and it will continue to run that that command over and over and over again and fill up this hello.txt file. Okay, now when that actually runs, we'll see that more data has been added. We've got about 18 seconds or so. So if you can wait with me for like 18 seconds, we'll see this happen, okay? So here we go. We're seeing another 11 seconds or so. And now if I check here now, we can see that there's 5 seconds to go, 5 seconds to go, 2 seconds to go. It should have done it now. So if we look inside, yep, it's run and it's added another row to the file, and I didn't touch anything, I promise. So our cron tab is working. Hooray! Okay, we've just made it run a command over and over again. So let's take a look at our cron tab again. Let's go cron tab with the E option, and we've opened it up. See, it's remembered that Nano is our editor, and just in case you're interested, if you go onto your home directory and you look at your all the files with ls-a, there's a hidden file here called selected editor, and it's that file that stores your preference for editor. So in here, if we look at .selected editor, you can see you can change that if you want by putting the path to the editor that you want to have, or alternatively you could just type the select editor command and it would give you the choice again. Okay, but I'm going to keep it to Nano and leave it like that. But that's how if you wanted to change the editor later on, maybe you get better with another command line editor, that's how you can change it. Okay, so let's go on cron tab -E. And now what we're going to do is we're going to look at some more advanced options and more advanced ways that you can do some scheduling. Okay, we can add as many rows as we like in this cron tab, and they'll all work exactly the same. So I'm going to make a new row and look at some more advanced scheduling opportunities. So for example, let's say I want to run something exactly at the hour and 15, 30 and 45 minutes past. Okay, so I don't just have to have one option here. I could have 0, 15, 30, 45. That's going to be my first column, right? So this is going to be the minutes. I could have at 0 past, 15 minutes past, 30 minutes past, and 45 minutes past. Notice how I've got commas but no spaces. You're not allowed to have any spaces because spaces separate the columns. Okay, so that would be like my first column. I could, then space this stuff over so I got a bit more space, and now I could say, okay, run it at every hour, every day of the month, every month, every day of the week, and then whatever command I wanted to happen here. So something like, hello, echo, hello, for example. And this would run at exactly as the hour turned, and 15 minutes past the hour, 30 minutes past the hour, and 45 minutes past the hour or quarter to the hour. Okay. Or I could just say, more simply, run every 15 minutes. And the way I do that is star, then a /15. Okay. Now that says run every 15 minutes. I could say run every 5 minutes by */5, or every 3 minutes */3, every 7 minutes */7, okay, or */15, like I said, for every 15 minutes. But what about what if I wanted to run every 15 minutes every 3 days, let's say? So what I'd do is I'd keep the hours the same, and I'd go to the days of the month option and do */3. Okay, now, so every 3 days, so let's say on the 1st of the month, the 4th of the month, the 7th of the month, and so on those days, it'll run every 15 minutes. Okay, so you can see how this kind of works here. What if I wanted the command to run once a week at 23:59 on a Sunday, only in December and January? 23:59 on a Sunday, but only in December and January. Well, how we do that? Let's make another row. We'd say so 23:59. So 59 is the minute. The hour is going to be 23. It doesn't matter which day of the month. It doesn't really, actually, the month does matter. Only January's and December's. So January's and December's, day of the week, only Sundays. Okay, we could say because we can. Okay, so there we are. Now what we've got, 23:59 every day of the month. So what this is going to do, 23:59 in January and December, but only on Sundays. Okay, so there we are, and it's going to echo because we can, for example. Now, there's a great website called crontab.guru, okay, that you can take a look at and play around with to see what different cron tab expressions mean. And I'll put a link to it in the resources section. It's awesome, okay? But a great use of cron is to schedule automated backups of the file system. So let's say we want to run weekly backups every Friday at 23:59 for every month of the year. Okay, so if I delete these examples here, delete these. So 23:59 on Fridays for every month of the year. So we know that 59 is the minute. We know the hour is 23. it doesn't matter the day of the month, like numerically, it doesn't matter whether it's the 1st or the 7th, just every Friday of every month of the year, but only on Fridays. And then we'd put the command, which is going to back up our stuff. Okay, and that's how it would work. But we know how to do this because we can make a script for it. Okay, so let's save our cron tab so far, just like that. And you can see it's wrote 24 lines. But if I actually look, just by the way, while we've been editing that, if I look in the hello.txt, you can see we've got so many more hello worlds being added to that as our cron command that we set before has been continuing to run. So that's really cool, right? It's automated and it's running in the background. Alright, so let's set up the script that we want to run. Now, you remember in the last few videos when I was telling you about bash scripts, we made a folder called bin, and inside that bin folder is where we started putting our scripts, and we had this one file called backup. So let's take a look inside that backup script again. Well, in here, what it does is it compresses into a archive on our desktop every single one of the contents of our documents, downloads, desktops, pictures, and videos folders, and it also outputs some the error, like the standard error, like the log messages that come from the command into the bit bucket. So they're just sent to the void. They're no longer printed to the screen. Okay, so this is good. This is going to do a backup for us. Let's say that actually, instead of sending them to the desktop, let's say that in our home directory, let's say we made a directory called backups. Okay. Oh, I spelled that wrong. So if I rename backups with 2 S's into just backups with 1 S. There we go. We've now got a folder called backups, okay? And let's say we wanted to save the backups in there. So if we go to the bin folder, and we edit our backup script, now we can say, okay, go into instead of our desktop, go to our backups folder, okay, and then save the backup.tar.gz. Okay, that's good, and that's good for that. But what we want as well is we want to also log the date and time that the backup was created into a log file. Now, the way that we could do that is we could use the date command, and we could append that data to a file in our backups folder called, let's say, backups.log. Why don't we say that? Okay, so we're going to call it backups.log, and that's just going to keep in there the date and time that the last log happened. Okay, so if we save that, actually we could make it a bit more advanced. We could actually, no, let's leave it like that. Let's not make this any more complicated than it needs to be. Okay, so we're going to take that date and we're going to append it to our backups.log file, and you can see here that I'm using the double arrows to make sure that as this script runs each time, it's going to add it so the file gets longer as time goes on. Okay, so we've now got this script that we want to run, and if we run it, we just run backup from anywhere. If we run backup, you can see that now, if I just put this back to a normal size, if we go into our backups folder, we've now got backups.tar.gz, and we've also got this backups.log. If I open that with nano, backups.log, you can see that it's logged the date and time. Okay, so if I just remove everything in here using RM, you can see they've all disappeared. Okay, so we're good. We know that script works. Let's try and add it to our cron tab. Okay, so here we are. We've said that we want every Friday at 23:59. We want that script to run. So how can we do that? Well, the way we can run that is, because it's a bash script, we'll type the bash command, so just bash like that, and then we'll give it the path to the script that we want to run. So in our home directory, in the bin folder, we're going to run the backup script. So that's all we've got to do, right? We just type bash and then give it the path to the script that we want to run, and then that script will now run at 23:59 on a Friday. But to save you waiting all the way till 23:59 on next Friday, let's go ahead and make this run every minute so we can watch it happen. Okay, so look what I'm going to do. Nice hack. Okay, so I'm going to cut the line and uncut the line and then uncut the line again. So that's a nice copy and paste. And I'm going to make this run every minute. Okay, so here we go. We're going to change all of these to stars. Okay. So there we go. Now that should run every minute now. So if I write the file and close it, you can see it's installed the new cron tab. Now in backups, there's nothing in here, but if I look at the date, we can see that we've got about 40 seconds until this runs again. It needs to be very excited, I'm sure. So we've got about 30 seconds. So I'm going to cut the video here and come back close to the time. So here we are. Let's take a look. And it's just gone past the minute, so let's take a look in our backups folder, and hooray! We have indeed run our script correctly. And if we look inside the log folder, if we look at backups.log, we can see that it ran at just past the third minute of today. So the reason that it runs at just the minute past, it's just there's just 1 second error. I think it's just a clock thing. It's, the computer can only process things at a certain time resolution, and 1 second's really not that much of a bad error. Okay, so you'll tend to see things like this. I think it actually does run at exactly the time the minute goes, but the date command takes just about a second or so to run, or something like that. So there's a slight delay, but really 1 second is not bad at all. So now we have indeed ran our command, and look, it might even happen again. It might even happen again. So if we wait 4 more seconds. 1 more second. Yes. Now we look inside our backups.log. Backups.log. We can see that another one has run again just at 1 second past the 4th minute. So now we are making backups every single minute, but that might be a bit of a burden on our computer here. So let's just go ahead, Control and K to delete the line, and then we can save our cron tab and leave it so that it just runs at 23:59 on Fridays. So there you are, guys. How awesome and how epic is that? So I'm sure you can see the power of combining together bash scripts and cron scheduling to control whatever you want about your computer. Now these two skills together are incredibly powerful combination, and you now have the foundation in how they work. So let's have a quick recap of what we've learned in this video. So in this video you took a look at how to use cron to schedule when commands and scripts should be run, and you learned that every user has what is known as a cron tab, and that you can edit cron tabs using the cron tab command with the E option, with the E standing for edit. Now cron tabs are text files that are broken up into many rows, and you can have as many rows as you like, and each command or script has its own row, and each row has 6 columns. The first 5 columns are scheduling information, and the 6th and final column details which command or script should be run at that scheduled time. So the columns are for the scheduling columns, you've got the minutes of the hour. So for example, if you put 15 in that column, the command would only run at the 15th minute of each hour. So things like 11:15, 2:15, 3:15, and so on. Then you've got the hour itself. So that's a number that you can put in 24-hour clock time, so from 0 to 23. You've got then the third day of the column is the day of the month. So again, from 1 to the end of the month, whatever that might be. The 4th column is the month. So that could be numbers, with 1 being January and 12 being December, or you could just type in capital letters the 3-letter version of the month. So JAN for January, DEC for December, and so on. And the 5th column is the day of the week. So that could be 0 to 6, with 0 being Sunday and 6 being Saturday. You could also enter 7 as Sunday again, if you wanted. But a good way to do it is just to enter the day names. So MON being Monday, SUN being Sunday, so 3-letter day names, okay? And you also saw some advanced ways to schedule this stuff as well. And a great place to look at these scheduling things is to look at a website called crontab.guru. I'll put a link to that in the resources section, because it's a great website for you to practice setting up these scheduling conditions, and it also will come useful for you at some point in the future. And as I should mention as well, columns can be separated by as many spaces as you like. All cron wants is that you separate each column by at least 1 space, but feel free to format each rows however you like. Okay, and you also saw in this video how to use cron tabs and bash scripts to schedule automated backups of your home directory, which is an incredibly useful thing to make sure that all your files stay safe, and it built upon what you learned in the last section about file compression and archiving. So that's super awesome as well. Now the key thing that I want you to remember from the last 2 videos is that in Linux practically anything can be edited using the command line. Now since you can write bash scripts to execute these commands in a controlled sequence, and then use cron to schedule when these scripts should be run, you have the necessary toolkit to do whatever you want on your system whenever you want to do it, which is a crazily powerful combination. All you need now is a bit of imagination to decide what you might like to do. Now bash scripts are a whole massive topic in and of themselves, so we only really had time to scratch the surface and cover just a small bit of what they can do in this course. But at least now you have an understanding of what bash scripts are, how they work, and where you might use them. And if you'd like me to create a specialized course on just bash scripts, then send me a message, and if I get enough of you saying that you want that, then I can potentially put that together for you. But for what we've learned in this course so far, I want to make sure you get some practice in using it. So in the next video, you're going to be getting the brief for your next project assignment. Now, it'll be a rather simple and fun one this time, but it'll allow you to go off and try writing bash scripts and cron tabs for yourself, so you can get a hands-on understanding of how these incredibly powerful skills work. So for the brief of your next assignment, I'll see you in the next video. Hello there, you beautiful people, and welcome to this section of the course all about how to install and manage software on a Linux computer. Now, Linux is an open source operating system, and the great thing about that is that there are around the world millions and millions of software developers who are creating software and all kinds of fantastic stuff and making it available for free for people to download. Right, so that's pretty cool. That means we can benefit from that a little bit. Now, Linux has some amazing ways for you to gain access to this software, and in this section, I'm going to show you how to do it. So in this section, you're going to start off with a tour of what open source actually means, and we're going to show you how you can see the actual source code for some commands that you've already seen in the course. And then you'll learn how to use the software repositories to search for and install new software, keep that software up to date, and also how to remove it when you no longer need it. So we're going to show you the whole package. Now, usually when talking about software management on Linux, courses just tell you enter this command and this command and this command. You just got to memorize it, which is useful and all, but it never really shows you, the meaning behind it, or leaves you feeling like you actually understand what you're doing and why you're using a certain command. So in this section, you're not only going to understand what commands to run, you'll also understand how your software manager is working under the hood to help you install, update, and manage software in your GNU Linux system. Okay, so by the end of this section, you'll have a wonderfully in-depth and practical understanding of software managers, and you'll also have the practical know-how to get more shiny new toys to play with than you can possibly imagine. So for all that good stuff, I'll see you in the next video. Hello there, you beautiful people. Now, one key thing that probably brought you to work with Linux is the idea of open source software. But what does that term really mean? Well, in this video, we're going to talk about the GNU project and what it actually means for software to be open source and the history of the whole open source movement. So let's go ahead and get into it. Okay, so the first thing that we probably need to understand is what Linux actually is. When we hear the word Linux, we probably think of a whole operating system that we use as being the Linux operating system. Now, surprisingly, this is actually not the case, and Linux is actually just one of the pieces of the whole operating system, the kernel. So let me explain. On the 27th of September in 1983, a person called Richard Stallman announced that he was going to begin developing a operating system that was similar to the Unix operating system, but made of entirely free software. Now, the operating system was called the GNU operating system, spelled GNU, which stands for GNU is not Unix, which they like to call a recursive acronym. Okay. Now, in January 1984, Richard Stallman quit his job in the Artificial Intelligence Lab at the Massachusetts Institute of Technology, so MIT, to work on the GNU project full-time in the aims of creating an operating system made of completely free software. Now, the term free software actually refers to several freedoms that the software gives the user, rather than being free as in money. So when you hear the term free software, think free speech and not free lunch. Now, these freedoms are, the first one is the freedom to run the program as you wish for any purpose. That's the first freedom. The second freedom is the freedom to study how the program works and change it so that it does the computing as you wish, which is what freedom 1 is, okay? Freedom 1 is that the program will do what you wish, and freedom 2 is the freedom to study how the program works and to change it so that it does as you wish. Now, access to the source code for a program is a precondition for this. You can't study how a program works unless you can look at its code. So having access to the source code is a precondition for freedom number 2. The third freedom is the freedom to redistribute copies of the software so that you can, as they say, help your neighbor. And freedom number 4 is the freedom to distribute copies of your modified version of the software. So if you modify it, you can redistribute that, which links to freedom number 3 of helping other people. But apparently by doing this, you can give the whole community a chance to benefit from your changes. And again, access to the source code is a precondition for this. Okay, so if you want to modify software and redistribute it, you need to have access to the source code in order to be able to change it. Now, there's a license that legally provides a user of software with these freedoms, and it's known as the GNU Public License, or the GPL. Now, there's several versions of the GNU Public License, or the GPL, but at the time of recording, the GPL version 3 is the most modern version. But in 1991, the GNU system was almost finished, but there was still one part missing from the GNU operating system, and it was an important part. This final piece is a major part of every operating system, and it's called the kernel. Now, the kernel is responsible for allocating the resources on the computer's hardware that is required by the software that it's running. So it's the interface layer between a computer's hardware and the applications that it's running. Okay. Now, at this time, in 1991, a man called Linus Torvalds was completing his MSc thesis at the University of Helsinki in Finland. And as part of this work, Linus invented a Unix-like kernel called Linux, and it was called Linux after his own name, but everything in the Unix world kind of ends in an X, so Linus ending in an X is Linux. Okay, and after being invited by a fellow student to go see a talk by Richard Stallman, who was also a prominent activist at the time, Linus released the Linux kernel under the version 2 of the GNU Public License, or GPL, thereby making the Linux kernel free software. So thanks to the Linux kernel, the GNU operating system was complete and was a fully runnable operating system made of entirely free software, with those 4 freedoms we talked to you about before, and it began to gain popularity. And it's in fact the Linux kernel that is used today on Android devices and even Chrome OS. So if you ever hear people say, oh, Android runs Linux or Chrome OS runs Linux, what they mean is they use the Linux kernel to interface between the software layer and the hardware layer of your computer. But because the Linux kernel was the final piece, it kind of got a whole lot of attention, and the rest of the work that went into the GNU operating system was kind of forgotten. But because what we run when we run a distribution like Ubuntu or any other Linux distribution is actually the GNU operating system and the Linux kernel, it is recommended that in order to give the GNU project its credit, instead of just calling the whole thing Linux, we should call it GNU plus Linux. In fact, there is a command called the uname command that will actually tell you loads of information about your computer, such as what hardware it has and what operating system that it's running. So if you run the uname command with the O option, it'll tell you your operating system. So if we run that, we see that we get GNU/Linux as the operating system. So that's pretty cool, right? Okay, so with that history understood, we now know pretty much all of the commands that we've used so far in the course, such as the ls command and the find command and so on, are all part of the GNU project. And to give the users the freedoms that free software provides, the source code needs to be available to read, because access to the source code is a precondition for those freedoms, right? So in other words, the software must be open source. Okay, so the source code must be openly accessible, it's open source. So how can we have a look at the code that our computer runs? Well, it's actually all freely accessible on the GNU project's official website, gnu.org. So if I just open up a Firefox browser here, and when that boots up, we head over to gnu.org, we'll be able to see what I'm talking about. So here we are, here's Firefox. Let's go to gnu.org and press enter. There we go. So you can read all about the philosophy behind the free software ideology in more detail. And you can see here it's telling you to try GNU Linux here. But if you head over to the software section, so if we click on software here and scroll down to a part that says all GNU packages, so here it says all GNU packages, you can see here that there's basically links to every bit of code that is run on a GNU system, including a free software version of the Linux kernel itself, which we can find under the Linux Libre package. So here we are, Linux Libre. Okay, that's the package, that's the downloadable folder that contains all of the source code for the Linux kernel itself. So that's pretty awesome. Now, for all the commands that you've run so far, such as the ls command, grep, find, whatever it might be, okay, you can find those under the core utils package. There we are, core utils. Okay, so that's where you can find the stuff in there in that core utils package. And in the next video, we're going to download the core utils package, modify it, and install a new version of the ls command to our computer, which is going to be super, super exciting. But first, let's just take a quick recap of what we've learned in this video. Okay, so in this video, you learned about Richard Stallman beginning the development of the GNU operating system in 1983, and the idea was to create a Unix-like operating system that was made of entirely free software. And you learned that when we say the words free software, we mean software that provides users with certain freedoms. So think of free speech rather than free lunch. Okay, now there are four freedoms that the free software gives the users. So it gives the users the ability to run programs as they wish for any purpose. It gives the users the ability to study how a program works and change it so it does the computing as they wish, and access to source code is a precondition for that. It gives the users the ability to freely distribute any copies they get so that they can help out other people, and it also gives the users the ability to distribute modified versions of the software that they create to other people. So this allows the whole community to benefit from any changes that a user makes, and again, access to source code is a precondition for that as well. Now, these freedoms are legally provided to users using the GNU public license, or the GPL, and as the time of recording, the third version of the GPL, so GPL version 3 is the most modern version of the license. And open access to the source code is a precondition for giving these freedoms. And when a software has openly accessible source code, it is known as open source software. So you can say that free software is open source, but not all open source software is free software, because whilst people might let you see the source code, that doesn't mean they necessarily give you the freedoms required to modify and distribute it. They might just let you see the source code, okay? But free software does require open source software, so it works one way but not the other. And you've also learned that in 1991, the GNU project was almost finished, but it had a important missing piece, which was the kernel. And the kernel is the part of the operating system that interfaces between the hardware and allocates resources from the hardware depending upon what software requires it. And in 1991, Linus Torvalds created his own version of a kernel and called it the Linux kernel, and released it in 1991 under the GNU public license version 2, thereby making it free software. So the Linux kernel was the final piece for the GNU operating system, and now the two tend to work together. So when you download Ubuntu, or when you download any other type of Linux distribution, what you're actually downloading is a version of the GNU plus Linux operating system. So henceforth, we won't just call it Linux, we'll call it the GNU Linux operating system. Okay, so in the next video, now that we understand this little bit of a history lesson, we understand about the freedoms and what open source software is all about, we're going to play with some source code, okay? We're going to download and take a look at some of the source code for some core commands, modify their code, and install that modified code on our computer and see how they behave differently. So this is going to be amazing, and it's going to really allow you to see what open source free software is all about. So for all that goodness, I'll see you in the next video. Hello there, you beautiful people, and welcome to this video where we're going to be learning how to turn source code into runnable programs with our own little modifications. So in this video, you're going to learn how to download source code, edit it, and use the GNU C compiler to turn that code into runnable binary programs. You're also going to learn how to install software from source code using the make command. And we're also going to modify the code slightly so that we can see that it is indeed our modified code that is being installed. And by the end of the video, you should have a much better understanding of the awesomeness of open source free software, and you should also know how to compile software from source code for yourself. So let's go ahead and get right into it. Alright, so here we are again on the GNU.org website, and we can see on the software tab here that we can get each of the packages, scrolling down to the bottom, that comes with the GNU operating system. Now, all the source code for the commands that we've run so far, such as the find command, the ls command, and so on, can all be found in this core utils package over here. So let's go ahead and download this package and take a look at it. So to do that, we click on the link, and it will open up another page, and if we scroll down to the downloads section here, it'll give us a couple of links, and it tells us that the stable source releases can be found at this link, and the test source releases can be found at this link. Now, the difference between the stable and test is that stable source releases, are known to work, they've been tested, whereas test source releases are, maybe where they're trying out new things and, it's not fully stable, it's not final, right? So we're going to try out the stable source, and we're going to click on that link, and we can see here that we get a bunch of packages, a bunch of bundles that are in a list format, and the most recent versions are towards the bottom of the list. So if we scroll down as far as we can to the bottom of the list, we'll see we get Core Utils version 8.28, and what we're going to click on is the one that ends in .xz, so not the one that ends in .xz.sig, just the one that ends in .xz. So if I go ahead and click on that right now, we'll see that we see a pop-up come here, and I'm going to click Save File. I'm going to click OK, and that has been saved in our Downloads folder. So if I just if I head over to our Downloads folder right now in the terminal, and you can see at the minute I'm in our home directory, I go to the downloads folder and list it out, and you can see that we have got this core utils version 8.28.tar.xz. Now that's a compressed tar archive that's been compressed using the xz compression algorithm. So if I look at that, we'll see with the find command, we'll see that it's xz compressed data. Now xz is just a compression algorithm, just like the bzip or the gzip compression algorithms that we touched on in the file compression and archiving video very briefly, because it's not one of the more common algorithms, but we can unpack it using the tar command. Okay, so let's just do that. What we can do is we can type tar, and as you know how to extract a file, you give it the X and F options, and then you tell it which archive. But to extract through the xzip compression algorithm, you need to give it the capital J option. So the lowercase j option is for bzip2, but the capital J option is for xzip. And if you want more information on this, check out the file compression and archiving cheat sheet that I gave you in the appropriate video. Okay, so if we go ahead and press enter, we'll see that we didn't get any information because we didn't give the tar command the V option, but if now I use ls, we'll see that we've now got a new folder called Core Utils 8.28. So if we cd into there, so we cd into Core Utils and take a look, we can see that we've got a whole bunch of stuff in there, okay? But we can specifically pay attention to this src directory. Now that src is short for source, and that's where the source code is kept. So if we cd into src and take a look, by clearing the screen, take a look, we can see that we've got a whole bunch of files in here. Let's pipe that ls data into the less command first of all. Now this makes it a bit easier to scroll up and down, and you see. Now we can see that we get loads of files that end in .c. Now that .c indicates to us that these files are all written in the C programming language, okay, which is a very common programming language that the GNU software is written in, given the date of when it was written being in, the 1980s, 1990s. So let's take a look at the code behind the ls command, for example. We could ls, and let's just grep out ls. We can see that we've got this ls.c file going on here. So let's take a look at it, nano ls.c. And there we are. This is actually the source code in here. This is all the source code. Let me maximize it a bit. The source code for the ls command. So isn't that awesome, right? Now, if you had the time, the ability, and the intention, you could go through this code and study exactly what it was doing, which is one of the freedoms that the free software movement aims to give you. But we can actually also modify this code and recompile it into a running software, which is what we're going to do now. Now, this isn't a course on C programming, but in every C program, there is a function in there called the main function. And it's a very important function that always runs, okay? Now, I'm going to modify that function so that whenever ls runs, the computer will print out, "Hello there, you beautiful people," onto the screen, okay? So I'm going to type a bit of code into the main function that makes that happen. Now, after preparing a bit for this lecture, I found that the main function in this file starts at about line 1443. So if we use Nano's go to line function using the control and underscore option, if I put in line 1443 and press enter, you can see that we've ended up at the main function. Magic. So I'm going to add a line of code right at the top here that does that printing stuff. So print f, and I'm going to put in there, "Hello there, you beautiful people," and make sure that it ends on a new line with the \n character right there, okay? And I'm just going to tab this over. It doesn't make a difference, but, that's a bit nicer. And let's try and get rid of this extra space at the end of the line. It doesn't matter, but Okay, there we are. So we've put in the function there, hello there, you beautiful people, with a new line character. Okay, so the line, it goes to a new line. Now, if we save the file with Control and O, and we exit with Control and X, we've now modified the ls commands code. Okay, so that's pretty cool. But now, how do we turn this code into a runnable program and install it on our computer? Well, because they're written in C, the code needs to be compiled into machine language before it can be run, and for that we need a compiler, and more specifically a compiler for the C programming language. Now, the GNU C compiler, or GCC, is the compiler that's used on GNU Linux systems, and we can get it by entering the following command. And that following command is sudo apt-get install GCC. Now, for now, I don't want you to worry too much about this, because we'll be explaining in great detail later on what this command actually means, and we'll be doing it in this section of the course. But in short, what we're doing is we're telling the computer to look on the software repositories available for Ubuntu and download and install the GNU C compiler or GCC package. Again, this will become much clearer in the next few videos, but just type it as I have done so here, and when you're happy, press enter. And because we've used sudo, it'll ask us for our password, just like when we've used sudo before. So I'm just going to enter that in there, hopefully correctly, fingers crossed. Nope, let's try it again. There we go. And now it's saying, hey, we've got to install a whole bunch of packages in order to get this GCC package. And it's going to be about 72 megabytes of additional disk space. Do you want to continue? Now I can just type yes, so I'm just going to type Y, press enter, and it's going to go ahead and do that. Okay, and this might take a bit of while depending on your internet connection. But it appears to have downloaded it in my case, and now it's just doing the installation. It's going to start unpacking each of those different packages that it's downloaded, and we are actually seeing an installation process happen right now. We will look into this a lot more in more detail later on in the course, but you can see that we didn't have to download any wizard and click next, agree to any terms of conditions or anything like that, because all of this software is under the GNU public license, and it all gives you the same freedoms as each other. Okay, so now that's gone ahead and installed. We didn't have to do anything. We've now installed the GNU C compiler and a whole bunch of other stuff. So now we're ready to compile our code. Okay, so let's turn our attention to our beautiful source code. Now, because different computers have different architectures, we need to configure the installation of this code to our specific machine. Now, there's a script that comes with that called configure. Now, we're in the source folder here, so let's just go back up a folder with cd ... to go back up a folder, clear the screen and take another look, and you can see here there's a script called configure, and we know it's a script because it's green. Okay, so let's run that by typing bash configure, and we press enter. And what this is doing is it's configuring the GNU C compiler, the GCC, to make sure that when it compiles all this the software that we tell it to, it's going to do it in a way that's appropriate for our computer's architecture. Okay, and it's making the appropriate adjustments. And the important thing that this configure script does, besides configuring the GNU C compiler, is that it creates a new file called the make file. Now, the make file is responsible for the installation of this new software package. But to make the make file work, which is a massive tongue twister, by the way, we need a new command called make. So when this thing has finished configuring, we're going to install the make command in a very similar way to that we just installed the GNU C compiler. So if we just sit tight here for a second while we see all this beautiful text flying up the screen, it looks pretty awesome though, right? It's like something you might see on like a film with hackers, you know, and stuff like that. We're literally doing that right now. So be very proud of yourself. Okay, so now that's finished. If we just take a look in this directory, we should be able to see this new file here called the make file. Now, the make file is an important file, but we need to be able to run that, we need to have the make command. So to get that, we're going to type sudo apt-get install make. Okay, and when we press enter, it's going to go through a very similar process of installation. And now that's all installed. Very quick, very easy to install that one. Okay, so now when we're in the same folder as the make file, if we just run the make command, you can see that it's going to go through and it's going to compile all of the C files that it finds have not been compiled recently, and there are still some changes outstanding, which is effectively all of the C code in this folder, including our ls file. Okay, so what this is doing is it's compiling it all into machine code, into binary code that can be ran on the computer. Okay, so this is what's necessary when you run a compiled language like the C programming language. So when that's done, we'll be able to install the newly compiled programs. But I'm going to cut the video here to save time and stop you waiting around too much. Okay, now that's completed. So what's happened is we found the code for the ls command. Okay, we edited that code, and then we installed something called the GNU C compiler, which is what's required to turn that code into machine code that the computer needs in order to run. Okay, so what we did is we installed the GNU C compiler, and we had to configure that compiler before it could work correctly for our computer's specific requirements. Okay, so we configured the compiler, and then when it was configured, we've just run it using the make command, okay, to make sure that every single bit of code is now turned into machine code. Okay, so the only step that remains now that we've got this machine code is to install that machine code in the required places on our path for it to actually work. And the way that we can do that is using the sudo make install command. So if I clear the screen, type sudo make install, what it's doing is it's installing all of the stuff like that, and that was very, very quick. We've now installed each of the different pieces of software that came with this version 8.28 of the core utils package. Okay, so let's take a look at how that works. Okay, so if we just close our terminal and reopen it again, then now if we run the ls command, we can see that it says hello there you beautiful people every time that it runs, because we modified our code and installed it. How awesome is that, right? So hooray for open source and free software. So this is actually a much faster process in reality than what I've showed you here. So to change back, we would just re-edit the source code, recompile with make, then reinstall with make install. So if I head back to our downloads, okay, it's actually a much faster process when you get a bit better with it. So here we are, we're in our core utils file. We're going to go over to our source code folder. Now we're in there. Okay, so let's go to nano-ls.c. Let's head over to line 1443, and we're going to delete this line that I put in there, save the file. Okay, now if I just clear the screen, now all we have to do is do make and sudo make install. Because I'm in the wrong folder. There we go. Make and sudo make install. Okay, so now notice how the make command is just really compiling the ls command, because it notices that's what's different. Let me run with enter my password there so it can install it. And now when I close the terminal and reopen it and use the ls command, now it's back to normal. So you see how much faster that was, right? Once we've configured the GNU C compiler once, or at least for the package, it's really fast to just go and edit it thereafter. Okay. That's because the make command knew as well that it only needed to recompile the code that was affected by our change, not the whole package, which was new to the system the first time we did it. Okay, so make is a very clever program. And as I say, now that we've installed the new version of the ls program, now the hello there you beautiful people message has disappeared and it's back the way that it was. So there you are, you beautiful people. In this video, you've seen how to access source code from the GNU.org website, how to modify that source code, and how to use configure, make, and make install to install the new software. Now the great thing is you can access and modify the source code for everything on a GNU Linux operating system, and if you care to exercise it, you have absolute power over how your computer works. So hopefully you can see how having open source free software running on your computer is a great asset, and you also that you can appreciate the effort that the pioneers of such a system took to build it. But the process that we went through in this video is relatively lengthy, and sometimes you just want to install software and get on with what you are doing. So for this, there are massive bodies of maintained and pre-compiled code in what are known as the software repositories. And we use the repositories in this section actually to install the GNU C compiler and the make command, and software repositories are what you'll use to install software 99% of the time, and they come with so many really cool features. So now that you understand that yes, you can look up source code and modify how your computer works however you like manually, let's take a look at how the software repositories, which give you access to a massive library of software that is already pre-compiled and ready to go, let's have a look at how they work as well. So for all that goodness, I'll see you in the next video. Hello there, you beautiful people. Now, in the last video, you saw how you can compile source code from scratch and install it on your machine. Now, this is a great process for understanding and customizing the software running on your computer, but for most everyday things, it's usually just a bit too much work. So what if you could have a library of software that you can browse and have all pre-compiled and ready to go with the push of a button or a run of a command? Well, that's exactly what the software repositories and package managers are for, and in this video, we'll be covering what they're all about. So in this video, you're going to learn about the different software repositories that are available on Ubuntu and how to search them using the online websites. And by the end of the video, you'll know what the different Ubuntu repositories are, and you'll also know what a package manager is. So this lecture is going to be jam-packed with useful information, so let's go ahead and get right into it. Okay, so the first thing we need to know is what a software repository is. So think of a software repository as a big library filled with software. Now, when you go to a library, you can search for books, you can read about the books, you can look at different versions of the books, and you can compare which books that you might want to borrow, and then check them out of the library. And a software repository is like a library, except you don't have to give the software back. And even better, when a new version of the software comes along, you can automatically update that piece of software and all the software on your entire system to the new versions that are available with a simple command, and this helps keep your system secure and reliable, and it's also totally epic. Now, in Ubuntu, there are 4 different repositories, and each repository stores a different type of software, and they are described on the main website for Ubuntu, which is ubuntu.com. Now, if we head over to help.ubuntu.com/community/repositories with a capital R and then /Ubuntu with a capital U, I'll put a link in the resources, by the way. If we head over to that, we'll see information about the different repositories. Okay, so you see a section here that says what are the repositories, and you can see that for Ubuntu there are 4 main repositories. Now, the main repository is the repository that holds all the software that is actively maintained and updated by Canonical, and Canonical is the company that created Ubuntu. Now, all the software in there is free, as in freedom, and is also open source. Okay. Now, the main repository is the most reliable repository, and you should try and select from suitable software in the main repository at the first instance where possible. Now, the second Ubuntu repository is the Universe repository. Now, software in this repository is also free, as in freedom, and it's also open source. However, instead of being maintained by Canonical, it is maintained by the Ubuntu community, and as a result, it is therefore theoretically maybe less rigorous and more prone to bugs than the main repository, but most of the time it's fantastic in my experience. Now, the third repository in the Ubuntu system is the restricted repository. Now, the restricted repository includes proprietary software and drivers for company-specific devices such as wireless cards and so on. Okay. Now, this repository helps ensure that the devices on your computer are more likely to work out of the box, shall we say, but the software is usually proprietary and therefore doesn't usually give you the freedoms that the other software gives you. Also, you might or might not be able to directly examine the source code of the software in the restricted repository, and this depends on the specific use case. And the 4th and final repository is the Multiverse repository. Now, the Multiverse repository contains software that is restricted either by copyright or legal issues. The software in the Multiverse repository might or might not have accessible source code. Now, you can see here that the Ubuntu philosophy is generally about giving the user choice about what software they want to use. There are 2 repositories that are free and open source, which are the main and the Universe repositories, and there are 2 other repositories which aren't free and open source, or where the software is unlikely to be so. So to some people, using non-free software is abhorrent and completely unacceptable, whereas to others it will be fine if it gets the job done. Now, Ubuntu leaves that choice up to you. But other distributions, such as Fedora, only include free software in their repositories and do not include software that is non-free. Now, this can cause reductions in convenience, but it has other benefits. Now, Ubuntu leaves the choice up to you as to what you prefer, and now that you've been informed about the free software debate, you're in a better position to choose for yourself. So now that we understand what the 4 Ubuntu repositories are and the differences between them, let me show you where they hang out online. Now, I don't mean social media, but there's a link called packages.ubuntu.com. So if we head over to that, here we can browse through the list of packages, and we can see different links depending upon what version of Ubuntu that we're running. Now, the code name will change for every new release of Ubuntu in alphabetical order. So, for example, the current one is called Artful Aardvark, or Artful for short. And you can see what the code name for your distribution is by using this command in the command line. So you open up your terminal and you type in lsb_release, okay, and you give it the A option, and it will print out all the information about your Ubuntu distribution. And you can see that mine is called Artful Aardvark, and it tells me down the bottom here the code name is Artful. So I would click on the Artful link, which you can see here, to open to see what packages are applicable to me. But you can click on whatever code name is appropriate for you when you watch this video. Okay, it all works basically the same. Now in here are all the packages, all the package categories. Okay, so you can see a whole bunch of categories in here. You can see, for example, we've got things for web servers. You can see things that we've got for fonts. We've got editors. We've got documentation, databases, administration utilities, and a whole lot of other stuff. Programming languages, Python, text processing, video. It just goes on and on. Okay, there's so many different things, and these are just categories. Okay, so there's loads of different packages inside each of these categories. But if we scroll down, we'll notice that there's a couple of important links down here. We've got the all packages link, and we've got the compact compressed text list. So this one here is just if I open it in a new tab, we can see that it's just a kind of text file here with a list of every single one of the packages. And I downloaded this text file when I was preparing the course and ran it through the word count command and counted the amount of lines after cutting out any header information, and found that there were 74,060 packages, which is crazy. But you know, this is there for you to play with. Well, I'm just going to close that, but we're not interested in that for this video. What we're interested in is this link here that says all packages. And if I click that, it'll open up a web page that shows you all the packages. So let's just wait for that to load up a second. So there we are. So now we get a web page that gives us a link to each available package in Ubuntu. And you may notice that it shows you in square brackets which repository the things came from. So we can see here that this 0AD package came from the Universe repository. And if we scroll down, we'll be able to see some that come from other repositories as well. We're getting a lot from the Universe repository, but you see here we've got one coming from Multiverse. And if you find a package that doesn't have anything in a square brackets next to it, that means it's from the main repository. Okay, so for example, this AA lib bin, you can see it doesn't have anything next to it. That means it comes from the main repository. Okay, so that's just something to be aware of as well. But for now, for the purposes of this video, let's just go ahead and click on this top link, this package called 0AD. And when we click on it, we'll notice that a new web page opens, and we see that the package is called 0AD. We can see the package name right at the top, and then in these parentheses we can see the version number of the package, and then we can see in these square brackets the repository that the package has come from. And as I said, if there isn't any such information, then it's from the main repository. Okay, and as we know, the Universe repository contains free and open source software, but is maintained by the community and doesn't receive any formal updates or maintenance from the Ubuntu developers at Canonical. Then underneath that, we can see a list called Other Packages, okay, that are related to this package, and we can see that they have required version numbers in these parentheses here. So for example, this dpkg package must be greater than or equal to version 1.15.6. okay, and you can see that there's quite a few different packages that are related to this one. Okay, and you can see that they have a special symbol at the front as well, and we can see that red means that it depends on this package. Okay, so the red dot means that the 0AD package depends on these packages. So that means in order to install 0AD, we need to install all of these packages with red dots in front of them as well if we want 0AD to work. Okay, but the red dot isn't the only symbol that can appear next to a package in the other packages list. So we can see that there are other symbols as well. Okay, so you can see on the key up here that the green diamond next to a package means that 0AD would recommend you to install another package. So let's make this a bit more general. Let's call the package that you want to install, which is in our case 0AD, let's call that package A. Okay, then let's call a random package in the other packages list package B. Okay, so if package A recommends package B, that means that in order for package A to function normally, we should get package B, but package A will function without it. Okay, then the blue square would say that package A suggested to us another package. Okay, so recommends means that it will function without it, but we recommend it for normal use. Okay, depends means it won't work if you don't get these packages. Recommends means it will work, but not like how it should. And the suggest package is just some entirely optional stuff, that things you might like to check out, okay? And the final one is the enhances. Now, anything with a black dot means that it enhances the current package in some way or another, maybe through new features, but again, it's not required, okay? And if we scroll down to the bottom of this page, we can see the sizes. We can see what size the package is to download, and we can see what size it is when it's uncompressed and installed. And we can also see what the files each package contains, which is useful. So you can click on there and you can see a list of each of the files that each package contains. And you can see that there's different packages for different computer architectures. So for example, if you've got a computer architecture that has an AMD 64 architecture, you would download this one package. And if you've got one for the i386 computer architecture, you would download this package, okay? And you can see your computer's architecture by opening up your terminal and typing uname-m. Okay, we can see that in our virtual machine we're running on an x86 64 architecture. Now AMD 64 and x86 64 are the same, so we would get the AMD 64 package is most appropriate for us here. Now, if you just get x86, then you download the i386 package because that's probably the one most appropriate for your computer. So now you might be thinking, wait a minute, Ziad, hold on. Are you saying that in order to install software, I first have to search through thousands of packages, then find out what dependencies it has, and after that I must ensure that I download all of those different packages and satisfy their dependencies, and so on and so on. But before I download all of those, I need to make sure that they're all the right version number and that the packages are appropriate for my computer's architecture? You have got to be kidding. Well, that's what I'd be thinking anyway. But no, the good news is that there's a command line tool installed on your computer that deals with all of this stuff, and it's called your package manager. Now, the actual program differs from distribution to distribution, but on Ubuntu, the package manager is called apt, spelled APT, which stands for Advanced Packaging Tool. And this is what we're going to use to do all this hard work for us. And in the next video, you're going to see how to use it. But first, let's have a review of what we've learned in this video. So in this video, you've learned that a software repository is kind of like a library, but for software, except you don't need to give the software back. Now, it does differ for other distributions, but in Ubuntu, there are 4 main software repositories. So there's the main repository that contains free and open source software that is actively maintained by the Ubuntu developers. There's the Universe repository that also contains free and open source software, but it's maintained by the community instead of the Ubuntu developers. There's the Restricted repository that contains proprietary software for device drivers. Now, software in this repository is unlikely to be open source, although it might be, but it's not actively maintained by the Ubuntu developers. And finally, there is the Multiverse repository that has software that is limited by copyright or legal issues. Again, it's unlikely that the software will be open source in the Multiverse repository, but it might be. Now, with your knowledge about free software, the GNU project, and so on, you can now decide for yourself whether you will only use free software from the main or Universe repositories, or whether you're happy to use the software from the Restricted and Multiverse repositories as well. Ubuntu leaves that choice completely up to you. Now, when we wanted to see a list of packages available to us, we headed over to packages.ubuntu.com, and a link for that is in the resources section in case you're interested. And we saw all the packages were broken up by our distribution's code name, and you can see the code name for your distribution by entering the lsb_release command with the A option. And we saw that our command name was Artful, but yours might be different depending upon when you downloaded Ubuntu and when you watched this video. Now, all the packages are organized by a theme or sections, and you can see a full list of packages by scrolling down to the bottom of that page and clicking on the appropriate link. And each package tells you what repository it comes from in square brackets next to its name, but if there's no square brackets next to the name, then it comes from the main repository. And when you click on a package, you'll find that you get more information about it, as well as information about other packages that are related to it. Now, some of these packages will be required for that package to run, and these are marked with a red dot and called, the one package is said to depend upon these packages. Some will be recommended packages and required for normal functioning, and these will be indicated by green diamonds. Some will be suggested packages, which are there just for interest and indicated by blue squares, and some will be called enhance, some will enhance the package's functionality in some way, and these will be indicated by black dots. And finally, we discussed that due to the complexity of managing dependencies and ensuring software has the correct version number and so on, software management is usually done using a program called a package manager. Now, package managers differ from distribution to distribution, but on Ubuntu, the package manager is called apt, which stands for Advanced Packaging Tool. So in the next video, you're going to learn how to use the advanced packaging tool to upgrade your system and search for new software. Now, using a package manager is a critical piece of using a GNU Linux system, and luckily it's also super easy. So for incredible superpowers beyond your wildest dreams, I'll see you in the next video. Hello there, you beautiful people. Now, probably one of the most confusing things for new users of a GNU Linux operating system is understanding how to get new software. Now, on other operating systems like Windows or Mac, every time that you want to install a piece of software, you're probably just used to downloading an executable file, opening it, hitting next a load of times, avoiding reading terms and conditions but agreeing anyway, and celebrating internally when your new software is installed. Now, in Linux, it works a bit of a different way. I mean, you still celebrate internally when the software is installed, but you tend to install it in a way that is much more integrated, standardized, secure, and scalable than is possible with the other operating systems. But to get those benefits from using a package manager, we first need to let go of our preconceptions from Windows and Mac and actually get a solid understanding of what is going on in Linux package management, because it's not the same at all. But it is a lot better. So in this video, you're going to learn about how to search for packages using apt by building off our existing knowledge of the software repositories. And we're going to show you how you can search those software repositories using the apt package manager. And you're also going to learn about how the apt package manager uses caching to speed up performance and ensure that you have a fast installation experience. So by the end of this video, you're going to be able to know how to search the software repositories for new packages, and that's going to give you the fundamental understanding that you'll need in order to install them. So let's go ahead and get right into it. Okay, so as of now, we understand that there are a bunch of packages that exist, and that we'll be using a package manager called apt to download and install them. So far, so good. So let's start off by getting the apt program to search for packages. And let's say that we wanted to search for packages that will help us when working with Microsoft Word files. Now, Microsoft Word files have conventionally had the extension .docx, so let's find all the packages that are relevant to the text docx. Okay, so to do that, we would type the command apt-cache, okay, search docx, okay, and when we do that, we see that we get a few results back with one package per line. And we see that for each package, we get the name of the package on the left. So you can see we've got one here called docx2txt, we've got one here called libapache, and so on. And then on the right, we get a short description about that package. So this will turn Microsoft XML files to plain text, and this one is a general markup converter, okay, and it's the libraries for that general markup converter. So you can see at a glance what is available. And for example, if we wanted to search for things to do with text, we could always use grep and search for the word text, and we would get just a few results there. So you can also narrow this down using grep, okay? So it appears here that we may be interested in this one here called docx to txt, okay? So how would we get a bit more information about that? Well, what we could do if we clear the screen is use apt-cache show docx to txt. So instead of apt-cache search and then a keyword, we're going to use apt-cache show and then the package name. And when we enter that, you can see that we get a whole bunch of information about that package. Now, this is exactly the kind of information that's good to pipe through the less command to make it a bit easier to deal with. There we go. So now we can see the package name is docx to txt. It's available for all architectures. It gives you the version number, and it also tells you where it's from. So it's from the universe repository, the text section in there. It tells you the maintainers with their contact information. It tells you where to report any bugs. And it tells you loads of other stuff, but down here there's also a description.
And it says it converts Microsoft OOXML files to plain text, and it gives you more information. Doc.txt is a tool that attempts to generate equivalent ASCII text files from Microsoft docx documents. Okay, and you can read that if you wish. Okay, so you can see by using apt-cache show, we can see plenty of information about the docx to txt package. So that's a really useful ability there. Now let me show you something. So we've done all that with access to the internet, right? So if I click up here, you can see that I've got a connected internet connection. Well, let me try and disconnect my virtual machine from the internet and try that again. So I'm going to turn off my connection, and you can see now I've got no internet connection whatsoever. If I open up Firefox, we'll probably see it tell us that there's no internet connection. If I go to somewhere like, I don't know, let's say youtube.com, it'll tell me that the server's not found, okay, because there's no internet connection, okay? So with that, let's try and do it again, okay? Let's search for the term web server, okay? So if I do apt-cache search, and I want the term web server, because there's two words in here, I'm going to enclose them in quotes here, so they go as one search term rather than two separate search terms. If I didn't have quotes and I did web server, it's as if I search for web on its own and then server on its own, but I want to search for web server together. Okay, so apt-cache search, and you see we get actually a whole bunch of results. So let me clear the screen and pipe that through less to make it a bit easier to handle. But actually, wait a second, isn't that quite strange? How was apt able to search for all these packages without having any internet connection? And there appears to be a package here called Apache 2 that gives us the very popular Apache web server. Okay, so let's try and get more information about that. Okay, so it's called Apache 2. Let's do apt-cache show Apache 2 and pipe that through less just to make it a bit easier to read. And yeah, we managed to get information about that. How strange. We managed to even get detailed information about the package. So how is that possible if we don't have an internet connection? Well, if the information is not stored on the internet and it's not being downloaded from the internet, then it must be stored somewhere on this computer. And it is. So this information is stored in something called a cache. Now, what's a cache? Well, you may have come across the word cache when browsing websites, and when your browser gets a bit slow, so you decide to clear out your browser's cache to speed up performance. But what is a cache exactly? Well, a cache is a kind of storage place for information that's supposed to be efficient and easy to access. To explain this, let me tell you a little story. So let's say that you wanted to keep looking at a certain website, and it was called www.awesomesite.com. Okay? Now, without a cache, every time that you wanted to visit awesomesite.com, your computer would send a request all the way across the internet to a computer known as a web server that holds all the files for www.awesomesite.com. And this web server could potentially be across the other side of the world, and sending messages back and forth can take some time. But let's say that you visit awesomesite.com and your computer sends a message all the way to the web server that happens to be on the other side of the world. After its long journey, your request arrives, and it waits patiently in line behind all of the other requests that have arrived there first. So after dealing with all the other requests and that have come before you in the queue, the web server will ask, "How can I help?" And your request would say, "Can you give me a copy of your homepage, please?" And the web server would reply, "Sure, let me find it for you." It searches around for a little while and then goes, "Here you go," and transmits, bit by bit, a copy of that file all the way back to your computer over the internet across the entire world. Now you can imagine the whole process might take a bit of time, wouldn't it? Now without a cache, the next time that you want to access www.awesomesite.com, the same thing happens all over again. Your request travels to the other side of the world, waits in line, and the file is sent bit by bit all the way back across the world. And this happens again and again and again. Now imagine that it's not just you, but thousands or even millions of people all at the same time requesting awesomesite.com. I mean, it is awesome after all. And if everyone in the world has to do the same process over and over and over again, you can imagine that the web server might start to become a bit overburdened. The queues get really long, there's a backup on the data highway, and your web experience just slows way down. So to fix this problem, that's where a cache comes in. That's where caches come in, okay? So instead of there only being one copy of the file stored on the web server, instead, the very first time your request comes back, it'll keep a copy on the local computer in what's called a cache. Now, the cache is nothing more than a place to store files locally so that you get performance benefits later. Now, the second time that you want to visit awesomesite.com, your computer doesn't need to shoot messages all over the internet. It realizes that awesomesite.com's files are already in your cache, and then it just looks in the cache on your computer locally and loads the page, which is much, much faster. Now, the only issue is that the cache must be kept up to date with what's on the actual web server, otherwise you'll keep viewing an outdated copy of the files. So that's what a cache is. Now that we understand what a cache is, we now understand the reason why the command is called apt cache, okay? And when we run apt cache search, what we're doing is we're telling the apt package manager to look inside the cache for any packages matching the text that you give it. So if we did apt cache search text, it's looking inside its cache for all packages that match the word text. And if we run apt cache show Apache 2, it's going to look for the Apache 2 package in its cache and bring up all the information that it's got about it. So where is this cache then? Well, on Ubuntu, the cache is located at /var/apt/lists. So if we cd into there, let's go ahead and take a look. Okay, /var/apt/ /var/lib/apt/lists. Okay, so now we're in there. If we take a look, we can see there's a whole bunch of different lists in here. Let me just list them out into the less command, and we can see that we've got a whole bunch of files in here that are actually just lists of packages. Now, these are the lists of all the packages available from the repositories that I've enabled on my system, and the lists also cover specific type of packages. Let me clear the screen and let me just maximize it as well and list it out again, but piping it through the less command with the capital N option, and this allows us to have some line numberings, which will make it a bit easier to explain what I'm talking about. So here we are, we've now got each of the lines with some line numberings. Now you can see that there's so many different lists in this folder, okay? Each containing lists of a specific type of package depending upon where it came from and what type of computer architecture it's for. Now, a lot of mine start with the gb.archive.ubuntu.com, okay? Now, that's because my nearest Ubuntu archive server will be in the UK, because I'm based from the UK, okay? And GB is for Great Britain, and because I'm in the UK, that's where it sends its requests, because it's a bit more efficient to send your requests to a server that's closer to you, but yours might be different depending upon where you are in the world, okay? So if you're in the US, it might say something like us.archive.ubuntu.com, and so on. So don't worry about not having GB there. Everything else should be more or less the same, though. Now, on line 3, there's a list of available artful packages, so for the artful codename version of Ubuntu, and you can see that we've got the binary packages, so the pre-compiled packages that are for the AMD 64 computer architecture from the main repository. Okay, and if we take a look on line 15, we can see that we've got, again, for the artful version, we've got the binary pre-compiled packages for the AMD 64 computer architecture, so 64-bit architecture, from the restricted repository, and you can see here we've got some from Multiverse and so on. Okay, so the lists are broken up very specifically by where they came from and what they're for. Okay, now these are not the packages that are installed on my computer, but they are the packages that are available in the software repositories that I've chosen to access. So these aren't lists of packages that I have installed, but they're lists of packages that I could install from the software repositories. Okay, so let's take a quick look at one of these files that edited entry. Okay, so let's say that we want to edit the entry for the GCC package that we downloaded a couple of videos ago. Well, we know that it's going to be in the main repository because it's open source and it's free software, but it's not maintained by the community. So we know that GCC should be in the main repository. We also know that it's pre-compiled and it's therefore a binary package. Okay, we didn't have to download GCC and then compile it. We just installed it straight away in the last few videos, which means it's pre-compiled. So if we look for the list that we see that's for artful main repository with a pre-configured 64-bit binaries. Now let's have a look for that. So we've got artful, and we see let's look for main. Here we are, main binary AMD 64. So it should be in this list. So if I just copy that, okay, and I quit out of this, and I open that up with nano, so I do nano and paste that, if I can. There we go. So now if I press enter, you can see that we've opened the list and we've got a whole bunch of different packages in here, and you can see that this is starting to look like the results from apt-cache show, and that's exactly what happens. Apt-cache show will just search through the files and print out the information regarding that package. So now that we're in this file, why don't we just go ahead and search for the package called GCC. So the way we can find that a bit easier, instead of just searching for GCC, you can notice that the actual package bit starts with the word package, then a colon, then a space, then the actual package name. So let's try and do that for GCC. So we're going to do package, colon, space, GCC. Okay, and if I press enter, we'll see that we've ended up at the GCC package. And you can see that we get all the information about the GCC package that we installed a few minutes ago, okay, in the last video or so, okay, and it comes up. So let's change the priority from saying optional here to saying optional but awesome, okay. So if I save that, like write that file. Oops, it's saying permission denied because this is a special file. We need to open it with sudo. Okay, so let's open it with sudo nano. Where you can do that is just press the up arrow key, then type sudo at the beginning and enter your password. Then we're going to search for package colon GCC. There we are. And instead of having it say optional, we're going to have it say optional but awesome with an exclamation mark, of course. Save the file and exit. Okay, now if we just close the terminal and open it up again, okay, now if we do apt-cache show GCC and maximize the terminal a little bit and pipe that through less, we can see here that it's pulled the information for GCC and now the priority is optional but awesome, which is fantastic, okay? How cool is that? So you can see here that what's actually happening is you've got a cache, a place, a folder on your computer that stores lists that your package manager can search through regardless of whether you've got internet connection or not. And that is located at /var/lib/apt/lists. Okay, so if we go there, it's a massive difficulty to say. If you look in there, you've got all these different lists, each for specific purposes. Okay, and because we wanted to look for the GCC package, we used a little bit of our understanding of repositories to understand that the GCC package would be located in the main repository because it's maintained by Canonical. Because it's so old, you see. You've got it's pre-compiled, it's ready to go, so it's going to be binary, and we are on an AMD 64 computer architecture, so that's the list that we're looking at. So we kind of took this file here, this file name, which is very long, but it's a file name nonetheless, and we took a look at it with nano, and we opened it up, and oops, I need to enter my password. So we opened it up, and we saw that this is where, when you try to show more information about a package, the app package manager gets this information. And we looked for the GCC package, okay, and we found out that this is where it is, and then we edited some of that information to demonstrate that this is exactly where the information is coming from. So if we now look at apt-cache show GCC, we can see that now the information is no longer optional but awesome, but it's just optional. Okay, so now you can see a bit behind the scenes how your package manager is working. So now we understand that for performance benefits, apt saves a cache of all available Ubuntu packages on your local system in the /var/lib/apt/lists directory. Okay, and that's called the apt cache. Okay, that folder is called the apt cache, and by searching the apt cache using apt cache search and then a search term, apt will search all of the lists in that cache, in that folder, for any package names that have something to do with that search term. So it'll search the package name and the package description in all of those lists and return to you the package names with a little snippet, a little description of each package, so that you can look for more information if you want. And you would look for more information using apt-cache show and then the package name that apt-cache search would give you back. And this will show you detailed information about the package, okay? Anything from the size of it to a description to what it does, who the maintainers are, where to report bugs, and everything that you could possibly know about that package. Now, all of this is done using lists that are installed in the cache. So lists are downloaded to the /var/lib/apt/lists folder, and all of those files in there are just lists of packages, and they all have basically the same format, but that's where everything is saved, and it just uses the lists in that folder to produce all this functionality. But this makes us wonder, how did the lists actually get into the cache in the first place? And just like any cache, it must be kept up to date. Otherwise, new packages could be released and you wouldn't know. So how do we keep the cache up to date? Well, you're in luck. These questions and many more will be answered in the next video. Hello there, you beautiful people. So in the last video, I left you with kind of a cliffhanger with some burning questions that we have about how our apt package manager works. How does the cache get there in the first place? And how can we make sure that the cache is kept up to date? Well, these are the questions that we'll be answering in this video. And by the end of this video, you'll know how to update your cache, and you'll also know how to use that cache to upgrade all of the software on your system to the most up-to-date level with one simple command. Now, this is going to be so awesome, and I'm sure that you'll begin to see why package managers are far superior to the simple wizards that you may be used to using. Now, I can't wait to show you this stuff, so let's just go ahead and get right into it. Okay, so how do the lists in the cache actually get there in the first place? Well, these lists are actually downloaded from servers somewhere on the internet, and these servers are maintained by credible sources and contain up-to-date lists of all existing packages. And as we mentioned in the last video, in order for a cache to be functional, the files in the cache must be the same as the files on the server. Now, this is especially important for the software repositories. So think with me about the GNU Linux community for a moment. There are millions of people around the world all contributing to this massive body of software and creating things all the time. And this massive body of people contributing simultaneously to the software repositories and projects means that software changes a lot, and it changes often. Bugs get fixed, security holes get patched, new features get added, documentation gets clarified, and so on and so forth. Now, sometimes programs get developed so much that they require new dependencies in order to work. And in spite of all of these changes, keeping all the software on your system up to date and managing everything yourself manually would just be a complete nightmare, okay? It just wouldn't work. There's too much room for a person to make a mistake and too much stuff to keep track of. But fortunately, you don't have to. The apt package manager has a way of using the cache to make sure that all the software on your system is completely up to date. And here's how it works. So the first thing you need to do is to update your cache. And to do that, you'd run sudo apt-get update. Okay, and that's the command you'd run. Now notice how we need to use the sudo command at the beginning here. Now that's because we're going to make changes to important files on our file system, and we need administrator privileges in order to do so. And instead of apt cache, we're using apt get, because we're going to get data from the repositories. So we'll be getting the updated lists, and update will update the lists in our cache to make sure that the package versions in there are the same as the package versions in the repositories. But of course, in order for this to work, we need to be connected to the internet. So I've re-enabled our internet connection before recording this video. So if you are following along, make sure you re-enable yours too. And if we run that, so sudo apt-get update, it'll ask us to enter our password because we're using the sudo command, so we enter that. And we press enter, and you can see that it's getting loads of different lists from the Ubuntu repositories, and it's downloading them and installing them. Now, it's going to be updating our cache, which might take a various amount of time depending on how long it's been since you've updated, but ours has gone and completed now. So now that we've updated that, our cache will have the most up-to-date package numbers and dependencies for all the packages in our cache. So now that we have an up-to-date cache, what if some of the software on our computer is out of date? How can we upgrade our software to the newest versions that are in the new versions of the package lists? Well, that's actually really easy and quite magical, to be honest. So to upgrade every single piece of software on your system that you installed from the repositories, all you need to do is type, now if I clear the screen, sudo apt-get upgrade. Okay, now this will run through, so if I press enter, this will run through all the package lists and see all the software that we've got on our system, and it will tell us what's out of date and what needs to be updated, and it will also tell you how much needs to be installed and so on, and it asks for our permission to continue. So if I press yes, so this is going to run an through the updated cache and see what packages on your system are behind. It'll then figure out what new dependencies need to be installed and which ones are no longer required, and it'll tell you how much space is required and so before asking your permission to continue. But now that we've given it permission, it will go ahead and start updating every piece of software on the system. So it will download the required packages, unpack them, install them, and remove the old versions all automatically for every single piece of software on the entire system that was installed using the repository. So this is an incredibly powerful automated system, and this is really the beauty of using a package manager. You don't have to go to the website and download manually each new package like you might have to do on Windows or Mac, where you've got to download the new installer or click for updates on each different piece of software. No, all you've got to do is run sudo apt-get upgrade, and everything that was installed through the repositories will be upgraded to the newest version levels, which helps you with security. It helps you with having the most modern features, and it's just absolutely amazing. And also, if you use cron, you can schedule this stuff to happen on a regular basis as well, so that's a useful thing to bear in mind. Now, this might take a varying amount of time depending upon how long it's been since we've upgraded our software, and because I haven't actually done it on this virtual machine, so it will take quite a while. So what I'm going to do is I'm going to cut the video here and come back when it is done. And just like that, in 2 commands, all the software on our system has been upgraded, and we can actually see that the Firefox logo has been updated to look a whole lot more epic. So notice how the system also didn't need to reboot. All the software that we've installed through the repositories has been upgraded and it's ready to go. So all we had to do was update the package list using sudo apt-get update. And then once we'd updated it, all we had to do was sudo apt-get upgrade, and then we upgraded all of the software to the new versions. So do note that sometimes, though, you will need to reboot your system when you do these updates, but this is kind of unusual, but sometimes it will need to happen. But it's important to note that you should always update your cache before you perform an upgrade, and this makes sure that the upgrade occurs using the correct software versions and everything is updated uniformly. So to update your cache, you run sudo apt-get update, and what this will do is it will download the most updated versions of the package lists from the Ubuntu servers into your cache that is stored on your computer. So in order to do that, you need to have an internet connection. But once you've updated your cache by downloading the most updated package lists, you can upgrade all of the software on your system using sudo apt-get upgrade. And what this will do is it'll make the package manager look at all the software that is currently on your system and compare it to what is available in the package lists, and then the package manager will automatically download and upgrade all the different packages that can be downloaded in order to update your system to the most up-to-date level. So this will download any new versions of packages, it will remove old versions, it'll download any new required dependencies, and this just helps, increase your system security. It helps give you maximum functionality, and it's all round just fantastic. But something that you need to bear in mind is that you need to update the cache before you upgrade, because otherwise you'll be upgrading all your software to not the most up-to-date versions, and you want to be able to update your software to the most up-to-date versions. And in order to do that, you need to have up-to-date package lists. So to update those lists, you update your cache, and then when you've updated your cache, you can upgrade your software. So bear that in mind. Always update your cache before you upgrade your software. And another important thing to bear in mind here is that you can only upgrade software that was installed through the repositories. Okay. Now it is possible on a GNU Linux system, like we did in the previous videos where we modified the ls command, that you can download packages manually, extract them, and compile them and install them yourself. But because that process doesn't happen through the repositories and package manager, you lose the ability to keep them up to date like we are doing here. So therefore, if you can download a package from a website and you can also get it from the Ubuntu repositories, make sure to get it from the repositories, because then you can make sure that it's up to date and make sure you always have the best features available using this automated process. So as of now, we've discussed how to search for software, how to update caches, and how to upgrade software, but we haven't discussed how to actually install new software. Well, with all the understanding that you have now, that's actually going to be really easy for you, so I'll save that little gem for the next video. So in the last few videos, we've been learning a whole lot about our package manager and how it works. And we learned about the cache and what it's for, and we've learned about how to update the cache and how to upgrade all of the software on our system to the newest versions using the package manager, which is all super awesome stuff. But how can we install new packages? That's what we want to know. Well, with the background that you've gained from the previous videos, installing will now be really easy to understand and not just something that you have to memorize. And by the end of this video, you will know how to install new software from the command line. So let's go ahead and jump right into it. Okay, so now that we know that our cache and system are fully up to date, let's go ahead and install some new software. So let's say that I've heard of a program called X-Eyes, and X-Eyes apparently makes a window with some funny eyes pop up that follow your mouse cursor around the screen, and I think this is interesting and I want to install it. So to do that, first we need to know what package the X-Eyes program comes in. So let's search the cache for it. The way that we do that is we do apt cache search for X-Eyes. and it will give us every package that has something to do with XIs. And we've heard of this package called X11 apps, let's say, and we're like, that's the one I've heard of. Let me go and have a closer look at it. So what we do apt cache show X11 apps. Okay, so you give it the name of the package here, and that'll give us a bunch of information. But let's just clear the screen and pipe that through less so we get a bit of a closer look. Okay, and when we open this here, we can see that actually we get a lot of information about the package, but down here in the description, it says that this package provides a miscellaneous assortment of X applications that ship with the X Windows system, including, and it will tell us that we've got tools for manipulating bitmap images, something for a tool that tells you when you have new email, and so on. And then there's one here called XIs, and XIs is a demo program in which a pair of eyes track the pointer. So that's what we want, and we realize that actually we want to have a look at this. There's also another one called Xman, which is a manual page browser, which might be useful as well. Okay, so now we're pretty convinced we want to install the X11 apps package. How can we do that? Well, it's actually really easy. All we've got to do, if we get out of less, is just, when we clear the screen, all we have to do is type sudo apt-get install X11 apps. So we just enter the name of the package. Now, notice that we're using apt-get again, to install the package, because we want our package manager to get data from the internet and not just from the local cache. And we also pass the package name that we want to install, and because we want to install X11 apps, we typed X11 apps in there. Then when we press enter, we see that it'll ask for our password, which we enter, and then the package manager is going to go ahead and install the new packages with any dependencies that are actually required. Now, sometimes it might ask for your permission if it needs to install a lot, but because it's only installing about 600 kilobytes, it was like, yeah, let me just go ahead and install it. I don't need to ask for permission for something that's so small, okay? But now there's nothing we need to do. The package is installed, and it's as simple as that. Now, X11 apps is a pre-compiled package, also known as a binary package. Now, most packages are binary packages, which means that the code that make the software has been pre-compiled and ready to go beforehand, so you don't have to do any of that configure, make, and make install stuff that we did a few videos ago yourself. Okay, just install the package from the repositories and you're done. And what's better, the package will also be tracked for updates, so that you can update the package if new updates are made available. How awesome is that? Now let's try out our new software. So we wanted to use the XIs program. So if we just clear the screen and type XIs in there and press enter, we'll see that we get these funny googly eyes pop up on the screen that follow our mouse around. So if I put the mouse down here, oh, where's it gone? I scared away the eyes. If I pop him up here, then it'll follow around. Probably not as fluidly as I'd like, but I'm going to put that down to us running this in a virtual machine. But if, it does follow it a whole lot nicer. But that's pretty cool, right? Now, the awesome thing is the way that you everything that you install will come with its own man page. So if I just close XIs here, then if I do man XIs, you'll see that it's actually now also got a manual page installed, and it says a follow the mouse X demo, and it's also got some options, so you can even control the XIs program from the command line. And we can see here that there is an option here called center, which allows you to choose a different color for the center of the eyes. So let's, for example, if we do XIs, then give it the center option and tell it, I think it's 2 dashes, center blue. Oops, no, maybe just one dash. There we go. Now the center of the eyes is blue. But what I want you to notice here is the way that, look, when you open the XIs program graphically, you don't have the option to change the color of the eyes, right? But from the command line, you can change that and a whole lot more. So this is highlighting for you just how powerful the command line is and how it does give you more abilities than is possible with a graphical editor. And if you can't edit the colour of googly eyes, then tell me, what really is the point of having a computer? Now, the X11 apps package came with quite a few other pieces of software inside, one of which is called Xman, which you might find useful. Now, Xman is a graphical window for looking at the manual pages. So if we get rid of XIs here and close it, and then we type Xman, we'll see a window pop up over here. Now, you can search the man pages using this. So if we click on manual page right there, it'll open up a bigger window. And if we click on the options at the top here, if we hold down the mouse button, it shows the menu. So you need to hold down the mouse button and you'll see this drop down menu. Then if you go on search and let go of the mouse, that's as if we've clicked the search thing. And now we can search for something in here. So this is, for example, if we take a look at LS and we try to look at it as a manual page, then it'll open up the LS manual page and you can browse through it here. So this is a more, I guess, graphical way of taking a look at the manual pages than you do with the command line. But, you know, I guess it just makes it look a bit prettier. And you can also look at the sections. So you can look in user commands and you can see all of the user commands here. And if I wanted to look at, let's say, the address to line command, I just click on that and it will open up. So it's a nice graphical way of browsing through the manual. So that's something that you can play around with if you like. And one thing I also want to highlight is how by installing one package, the X11 apps package, we've actually installed multiple different pieces of software, which is super cool. And we didn't have to do any compiling, we didn't have to do any configuring. All we had to do was make sure that our package list was up to date using sudo apt-get update, and then all we had to do then was just sudo apt-get install and then a package name, and that's it. We can rest assured that we've got the most up-to-date version of that package, and it's all sorted. We didn't even have to find out if the package was suitable for our computer's architecture and decide between, you know, i386 or AMD 64. That was all catered for automatically, which is awesome. But all of the software in that package was pre-compiled. So what if we wanted to utilize the freedoms that free software gives us and access the source code for a package and modify it? Well, accessing the source code from the repositories is also very easy, but there are a few edits that you need to make. So for all that freedom goodness, I'll see you in the next video. Hello there, you beautiful people, and welcome to this video where we're going to be talking about how you can download the source code for packages. So at the minute, all we've been able to do is download and install pre-compiled binary packages, but we're interested in how we might be able to go about getting source code so that we can exercise the freedoms that free software gives us. And it's actually a very easy process in order to do. So all you've got to do is, as an administrator, so with the sudo command, open up in nano the /etc/apt/sources.list file. Okay, now in here, when you enter your password, you're going to be opening up a configuration file that your package manager uses to determine which repositories and which package files it downloads. In other words, which sources it downloads. Okay, so what we're going to do in here is you'll notice that there are lines that start with deb source or deb-src, and those lines have a hash in front of them. What I want you to do is I want you to just delete all those hashes on those appropriate lines. And what this will do is it will activate the ability for your package manager to be able to download source code, which is deactivated by default just to save efficiency, basically. So there we are. I've gone ahead and done that. I'm going to press Ctrl and O to save the file, and press Ctrl and X to exit. So now what we've done is we've said to the package manager, hey, why don't you go ahead and download the package lists that contain source code, okay? But to be able to get those things in the cache, we've got to update our cache, okay? So all we've got to do now is do sudo apt-get update, and it's going to go ahead and start downloading all the source packages here. So you can see that this is installing all the source packages into our cache. This is a very useful thing because now we're almost ready to be able to download source code. Okay, so before we can download source code, we need to install one more package, which is so if we do sudo apt-get install, it's going to be the dpackage-dev package. So dpkg-dev, you install that, you type yes when it asks you, and there we are. We've managed to now, it's going to go ahead and download and unpack that package. And now we can go ahead and install source code. It's literally that simple. Okay, so we've been messing around with the xeyes package. Let me head over to the desktop, and we've been messing around with the xeyes package. So how can we get the source code for the xeyes package or the xeyes program? Well, it's contained in the X11 apps package. So if we do sudo apt-get, and we used to do install, right? We used to do install X11 apps, right? And that's how you'd get the pre-compiled binary version. But if you want to get the source code, instead of install, just put source. And you'll see that it goes ahead and downloads these packages that contain source code. Now, we can actually go ahead and enter these using cd. So if we cd into the package and take a look around, we can see that there's a folder here for xeyes. And if we take a look in xeyes, so cd xeyes, we'll be able to see in here that we've got the source code for the xeyes program. So you can see we've got our configure file that we can use to configure our GNU-C compiler, but what we're interested in right now is this xeyes.c, which is actually the source code for the excise program, and we can take a look in here and read the source code for the excise program. It's literally that simple, okay? All we had to do was go ahead and change our /etc/apt/sources.list file, and in here just uncomment all the lines that had a hash in front of them for deb source, and those are the repositories that allow you to actually download source code. So if you uncomment all of those and then update your cache using sudo apt-get update, then once you've downloaded all the new lists, all you've got to do is install the dpkg dev package, and then you're good to go. From now on, if you ever want to download any source code, all you've got to do is sudo apt-get source and then a package name. Okay, and that is all you need to know in order to be able to download and play around with source code. But one thing that you should bear in mind is that if you go into these source code packages and you actually compile them, you'll lose the ability, and install them that way, you'll lose the ability to keep them updated with your package manager. So therefore, if you have the choice to install a package through the package manager or install it from source, make sure that you install it through the package manager and through the repositories rather than compiling it yourself. But this is a really cool way to be able to go ahead and take a look at how code works and maybe incorporate it in your projects. Hello there, you beautiful people. Now, as you know, there are two sides to every coin. And now that you've learned how to install packages to your system, in this video, we're going to be covering how you can uninstall packages from your system and make sure that your system is squeaky clean. So let's just go ahead and get right into it. Okay, so in the last few videos, we've been messing around with the X11 apps package, and we're going to continue using that as kind of our guinea pig for this video. So to uninstall a package in Ubuntu, the most basic way to do it is to type sudo apt-get remove and then the package name. Okay, so because we're talking about the X11 apps package, we just type sudo apt-get remove and then X11 apps, and that would remove it. But that's not the preferred way to do it, okay? And the reason is when you install packages, there are sometimes configuration files that come along with the packages. And if you just remove the package using sudo apt-get remove, then the configuration files are left behind on your system, taking up space and not being helpful. Now, this can be useful if you want to install the package again in the future and want all your settings to be the same, but it's still not really the preferred way to do it. Instead, to remove a package and all of its configuration files, what we do is instead of typing sudo apt-get remove, we type sudo apt-get purge and then the package name. Okay, so sudo apt-get purge X11 apps. Now, the purge will remove the package and its configuration files. So always use purge whenever you want to uninstall a package. So if I go ahead and do that, it's going to go and say, hey, I want to remove this, is that okay? I press yes, and it will go through and remove X11 apps and any of its configuration files. So you can see here it says purging configuration files for X11 apps. Okay, so it's gone ahead and done that. Now, that will have the X11 apps package 100% removed from the system. But sometimes when you install packages, you need to install like 10 other different packages as dependencies, okay? So you need, in order to get the package that you want to install to work, you need like 10 other packages or maybe even 100 other packages in order to get that one package to work. And we call those extra packages dependencies. So what if those dependencies are no longer required, but you don't know what they're called? How can you remove them? Well, you're in luck. In order to remove packages that were installed as dependencies but are no longer required for any other package on the system, you can just do sudo, if I clear the screen, sudo apt-get auto remove, and that's it. So sudo apt-get auto remove. Now, auto remove will automatically remove any dangling dependencies that are no longer required, which helps you save space on your system. So if I do that, it's going to tell me there's actually not any that need to be removed, but you can save a lot of space in this. So bear in mind, this is all happening across hundreds or even thousands of different packages on your system, and having the package manager keep everything in order automatically is a really great asset. I'm sure you'd agree. It beats it doing it yourself anyway. Now, whenever you download and install a package, a copy of the package is saved locally on your computer. Now, this package is then unpacked and installed on your system. So that's how it works. When you install a package, it downloads itself as a compressed archive, then unpacks itself and installs itself on your system, okay? Now, because of that two-step process, not only is a package installed on your system, but a compressed version of it is also saved. Now, these compressed files usually take up space and aren't really necessary if you already have the package installed, because they're just, an archive. They're like the wrapper that comes with the stuff, okay? So you can actually save yourself massive amounts of space, sometimes even gigabytes of space, just by deleting these archives, okay? Now, these archives are stored at, if we go there, /var/cache/apt/archive. archives. So if we go there and take a look, we can see there's quite a few little deb files here, some compressed archives saved in there, and you can see the one for X11 apps, even though we've actually removed it from the system. And you can see how large these are by doing ls with the lh command, and you can see that there's a total of about 10 megabytes in there. Now that's not much, but you know, this can easily grow to gigabytes after you keep installing packages on your system. It can get quite mad because every package you install comes with its own dependencies, and even those dependencies are saved as copies, so you can really save a lot of space by removing the stuff from here. Now you don't have to even be in the folder to remove them. So if I just head back to our home directory, as you can see we're in our home directory, if we run sudo apt get clean, that will delete all of the packages from that directory. So if we head back up into the /var/cache/apt/archives and do an ls, we can see that now they've all been deleted, even though we weren't in that folder. So if you want to get rid of all that stuff, do sudo apt get clean. But sometimes you don't want to delete all of those for whatever reason, and you only want to get rid of the stuff. You want to get rid of those packages, those archives, but the ones for packages that can no longer be accessed from the actual Ubuntu repositories. Now this is usually for systems that are very old and want to keep their cache going for years and years and years, and every now and then just, you know, trim the leaves and get rid of their deb packages that can no longer be downloaded for whatever reason. And to do that, instead of using sudo apt get clean, you'd use auto clean. Now, as just to highlight, clean gets rid of everything of those in the archive cache. Now that's different from the list cache, by the way. This is just a storage space for saved archives and packages and stuff. So this is a completely different cache. But clean will remove everything in there, and auto clean will check what's in there and only delete the ones that you can no longer download from the repositories to make sure you don't have stuff in there that you'll never use again. So there you have it, a no-nonsense guide to uninstalling packages. So let's review, okay? We discussed that the most basic way to review packages is to use sudo apt get remove and then the package name. But this is not recommended because it leaves behind configuration files. Instead, use sudo apt get purge and then the package name, okay? Now, when you install a package, it's likely that other dependency packages were also installed in order to make that package work. And in order to get rid of those dependencies and automatically remove them from the system, as long as they're no longer required, you would use sudo apt get auto remove to remove any unwanted and any unneeded dependencies, okay? And just because they were used for one package and you've removed that package doesn't mean they're no longer needed for another. But don't worry about that. The package manager is going to take care of all that for you, okay? And you also learned that when a software package is installed, it is first downloaded and saved on your system in a compressed archive. Now, this archive is saved on your system even after the package is installed, and that means it's taking up space. It's kind of like the wrapper or the packaging behind the actual thing that you want, okay? So to clean up all the packaging and clean up all that stuff, what you've got to do is sudo apt get clean, and that's going to delete all the compressed package archives and save you a heck of a lot of space. You'd be surprised sometimes, even gigabytes at times. But perhaps you don't want to clean up all of those packages for some reason, and instead you just want to clean up the ones that can no longer be downloaded from the Ubuntu repositories. So for that, you'd use sudo apt get auto clean. Okay, so there you have it, you beautiful people. You now know everything that you will ever need to know about package management in Ubuntu. And you've done so unbelievably well that in the next video, I would like to congratulate you and have a recap of what we've learned. So for some well-deserved praises and a recap, I'll see you in the next video.
Hello there, you beautiful people, and a massive congratulations from me for making it through this section of the course on managing software with your package manager. Now, I know it was a tough one with loads of new concepts for you to have to digest, but you got there anyway, and in fact, we covered so many concepts in this section of the course that I wanted to take the time to have a quick recap of what we covered and to give you some wholehearted and well-deserved praise for making it this far. So congratulations and well done. I don't know of any other course or resource on the internet that covers these concepts in that much detail, so you should be very proud of yourself for digesting it and making it all the way through. Massive congratulations. So let's have a quick recap of what we covered in this section of the course. So first we started off by discussing the GNU project and free software in general, and you learned about the history of the GNU project that was started by Richard Stallman in 1983. Now, the GNU project started with the aim of creating an operating system based upon giving users freedom to control how the software was used and how it functioned. And you learned about the 4 freedoms that free software gives you, and you learned that a prerequisite requirement for those freedoms is to have access to the source code of the software. Now, because this software is openly accessible, such software is called open source software. Okay. Now, when we headed over, we headed over to the GNU website and downloaded, modified, and compiled our very own version of the ls command, so that it said, "Hello there, you beautiful people," whenever it was run. And in that process, you saw how to configure the GNU C compiler using the make command, and you saw how to compile code and install it on your system. But this was a rather tedious process, and so we next introduced to you how to use package managers and software repositories. Now, Ubuntu and many other distributions have thousands and thousands of software packages available for you to download and try out. And on Ubuntu, these packages are stored in 4 repositories that help keep software separated based upon the different freedoms and levels of reliability they give to the user. So the main repository is maintained by Canonical, which is the company that makes Ubuntu, and therefore the main repository should be your first port of call. The Universe repository contains free software that is maintained by the community, and then you've got the restricted repository, which contains software for device drivers, and then you've got the Multiverse repository, which contains software restricted by legal and copyright issues. So we then headed over to packages.ubuntu.com and browsed through the packages that are available to us. We saw that there are thousands and thousands of packages that can each have different dependencies, they can have different recommendations, they can have different version numbers, and so on. And you realize that this would be an absolute nightmare to try and organize all manually, and that's where you learned about the benefit of Ubuntu's package manager that will do all of that for us. Now, pretty much every Linux distribution has a package manager, but the one on Ubuntu is called apt, which stands for Advanced Packaging Tool. So APT for Advanced Packaging Tool. Now, we then started to look at how the package manager works. We saw that it downloads lists of available packages into the cache on your system. And you can search this cache for packages relevant to a search term using apt cache search, and show more information about a given package using apt cache show. Now, the most important thing about having a cache is making sure that it's always up to date, and you learned how to update the cache using sudo apt-get update. And one amazing thing about the package manager is their ability to make sure that all the software on your system is completely up to date in one go. Now, to do this, you use sudo apt-get upgrade. But remember that you should always make sure that the package lists in your cache are up to date first using sudo apt-get update before upgrading packages to the new version numbers using sudo apt-get upgrade. However, in order to be able to keep a package up to date, it needs to be installed through the package manager and not compiled from source. So do bear that in mind and try to install packages from the software repositories wherever possible. Which is actually the next topic that we came on to, installing. You saw that you can install new packages on your system using sudo apt-get install, and the packages come pre-compiled and ready to go. You don't even need to reboot your system, okay? It's all ready to go as soon as you install it. And we installed the X11 apps package, which gave us the fun Xeyes package to play around with, and we saw so many other applications such as Xman, which is a graphical way of browsing the manual pages. But because the packages installed via the package manager are pre-compiled, that means we need another way to take a look at the source code, right? So then we discussed about how the Ubuntu archives are structured and how to configure our sources.list file to allow us to actually download source code. We then downloaded the source code for the X11 apps package and took a look at the code for the Xeyes program. So we saw behind the scenes, and this code can be compiled and installed in the same way as the code we downloaded from the GNU website. But remember that code that's compiled and installed manually loses its ability to be kept up to date with the package managers. Oh, and by the way, everything that is on the GNU website is also in the software repositories, so you can just use the repositories going forward. And finally, we saw how to uninstall packages using the package manager. To remove a package, the best method is the sudo apt-get purge, because that removes any configuration files that came with the package that might just stay behind and clog up your hard drive. So sudo apt-get purge to remove packages. And when you install a package, it often comes with some dependencies that might no longer be needed when you uninstall that package. So to get rid of any dangling dependencies, you can use sudo apt-get auto remove. So you also learned that when a package is installed, its .deb file is saved locally on the computer. And if a lot of these .deb files build up, they can really take up a lot of space. So to remove all of these .deb files, you simply run sudo apt-get clean. Now you may not want to remove them all, but instead just remove the ones that are no longer accessible from the repositories. So to do that, run sudo apt-get auto clean. Okay, now with that, you now have a solid understanding of what open source and free software is all about, where it came from, how to search for it, how to install it, how to manage it, and how to uninstall it on your GNU Linux computer. So remember that each of these pieces of software comes with its own man page for you to read and learn about the packages as well. So you've got complete freedom. Now I've put a cheat sheet in the resources section for this video that lays out each of the commands and useful files and folders on the system that we've covered in this section, so that you can refer to that when you're working with packages if you ever need a bit of a refresher. But in all honesty, you have come so far in this section of the course, and I am so unbelievably proud of you. There is a whole massive world of software out there for you to explore, and if you can think of it, it's probably in the repositories. So go and have an explore. Why not head over to packages.ubuntu.com and have a search around and see, install some stuff and try it out. Now, unfortunately, all good things must come to an end, and the time has come that we need to wrap up the course. So to say goodbye, I'll see you in the next video. Hello there, you beautiful people, and congratulations for making it through the course. So our journey together has taken you right from learning how to open the terminal and run commands all the way to creating file archives, writing automated bash scripts, and managing thousands of pieces of software using the package manager. So you truly have come an incredibly long way, and I'm incredibly proud of you. Well done. And I just wanted to shoot this video to say thank you very much for coming along with me on this journey through the Linux command line, and I hope that you've received some benefit from our journey together. And I wish you the very best in the future, and if you do want to learn more, do take a look at some of my other courses and keep an eye out for information about more advanced courses to take your learning to the next level. And in fact, I'll be putting special discount coupon links for you in the resources section for this video or somewhere around here for all my courses, just to say thank you for being a student. So go ahead and enroll in whatever you like. Now, if there's something in particular that you would like to learn or another course that you would like me to create, I always listen to suggestions, so send me a message and I'll do whatever I can to make that happen. And if you finish the course 100%, you should soon receive a certificate of completion from Udemy by email for you to print off and put on your LinkedIn profile, or to show proudly to the world that you are now a Linux master. And if you do have any troubles getting the certificate through, do contact the Udemy support team on support@udemy.com and they'll sort it all out for you. And other than that, I wish you the absolute best, and you have my utmost respect and gratitude for trying to invest in your learning. So good luck with everything, and I hope to have the pleasure of teaching you again soon. Hello there, you beautiful people, and welcome to this video where we're going to be getting you set up with VirtualBox on your computer. Now, VirtualBox is an amazing piece of software that allows you to run what are called virtual machines on your computer. Now, virtual machines, other than having a totally awesome sounding name, allow you to run virtual computers inside your computer without affecting your actual computer. So they are perfect for running things like new operating systems and trying them out without affecting the way that your current computer works. So running a virtual machine through VirtualBox is going to create the perfect playground for us to try out the Linux operating system without us affecting the way that your actual computer works, so nothing can actually go wrong. So it's the perfect playground for us to try out stuff with. So what I want you to do is I want you to head over to the VirtualBox website, which is www.virtualbox.org/wiki/downloads. I've put a link in the resources section for this video, or you could just head over to your favorite search engine and just search for VirtualBox download, and it will likely be the first link that comes up. And when you click it, you'll come to a page like this. Okay. Now here you'll find some links to some specific executable installer files that I want you to download. Okay. So if you're on Windows, I want you to click Windows hosts. If you're on Mac, I want you to click OS 10 hosts. Okay. And if you're already on Linux, you basically don't need to install Linux, do you? So you can just skip this entire section and move on to actual learning stuff. But here we are. If you're on Windows, click Windows. If you're on Mac, click OS 10. But I'm on Windows, so I'm going to click that, and it's going to download and install a file here. Okay. Now what I'm going to do is I'm going to just save that in my downloads folder, but you can save that wherever is best for you. But I'm going to save that in my downloads folder, and it's going to download an installer that's going to install VirtualBox for us. Okay. So when that's gone ahead and downloaded, which should be in just about 2 seconds or so. There we are. It's downloaded. I'm going to click that, or head over to my downloads folder and double click that however I wish. So I could double click that. It's going to be the same thing. And it's going to open up this installer wizard, which we're just going to basically power through, guys. So I'm just going to click next here.
going to click next again, and then it'll ask you, where do you want to put some shortcuts? I'm just going to have a shortcut in my start menu and on the desktop, but I don't really want one in the quick launch bar. But make sure you have this one here. Make sure whatever you choose, just don't uncheck register file associations. Just leave that with a tick. Okay, that must stay the same, but you play around with the others depending on how you want your system set up. Where do you want the shortcuts? It doesn't really matter. You can remove them anyway, but your preference. Then go ahead and click next. It's going to say, hey, we might need to access your network interface. Just say yes, don't worry about that whatsoever, and click install. It might give other pop-ups. Go ahead and click yes to any pop-ups that come up, or click install, or just give it permission. Whatever it needs, just go ahead and do it. It's just going to be giving VirtualBox the ability to have your virtual machines access the internet, which is usually a useful function. So just click yes to whatever it asks for, and then it will come to the installation complete screen. And there'll be a tick box here that says start VirtualBox after installation. Make sure that that has a tick in it, and click finish. And it will go ahead and open up VirtualBox. So there you are, guys. That's how you go ahead and install VirtualBox. Nice and easy. Click, 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 click process. So now that we've gone ahead and installed VirtualBox, in the next video, I'm going to be showing you how you can set up your own Linux virtual machine. So thanks for watching this video, guys. You've now got VirtualBox installed on your machine. Let's go ahead and set you up with Linux. Hello there, you beautiful people, and welcome to this video where we're going to be getting you set up with your very own Linux virtual machine running a specific flavor of Linux called Ubuntu. So flavors of Linux are called distributions in the Linux lingo, and we're going to be getting you set up with the Ubuntu distribution of Linux for your VirtualBox virtual machines. So what I want you to do is I want you to head over to www.ubuntu.com/download/desktop. I will be putting a link in the resources section for this video, or you could just head over to your favorite search engine and search for Ubuntu download, and it'll be the first link that comes up. And when you click on it, you'll find a page that looks like this. Now what I want you to do is going to give you multiple options of what version of Ubuntu you want to download, but I want you to click on the most up-to-date option. So for example, here I've got Ubuntu 17.10. Now an interesting thing, you can actually tell when the Ubuntu releases were released by just looking at the version numbers. So here I can tell that it was released in 2017 in the 10th month, which would be October. But up here, for example, I can see that this was released in 2016 in the 4th month, which is going to be April. So the more up-to-date version numbers mean they were released later on. Okay, so what we're going to do is we're going to click well, I am anyway. I'm going to click on Ubuntu 17.10, but you just click on whatever is most up-to-date for you. It will not affect your experience of the course. The entire course will be the same for you regardless whatever version you pick, but you may as well have the most up-to-date version. So I'm going to click download, and it's going to open up another page where it's going to ask me for a few donations, but I'm going to say, unfortunately, that I'm not going to donate any money here today, and I'm just going to be taken to the download, but you feel free to do whatever you want to do. Okay, and then it's going to start to download what's called a disk image file to my computer. Now I'm going to save it in the downloads folder for myself. You can download it wherever you want, and you'll notice that a download starts to begin. Now these ISO files usually tend to be quite large, usually on the order of gigabytes. So you can see here that this is 1.4 gigabytes in size. So this might take quite a while depending on how quick your internet is. Now I'm going to have to wait for that to go ahead and download. So what I'm going to do is I'm going to cut the video here, and I'm going to come back when it has downloaded. So just be patient with this. You won't ever have to really do it again. So once it's done, it's done. So just wait for that thing to download and then unpause the video to follow through with the rest of the setup. Okay, so the download has gone and completed, and now I can go ahead and install the virtual machine. So you can see that we've got this disk image file saved in my downloads folder, and with that there, we're going to go ahead and open up VirtualBox. Now with VirtualBox, this is where you can set up virtual machines to run, and you can have more than one. So we're just going to create a new virtual machine. I'm going to call it Ubuntu because I am imaginative, and call it, and you can see it's found the type, which is Linux, and Ubuntu 64-bit, which is what my one was. If yours was a 32-bit download, then go ahead and click Ubuntu 32-bit, but I think by default it should be a 64-bit, so I'll leave it at that. Now I'm going to hit next, and it's going to ask me for the amount of memory or RAM in megabytes to be allocated to the virtual machine. Now an important thing to notice here, that this is only allocated when the virtual machine is running. When you close the virtual machine, it will be given back to the host computer. So don't worry about this too much. Just give it a generous amount. So let's say up to about 3/4 or 80% of the green distance. You don't want to go all the way up to here because this might make your system stutter a bit and jitter a bit. So just take it most of the way up to the green, to the end of the green, but not all the way. So leave some buffer room there, okay? So I'm going to leave it at that. Just do it by eye. This isn't a perfect science. Just go ahead and do it by eye. Then it's going to ask you about a hard disk. Now, what you've got to imagine is that this virtual machine thinks that it's a computer, okay? And a computer needs a hard drive space, okay? So what we're doing is we're creating an imaginary hard drive that this virtual machine is going to think is a real hard drive, but it's actually just a file saved on our actual computer, okay? So what we're going to do is we're going to create a virtual hard disk now. So let's create it. And it says, what type do you want it to be? Just leave it as the first option, a virtual box disk image. Leave it just like that. And then it's going to say, do you want the file data to be dynamically allocated or fixed size? Dynamically allocated means that when the data fills up on that imaginary hard drive, the file will get bigger. Fixed size means that the file will be that size no matter what, even if it's basically empty. Now, for efficiency's sake, let's just have it dynamically allocated, and then you can call it whatever you want and store it wherever you want by clicking this arrow here to change where you want to save it, but just leave it as the default if you're not particularly fussed. And it doesn't really matter massively how much size you give it. I tend to just give mine 20 gigabytes. That's usually more than enough, but you can just choose what's all right for you. It's as long as you've got something above 1 or 2 gigabytes, you should be absolutely fine. So I'm just going to have 20 gigabytes there as an imaginary hard disk, and I'm going to click create. Okay, so we're almost there now. We're very, very close. All we've got to do is click on settings to set up a few more things. So to make sure that our virtual machine has just a bit more power, what we're going to do is we're going to click on settings, go to system, and click processor, the processor tab, and increase this to 2 cores if you have them. So 2 processors, or up to the end of the green here. So what I'm going to do, that just basically allows the virtual machine to just have that bit more performance. Okay, and everything else should be the same, except when you click on storage, there's one final thing to do. So on storage, this is where we're going to basically insert that disk image, so that you can imagine the imaginary computer booting from that Ubuntu image into a real computer. Okay, it's a bit confusing, but just follow with me. Just click on storage, then you'll see this bit here where it says controller IDE, and it will have a disk that says empty. Okay, so click that, then click on this disk at the top right, click that, and it'll say choose virtual optical disk file. So let's click that. Then we'll go to my downloads folder and click our Ubuntu 17.10 disk image that we downloaded, or whatever disk image version that you downloaded, your Ubuntu version. Click open, and now that's all set up. Click OK, and we're basically all good to go. So that's all set up ready to go, and in the next video we're going to run you through the final bit of the installation, which is setting up the actual Ubuntu machine when it boots up. So for all that goodness, I'll see you in the next video. Hello there, you beautiful people, and welcome to this video where we're going to be doing the final step of setting up your Ubuntu installation inside the virtual machine. Now, I should say that if you do get any errors in this process, like, it says the virtual machine crashes, just go over here in VirtualBox, click on Settings, System, and drag this bar a bit lower down into the green, okay? Just to give your host computer just that bit more memory in case it needs it, okay? So that's just in case that happens, but don't worry if it does. Nothing's gone wrong. Just close it, reduce that bar down to the green, and then try again, okay? But what we're going to do now is we're going to open in VirtualBox, we're going to click Start on our Ubuntu virtual machine, and what this is going to do is it's going to open up an imaginary computer inside our computer. So this is super awesome, and this is the actual process that you would have to go through if you wanted to install Ubuntu for real as the only operating system on an actual computer. So what's opening up now is called a virtual machine. It's an imaginary computer inside our computer that thinks you're installing an operating system on it, because we're booting from that live CD, okay? So or that imaginary disk file that we downloaded in the last video. So what we're going to have to do now is we're just going to have to install Ubuntu on this imaginary computer, and it's a really easy process. As you can see, it's opened up now, and it's going to give us two options. It's going to say try Ubuntu or install Ubuntu. I'm going to go ahead and what I want you to do is click install Ubuntu, but make sure you pick whatever language you would like from the side here. I'm just going to keep it with English, and then click install Ubuntu. Okay, so with that, it's going to give you some extra options here. Tick both of these boxes. This one is going to allow it to download some updates while installing Ubuntu, and this is going to install third-party software such as Wi-Fi hardware, MP3 players, and other stuff, just to make your experience a bit more complete and make your virtual machine just have a few more features than it would otherwise. So go ahead and tick both those boxes, and then click continue. And then it's going to give us some other options to play with on the next screen. This bit's taking a little bit of time. There we go. It's saying the computer currently has detected no operating systems. What would you like to do? Well, just have erase disk and install Ubuntu. Go ahead and click install now. It's going to say, do you want to write the changes? Just click continue. That's perfectly fine. And now it's going to ask you, whereabout in the world are you? Now, this is just for time zone purposes, and you can click on different areas depending on what you might where you might be. If you've got the US over here, but I'm in the UK, so I'm just going to click there, and it's going to. And actually, I want to have London as my time zone. So there we are. It says London, and I'm going to click continue. And now it's going to ask you for your keyboard layout. Mine's English UK, so I'm gonna click English UK, and that's going to be fine for me. But you can actually, if I just go back, you can test your keyboard layout by clicking Detect Keyboard Layout and typing one of these keys. So if I press Y in there, and then another one, and then is that present? No, it's not. It'll figure out for me which keyboard I should be using, and then it will help me out. Pick it like that, but I can just also select it from the list. It's up to you. English UK is fine for me. You just go ahead and pick whatever's good for you, then click continue. And then it's asking you for your username. So I'm going to put Ziad as my username. It's going to ask me for a computer name. It can automatically generate that, but I'm going to call mine VB for virtual box. Picking a username, Ziad, and then it's going to ask me for a password. So I'm going to enter a password. It says it's a weak password. Don't judge me, Ubuntu. It's a fantastic password. So there we are. We've entered that, and it says require a password to log in. Keep that checked. And that's all you really need to do. But make sure you do remember this password, because it will come very useful throughout the course, and if you want to use your virtual machine and not be locked out. So do remember that one. Then click continue. And now what it's going to do is it's going to go about installing all of Ubuntu onto this virtual machine, and it's telling it can, you've got some information about Ubuntu here. It says fast and full of new features, the latest version of Ubuntu makes computing easier than ever. Here are just a few cool new things to look out for, and you can click on this arrow, and it says find even more software. Say goodbye to having searched the web for new software. With access to the Ubuntu software store, you can find and install new apps with ease. Just type in what you're looking for, or explore categories such as science, education, and games, all alongside helpful reviews from other users. Awesome. You can take your music with you. Ubuntu comes with the amazing Rhythm Box music player. With advanced playback options, it's simple to queue up the perfect songs. And it works great with CDs and portable music players, so you can enjoy all your music wherever you go. Wonderful. And you can keep clicking through these things. So there's stuff about photos, web browsing. So it already comes with Firefox, for example. And it also comes with its own suite of Office software. So basically similar software to Microsoft Word, Microsoft Excel, PowerPoint, and so on, all come for free. And they can also work with Microsoft Office files. So that's useful. You've got other things here, so accessibility options. If you need any particular accessibility options when you use your computer, they also are included as well, and you can have them. And it tells you about some help and support from the Ubuntu team. So what this is doing is it's basically just going to install loads of software on your computer. It's going to do a full install of Ubuntu, and it might take a bit of time depending upon just how quick your computer is installing stuff, really. So what I'm going to do is I'm going to cut the video here, and then I'm going to come back when this installation has finished to continue the rest of the way. Okay, and I am back, and you can see that the installation is now complete. It says you need to restart the computer in order to use the new installation. So I'm going to click Restart Now, and that should shut down the virtual machine. just like that. And it says to remove the installation medium, please remove the installation medium, then press enter. So I'm going to press enter. And that should now start booting up the Ubuntu virtual machine again, but this time without having to install it anymore. So let's wait for this to open. Very exciting. And there we go. It's now popped up. It said, here's my username, which is Ziad. I can click on that. I can enter my password and click enter, or click sign in. And it's going to show me this rather awesome looking hacker stuff. And there we are. We've now gone ahead and successfully installed Ubuntu on our virtual machine. So isn't that awesome? What we've got here, you can see you've got the Firefox browser installed. You've got Rhythmbox, which is like a music player. You've got Files, which is like your file navigator. We'll be using this quite a bit in the course. You've got folders installed here. You've got Software Center, which is going to be a way for you to download extra software. We won't use this directly in the course, but it's there in case you wanted to browse and have a look at. You can browse through cool little add-ons you can have a look at here, and there's so much to do. You've got up here, you've got your different settings and stuff. You can take a look at your settings, and really what I want you to do is I just want you to have a play around with this stuff. It works. It's just a computer, guys, okay? Things are just laid out in a different way, but it's not going to be too strange compared to what you're already used to. Things might have a few different names. One thing that's good is this show applications button down here, which when you click that, it'll open up in a rather awesome way, showing you some applications that are installed that you can click on and have a look at. So you've got Thunderbird, which is like an email client, videos, which shows you videos, games in here such as Mahjong. You've got LibreOffice, which is like Microsoft Office, a calculator because maths. You've also got text editors and loads of really awesome things on here. Okay, so one thing that we're going to be making a lot of use of course, is the terminal, which is what you guys came here to learn. So with that all set up, and once you've got yourself comfortable with this, it only should take you about 5 minutes or so. It's really easy to get used to. What we want to do in the next video is get you started learning how to use commands. And when it says here, updated software has been issued, do you want to install it now? Sure, go ahead. Just go ahead and click install now and wait for that installation process to complete. It should sort itself out on its own. Ask you for your password. Go ahead and enter that to give it some permission to go ahead and do the installation. And yeah, you should have a fully updated and ready to go system for learning Linux on. And when you are ready, all you've got to do every time you want to launch this is just head over into VirtualBox and then just click start, and it will boot up this imaginary computer. So there you are completely ready to go. So I look forward to seeing you in the next section of the course, where we're going to start you off by learning how to use the terminal. Can't wait to show you. Glad you're all set up, so I'll see you in the next video.